All right, so I know you're excited to dive into VBA. Before we get there are a couple things we need to configure within Excel. The first thing we need to do is to enable something called the Developer tab on our ribbon. Now, as a review, the ribbon is what we call the main Excel menu. This thing up here is what we call the ribbon. The ribbon consists of several tabs, for example, Home, Insert, Page Layout, Formulas, etc. And each tab is made up of groups. Groups are just collections of related commands. For example, here on the Insert tab, I have the Tables group, the Illustrations group, the Add-ins group, and so on. On the ribbon, we also have this File option, which takes us into something called the Backstage Window view. Right here, we can do a couple extra Excel-related functionalities like opening and saving a workbook, printing, and more. Whenever we want to come back to the main Excel interface with the ribbon, we just click this arrow, and that takes us back to the ribbon. So there is a primary tab that we use for working with VBA, but unfortunately, it's disabled by default. It's hidden. I think the reason for this is that Microsoft assumes that the majority of people will not be using VBA in their workbooks, so they feel like it clutters up the main ribbon. The first thing we need to do is to actually enable it on our ribbon. As a heads up, throughout the course, I'm going to be zooming in on content from time to time, whether it be VBA code in my editor, or a value that I'm entering into my Excel worksheet, or the ribbon like now. My goal here is to ensure that everything I type is easy for you to see. The only thing that you have to remember here is that the way that Excel appears on your screen in terms of size may be different from the way that it appears on my screen. That's intentional, so don't worry if things don't look exactly the same. Okay, now that we're zoomed in on the Excel ribbon, I want to hover my mouse here in this green section. You can really hover it anywhere. I'm just going to hover it a little bit over View and right-click. You're going to see this small menu pop up, and I want to select the option Customize the Ribbon. This will bring up a little Excel Options dialog box, which essentially allows us to modify what groups, what commands, and what tabs appear on my main Excel ribbon. On the right side here, where it says Customize this ribbon, and by the way, if you don't see this screen, make sure you're on Customize Ribbon right here on the left. On the right side here, we can find the Developer tab, and we want to make sure that we select it right here. As soon as we select it, that will enable it as soon as we click OK. And once I activate that, Developer pops up at the very end of our ribbon. I can click it, and here we go, our now exposed Developer tab. The last thing I want to do in this lesson is offer a brief rundown of some of the most popular commands on the Developer tab. We're going to be diving into all of these in a lot greater detail over the course of the next couple lessons, so don't worry if something doesn't make sense now. I assure you it will in time. The very first button we have here to the left is Visual Basic, and this will actually open up the Visual Basic Editor, or the VBE, where we'll be writing the code throughout the course. The shortcut for this is Alt plus F11. To the right, we have a button called Macros. I'm going to press it right now. This is going to bring up the macro dialog box, which is going to show us all macros that we have written that are public. Public means that they are exposed to the Excel interface so that a user can use them. There are going to be a lot of options here for things like editing the keyboard shortcuts for a macro, running it, or even executing it step by step. Predictably, we don't actually have any macros listed here because we haven't written anything, but once we write a macro, they're all going to populate here in this list. Next up is the Record Macro button on the top here. As it turns out, Excel has a built-in feature called the Macro Recorder, and it's kind of amazing when you first hear about it. What the Macro Recorder does is generate automatic VBA code for you. Essentially, you take actions on the worksheet. You take regular actions like clicks and typing, and the Macro Recorder understands what you're doing and generates relevant VBA code. The question you might be asking is, well, if this feature exists, why the heck do we have to learn VBA? The answer is that the Macro Recorder tends to be very inefficient and error-prone. Many times it writes more code than is required. Many times it doesn't use the right kind of idea when accomplishing a task. It'll get the task done, but it won't do it in the most logical manner. There are a lot of minor quirks and inefficiencies with the Macro Recorder, so we should never use it as a final solution when it comes to creating a macro, but it can serve as a really great resource for generating code that we can look at just to get a general sense of how things work within Excel. Right below Record Macro, we have a Use Relative References button. This is related to the Macro Recorder, and it tracks how references are treated when there is a macro being recorded. By references, I mean how Excel interprets movements within the workbook. For example, if I have my mouse in cell A1 and I move into cell B3, There's two ways that you can interpret that movement. The first is to say, oh, he literally moved to cell B3. The other way to interpret that movement is he moved 2 cells down and 1 cell to the right. The two conditions that I described there are called absolute and relative references, and that option has to deal with how the macro recorder is going to treat your movements like that. We're going to dive into that in much greater detail later on. Finally, we have this macro security button. That's going to bring up our trust center options, which deals a lot with macro security. We're going to cover that in a few lessons, so no need to worry about it now. That's all there is to cover in this lesson. The last thing I want to do, I've been saving this moment up until the end. Let's go ahead and actually open our VBE, our Visual Basic Editor. So I'm going to click the Visual Basic button right here on the left, and we have this thing pop up. This is the Visual Basic Editor. This is where we're going to be writing all of our code throughout the course. Now, this is a completely separate application. It is connected to Excel, but it is running in its own separate window with its own separate memory. And I can imagine how this new Visual Basic Editor might be a lot to take in. There's a whole new system of toolbars and menu options. We see this project pane, we see this properties pane, we see this immediate pane. In fact, your screen configuration may be different than mine. It may look a little bit different. That's all totally okay. It's totally fine if you don't know any of this. We're going to dive into all of these details over time. What I recommend you do now, though, as an experiment is just to poke around here a little bit. Spend some time clicking around the menus, click some of the available options up here, maybe hover your mouse over some of these buttons and read the tooltips. Try to get a general sense of what's going on here. It doesn't matter if you understand everything. I just want you to be a little bit more comfortable on the general structure of how the VBE looks, because it is a little bit different compared to Excel. It is a little bit more outdated, a little bit more like a classic Windows application. It's not so stylish and filled with color. So just get used to kind of moving around this interface and get comfortable with it. And in the next lesson, we're going to start our actual setup for the course, and we're going to discuss Excel file types. So I'll see you there. In this lesson, I want to talk about the different file types available in Excel. As it turns out, the default Excel file extension, XLSX, does not actually support macro code. So we'll need to save our workbooks in a specified file type in order to ensure that our code is preserved and that it can run the next time we open the workbook. On my screen here, I have a brand new unsaved Excel workbook. So let's go ahead and get to the save prompt. I'm just going to press the keyboard shortcut Control+S. That'll bring us to the Backstage view. And in this case, I'm just going to select anything that's going to bring up the save prompt. We're not actually going to be saving, so it doesn't matter right now. I'm just going to bring up the VBA course folder on my desktop where I asked you to unzip all of the course files. Right down here, we'll see this option Save as Type, and you can see the option that's listed here is Excel Workbook. That is the standard default file type, and in this standard default file type, macros are actually prohibited. It looks like right here, Excel is actually omitting the extension here, but the extension for an Excel workbook, a plain one, is XLSX, and it is no good. If we write our macro code in here and then we save it, Excel will give us a warning that says, hey, you're trying to save macro code in here, I don't support it. If you for some reason ignore that warning, which is highly likely because many times we just kind of save and click yes and don't actually read the prompt on the screen, if we accidentally save code in a regular Excel workbook, the next time we open it, the code will be completely gone and all of our work will be lost. So it's very important that we save our work in the proper format. If we select this dropdown, what we really want to do is always save our workbooks, at least in this course, in this format, the Excel macro-enabled workbook. This has a file extension of XLSM. You can always think of the M at the end as being short for macro. These macro-enabled workbooks are identical to the regular plain Excel workbooks. They look exactly the same. They have all the same functionality. The only difference is that they allow macros to be written and preserved. We're going to be sticking with this file format throughout the entire course. So there is one thing we can do to simplify the process of choosing this option as the default save type. Otherwise, every single time you'll save a workbook, it's going to default to Excel workbook and you might not properly save it in the right format. It's a little bit of a hassle to keep selecting the right choice. With that said, if you're using Excel for other reasons outside this course, you may not want to select this one as the default. So what I'm about to show you is an optional setting. This is setting the default file type as XLSM. You don't have to do this, but it's going to help make the course a little bit easier and make sure that you don't have to remember to do this every single time we save a file. I'm going to quit out of my Save As window right here. Let's just click Cancel. And on the left side of my Backstage window, we have this options option. Let's select it. This is going to open up this Excel options pane. It looks like it took me back to Excel as well. And on the left side here, I have save. I want to select that. And right here, we see save files in this format, and the default XLSX extension is listed here. That's the Excel workbook. So if we want to change the default save type, we simply click this, select Excel macro-enabled workbook, and click OK. And that will, from this point forward, if I try to save again, ensure that the right file format is listed. Here we go. I just brought up the Save As window, and we can see it says Macro-Enabled Workbook. Now, this is a global Excel setting, but you can go ahead and change it back if you ever need to. Again, if you're using Excel for other reasons and you don't want to accidentally save your workbooks as macro-enabled workbooks, you might not want to choose this optional setting. But if you want to add a little bit of efficiency to your progression throughout the course, this might be worth taking some time to enable. That's all there is to cover here. The key takeaway is all workbooks that have macro code must have the XLSM extension, which is depicted here with the file type Excel macro-enabled workbook. In this lesson, I want to talk a little bit about macro security. So why do we need security in the first place? Well, macros have access to parts of our Windows computer, like the file system. They need this access in order to be able to perform certain functionalities. For example, VBA can be used to open an Excel file. In order to open an Excel file, you need to be able to find it on the file system in order to open it. So these permissions are a good thing for us developers, but they have been exploited by malicious hackers in the past. In fact, viruses have been packaged directly within Excel macro files, and they're particularly dangerous because the user does not necessarily need to run a macro or a procedure in order for this virus to spread. A macro can automatically start running in the background when a workbook opens, which makes an Excel workbook a really dangerous way to distribute a virus, especially across multiple file systems. So to solve this problem, Microsoft introduced several security features way back in Excel 2007. Most importantly, whenever the user opens a workbook that has macros, they're going to be prompted with a yellow notification bar. That bar says essentially, hey, this workbook has macros. Do you want to enable them to run? By default, it's going to prohibit any of them from running. So the user kind of has this wall where they have to confirm that they trust the workbook, that it came from a trusted source in order to permit the macros to run. So right here on my desktop, I have a file here called file with macros, and I've put a macro in here. The macro doesn't really do anything important. It doesn't really matter at all what it does. As long as there's any VBA code in a workbook, we're going to see this yellow notification bar when I open the file. Let's take a look. I'm going to open Excel, and when Excel opens here it is, a yellow bar that says security warning, macros have been disabled. So macros cannot run, including those automated ones that I talked about a few moments ago. Only when we click enable content are all the macros going to be enabled, and only then can we run them. So where is this security option actually configured? Well, if we go to the developer tab and click on macro security, we're going to get this trust center dialog box that pops up. And here under macro settings, here's where that setting is actually configured. We have 4 total options available to us here. The standard default one is disable all macros with notification, and that's exactly what we're seeing. All macros are disabled, but the user is notified, and once the user gives permission by clicking enable content, then the macros are enabled. The option above is to disable all macros without notification. That means that all macros will be completely prohibited from running. The user is not even going to get a notification. Obviously, this option is not going to work for us in this course because then we won't be able to execute our macros. So this option is no good for us. Right below here, we have an option, disable all macros except digitally signed macros. Now, this is a feature that's more designed for people or developers rather who like to sell their code, who like to package their VBA code in something like a plugin or an add-on to add additional functionality to Excel. What they can do is register an account with Microsoft and provide essentially a token of authenticity that whenever you open their plugin or their program, Microsoft confirms that the code has not been tampered with, that it's authentic, that the developer is a valid contributor to their program, and kind of verify it through this digital signature, if you will. Now, of course, this is too long of a process for us. We just want to start coding automatically. We don't want to register with Microsoft. We don't want to start selling our code to other people. So this option is a little bit more complex for us, and we won't need it as well. Finally, the fourth option here is to enable all macros. And immediately to the right here in parentheses, we actually have it written, not recommended, potentially dangerous code can run. So this is very dangerous because, as I mentioned, if a macro includes some kind of malicious content, it can run automatically and infect our file system. So this default option, disable all macros with notification, what we see here is what we're actually going to be keeping throughout the course. There's just one problem, and that is that it's very, very annoying. This means that whenever you open a workbook, for example, something that you downloaded from me as part of the course files, or even your own workbook sometimes, if you, for example, move directory or download it from some kind of online storage system, you're always going to be greeted with this yellow notification bar, and it can get pretty annoying. Sure, you can always just click enable content and move on, but all of those little seconds add up and you're going to waste a lot of time. So what we're going to be looking for here is a compromise that maintains this security setting such that if we get some kind of brand new workbook that we're unfamiliar with, we're going to prevent all the macros from running. But what we also want to do as part of the compromise is ensure that we don't see this security notification bar for any one of our own files, the files that we trust. When we write our own code, we're obviously not going to put anything malicious on our own computer. So we can essentially say that we want to trust our own files. How can we do that? The way we do that is with a feature called Trusted Locations. It's available right here. It's the second tab right here in the Trust Center. A trusted location is essentially a folder or a directory on your computer that we label as safe or trusted. So any Excel macro files or macro workbooks that we put in these locations will be trusted. And when Excel opens them, it's not going to give us this security warning. And that's a good thing because whenever we have a file in any other folder, we're still going to get the security warning, which is a good thing. For example, our downloads folder where we download other people's files can always give us this reminder because it's going to follow the regular global setting of presenting the notification. But any folders that we put here, we can put all of our macro workbook files in there, and that way we can avoid this warning and reduce all of that redundant clicking. So how can we set this up? Well, I'm going to click Add New Location here. That's going to bring up this pop-up box, and I'm then going to click Browse. That's going to bring up the standard browse view in Windows. And what I want to do here is navigate to wherever I'm going to be storing all of the course files. That includes both the files you downloaded from me and all of the files that you'll be saving yourself. Because of course, the best practice here, the best recommendation is to follow along and actually write this code yourself. So what I recommend is to put all of your content just on the desktop. Here I have a sample folder called VBA course. Within it, I have all of my directories that store all of the sections of the course as well as all of the files within them. So I recommend just making a general folder on the desktop. You can call it whatever you want. I called mine VBA course, and then I'm just going to click OK. It doesn't have to be on the desktop. It doesn't have to be called VBA course. Just make sure you have one folder in a specific directory, and then you can locate it and select it. Once it's selected, you're going to see the path to it listed right here. And there's one more thing I want to check in this box, which is subfolders of this location are also trusted. What that means is that whenever we have subfolders or directories within this folder, any files within there will also be considered trusted. If we don't check this box, that only means Excel files at the top level within the actual folder are going to be the ones that are trusted, and we're going to ignore any of the files that are nested within other folders. We want to make sure that everything is covered no matter how many layers down we go, and this option will ensure that happens for us. So once that's selected, we can click OK. I can see here that that path for me has appeared here in my list. We also have the date that it was added. And now this path, this folder, is considered safe. So any Excel files that we have in there are going to be considered trusted. So when I click OK, what I can actually do is compare and contrast. Here we have an example where the notification bar is appearing, and that's because the file as it currently sits is on our desktop. Well, here I have my VBA course folder, which is now safe. So what I can do is drag this file into my folder. And now when I open this file, we're going to see a big difference, which is the notification bar is now gone and the macros are automatically enabled. And we can now run them with whatever we want to do. There's keyboard shortcuts we can use to run macros. We can run them directly from a macros dialog box, etc. But they're all enabled, and we don't have to go through the hassle of clicking that enable content button. That's all there is to cover in this lesson. We talked about how macros can potentially be used to deliver malicious viruses to our computer. So we talked about some of the security configurations that are available. By default, Excel will offer you a notification that says, hey, this workbook has macros. Do you want to enable them? We saw that it was pretty helpful for files that we're unfamiliar with, but it's going to become a hassle throughout the course whenever we're opening our own files. So in order to find a nice compromise between security and comfort, we set up a trusted location on our computer. For me, it was the desktop. And a trusted location is just a folder that Microsoft will not worry about whenever we are opening a workbook file. It's automatically going to assume that the file is trusted, and we don't have to confirm each time we've opened the file in that folder that it's a safe and trusted file that doesn't have any bad content for us. That's all there is to cover here. In the next lesson, we'll be taking a look at the macro recorder. I'll see you there. In this lesson, we're going to take a look at the macro recorder, which is one of the most powerful features available to us in Excel. So the macro recorder actually allows us to generate VBA code automatically. What we do is we run the recorder and then we do regular Excel operations. We can enter values into cells, we can highlight them, color them, delete columns, delete rows, generate pivot tables, etc. And the macro recorder observes our actions and it translates those actions and those keystrokes and those mouse clicks into valid VBA code. So you may be thinking, what's the point of learning VBA if the computer can automatically write it for us? Well, the macro recorder is functional, but it's also flawed, inefficient, and really prone to error. So it should never really be used for real macros. However, it's a really great resource for learning and exploring the syntax of the VBA language. Because whenever you don't know how to do something, but you know how to do it in Excel, in the main interface, you can always just run the recorder, execute that process, and then take a look at how it would handle that procedure, how it would generate that code. That code is not guaranteed to be perfect. It's actually quite likely that it's going to have a lot of flaws and inefficiencies, but it's going to give you a foundation for understanding the general gist of things, which is why the macro recorder is not just a tool for beginners, it's a tool that's used by professional VBA developers as well. Excel has a lot of moving parts to it, including VBA, so it's a really great tool for understanding some of those foundations whenever you're diving into something new. So here's how we can record a macro. On the Developer tab, there is a button here called Record Macro. And when we click that, we're going to have this Record Macro dialog box pop up. There are 4 options available for us here, and I want to dive into each one by one. The first one at the very top is macro name, which is a mandatory field. And here's where we want to assign a macro, our macro an actual name. And ideally, that name should be descriptive. It should describe what the macro is doing. So the default naming scheme here, as you can see, is going to be macro 1, then macro 2, then macro 3, which doesn't really tell us what the macro or procedure is doing. So a good name is descriptive. It usually starts with a verb. It explains what it is that we're going to be doing. What we're going to be actually recording here is just the process of writing our name into a cell and then doing some formatting with it. So I'm going to call this macro write and format name. Now, there are a couple of rules when it comes to macro names. The macro name must start with a letter. So here I'm starting it with a capital W. It cannot be a cell address, which means you can't call a macro something like A1. A macro name also cannot be longer than 256 characters. You really should never need that many because you want your names to be as short and sweet as possible. And your macro names also cannot contain spaces. So notice what I've done here is use something called camel case formatting. A camel case formatting is where you capitalize the first letter of each word. We can't have spaces, so how can we distinguish where one word ends and the next one begins? We simply capitalize the first letter of each word. That's called camel case formatting, and that's what a lot of VBA developers use due to the constraint of not being able to use spaces. The next thing we have here is shortcut key, which is an optional keyboard shortcut that we can set for this macro. So we can always run this macro from a list of macros in a dialog box, but we can also configure it to automatically run whenever we press something on the keyboard. So there is one big caveat that we have to watch out for here. Many of the keyboard shortcuts in Excel that involve just the control key plus some kind of letter are already taken. For example, Control plus S is save, Control plus B is bold, Control plus I is italic, Control plus O is open. So if we just put a regular letter here, it's very likely that we're going to overwrite one of those existing keyboard shortcuts. Now, that is not going to break Excel. It's only limited to this workbook. So if you open any other workbook, those keyboard shortcuts will work just fine. However, you never really want to overwrite those shortcuts because they're really part and parcel of Excel and many people use them. So we never really want to replace an existing shortcut. So we want to have some kind of solution here where we're guaranteed not to overwrite something that already has a keyboard shortcut. The way we do that here is by always including Shift in our keyboard shortcut. If we do Control plus Shift plus some kind of letter, those combinations are not taken up by Excel. So for example, let's say I'm going to use the keyboard shortcut Control plus Shift plus W. I know that's not going to be taken. So what I can do here is just click into this box, hold Shift, press W, and we're going to set up that as the keyboard shortcut once this macro is recorded. The next option we have here is where we want to actually store this macro. We have 3 options available here. We're going to stick with the default one, which is this workbook. It's going to save the macro code in what's called a module that's going to be directly connected to this workbook. So we're not going to be able to access this macro from any other Excel file. It's going to be tied to this one. Another option is new workbook, which is automatically going to create a new workbook as soon as the macro is done recording and store our code there. And finally, the third option is this personal macro workbook. The personal macro workbook is a hidden file that is opened whenever you open Excel. Whenever any file is opened in Excel, Excel loads this personal macro workbook. So whenever you want to use a macro across every workbook, whenever you have some kind of functionality that is common, for example, you may want to have a common styling across all of your workbooks. You like a certain font at a certain size with a certain bolding. You can store that macro in a personal macro workbook, and then it'll be available no matter what workbook you're in. It's not tied to any workbook. It kind of exists in this global scope, this global space where you can rely on it from any workbook. We don't need to do that here because this code is really going to be strictly limited to this lesson, so we don't need to make it global and available everywhere. So I'm just going to stick with this workbook for now. This option, by the way, is required, as is the macro name. The shortcut key is optional, and our final field, description, is also optional. And description, of course, is where we can offer an optional explanation for what the macro does. This is really helpful if someone else is going to be taking a look at the macro code later. They can see a brief comment or a brief description about what it's doing. So right here, I'm just going to write what this macro is going to do. We're going to be writing our name to cell A1 and then just formatting it with a couple aesthetic flourishes. So I'm just going to write a description of write name to cell A1 and format it. All right. Now here's where we have to be really, really careful, because as soon as I press OK, this macro is going to be recording. And that means that anything we do in the workbook, anything, whether we move to one cell, if we bold something, if we delete something, any kind of operation like saving, all of those steps are going to be recorded. The macro recorder is sort of like a video camera that's watching everything we're doing and is kind of recording it to cassette and then replaying it whenever we run the macro again. So we have to be really careful, because if we make some kind of mistake, the recorder has no clue that that's a mistake. It thinks it's just a regular action. So we have to be very careful and make sure that we're executing the steps in their proper order and doing everything correctly as soon as we press OK. So let's get started. I'm going to click OK. And now the macro is recording. There's two ways that we know that it's recording. The first is this thing is going to change to stop recording. And that, of course, is a button that we can click whenever we're done with all of the steps that we want to take. The second place where we can stop the recording is down here. We're going to see this square, sort of like a stop button, if you will. And this is going to also stop recording. You can see the pop-up tooltip says a macro is currently recording. Click to stop recording. So right now I haven't done anything, but if I do anything at this point, it's going to constitute the code in our macro. So here's what I want to do. The first thing I want to do is to click into cell A1, and then I'm just going to write my name in here. You can write your name or whatever you'd like. So as soon as I type my name in, what I'm actually going to press here is going to be Control plus Enter. That's going to allow us to enter the value but stay in the exact same cell. So it's not going to move down. So Control plus Enter is going to enter the value, stay in the same cell. Right now, let's go ahead and add some artistic flourishes to the cell. So the first thing I'm going to do is bold the cell. I can do that with Control B. So Control B. I'm then going to change the font. So let's go to the Home tab right here on the ribbon. Let's change the font to my favorite font, Comic Sans MS. You can, of course, choose whatever font you'd like yourself, Comic Sans MS. And let's also change the font size to 24. Let's do one more thing. Let's add a background to the cell. That's the paint bucket icon right here. This yellow color is totally fine. Let's just click that. And let's say this is our favorite format. This is how we like our name to appear on every professional corporate report that we're going to be submitting to our boss. So we're done recording the macro. Let's call it a day. So let's go to the developer tab and click stop recording. And that's it. Our macro is now recorded. It's stored. We don't actually see the code yet. We're going to explore it in just a second. But all of those steps have been recorded, and we can now replay them from the beginning. So let's go back to a blank spreadsheet. What I'm going to do here is just delete column A to get rid of all the changes that we just did. So highlight that, click delete. I'm just going to click into a random cell. And let's run this macro twice now to make sure it's working. The first way we can run it is from this macros box that we see right here on the developer tab. When we explored this in the previous lesson, it was actually empty, but now we see we have one macro listed exactly with the name that we gave it, right in format name. It's selected in blue. So we can click this run button, and that's going to execute the macro. So it's going to do all the steps that we did. We clicked into a cell, we put in a value, we bolded it, etc. with the font. It's going to do all those steps from the beginning. So when I click run, there we go. This is exactly where we finished recording the macro. All of those steps have been executed instantaneously. By the way, you can access this macros box that we just saw by using the keyboard shortcut Alt plus F8. That's going to bring it up if you want a shortcut, just a little bit of a quicker way to get there. All right, now let's try activating this macro with the keyboard shortcut that we assigned. So once again, I'm going to delete this column. That's just to make sure that we actually see the results. Otherwise, we wouldn't know that anything has actually changed. So let's go ahead and delete this. And our keyboard shortcut was Control Shift plus W. So I'm going to hold Control, hold Shift, press W. Here we go. There we go. The macro has once again ran, and we are back to where we ended up at. All right, so now the time has come to actually take a look at the VBA code. By all means, don't feel like you have to understand everything that's going on, but it's a good idea to take a look at what we just generated to see how VBA processed all of our actions. So there's two ways that we can get to our code. The first is just clicking the Visual Basic icon to open the Visual Basic editor. We'll get there in a second. And then if we go to macros right here and we select our macros, we can also click Edit, and that will launch us automatically into the Visual Basic editor as well. So let's click Edit. And here is the Visual Basic Editor. This might be our very first introduction to the VBE, so if this is your first time seeing it, congratulations. This is a totally separate program from Microsoft Excel, and this is where all of our macro code is actually being stored, and this is where the actual macro recorder has placed all of its automatically generated code. So let me go ahead and expand this so we can see it a little bit. I think this should be our entire macro. That's it. So this is all of the code that's been generated. You can see here a whole bunch of keywords and syntax that you're unfamiliar with. Don't worry, we're going to dive into it later throughout the course, and every single thing is going to be explored in much greater detail. But let me just go through and offer you a bird's eye picture, a big overview of what's going on here. We're creating a macro here, or a procedure called write in format name. Right here, we have what are called comments, which are just lines that are ignored by VBA whenever it's running this procedure. And these procedures, of course, are run from top to bottom. So one line is executed at a time, and it just proceeds from the top to the very bottom, one line at a time. These lines are ignored. That's what the apostrophes do at the very beginning. And these are where we actually put the comments. And you'll notice that this is where our actual description is going to be listed, as well as the keyboard shortcut that we defined. So if some other VBA developer is looking at our code later, they can identify how they can actually run this macro with their keyboard. So let's take a look at what we're doing here. Again, very briefly, not an in-depth dive, just a big picture overview. We're selecting a range here. We are navigating to cell A1, which is exactly what we did. Here you can see we're setting the value into the cell. That was my name that I wrote. Here we can see with the bold keyword that I'm actually making that selection, that cell bold right here. And right here, this is a really, really complex part, but this is the part where we're actually setting the name of the font and the size. You can start to see, and hopefully get a sense of how much extra code VBA is generating. This is tying back to that point I made at the beginning of the lesson about all the inefficiencies of the macro recorder. So what we wanted to do here is to actually change the font name and the font size. But VBA doesn't necessarily understand that completely, because it can think of things both in positives and in negatives. So when you're changing the font, you can think of that as a positive change where we're changing something from one value to another. But VBA can also think, hey, whenever you're changing the font, you're not changing the strike-through property, and you're not changing the shadow, for example, and it's preserving all of those things that we didn't change, because it's kind of taking a picture or a snapshot of what that cell looks like at the time, and that includes a lot of things that we're not actually focused on. We didn't really care about the shadow or the strike-through, but VBA recorded the state of that cell at the time, and so it included all of this extraneous extra data in the macro, in the procedure code, that is actually irrelevant to what we wanted to do. It's still functional. We just saw that it properly did everything that we wanted it to do, but it's also recording a whole bunch of extra stuff that we don't need. That's what I meant when I talked about how the macro recorder tends to be inefficient. So here we're changing the name of the font. Here it's Comic Sans MS. And here we can see with the same font, we're also changing the size to 24. And again, whenever we're changing the size to 24, VBA is thinking we're doing a whole bunch of other things, including things that we're not doing. And finally, this section right here is where we're actually setting the yellow background. So all in all, if you take a look from the top to the bottom, this is probably about 25, maybe more, 30, 40 lines of code. And we really don't need this many lines of code in order to do something simple like this. However, if this is your first time ever working around in VBA, you can sort of start to get a sense of how this can be helpful, because you can take a look at syntax like this and say, okay, I don't know anything about VBA yet, but this says font and this says bold. So maybe this has something to do with making the font bold in that specific cell. And so you can use this generated code to kind of train yourself to explore different parts of the syntax, different things that we're affecting, and learn that way, kind of pick things up piece by piece depending on how the macro recorder does it. So again, just because the macro recorder is often criticized and made fun of by the VBA community doesn't mean that it's a weak tool. It's a really, really, really great, powerful, useful tool. It's just a learning tool. It's a foundation for understanding how something might work in VBA, but you shouldn't use it to actually make your final macro because, as we can see here, it tends to be inefficient. That's all there is to cover in this lesson. I'll see you in the next one. In this lesson, we'll discuss the differences between absolute references and relative references. These are two different ways of looking at cell navigation in our Excel workbook, and they greatly affect how the macro recorder is going to interpret all of our navigation. The default setting in Excel is absolute references, which means that macros will note the actual address of the cell that we are navigating to. For example, if I have absolute references enabled, which is default, and I click in a macro into cell B1, the VBA recorder will interpret that as an absolute reference to cell B1. You can think of the word absolute as meaning definite or final or fixed. If somebody tells you, I know I'm 100% absolutely right, you know that they're 100% certain of something. And in this case, it's the exact same kind of idea. The place where we're going to end up, the cell location, the range, is certain. It's guaranteed. It's always the same thing. If we go into cell B1, the macro recorder will treat that as an actual reference to cell B1. In comparison, macros recorded with relative references are relative. They look at navigation as relative to a starting cell, compared to a starting position. While absolute references are more concerned with the final destination, where you end up, relative references are more concerned with how you get there. So the way the macro recorder looks at navigation is in a sequence of steps, like move 2 cells to the right and move 3 cells down. It doesn't matter what the final cell is, it matters the journey of steps to get there, which allows macros that are recorded with relative references to be used in a lot more locations because they're not so constrained, they don't have so many limitations because they're not bound to ending up in any specific location. The easiest way to demonstrate the difference between these two is to actually record a macro with both. So in this lesson, we're going to record 2 macros, one with absolute references and one with relative references. It's going to be the simplest kind of macro. We're going to put our cell cursor into cell A1, click into there, and in both of our macros, as soon as we start recording, we're going to navigate 1 cell over to B1, enter a value in the cell, and then just end the macro completely. And that's it. So let's begin with absolute references. I'm going to click record macro. I'm going to give this macro a name of move right absolute. This is an example of absolute references. Let's click OK right here, and we are actively recording. So I'm going to press the right arrow key on my keyboard to go into cell B1. I'm going to type in a value here. Let's say hello. And I'm going to press Control plus Enter to enter the value in the cell without moving. So Control plus Enter. Okay, looks good to me. So I'm going to click Stop Recording, and we have our very first macro. Next up is a macro using relative references. So I'm going to delete my value in cell B1. I'm going to navigate back into cell A1. This time, I'm going to enable the Use Relative Reference setting right here. You'll know that it's activated because it's going to have a gray background under the setting. So we're all good here. We can now record a macro with relative references. Let's call this macro move right relative. Let's click OK here. We are now recording. Once again, exact same procedure. Right arrow key to go to cell B1. I'm going to enter the value hello. Control plus Enter. OK, it's entered in the cell. And now I can stop recording. Let's take a look at both of these macros in our actual VBA editor. So I'm going to open up Visual Basic. You can do that right here by clicking this key. And right here under modules, we're going to have module 1. That's where all of our macro code will be collected. Let's open that up. These little lines in green are what's known as comments. They are completely ignored by VBA. They're just used to leave notes behind for programmers, and the macro recorder will make a couple of them for us, but they're negligible, so we can go ahead and delete them just to make these macros a bit more compact and readable. So let's delete the ones there, as well as the ones in the second macro below. Let's also buy ourselves some space so we can compare these macros. And here we have it. So I know that some of this syntax is still going to be a bit unfamiliar, but hopefully you'll get the general gist of what's going on here. At the very top, we have our absolute macro, the one recorded with absolute references. And just as I mentioned earlier, notice that all of the cell references, the range references, are definite, they're absolute, they're fixed. The very first line of code here selects the range that encapsulates cell B1, right? A literal reference to B1. This second line of code, which is actually identical between the two macros, simply writes the value hello to that cell. The more important line is the very first one. We're selecting cell B1 explicitly. In comparison, in the relative macro, we are starting at the active cell, which represents the currently activated cell, the one that the user selected, and we're navigating with this offset method. We're going to dive into that a little bit later, but what it does is it essentially navigates. It moves to somewhere else in the spreadsheet. And this 0, 1 syntax means 0 rows down, 1 column over. So we're moving over relative to our original cell, 1 column over. This syntax right here, range A1, is a little bit confusing because this is a relative macro. It's actually a little bit of what I call that extra useless VBA code that the recorder generates for us. We can actually go ahead and remove this. It's actually a little bit confusing, and the macro will still work regardless. This is much better. So we're starting at an active cell. We're moving over 1 column to the right. We're selecting that cell, and then in that selected cell, we're writing the exact same value, hello. So this one is relative from where we start, and this one will always end up in cell B1. Now let's take a look at how these macros will actually work in our Excel workbook. I'm going to go ahead and delete the value in cell B1. And the important thing here is that I'm actually going to navigate to some random cell in the workbook. It doesn't really matter where. So let's say D6 for me. It doesn't matter where you go. I'm in cell D6. I just want to make sure I want to turn off this reference. It won't really matter because the macro has already been recorded. I just want to go back to Excel's default. Let's go ahead and run our 2 macros in a row. So I'm going to open up my macros dialog box. Here it is. And let's execute move right absolute. When I execute this, we're starting in cell D6, but what happens here? Well, we have our value of hello written in cell B1. Why? Well, because our macro is absolute. So when we recorded it, remember, we literally referenced cell B1. That's how it interpreted our movement 1 cell over. It said to itself, oh, they moved into cell B1, and then they wrote the value hello in there. That's an absolute reference. That's how I'm going to record it. Let's go ahead and delete this value in cell B1. Let's go back into another cell. I'm just going to go into D6 again, just to kind of have an equal experiment set up. But this time, when I execute a macro, I'm going to execute move right relative. Let me just move this box a little bit out of the way here and execute this. And now we're going to end up in cell E6. Why? How come when we recorded the original macro, it was cell B1, but now we're in E6? The answer, of course, is because of relative references. Relative references don't care about the final destination. They're recording relative to where we started from. So when we started in cell A1, relative references interpreted cell B1 as 1 cell to the right. So when we started the macro from cell D6, it once again applied the same methodology, 1 cell to the right, then write the value hello, and thus the value ended up in cell E6. To summarize, absolute references target a specific cell, a specific location, while relative references target a cell relative to a starting position. And as much as it may seem like a small difference, it actually has a huge impact on how successful a macro can run. You really have to know which option you should use if you're going to be using the macro recorder. But that's all there is to cover in this lesson. I hope you're excited to tackle your very next challenge. In this lesson, I want to show you an example of how absolute references can lead to a macro not functioning as expected. So let's begin by creating a sample data set. I'm just going to do a column of regular numbers. So I'll begin with a number 1 in A1, a number 2 in A2. I'm going to select both of these values and just drag them down, let's say to row number 24. All right, so we have a list of numbers. Now what I'm going to do is to delete every 5th row, so every 5th value rather. So I'm going to click on number 5. Let's delete number 5, number 10, number 15, and number 20. Let's say this represents a collection of 5 different data sets. We have a spreadsheet, let's imagine it's much bigger than this, that just has a collection of data every 4 rows and then a blank line. And our goal is to remove every one of those blank lines step by step. The goal of this macro is for us to click into the top cell of any 4 cells that have data, so maybe number 1 or number 6 or maybe number 11, and have a macro that when executed moves 4 rows down and deletes the row that is blank, which is always going to be 4 down from where we're starting, right? So I want to be able to click into, let's say 6 right now, run the macro, have this row be deleted, click into, let's say 16 right here, run this macro and have row 20 be deleted. Focus on the row that is 4 down from where we're starting and just delete that row entirely. Let's see what happens when we record a macro to do this with absolute references and then with relative references. So I'll click into cell A1. Let's click record macro. Let's call our macro here absolute delete. Absolute references are enabled by default, so we can click OK. First thing I'm going to do here is to right click on row number 5, click delete, then put my cursor back into cell A1 and finally stop recording. Pretty simple macro. Right here in my modules folder in my Visual Basic Editor, I'll have a module 1 module. Let's open that. And here we see the automatically generated macro. In fact, let me go ahead and delete these comments so we can read it a little bit easier. So we can take a look at what's going on here. 3 lines, pretty simple. First step is we're selecting row number 5. And this actually is going to be where our problem is going to occur, because we can see that row number 5 is absolutely referenced. It's explicitly written down that it's row number 5. So no matter where we run this macro from moving forward, if we, for example, want to run this macro right here on row 15, what's actually going to happen is the first line is automatically going to select a row number 5, this one. And the next line of code is with the selection, which represents our row, we're going to delete it and shift all of these cells up. This is where everything is going to go wrong, because rather than deleting the 5th row below from where we're starting, we're automatically going to delete row number 5. So for example, let's say I start right here in cell A5, and I think I'm going to delete this row below, row number 9. When I execute this macro by going to macros, finding this absolute delete macro, clicking run, well, we can see things don't go as expected. We actually lose a value. That value is number 6. It's now completely gone. It was in the position of row number 5. It's been deleted. It's now lost. Our macro isn't working as expected because of absolute references. So this is how absolute references can lead us astray. So now let's take a look at how we can fix this problem using relative references. The first thing I want to do is to bring our data back into its original shape. So I'm going to highlight all of the values below. Let's once again create a little bit of a longer data set right here. So let's just drag it down to row 24. Let's delete lines 5. Let's do row 10, row 15, and row 20, all of the 5s. Once again, let's place our cursor in cell A1. The thing I want to do here, of course, is to enable relative references. So I have to click this button again. It's on the developer tab on the code group on the left. Now we can record our macro. So let's click record macro. That brings up the record macro dialog box. Let's call this macro relative delete. Once again, no shortcut, no description, doesn't matter for now. As soon as I click OK, everything is being recorded, so we have to be very careful with all of our steps. I'm going to repeat the exact same steps that I did last time. Right-click on row number 5, click delete, click back into cell A1. Let's stop recording the macro. All right, so there's our code on the right side. Let me go ahead and once again remove the comments. Let me also scroll up so we can see the difference between what's going on here. So as a reminder, the syntax here is not incredibly important. I know that this is a lot of code to take in, so it doesn't really matter if everything is understandable. We can take a look at the difference between these two macros above and below each other. In the absolute macro, we're selecting row number 5 all the time. Here you can see what we're doing is where we have the active cell, which represents the cell that's currently selected or active on our spreadsheet, we're moving down 4 rows. That's what offset does. You don't have to memorize this right now because we're going to dive into it much later. But essentially what we're doing here is no matter where we are in the spreadsheet, we're moving 4 rows down dynamically from that cell. That cell could be anywhere. It can be cell A1, it could be cell G7, it can be cell Z26. It doesn't matter. We're moving 4 rows down. We're selecting that entire row. We can see that with entire row right here. And that selection is what's actually being deleted. You can see selection delete with the shift right here, XL up, is the exact same line as we have right here. So the deletion step is exactly the same. The difference is in what is actually being selected for deletion. In the absolute macro, it's always row number 5. In this one, it's a relative row. It's the row that is 4 down from where our original cell is, which is exactly what we want. It's relative to where we're starting from. So now, if I click into cell A5, that's the top of a code block or a data block to be more precise. And now I want to delete row number 9 because it's 4 down from where I'm starting. If I go to macros and I execute relative delete, let's click this. Everything works as expected. I've deleted the row that is 4 down from where I'm starting from. So now if I click into this cell, again, that's the top of my next block of data. Once again, go into macros. Once again, execute relative delete. We click run. The next one is deleted. One more time, we're going to click into cell A13. That's the beginning of the next block of 4. Let's go into macros, relative delete, run. Everything is working exactly as expected. And if we, of course, had a keyboard shortcut, we can just hold it in place, and that would execute this over and over and over and delete every fifth row automatically. So hopefully this lesson will serve to reinforce the idea of how relative references work. They are relative or based off of where you're starting from. They're dynamically created. Where we're starting from, that cell is used as the basis for figuring out where you're going. So all sequences of movement, whether you're moving up or down or left or right, are interpreted as being relative to that starting point, that starting cell. In comparison with absolute references, everything is absolute. So if you go into cell C3, VBA will look into that as literally cell C3 every single time. In this example, Excel interpreted our deletion of row number 5 as the deletion of row explicitly number 5, specifically row number 5. Not the row that was 4 below where we started from, that's relative, but actually explicitly row number 5. That's what absolute references do. It's absolute, it's predetermined. You can think about what the word absolute means. It means kind of fixed in place. That's exactly how these references work. They're always targeting the exact same location, the same cell, the same column, the same row, etc. Relative references, which is going to be the one you tend to use more often than not whenever you're recording macros, targets things dynamically, which makes it a much more powerful and flexible choice when recording macros. In this lesson, we'll explore the interface of the Visual Basic Editor. As a reminder, there are 2 ways that we can access the VBE. The first is by clicking the Visual Basic button on the Developer tab right here. That will launch us into the VBE. The second is to use the keyboard shortcut from Excel, which is going to be Alt plus F11. If you forget that shortcut, you can simply hover your mouse over this button and it'll appear here in the little highlight that pops up. Alt plus F11. So let's go ahead and click that, and that'll take us into the Visual Basic Editor. So the VBE, or the Visual Basic Editor, is a totally separate program from Excel. It's dependent on it, it needs it to run, but it's a totally separate application in itself. It runs with its own interface, its own set of toolbars, its own set of settings. So you can imagine them as 2 separate entities. Because the VBE is designed for more technically oriented people, the programmers and developers and the like, its interface certainly isn't as pretty as Excel's, but you'll find as you play around with it that it's still pretty simple and pretty functional. So let's explore the different parts of the VBE, starting with this top left section, which we call the Project Explorer. The Project Explorer window is typically placed on the top left, but you can go ahead and click this bar and drag this window and dock it anywhere you want in the actual window that we see here, the VBE. The Project Explorer lists all open workbooks and add-ins sort of as a tree diagram with nodes. It's very similar to what you might see in Windows Explorer when you're looking at directories and all the files within them. It's kind of a nested structure that stores the logic of all of the objects that are within the spreadsheet. What I mean by objects are all of the data entities within every workbook. So right here at the very top, we have our VBA project, which represents the currently open workbook, absolute versus relative references. This is the exact same workbook that I worked with in the last lesson when I created the automatically generated code. Below, we have a folder called Microsoft Excel Objects, and that's going to store an object, or essentially a data structure, to represent every single worksheet. Right now in this workbook, I only have one worksheet. It's called Sheet 1. So here it is right now highlighted in blue. But if I had more worksheets, they would all be listed here kind of as a drop-down list. And finally, at the end, I have this workbook, which represents the entire workbook as a whole. Now, primarily, most of the code that we're going to be writing in the course is going to take place or be written in modules. And so modules are organized still within the same project, but within a totally separate folder called modules. By default, as we create modules, or as the macro recorder generates them for us, they're going to be named numerically in order. So module 1, module 2, module 3, and so on. But we can go ahead and change the names of these as we proceed if we want to organize related procedures into different modules. So for example, we may have a module for mathematical operations, one for worksheet operations, one for workbook operations, one for specific reports, things like that. It's just a way to organize our code into different buckets. A module, again, is just a container for procedures, and procedures are just snippets of VBA code that perform some kind of operation. All modules will be listed here under the modules folder, and a single module is actually limited to 64,000 characters. We can see here, in order to actually see what's in the module, we can double click it. That's going to open the content in the code editor on the right. And here we see all of the code that's currently saved within this module. It's two procedures for us, this move right absolute and move right relative. As soon as I click on any of these other objects within the Microsoft Excel objects folder, you can see there's no code currently written in there. So whenever we're looking for our code, we have to go to wherever it was originally saved. In this case, it's in module 1. So VBE will open a brand new code window for each module or worksheet that we click. We're going to see all of our code right here. By default, we're going to have these horizontal lines that separate each one of our procedures. So we have a visual indicator of where one ends and one begins. We're going to dive into this option a little bit later. On the top right here in this dropdown, we have the ability to select any one of our procedures to go to the place in the module where it's defined. So right now we only have 2, so it's kind of not really an effective feature because we can see everything on screen. But you can imagine if we have 15 or 20 different procedures in a single module, they're all going to appear right here. We can very easily click on one of them and it's going to bring us to that section of the code. Down here on the left side of the Visual Basic Editor, we have the Properties window. If for some reason you don't see the Properties window, you can always click View up top here, and Properties window will be listed right here. It's also enabled by the keyboard shortcut F4. By the way, if you don't see the Project Explorer, which is the thing on the top left that lists all the modules, that's this thing right here. You can click that as well if for some reason it's disappeared, or use the keyboard shortcut Control++R. It may pop up somewhere else on the screen undocked. If that's the case, just click and grab it and drag it to where you want it to stay on the screen. We'll dive into properties a little bit later in the course, but you can think of properties as configuration settings or options for a specific data entity within our system. So on our module, for example, we only have one property and it's called name right here. And we can use that property to change a specific value. So if we want to change the name of this module, which is currently module 1, we can change it. So for example, we can do something here like deletion procedures. Press enter to save. You can see the name has changed below, and it's also changed up here. So we've used properties to alter the name of the module. It's a little bit more of an advanced concept, but essentially, as we click around different objects, we're going to have different settings, different configurations that we can set depending on what the data structure is, depending on what the data entity is. Because of course, what a workbook can do is different from what a worksheet can do, from what a module can do. So each thing in our application is going to have its own bucket of settings, and the properties window is where we adjust and configure those settings. Finally, down here on the bottom, we have the immediate window. If for some reason you don't see this window, let me just go ahead and close it. The keyboard shortcut for that is Control-G, and the alternative way to access it, I'm just going to close it again, is going to the View, drop down, and there should be an immediate window setting right here. That's the exact same thing. You can see the shortcut. That brings up the immediate window. The immediate window is a console of sorts. It's a playground. That's the best way that I can think of it. It's a place where you can test little snippets of code. So it's not designed for writing an entire procedure from scratch. It's not designed for any kind of lengthy operations. But whenever you want to check how, for example, a single line of code would execute without packaging it within a procedure, without going through that hassle, you can test kind of snippets of code here very briefly. For example, I can perform a basic mathematical calculation or check the current value of a cell in my Excel window. So as an example, we're going to dive into the syntax later, but if I want to find out what 1 plus 1 is, I can place a question mark here. That's sort of asking the immediate window a question. I can put some kind of expression like 1 plus 1, press enter, and get the value of 2. So really simple operations, really simple things that we want to check. One-liners of code, maybe 2 lines at maximum. Whenever we want to test something really small, we use the immediate window. Whenever it's something larger, we're just going to package it within a procedure. We can also use the immediate window, by the way, to check the current values of properties. So we can use it to check current settings, see what they're currently set to, things like that. We're going to dive into that in much greater detail when we explore the immediate window in a section or 2 from now. And that's basically the whole interface of the Visual Basic Editor. There are additional options available right here in all of the drop-down menu options, but we're going to explore those in detail a little bit later. So to close or exit the VBE, it's a totally separate program. So when we close it, it doesn't affect Excel in any way. All we have to do is just click the X button at the top right. That closes us out of the VBE. There is a keyboard shortcut as well. So let me go ahead and open it. The keyboard shortcut to exit the VBE is Alt plus Q. I'm going to press that right now. Brings us back to our Excel interface. So again, we do not need to have the VB running. Excel is a totally separate application. It can run by itself. But when we do have the Visual Basic Editor running, we do need Excel open because it is dependent on it to essentially get its data and manipulate it. So that's a quick exploration of the Visual Basic Editor. It's a lot to take in, but we talked about the properties window, the immediate window, the code editor, the Project Explorer, and we're going to dive into all of these sections in much greater detail. We're going to explore them one by one, but essentially it's just a way to organize our project. On the Project Explorer, we're going to have all of our available projects, our objects within them. By objects, I mean worksheets, workbooks, etc. In the Properties window, we're going to be able to configure our settings. In the Code Editor, we're going to be able to actually write our code and our procedures. And in the Immediate window, we're going to use it as a console of sorts to test values, do a dry run through certain procedures, test a couple small things here and there, minor operations like that. And that's basically it. Once you memorize those 4 pieces, that's most of the VB interface, and you'll be surprised how quickly you can pick it up. That's all there is to cover here, so I'll see you in the next lesson. Welcome to the fundamentals section of the course. In this section, we're finally going to get to writing valid VBA code in the Visual Basic Editor. But before we get there, there are some other fundamentals that I want to cover. I know that this material may be a bit more dry, a bit more technical and boring, but it's important to lay a good foundation here because if we are willing to invest our time and energy up front, it's going to pay off a lot when we start applying these ideas to more technical concepts within VBA. I want to begin here with a discussion of object-oriented programming. What is that? Well, as I mentioned before, VBA is an object-oriented programming language. Object-oriented programming is a development paradigm, which just means a way of thinking that views a software application as a collection of objects that talk with and interact with each other. The first question you probably have is, okay, what is an object? Well, an object is some kind of entity. It's a data structure. It's some kind of thing. If you take a look at the objects around you, the real world objects that you may see a computer, you may see a lamp, a bed, a drawer. We as humans are able to differentiate between these things. These objects are different entities that we recognize, and we can do different things with these objects, and these objects also have different attributes about them. Code and the computer have a similar design concept, right? Excel needs the ability to differentiate between different data structures. What are some of the objects that we might run into in Excel? Well, you can think about a workbook versus a worksheet versus a cell range. Excel needs to be able to differentiate between these things, much like we as humans differentiate between these things. And that's accomplished in programming terms by identifying each one of those things as a separate object, right? It's just a different thing within the context of the application. Each object has its own set of properties and methods, okay? A property is like an attribute, a detail, or a characteristic about an object. A property defines what the object looks like and how it acts. It's some kind of characteristic about it. You can think of it almost like a passive detail, right? It's not an active activity that we're doing with the object. It's something that describes the object's state. In comparison, a method is an action or a command that we can do with an object or on an object. I know that right now these ideas are very high level, so what I want to do over the next couple of slides is to apply these principles to a couple real life objects to kind of give you a better understanding of what I mean when I say properties and methods. A really good way to think about it is in the context of language. An object is like a noun. A noun is a person, place, or thing, right? You can think about, again, the objects around us, a water bottle, a refrigerator. These are objects. They're things that we can interact with. Those objects have properties, which are details about the object, right? Properties in the context of language are like adjectives. That car, which is an object, is red. Red is describing the color of the car. So color can be thought of as a property, and red can be thought of as a value. A method is like a verb. It is an action. What can we do with a car? We can drive a car, right? We can fix a car. We can sell a car. So an object is like a noun, a property is like an adjective. It's some kind of descriptive way that we can talk about the object and what it looks like. And a method is something that we can do with the object. It's a verb. Let's reinforce these concepts with a couple other real-life objects. So here I have 3 objects. I have a book, I have an apple, and I have a basketball. And I want you to think about some of the properties or characteristics that these 3 objects might have as well as some of the methods, which are the things that we can do with these objects. And here's a few that I came up with. Feel free to come up with some more of your own. There's no right or wrong answer here. So what are some of the properties that I can see on a book? Well, a book will have a name, a book will have an author, it will have a certain number of pages, and it will have a price. Notice that none of these things are things that I do with a book, right? These are not verbs that I would ever use when writing something about a book. These are rather details that describe what the book is like, what its shape is like, what its structure is like, what its state is like. In comparison, methods related to a book, things that I can do with the book, include reading. I can read a book, I can sell a book, and I can trade a book. Let's dive into another example with an apple. An apple may have a property of a color. That value of that property may be red, just like an adjective. An apple may have a red color. Variety, the type of apple that we're dealing with, is another property. An apple may be a Granny Smith apple, it may be another kind of apple. An apple may have a price property. That price can be 99 cents, it can be 49 cents. Different apples can have different price values. Again, properties are just characteristics that describe what the object is. A price is not something that we can necessarily do with an apple, it just describes the apple. What can we do with an apple or with any object? What we can do is what we call the methods. So methods related to a real-life apple are eating it, we can slice it, and we can wash it. Finally, with a basketball, some of the properties I can think of on a basketball: it has a color, orange, it has a weight, 3 pounds, and it has a company that makes it. Some of the things we can do with a basketball, some methods: we can throw a basketball and we can sell a basketball. An important thing to notice here is that different objects can share the same properties. For example, the book and the apple both have a price property. In real life, nobody would confuse a book for an apple. They're two different objects, they're two different entities, they're two different things, but they both may have similarities. They may both have a price. Similarly, objects may have the same methods. For example, the book and the basketball both have a sell method. A book is a totally different object from the basketball, but they can both be sold. We can both do the same thing to them. Objects may have unique properties, they may have shared properties or identical properties. Objects may have unique methods that are exclusive to them, and they may also have shared methods. To conclude this lesson, I want to dive into a little bit of the technical syntax that we'll be using in VBA when we're dealing with objects. So let me just bring up this slide right here. This is a lot to take in, so by no means do you have to memorize all this stuff right now. I just want to introduce you to the syntax so it's not going to feel as awkward when we throw all this stuff at you a little bit later, okay? So there's 3 things that we can do here. We can get a property, we can set a property, and we can call a method. The syntax for getting a property value, which means finding out a characteristic about an object, looks like this. We have an object, we have a dot, and then to the right of the dot, without any spaces, we have the name of the property. You can see that in the middle of the table right here. So let's take a look at the 2 examples in the right-hand column. Let's say we have a book and a basketball object in the context of a program like VBA. A book, as I mentioned, may have an author property. It's a characteristic about the book. And we can reference that property. We can get the value by writing the name of the object, book, then a dot, then the property name, which is author. And that will return to us an author, like, let's say, George Orwell. Similarly, if we have a basketball object, we can reference a color property on it with that dot syntax. Object, then a dot, then the property on the object that we want to access. And that will give us a value like a basketball color, let's say, is orange, okay? Now, predictably, if an object doesn't have a property, then we're going to run into an error, but we can dive into that a little bit later. Some object properties are what we call read-only, and that means that they can only be read. We can only get them, we can't change them. For example, in real life, a book will always keep the same author, right? However, there are some object properties that can be overwritten. They're not read-only, they can also be written, right? We can read them, we can write them. That means that new values can be set. For example, a book may have a price right now, but that book's price can also change when the shopkeeper decides to give it a different price. A basketball may have a color of orange, but we can always pick up the basketball and paint it and give it a new color of black, right? So some properties can be overwritten. The syntax to set a property value, to give an object property a new value, is very similar. On the left-hand side, we're going to have the object, a dot, and the property. And then unlike the syntax for getting a property, we're going to write an equal sign. And then on the right-hand side, the new value that we want to assign. So let's take a look at the 2 examples here. If we do just book.price, we're going to get the current price property of a book, which is going to be some kind of number. If we want to overwrite that, if we want to set the price property to something different, we do book.price equals, and on the right-hand side, the new value, which let's say arbitrarily is $14.99. Similarly, if we want to change the value of the color property on a basketball object, we would do the object basketball dot the property, which is color, an equal sign, and the new value on the right, which in this case is black. I want you to notice here that black is written in double quotes, and this is very important. When we have something written in double quotes in programming terms, we call that a string. A string represents a collection of text or characters. So anytime you're going to be writing words, things with spaces, names, you're going to be using strings. And whenever you write a string, you need to do double quotes. You do not need to do double quotes if you're doing things like numbers, as we have here with $14.99, with either floating point numbers with decimals or whole number integers. But whenever you're using some kind of text as a property, like a name, you're going to have to use double quotes. We're going to repeat this many times, so don't worry about memorizing it now. Finally, we have a syntax for calling or invoking a method on an object. And when I say call a method, I just mean to run it, to execute it, to tell the object, hey, you have this functionality, you have this ability, I want you to do it, okay? The syntax is exactly the same as it is to get a property value. It's going to be the object followed by a dot, followed by the method on the object that we want to execute or call. You might be looking at these syntax options and saying, but hey, the object property syntax for getting a property value is very similar to the object.method syntax for calling a method. And you're absolutely correct. The syntax is essentially identical. We have to ourselves know whether we're calling a method or getting the value of a property, because VBA is not always going to tell us, okay? But the syntax is going to be very similar. Let's take a look at these two examples. Again, these are real-life objects. These are not things that exist in VBA. But just like we have apple and basketball here, we're going to be applying these concepts later to a workbook or a worksheet. So in order to invoke the eat method on an apple, we write the object apple, a dot, followed by the word eat. We have basketball, the object, a dot, and then the word throw, which is the method, what we're asking the object to do, okay? This is a very big picture overview of objects, methods, and properties. And in the next lesson, the assignment, what I want you to do is to take some of these concepts and apply them to the real life objects around you. Hopefully that will give you a better sense of the ideas that are being discussed here. And once you start thinking about real world objects in this sense, it's going to be a lot easier to apply these concepts to VBA objects in our environment, okay? So I look forward to seeing you in the next lesson, and get ready to tackle your very first assignment. In this lesson, I want to talk a little bit about collection objects, again in a real-life context. I want you to think about an object like a bicycle. A bicycle can have properties like maker, gears, and year, and a bicycle can also have methods like ride and paint, things that we can do with it. Now, VBA, in addition to the concept of a single object like a bicycle, has the concept of a collection object. A collection object gathers together one or more related identical objects, okay? And syntactically, in VBA, a collection object is always going to be the pluralized version of a single object. Let me provide you with a more concrete example. Imagine we have a bicycle shop in our neighborhood, and it's going to have multiple bicycles, right? So imagine bicycles as a collection object. It is an object that represents a collection. Think of it like a box in real life. A box can store multiple things together. In VBA, we have certain objects that exist solely as containers for other related objects. So a bicycles object with an S at the end, the plural form, is a collection that collects multiple bicycle objects, singular. So in this case, I have a bicycles collection object that is storing 3 different bicycle objects. These are 3 completely different objects. Each one of these is going to have properties like makers, gear, year, and methods like ride and paint, but the property values on each may be completely different, right? These are 3 different bicycles that we're storing. Many times what we want to do is to reference a specific singular object within a collection. For example, in VBA, we have a worksheets object, which represents the entire collection of every worksheet that exists in the current workbook. And many times we want to say, hey, get just the second worksheet in that collection and do something with it. The important thing to remember here is that collection objects and individual objects are totally different things. Bicycles is going to be a collection object that's going to have its own set of properties and methods. Just because it's a collection of something else doesn't mean that it's a different idea. It's still an object. It still has the concept of properties and methods. It's just an object that's going to hold other objects which will also have properties and methods. In VBA, the syntax that we use to reference a specific object in a collection is this. We write the entire name of the collection, in this case, bicycles. We give a series of parentheses, opening and closing parentheses, and inside we write the numeric index of the item. What I mean by index is the position in which it's in, okay? So in this case, we're writing number 1 because we want the first item in our collection, and you can see it's pulling out this red bike that's at the very beginning of our bicycles collection. The count in this case, when it comes to collection objects, always starts at 1. This is not always the case in VBA or programming in general. Sometimes the count starts at 0. But when it comes to collection objects, the first item, the first object within that collection is always going to be referenced by the numeric value 1, and the second bicycle by the numeric value 2, and so on. So when we use this syntax, bicycles, parentheses 1, we are pulling out a single object from the collection. In the example below, I have bicycles 1 maker, right? Maker represents a property, but here's the tricky part. Here's where it gets confusing. The maker property here that I'm referencing is not a property on the bicycles collection object. Rather, it is a property on a singular bicycle object. How do I get to a single bicycle? That's because when I use that parentheses syntax, I'm pulling out just one bicycle from this collection, and then I'm referencing an existing property on it. Let's give you another example, this time with methods. Let's say I want to call a method on another object in this collection. For example, in VBA, let's say I want to do something on the second worksheet in my worksheets collection. In this case, bicycles is my collection, so I use the parentheses with a 2 to pull out the second bicycle object from my collection. Once I have that, I can call a method on it like ride. You'll notice we're combining the syntax from the lessons before. We're still using the object dot syntax followed by the method here. But in order to get that object, we're no longer writing it directly like bicycle. Rather, we're extracting it from a predefined collection of related objects, right? Finally, one more example here that I can provide. Let's say we want to set a new property value on one of our bicycle objects. Once again, I have to take it from an existing collection, from a box that's containing all of these related objects. So I reference bicycles, my collection. In order to pull out a specific bicycle, I give parentheses and the number, the order of the bicycle that I want to pull out. So in this case, I'm doing bicycles 3, which is that blue bike at the end. Once I'm pulling it out, I'm getting back a bicycle object, singular, that's going to have properties and methods. In this case, a bicycle has a gears property, which can be read, and it can also be overwritten. It's not a read-only property. So here I'm setting that gears property equal to 5. That's all there is to cover in this lesson. I just wanted to introduce the concept of collection objects, essentially an object that acts like a box. It collects related objects together. We pull out individual entities, individual items from this collection by using parentheses. It's going to be the exact same syntax when we translate this to workbooks, worksheets, and so on. In this lesson, I wanted to introduce the idea of objects serving as properties to other objects. This is a pretty complex idea, but once we understand this, it's going to tie together a lot of the concepts that we've explored in previous lessons. So I want you to imagine 2 objects here. On the left-hand side here, I have a book object and an author object with some pretty familiar properties and methods. And so far, whenever we've accessed our properties on our objects, we've used that familiar dot syntax, and our values have been simple data types, things like strings and numbers. For example, if we have a title property on our fictional book object, it may be equal to a string like Animal Farm. Notice here that our string, our text, is once again represented in double quotes. This is a requirement whenever we're using text, which is called a string in technical terms. Similarly, if we did something like book.pages, that may be equal to 100, and that is going to be a simple data value, an integer, just a whole number. And if we wanted to access a method, it would just be something like book.read. So here's where it gets really interesting. Stay with me here. An object's property can be a reference to another object, okay? Take a look at the 2 objects on the left here. The book has a property called author, the very last one. Imagine that that author property is not a basic thing like a number, but imagine that it represents the entire author object that you see below. So when I do book.author, I'm not going to get a simple value. I'm going to get the entire object that we see represented here on the bottom left. So if I wanted to access something like the author's name, and I know that the author property on a book represents the entire author object, my syntax would look something like this, right? Book represents my book object. It has an author property which links to, which nests a complete author object. Once I get that complete author object, that author object has a property called name, which I can use to access the author's name and get something like a string of George Orwell. The important thing to remember here, to understand here, is that name, that property is not being referenced on my book object. It's being referenced on my author object, which exists as a property of my book object. Book has a property called author, and that author property corresponds to a complete author object. As another example, if I wanted to call a method like complain on my author object, but I'm starting from a book's perspective, I begin with the book object, I reference the author property to get the author object, and on that author object, I have a method called complain, which I can invoke here. Let's once again tie this concept back to Excel. So let me provide you one example. In VBA, we have this concept of a range object, and a range just represents a clump of one or more cells on a worksheet. Like any object in VBA, a range object includes properties and methods. Some of the properties on a range object correspond to other objects. For example, range has a font property. That font property returns a brand new font object. That font object has its own set of properties and methods. This is the equivalent of our book author example. You can think of range as the book and font as the author. Font is a nested child. It's a nested object within range. That can be accessed again with .syntax, and that has its own set of properties and methods. Now, this example is very simple. It's just a two-layered example, right? There's two tiers. There's this parent object, and then there's this child object. Excel is a lot more complicated. So a single object can have a property that's going to be another object, and that nested object can have another property that's going to be another object. And that relationship can continue down many, many different levels, many different times, maybe 5 or 6 times. That hierarchy, that relationship, that collection of nested object properties that represent other objects, that whole shebang is what we call the Excel object model. It is the hierarchy of nested objects within VBA. The Excel object model is very complex. In fact, there are so many different objects in there that it's impossible to memorize. You can't possibly commit this to memory. But it's important to recognize that all of these objects are not independent, autonomous entities. Rather, they are related and connected. They're interwoven to each other by being nested within one another. And let me give you just a big picture overview that's going to go a few layers deep. At the very top of our VBA, we have an object called application, and this represents all of Excel, the entire open running Microsoft Office application called Excel. The application object has a property on it called workbooks. So it's going to be application.workbooks. That property of workbooks returns a workbooks collection object. Remember, we talked about collections 1 or 2 lessons ago in the example of a bicycles. Workbooks is a property on an application object that returns a collection, which is a box or container, of multiple workbook objects. So we can reference from an application a collection. Then we can use that familiar parentheses syntax with the numeric index of a specific entity to get a single workbook object. A single workbook object is going to have a property called worksheets. The worksheets property is going to return another collection object, this time a worksheets collection object, which, as you probably can guess by now, is just a collection object that includes multiple singular worksheet objects. All right. Using, again, the familiar parentheses syntax, we can tell this collection of worksheets that we want to target just a specific singular worksheet. And on that worksheet object, we're going to be able to have a property called range, which is going to return another range object, which we can use to reference one or more cells. This is just one kind of blown up example, but you can see here this idea of the hierarchy. You can almost think of it like an ancestry diagram where you have parents and children. Application is the parent of this nested object called workbooks, and then workbooks is the parent of each one of these workbook objects. And this relationship continues further and further down. We're nesting it. We're kind of hiding these objects within other objects, and we're proceeding down this hierarchical chain until we get to the specific object that we want to work with, and then use its properties and methods to do something with it. So where we stop in the hierarchy in the Excel object model is going to depend on what we want to do. If we want to do something on a cell value, on a cell range, we're going to have to get down to the range object. That's where we're going to alter things like its value. If we want to do something on the workbook level, we're going to have to find a way to get to the workbook that we want to work with and call some of its methods like open, close, or save. All that programming in VBA is finding out where you want to be in this hierarchy, what object you want to work with, and then determining the right property to get, set, or the right method to invoke. That's all there is to cover in this lesson. There's just one other idea that I want to reemphasize if it isn't obvious. This Excel object model is exclusive to Excel, but each Office application has its own different object model with its own collection of objects. So Excel is going to have the concept of workbooks, worksheets, and let's say pivot tables, while a program like Outlook, which is used to send email, is probably going to have something like an email object or a contact object. So a macro that's going to work in one of these programs is not guaranteed to work in the other because the object model is different. If you want to add a pivot table, it's not going to work in Outlook because the Outlook object model, its own structured hierarchy of nested objects, has no idea about the concept of an object called a pivot table. Similarly, the reverse is true. If we wanted to send an email within Excel, we wouldn't be able to do this because Excel's object model, its hierarchy of nested object relationships, it has no clue of the concept of something like an email. These are totally different Office applications. They have total different object models, and all that an object model is just a hierarchy of nested object relationships. Among those relationships, we have the concept of collection objects, which are boxes for more than one object. We have singular objects like a workbook or a worksheet or an email, and all we have to do as programmers is figure out which one we want to touch, which one we want to access, and what we want to do with it. That's all there is to cover in the slides. In the next lesson, we're going to take this concept of the Excel object model and start exploring it in the context of our Visual Basic Editor. All right, so the time has come to explore the Excel object model within our actual Excel application. We're going to continue expanding on the concepts that we introduced over the last couple lessons. So here I have a brand new workbook open, and it has 3 total sheets right now: Sheet 1, Sheet 2, and Sheet 3. On my right side here, I have my Visual Basic Editor. As a reminder, if you want to open that up, there's a couple ways to do it. You can go to Developer and click Visual Basic. You can also use the keyboard shortcut Alt plus F11. For this lesson, I'm going to be writing all of my code within the immediate window, which is this pane at the very bottom of our VBE. You can, in fact, click and drag it to make its size a little bit bigger. And if for some reason the immediate window is not showing up for you, you can use the keyboard shortcut Control plus G to bring it up. The immediate window, I think we discussed it a little bit previously, is a console of sorts. It's a playground. It's an interface where you can perform basic VBA code calculations. So you can use this thing to test out little snippets of code. It's not designed for complex procedures, but whenever you want to, for example, check the value of a property on an object or see how a method would operate by itself, you can always run it in the immediate window just as a playground of sorts. Now, there's actually 2 syntactical options that are available to us when using the immediate window. The first of them involves using a question mark, and you can think of the question mark as asking a question. And whenever we ask a question, we are querying some kind of expression or querying some kind of object. So you can think of a question mark as, again, asking a question as compared to something like issuing a command. So whenever we are getting a property on an object, that is asking a question. We want to find out what the current value or the current state of something is. Whenever we are setting a value, or for example, invoking a method, those are commands. Those are instructions. So whenever we have instructions, we don't need the question mark. Whenever we are asking a question or ascertaining the value of something, that's when we do the question mark. So as one example here, I can write some very basic VBA code. I'm just going to do a basic mathematical expression. I can do 1 here, and then the plus symbol, and then 1, and this is going to perform the basic mathematical calculation of 1 plus 1. Add those two up to get 2. So again, we're asking a question, so we want to prefix everything with the question mark. So let's go ahead and explore a few properties that are available across several objects in the Excel object model. What I'll do here is use another question mark. I'm asking a question here. And we know at the top of our hierarchy, we have the application object that represents the entire Excel app itself. Now, as soon as I put a dot here, we're going to see this feature called IntelliSense pop up. And IntelliSense is going to give us a list of all of the properties and methods that are available on the given object, which is the object that is right before the dot. So as we're putting in different values here, we're going to see totally different pop-up menus pop up. So what we have here is a list of all of the properties and methods that are on application. And as soon as I type any kind of letter, it's going to filter the results based on what we type. So I want to look for a property here called name. It begins with a capital N. So as soon as I type that, it's going to be filtered. It's going to go directly to that place in the list alphabetically. We have it right here, and then we can press the tab key to lock it into place. This is often recommended because it reduces the probability that you're going to make an error when you're typing out the name of a property. If a property doesn't exist, of course, VBA will give you an error. So we're asking a question here, application, that's the object. Tell me the value of your name property. And when I execute this with enter, of course, we're going to get Microsoft Excel. Now let's dive into a little bit more of a complex example. What I'm going to do here is just clean my work right here. And before I begin in the immediate window, I want to go right here in my workbook to sheet 1. And on sheet 1, cell A1, I'm going to write a value into that cell, and that's going to be hello world. And what I'm going to try to do is use my immediate window to reference this cell on this specific worksheet in this specific workbook in this specific application and get its value printed to my immediate window. How can I do something like that? I'll begin with a question mark, again, because I'm asking a question. The question is, what is the current value in cell A1? Let's begin at the very top of our Excel object model and then proceed further downwards and navigating that hierarchy. So we know at the very top we have application. That is Excel itself. And then we know that we have certain properties on objects that nest other objects. So on application, we have a property called workbooks. Workbooks, as you can tell by the plural form, is a collection object that stores a bunch of workbook, singular objects. How can we access any one of those workbook objects? We use the familiar parentheses notation where we put a pair of parentheses and then the number of the workbook that we want to extract. In this case, we only have one workbook open, so there's only one option available to us. The first count, the first item starts at 1, so we're going to extract the workbook in that position. So we've moved from application to workbooks to a single workbook. So when I put the dot here, the properties and methods that we're going to see here are those that belong to a single workbook, not the workbook's collection object. You have to be very careful here. On a workbook object, we have a property called worksheets. Worksheets is going to give us another collection object of all the worksheets within this workbook. In this case, we have 3. And we can reference sheet 1, which is the first one in line, again, with this familiar syntax of parentheses and a number inside it. So the number here, again, is going to represent the number of the worksheet in line. So in this case, sheet 1 is sheet number 1 as well, and sheet 2 is sheet number 2, etc. But if your worksheets have names, for example, finances or revenues or expenses, this syntax is going to extract them numerically based on their position. All right, so now we have a single worksheet object, and on a worksheet object, we have a property called range. Sometimes the IntelliSense feature doesn't work as expected, but that's totally fine. We have a property called range. And with range, we can actually provide what's called an argument. And this is going to specify the specific range, which is just one or more cells that we want to target on this specific worksheet. Now, whenever we're using the syntax in these parentheses, we have to provide what's called a string, which is just a clump of characters. The way we do that is with double quotes. So whenever you're creating a string, whenever you want something to represent text, for example, a name or a month, whenever you're going to type out something that's not numeric, you need to use a string, and that's wrapped in double quotes. And what we need to put here is the actual cell reference or range reference. In this case, we only want to target one cell, and that's going to be cell A1. Now, as a side note, this notation that we're using here is actually called A1 notation. It's a little bit confusing because right now we're actually literally referencing the cell A1, but that's where the term comes from. The idea behind A1 notation simply means that we use a letter for the column and a number for the row. So we're referring to our column by letter, whether it's A or C or D or E, it doesn't matter, and we're referring to our row by its number, like 1 or 5 or 10. So whenever that kind of methodology is used, we call that A1 notation. Okay, so now we have a valid range object, and as it turns out, a range is actually going to have a ton of properties and methods available to it. You may look at a cell like A1 and say, well, it's obvious it's hello world, but of course, a cell actually has a lot more properties and characteristics than simply the value it's holding. A cell, for example, has a font, it has a font size, it has a background color, it has a font color, it has a border. All of those properties in this default example, they're not visible so much, but they all exist and they're all stored by VBA, and VBA keeps track of that stuff. So when we have the range, we actually want to specify the specific property that we want to access. In this case, if we want the actual value that that cell is storing, there's a property on a range object called value. And this long syntax is going to actually give us hello world. So now we're successfully referencing that property. And again, we're using the question mark because we're asking a question. Well, what if we actually want to actually set this value? So instead of getting a property value, we're going to set a property value. That will allow us to actually overwrite what's currently in cell A1. How can we do that? Well, the first thing we need to realize is now when we are setting a property, just like when we're invoking a method, we are now giving a command. And whenever we're giving a command, we no longer need the question mark because we're not asking a question, we're giving an order. So we can limit our syntax a little bit here. And now, instead of referencing value, what we want to do is assign it. How can we do that? By now we should know it is the equal sign, and on the right side of the equal sign, we can put our new value. Now in this case, I'm going to use a string because I want to replace hello world with this text goodbye. So I'm going to begin my double quotes, type goodbye, close my double quotes, that's very important. And when I press enter here to execute, take a look at the left side, you can see that goodbye will now be the value in cell A1. So I can sort of guess what some of you are thinking. You might be looking at this syntax and saying, wow, that's a lot to write to reference a single cell, and you'd be correct. But luckily, VBA offers us a little bit of help. It gives us some shortcuts that we can use to cut down the total amount of text and object references that we have to write. When a range object is referenced like this, with every single part being explicitly mentioned, the application, the workbook, the worksheet, that's called a fully qualified reference. And that name makes sense because every detail of it is explained, it's qualified. However, we don't have to be this explicit because VBA can make some assumptions for us. For example, if we're dealing with something like a workbooks collection object, that only exists within the confines of an Excel application. So if we leave out, for example, application right here, and in fact, what I'm going to do here is just go back to our original syntax of getting the value instead of setting it. So I'm going to remove goodbye at the end here, remove the equal sign, and also put the question mark back at the beginning. So all I've really done here is just remove application. VBA is smart enough to assume that, hey, if you're working with workbooks, you're probably working with Excel. You don't need to write that. I can figure out the application. So when we execute this, we're going to get a predictable result, goodbye. But notice that we don't have to be so explicit with all of our references. We can actually continue to whittle down this code even further. So right now we're explicitly mentioning a workbook, which can make sense in certain coding contexts. For example, we may have multiple workbooks open at a single time, and we want to clarify which one we want to, for example, perform an operation in. But in this case, what we really want to do is basically reference the one that's currently active, because that's the one that's currently open. We only have one workbook open here, and the active workbook is the one that is currently selected or activated by the user. We only have one. And so if we actually take out this syntax that we have right here of workbooks 1, I'm going to go back to the beginning of this line and remove this. What's actually going to happen is VBA is simply going to assume that you mean the active workbook. And again, the active workbook is just whichever one the user is literally clicked into. That's an assumption. That's not an assumption that you always want to make. For example, if you have this workbook open, but you want to copy a value and paste it into workbook number 2, you have to make sure that you explicitly clarify that that's workbook number 2 that you want to do some kind of operation is in, because VBA will assume that it's the active workbook. We'll assume that it's the active workbook whenever it's not explicitly clarified. In this case, since we only have one, we don't have to worry about it. So again, when I execute this, we're going to get the value goodbye. Let me provide you yet another example, but this time with worksheets. The exact same logic is going to apply when it comes to worksheets. We have this concept in VBA of the active sheet, and the active sheet is whichever one is currently selected. So right now on my Excel interface, we can see that sheet 1 is my active sheet, and right now it's sheet 2, and right now it's sheet 3. So what I can actually do here is once again remove my question mark, and let's write in a brand new value. Let's write in something like ha ha ha. And what's going to happen if I remove this worksheet reference is that VBA is going to assume that I mean the active worksheet, whichever one is currently activated. So right now when I execute this code, again removing the question mark because I'm issuing a command, our active sheet is sheet 1, so that's where the value is going to be overwritten. So when I execute this, we're going to get the value of ha ha ha. But notice what happens if I click into sheet 2, which currently has no content, and then I go back up to this line and execute. I'm also going to get ha 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 written in sheet 2. So the active sheet is being dynamically determined. Do you want that to happen? That is up to your project demands. That is up to your business needs. If you want the current operation to affect the active sheet, whichever the user is currently clicked onto, then you don't need to explicitly clarify the sheet that you're referencing. However, if you want to explicitly make sure that you're targeting sheet 1 or sheet 2 or sheet 3 or whatever, then in that case, you do have to provide your object references. It all depends on what it is exactly that you're building and what your design vision is for it. That's really all there is to cover in this lesson. To sum up the big point here, it's the idea that references should be used up to the point that they clarify what VBA should work with. If something is obvious, if we're only working with one workbook, which is obviously going to be the active workbook, then you don't really need to clarify that that's the workbook that you want to reference. You certainly can. We took a look at fully qualified references a few minutes ago, but you don't have to. You can let VBA do that assumption for you. That's really all there is to cover here. We walked through some of the parts of the Excel object model, beginning with application, moving into the workbooks collection, then into the workbook object, then the worksheets collection, then the worksheet object, then the range object and its properties and values. So we actually navigated across something like 6 or 7 objects. It's a pretty complex operation. It may look simple, but there's actually a lot going on here. And of course, you don't have to keep this all committed to memory right now. As we proceed throughout the course, we're going to explore many different parts of the Excel object model, various properties and methods available across this entire hierarchy, across this entire tree of relationships between parents and children. But go ahead and explore some of the properties and methods that are available. Try using the immediate window with the question mark to see some of the properties and methods that you can activate with IntelliSense. Just poke around here, have fun, and I'll see you in the next lesson. All right, so we've talked a lot about collection objects and the individual objects that they contain. We know that we can extract an individual object from a collection object by using its index position, which is just a numeric count of that object within the collection. As it turns out, we can also refer to an object by its name. For example, right here in the immediate window, instead of writing workbooks 1 to reference the first workbook that's open, I can actually provide as a string the name of the workbook that I want to extract out of this workbooks collection. Right now, I only have one workbook open. That's the Excel object model workbook that we see right here on the left-hand side. But regardless, no matter how many we have open, we can always just extract them with the simple syntax of the name of the workbook as a string. We do have to remember to include the actual extension of the workbook in order to make this feasible. One thing I want to do here before I continue, though, is expand this window a little bit more so we can take a look at the actual code, because it's going to be a little bit of a big piece of code. All right, so here we have our workbook selected, and now we can go ahead and reference a worksheet within that workbook. And predictably, just like with workbooks, we can extract a worksheet collection object, or a single object that is, by giving the name of the worksheet instead of its numbered position as well. So for example, if I want to reference sheet 1, which is one of our available sheets, I can write it like so. Then I can provide my range syntax. Let's just do A1. And let's give it a value. Let's write the value of hello world here. Again, that's going to be a string, so I wrap it in double quotes. When I execute this, we can see right here on my left-hand side, hello world has appeared. So everything is functional. We've referred to a workbook by name and a worksheet by name, and that's just as valid as using a numbered syntax. What's really interesting about this is that the name is actually not case sensitive. So for example, my file name is all lowercase characters, but if I accidentally typed in capital letters like Excel, and maybe put a J capital here, and maybe put a sheet 1 here, but I capitalized the 2 E's, this would still work. So let me go ahead and delete hello world right here. Let me go back to my code right here, scroll all the way to the right and execute it. Here we go. You can see the result is the exact same. So just because the casing of the characters isn't the same, VBA is still able to figure it out. Now it does have to actually be a valid name. So if you mistype the name of the workbook or the worksheet, that will cause an error. For example, if I remove this L right here and try to execute it again, in that case, we're going to get this subscript out of range error, which simply means it can't locate the workbook or worksheet that we're looking for. But as long as the name is correct, the actual letters themselves and the casing doesn't matter. Finally, the last thing I want to bring up in this lesson is that string references can actually be paired with index position references. So far, we've only used index positions or only used strings, but we can mix and match the two. For example, I can refer to this workbook by name, but this worksheet I can extract, let's say, the first worksheet with the numeric position. So I can mix and match a string right here with a number right here. We're going to get the exact same result. Let me just go ahead and delete that, execute this. There we go, same result. And I can also mix and match in the opposite direction, so I can change this workbooks to refer to the first workbook by using a number while still referencing a sheet like sheet 1. Let me just make sure I close that double quote. And when I execute this, exact same thing, hello world appears in cell A1. So we can access objects from collection by name or by index position. It really is up to user preference. Sometimes it's better to use one or the other, depending on which one is least likely to change. So if you know that people are going to be moving worksheets around a lot in terms of their order, it might be safer to refer to it by name. If you know that people are frequently going to be changing the names of the worksheets, it might be a better idea to refer to them by their actual position in line. In this lesson, I wanted to talk about default properties. So as we know, objects in Excel have properties, and those properties store that object's state. For example, in the last lesson, we talked about the range object, which represents one or more cells. And a range object includes a value property, it includes an address property, it includes a font property, and more. Now, even though a range is much more complex than just the value it's holding, we intuitively as users have this understanding that basically, the most important thing about a range is the value it's holding. We can make a cell on the Excel interface a lot prettier. We can add some kind of fancy font. We can give it a border. We can give it a highlight. But at the core crux of it, Excel is a data analysis application. So we understand that the most important thing about a cell is really the value it's holding. VBA has that same kind of mentality in the sense that for certain objects, they will have something called a default property, which means whenever we reference that object, we don't have to include that property for specific objects because VBA will automatically assume that we're referring to the default property. Let me give you a couple examples, and this will make things clearer. So here in the immediate window, I want to show you the code we relied on in the last lesson. If I want to find out the value in cell A1, I can just enter range A1 and value, and we're going to get hello world. As it turns out, value is the default property on the range object, which means it's automatically assumed by VBA. It's just so common, it's just so likely that that's the property that you want to reference on that object that VBA takes it for granted that if you're referring to a range, you probably want to find out its value property. So if I execute the exact same code, but I leave out the value property, Excel will access the default property on the range object, which is value, and it's going to give us the exact same result. Let me give you another example. We talked about the application object, which sits at the very top of the Excel object model. If I enter application here, we know that application has a name property, which we can manually enter here and execute. Well, as it turns out, name is the default property on the application object. That sort of makes sense because an application can do a lot of things in Excel. We can use application to perhaps save or do some kind of process, but the most important detail about an application, the most important property available on it is its name, because that identifies it for what it is. So as it turns out, because name is the default property on an application object, we can just enter application and get the exact same result. The reason I wanted to introduce this concept of default properties is because you might find it in other people's VBA code. With that said, I personally don't like the concept of default properties. I don't like the syntax because it relies a lot more on implicit assumptions. A person has to be a bit more familiar with the concept of the Excel object model and the concept of default properties to know that when they type range A1, they're specifically going to be referring to the value property of range A1. So throughout this course, I'm not going to be relying on default properties at all. We're going to be explicitly writing out every single property that we reference. If we want to change the value in a range, we're going to be writing .value equals rather than just the range, all right? I think this will help us reinforce the concepts of the Excel object model, and I think over the long term, explicit is generally preferred over implicit. Whenever you write things out, it makes your code clearer and a lot more understandable to other users. With that said, I wanted to make sure you understood these concepts of default properties because you may find them in other people's code. In this lesson, I want to dive into the name property, which is actually available on both worksheet and workbook objects. There's two key takeaways in this lesson. The first is that properties can be both readable and writable. We saw an example of this earlier with the value property on a range object. And the second lesson to take away here is that permissions can actually vary from object to object. So a property on one object may only be readable, and on another one, it may only be writable, and on another one, it may be both, etc. So let's take a look at the name property on a singular workbook object first. In my immediate window here, I can go ahead and refer to my workbook by referencing the workbooks collection object and just getting the index position of 1. That's the very first workbook I have open. That gives me a workbook object, which has a name property. I can execute that. And we can see the name of this document, this file, is the name property.xlsm. I can also reference this workbook, by the way, by actually giving the string argument to the workbooks collection object. So I can actually reference the name property.xlsm. So referencing the workbook not by its numeric position, not by its order, but by its actual name. And predictably, that's the exact same workbook. So I'm going to get the exact same output. I can perform the exact same logic if I want to reference the name property on a worksheet object. So it's going to be the same property name, but it's a totally different object. So I have 3 worksheets in this currently open workbook, sheet 1, sheet 2, sheet 3. If I want to reference, let's say, the second one, I can do the worksheets object, give it an index position in parentheses. That's going to give me a singular worksheet object that has a name property. It's going to be sheet 2. I can similarly reference a sheet by using its name instead of its position. So I can reference something like sheet 3. Close my double quotes there. That's going to give me a worksheet object that has a name property. And that name, of course, is sheet 3. Hopefully all of this makes sense, but here's where it actually gets interesting. As it turns out, the name property on a workbook object and a worksheet object operates a little bit differently. On a worksheet, the name property can actually be overwritten with a brand new value. So we can use VBA to change a worksheet name. For example, let's say I want to change the name of sheet 1 to January. I can reference sheet 1. I can do worksheets, reference number 1, reference name, the name property, and this time I'm going to give it an equal sign because I don't want to get the value, I want to set the value, and I'll set it to a string of January. This time around, when I'm using the immediate window, I do not need a question mark because I'm not asking a question. I'm actually executing a command. So we can keep our eyes right here on the bottom left. Keep an eye on this on sheet 1. When I execute this, it's going to change to January exactly. And we can also just verify this by going to our immediate window and outputting the value of that name property again. So right now it's January. So that's worked exactly as expected. The name property on a worksheet object is both readable and writable. However, on a workbook object, it is only readable. So if I try to change the name of this workbook, if I, let's say, want to change the name of this workbook to monthly results, I'm going to extract it with my index position of 1, get the name property, try to use the familiar equal sign syntax, but unfortunately, we're going to be met with an error here, a compile error. It reads exactly as we expected. We cannot assign to a read-only property. That's all there is to cover in this lesson. I just wanted to point out that certain properties can be shared among different objects, but the difference is that on some objects, they may be readable, on other objects, writable, on other objects, a combination of both. So just because 2 objects will have the same property does not mean it's going to be exactly the same. You always have to do your research by diving into the documentation to seeing exactly how these properties work and what the functionalities are that are available to us when we're working with a specific object. That's all there is to cover here, and I'll see you in the next lesson. In this lesson, we'll take a look at some of the ways that we can configure how the Visual Basic Editor works. So on my Developer tab, I'm going to click my Visual Basic icon to launch us into the VBE. And up here on the top menu, there is a Tools dropdown that offers an Options setting. So let's click into that. And that's going to bring up a new dialog box, a pop-up box called Options. We can see here it has 4 tabs: Editor, Editor Format, General, and Docking. And in this lesson, we're going to go through all of these settings that are available here. Some of these may be a little bit advanced. You may not know everything that's going on, but I do want to offer this introduction at the very beginning, just so that we have a general sense of some of the things that we can configure. Of course, you can always come back to this lesson later in the course to get a good review of some of the options available here. And what I'm also going to offer you is a bunch of recommended settings, especially for beginners, that should ensure that you have as smooth a process as possible whenever you're actually going to be writing VBA code. Let's begin here on the Editor tab in this Code Settings panel. We have our first option here, Auto Syntax Check. If enabled, this means that VBE will display a dialog box or a pop-up box whenever it runs into a syntax error in your code. Now, you may think of this as a good thing, but it actually tends to get pretty annoying. Sometimes this thing creates a lot of false positives. So you may be writing a certain line of code and you may intentionally do something like a line break, which VBE might interpret as a mistake. And as soon as you do that, it's going to launch this pop-up box that takes you completely out of your flow. It prevents you from typing. It prevents you from doing any kind of action until you confirm that you're aware that there is an error. So it actually is pretty annoying and pretty restricting. So most developers prefer to have this option off. Now, the good news is even if this option is off, VBE will still show you syntax errors in your code. It's just going to highlight them in a different color in the actual code itself. It's just not going to show you the annoying pop-up box. So I recommend disabling this option for now. The next option below is require variable declaration. If this is enabled, VBA will insert a bunch of keywords at the top of each new module of code that you create, and those keywords will be option explicit. What that means is that all variables have to be declared within the scope of the module. Now, we don't know exactly what variables are at this point, but they are essentially placeholders or names that we're going to use for pieces of data. So whenever we're going to be referring to, let's say, a specific worksheet and a specific range, we might be assigning that data object a given name so that it's very easy for us to refer to it later on in the code. And that name is called a variable. And what this option does is ensures that all variables have to be declared, which means we have to tell VBA whenever we're going to use a variable exactly what kind of data type it's going to be, the fact that it's going to exist throughout the program, things like that. This is one of those things that will make you a better developer and that will ensure that the code is less likely to run into errors. I know it's a lot to take in right now, but I recommend keeping this option checked as a beginner. It means it's going to be a little bit more strict when it comes to evaluating your code. You're going to not be able to get away with certain things, but that's a good thing because when we're starting out, we want to be more strict. We want to be more likely to actually encounter errors so that we can go ahead and fix those early inefficiencies and become better developers over time. The three options below, auto list members, auto quick info, and auto data tips, are all pretty standard helpers. I recommend keeping them checked throughout your entire VBA programming career. Auto list members will display a list of options to help complete whatever it is that you're typing. That's the feature that we call IntelliSense, where when we're writing out, for example, a worksheet object, we're going to see a list of all of the properties and methods that are available there. We can tab into them. There's really no reason to disable this. It's just helpful for you to know everything that's available for you whenever you're doing some kind of object reference. Similarly, whenever you enable auto quick info, VBA will show you information about functions and their arguments as you type. This is another helpful feature, much like on the actual main Excel interface. When you sometimes type something like sum, it's going to show you here are the arguments, here are the inputs that you can give to the function, perhaps a description of what the function is actually going to give back to you or return to you. There's no real reason to disable it. It's really helpful for us to have a reminder of what we're actually doing whenever we code. So I recommend checking this as well. And finally, auto data tips. This means that whenever we declare variables in our code, which again are just placeholders for pieces of data, whenever we hover our mouse over those variables, we can actually get the value that's being stored in the variable. So again, a little helpful thing for us as developers to get a quick reminder of some of the data and how it's being stored. Again, keep all these options enabled. There's really no reason to experiment here. If you want to make the process a little bit harder for yourself, because you want to, let's say, remember things from memory and make sure that you're remembering them correctly, you can disable these options, but there's really no reason to. If you can help the computer help you become a better developer and help you complete code more efficiently, I think that's a good thing no matter where you are in your stage as a developer. To the right here, we have this auto indent option. I recommend keeping that checked as well. If this is enabled, VBE will indent every line of code the same as the previous line. So many times when we're going to be writing procedures, we're going to indent the entire body of the procedure in equal amount. This is not technically required, but it's a good visual indicator that all of the code is clumped together, that it represents a group, that what it accomplishes is kind of related to each other. So it's a good visual thing to do, and VBE will automatically do it for you whenever you have this option enabled. The tab width, predictably, is how many spaces a tab is going to represent, which is just setting the standard for how much something will be indented, for example, within a procedure. So all lines within a procedure will be equal to 1 tab length, which is equivalent to 4 spaces. That's what we're setting here. Down here below, we have the window settings options. This first one, drag and drop text editing, allows you to actually drag and drop text with your mouse. I don't tend to use this feature. I just use, copy and paste, but there's really no reason to disable it. It's an extra functionality if you need it. Finally, here we have default to full module view and procedure separator. This first one, default to full module view, will make sure that your procedures appear as a single scrollable list whenever you open up a module. If you keep this option disabled, you'll have to kind of navigate through each procedure one by one. I prefer to have everything kind of written out, sort of like one Word document where you scroll down and you see the next bit of text. In this case, you'll scroll down and you see the next procedure. I think that's a better way to organize your code. It resembles more of what real life code bases look like. So I think this is a good option to keep enabled as well. Everything in one big scrollable list of code. This final option, procedure separator, will create a horizontal line between any two procedures. It's a separator line. That's why it's called the procedure separator. And this is, again, just a visual indicator that two procedures are separate. You can, of course, read them and figure that out yourself, but it's much nicer when we have this helper feature that's kind of giving us a visual hint of what's going on. It'll make you much quicker in detecting where one procedure starts and where it ends and where the next one starts. So again, keep this option enabled, really no reason to disable it as well. Our next pane here in the options box is editor format. This relates to how your editor looks, so the aesthetics of your code. So I'm not going to dive too much into this because this is a matter of personal preference. In fact, I recommend if you're going to proceed throughout the course, I recommend sticking with the basic defaults. That way your code will look more similar to mine than if you start customizing it. Again, the most important part when it comes to programming is syntax, which means writing the right code, not exactly how it looks. But if you want to have, let's say, a custom font or a custom font size, you can even set different parts of code. So the actual code itself, how an error code will look. For example, this is syntax error text, and we're going to have it in red. You can customize all these options. It's totally up to you. Depends on whether you want to express yourself when you write code. But I'm not going to mandate anything. I'm just going to stick with the default settings. The only difference with me is I'm going to blow up my size a little bit here. I'm going to use 23 or 24. This is just to ensure that the videos are able to capture the font and it looks a little bit bigger and is easier for you to see, but you don't have to keep your code so big. You can keep your code at a standard default size font, maybe 12 or 14, whatever is comfortable for your eyesight. The one thing I do recommend is if you're going to be switching your font around from the default of Courier New, I recommend doing a monospace font. A monospace font is one in which every single character or every single letter has an equal width. So no matter whether you type an A or an R or a Z, they all have an equal width. And that is a good thing in programming because it means that your code is much more likely to line up. Whenever you look at multiple lines of code above or below each other, the letters in them will line up, which is a good thing when it comes to code. It's not always a good thing when you want to be stylish and have kind of a pretty presentation, but in this case it is. So whenever you're picking a new font, I recommend Googling, is this font monospace, and making sure that it is. Some fonts are not, and it's gonna break up your code a little bit and make it a bit more difficult to read. So make sure your font is monospace if you're doing something different. Otherwise, just stick with Courier New and you're not gonna have any problems with this standard option. Also, this margin indicator bar option should be checked. This will just create a margin bar to the left of your code. We're going to be using that for things like debugging our code, breaking it at certain points of execution. Keep this checked. There's really no reason to disable it. Let's move on now to the general tab, the third tab in our options pane. You can keep most of these options standard or default. This form grid settings pane to the left deals with user forms, which again are those custom forms that we can create to gather user information. They include things like buttons and checkboxes and input fields so that we can process data, but give the user a much more compelling form instead of having them fill out the spreadsheet. So we can keep all this stuff here, keep all this stuff here as well. That just relates to tooltips that help you figure out various things in the interface. The only important thing here that we should change is, if it's not already changed, is under error trapping, make sure you have the break on unhandled errors option selected. This means, just as the name says, that whenever you run into an error that is unhandled, which means you haven't prepared for it, you haven't warned VBA to expect it, if you run into an error, it will automatically break execution at that point, which is a good thing because we want to write code that is stable and secure. So we do want it to break on errors so that we can detect those mistakes and bugs, fix them, and then ensure that we don't run into them again. Otherwise, there may be options here like break on all errors, which means it's going to break on errors, even including those that we've accounted for. which is really not helpful. We only want to break on that which we haven't prepared for so we can have a heads up, we can be alerted to them and fix that stuff. Let's move on now to the final pane here, which is docking. On this pane, we can keep all of the standard settings as well. Whenever a window is dockable, it means that it's attachable to some part of the VBE window. So for example, we have our immediate window, which is available right here below. We have the properties window, which is this thing on the bottom left. And we have the Project Explorer, which is this thing on the top left. We can essentially click and drag these to various parts of the screen, and they're going to attach themselves automatically and contort their shape to fit themselves, maybe as an entire vertical column or as an entire horizontal column. In this case, you can see that both the Project Explorer and the Properties window are kind of nestled underneath each other, and they both occupy half of the vertical pane. It's just going to make your code a lot easier, rather your sections of code, your sections of the VB editor, easier to kind of behave like puzzle pieces and add them onto each other in different sections of the screen. So you can keep all these default settings. The only one that is disabled is the object browser, which we'll dive into later. The object browser is a documentation feature that allows you to look up things like objects and methods and the general structure of the Excel object model. This thing is typically going to open up right where this gray space is, and it's going to occupy the entire screen, the exact same way as our code editor does. So because it occupies this entire screen, we don't really need it to be dockable. We don't really need it to be able to be transported to any part of the screen and kind of latch on. So for the most part, these standard options are pretty good. We can keep them, and that's really all there is to cover here on the docking tab. And that's all of the basic options available for us in the Visual Basic Editor. Again, feel free to come back to this lesson to review some of these concepts. Feel free to Google some of these concepts in more detail if you're interested in how you can configure a Visual Basic Editor to work more on how you like to code. Again, maybe perhaps you want different aesthetics, maybe you want different help features. For the most part, the way that we've enabled this stuff is to ensure that you have as easy a time coding as possible and that we don't disrupt you in the middle of coding. We just offer you helpful hints. So this is a good place to get started for a beginning VBA developer. And most of these options you'll find that you're going to stick with even as you grow your proficiency. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the basic syntax for creating a new procedure in our Visual Basic Editor. As we know, a procedure is just a collection of one or more VBA statements that accomplishes some kind of task or goal. A procedure from top to bottom does something for us. A procedure is also known as a subprocedure or a routine or a subroutine or a macro or a program. There's many different terms that we can use, but for the most part, it's just some kind of thing that we're doing, a collection of related code, a snippet or grouped collection of code. A procedure is going to be executed from top to bottom, line by line. So we write our VBA code in the exact same order that we want the program to execute it. Procedures are going to be organized within files that we call VBA modules. We can go ahead and create one here right now in this brand new workbook in my Visual Basic Editor. On the left side here, I'm going to right click on Microsoft Excel Objects, hover over Insert and choose Module, and a new module will be inserted here, right here to the left. It's going to be called Module 1, and all modules will follow this numeric naming scheme. So if we were to add another module, it would be Module 2, Module 3, and so on. The number is just going to increment by 1 each time. And over here to the right in our code editor, we have this module and its code listed. Right now we have no code. You'll notice here at the very top, we have option explicit written. That's because we enabled this option back in our settings in the previous lesson. This ensures that our variables have to be declared. We're going to dive into what that means a little bit shortly, but you can think of this as just a way to ensure that our code is less prone to errors. To change a module name, we have to head to the properties window on the bottom left here of the VBE. Right here, we have this name property and it's set to module 1. We can change this to something different. Let's change this to something like my first module. And ideally, modules should store procedures that are related to each other. So whenever you have a workbook with multiple modules, you can store related functionalities, related procedures in each one of the modules. So maybe one of the modules is going to deal with aesthetics like fonts. Another one of the modules may deal with things like copy and paste operations. Another module may deal with creating tables and charts. It really depends on how you want to structure the workbook and how you want to structure your code. But ideally, each module should have procedures that are all related to each other. And if you want to insert a new module, you just once again go to modules, insert, create a brand new module, give it a name that describes what it contains, and just write all of your procedures within there. So let's go ahead and write a procedure within our code editor right here. Now, we're not actually going to be doing anything within the procedure. I want to dive into the syntax for creating a procedure from scratch because it can be pretty complex. There are a couple things that we have to remember, so I want to make sure we set our foundations here correctly. So all procedures begin with a built-in keyword in VBA called sub. So we're going to write the sub keyword. Sub is short for subroutine, which is an old technical programming term for a procedure. So anytime you're going to be writing a procedure, it has to start with this sub keyword. A subroutine in computer science terms is just a sequence of program instructions. And that's exactly what we're doing here. We're writing a set of commands that VBA and Excel will execute for us. Immediately after the sub keyword, we write the name of the subroutine followed by a pair of parentheses. That means an opening parentheses and a closing parentheses. Let's say I want to call this procedure my first procedure. So I'm going to do my first procedure and follow it up with a pair of parentheses. Notice that here I have multiple words in my procedure name. So the way I distinguish between them is to capitalize the first letter of each. The reason I do that is because subroutine names cannot contain spaces. So there's no way that we can do something like this. VBA is going to give us an error. So we want to make sure there are no spaces. And how can we differentiate between different words? We use capital letters. We call this type of syntax upper camel case. So you can look up that in more detail if you're interested. But it essentially means the first letter of each word is going to be capitalized. A couple other bonus quirks about procedure names. It's recommended to keep your first letter capitalized. If you don't, VBA will automatically capitalize it for you. You also can't use reserved VBA keyword. So by a reserved keyword, I mean a word that's already part of the VBA language. So for example, a word like sub or option or explicit. You can't just write sub or sub option. Don't use any words that are part of VBA because it's going to run into an error. You'll also notice that when I clicked around here, VBA automatically did some stuff for us. So I'm just going to remove it. It's actually trying to help us write better code, but we're going to remove this right here so we can write it from scratch. So after we're done executing this, as soon as we press enter, you'll see that VBA is going to do what it just did. It's going to add this end sub keyword. And what that means is that's the end of the procedure. So anything within this, what we call the body, anything between the beginning of the procedure, which starts with the sub keyword, and the end of the procedure, which is the end sub keywords, everything in between is going to be the actual code that's going to be executed whenever the procedure runs. So let's just write this from scratch so that we can make sure that we type it correctly. It's going to be the end keyword, and it's going to have a capital E followed by the sub keyword, and the S in sub is also going to be capitalized. So again, whenever you type your parentheses, Visual Basic will automatically add this end sub for you, but in case it forgets or in case it makes a mistake, it's a good idea to practice this entire syntax from top to bottom to make sure that you know you kind of commit it to memory. Believe it or not, this is a valid procedure. Now, it doesn't actually do anything because we don't have any code in here, but it doesn't really have to do anything. We can still run this procedure. We can still run this code and it's going to do nothing. You can sort of think of it like an empty text file. An empty text file doesn't have any content within it, but it's still a valid text file, right? It still has the right extension. It's sort of the same idea here. This is a valid procedure because we used the proper syntax. It's just a procedure that does nothing. So we can go ahead and try to execute this procedure. I can just hover my mouse in here, click into the body of the procedure, the white space between the sub and the end sub. And right here on the top menu bar, I can click the play button, the green play button. And you can see I'm clicking it, nothing is happening, but nothing should be happening because we haven't actually done anything. But we're also not running into any errors, which is the important thing, which means that VBA is telling us there's nothing syntactically wrong with your code. This is a valid setup for a procedure. So this is perfectly correct. That's almost all there is to cover in this lesson. I didn't want to burden you with too much because this is actually quite a lot of information to take in. The syntax can be a little bit confusing, especially when you have to remember things like camel case, spacing, the sub keyword, the end sub keyword, the parentheses, which we also don't know what that does yet, but we'll dive into that a little bit later. But this is the syntax that you'll be using for every procedure you're ever going to write in VBA code. So I do recommend writing a couple of these procedures from scratch, especially just removing your code, deleting it, and just typing it from memory, because you'll be surprised how many times it takes for you to actually memorize this stuff. Predictably, it may seem kind of obvious, but if you ever want to delete a procedure, all you have to do is just highlight all of the code that includes it and just press delete. Removing it from the text of the module removes it from the front end as well, so you won't be able to actually access this macro from the macros dialog box in the Excel interface. If you just want to bring it back, you can just bring it back. Just be very careful, because if you accidentally delete something like the sub part of it, but you forget the end sub, or vice versa, you're going to run into errors whenever you're trying to run another valid procedure. So just make sure you delete the entire procedure as a whole. If you want to delete an entire module of code, which you may want to do if it becomes outdated, for example, you can right-click on the name of the module here in the Project Explorer, select Remove. It's going to have the module name, Remove My First Module. It's going to offer to save some of the module code if you want to store it elsewhere. So it says, do you want to export My First Module before you remove it? We're rarely going to do this, so we can just click no, and then the module is permanently deleted from the workbook, and it's no longer storing any of our code. So instead of manually going through and deleting all of the procedures, you can just delete the entire module that's holding those procedures. That's all there is to cover here. Make sure to practice that procedure syntax, and then we're actually going to go ahead and start writing some actual valid VBA code in the procedure body over the course of the next few lessons. A few lessons ago, we briefly discussed the immediate window, which is located at the bottom of our VBE. The immediate window is a really helpful tool whenever we want to test, for example, a single line of VBA code without actually packaging it within a procedure. The immediate window is sort of like a console. It's a playground. It's a place to make experiments with code, because the process of creating a brand new module and writing a procedure is kind of time consuming. There's a lot of clicks involved. And if we only want to test that one line of code works as expected, we really don't need to go through that hassle. We can just use the immediate window as a little bit of a playground to try out something. So it's not intended for large scale procedures. It's really intended for 1 or 2 lines of code at a time, just to make sure that everything is functioning as expected. If the immediate window is missing from your Visual Basic Editor interface, for example, if it looks something like this, there's 2 ways we can bring it up. The first is using the keyboard shortcut Control+G. That will bring up the immediate window. I'm also going to click out of it and show you the other way to access it. That's going to be under the View menu at the very top. View, here we have immediate window listed alongside its keyboard shortcut. That's going to bring up the immediate window at the very bottom. Again, all of these tools, all of these aspects of the Visual Basic Editor are dockable. We made that happen in our settings configuration lesson. So we can actually move this around and place it on the left or on the right. But this is the traditional setup where we're going to have the immediate window at the bottom, and then the properties window at the bottom left, and the Project Explorer at the top left. In the immediate window, we can write completely valid VBA code. So we can access properties in here, we can execute methods, we can ask VBA to perform basic mathematical calculations. Everything is valid here. Just remember to keep it concise, one line of code at a time. So for example, let's say we want to try a basic mathematical expression. In that case, whenever we're asking VBA to answer some kind of question for us, whenever it needs to evaluate some kind of expression, we need to begin with a question mark. You can think of a question mark just like asking a real life question. If this is something that you might go over to your coworker and ask, then it requires a question mark in the immediate window. So for example, if I want to know the answer to 2 + 2, because I'm asking a question, I do need to prefix that expression with the question mark. When I execute this, I'm going to get the correct answer, which is 4. So whenever we're getting something like a property value, we are getting something, which means we're asking a question as well. So in those situations, we also have to include the question mark. For example, let's say I put a value here in cell A1. I'm just going to put my name, Boris. Let's say I want to find out the value that's currently in cell A1 from the immediate window. I once again have to begin with a question mark. I'm asking a question. I'm not performing some kind of process or action or method. I'm just inquiring about the state of something. So I can put my syntax here of accessing a range. Here in a string, I put the range or the cell that I want to access. That's cell A1. We know that a range object has a value property. If we're not setting it, we're getting it. So now when I execute this, we can see It's giving back to us the value that's written on the spreadsheet, which is Boris. If we're going to set the value of a property of an object or invoke a method, anytime that we're doing something that represents an action that we take, in that case, we do not need to use the question mark because we're not asking a question. We're telling VBA to do something. So setting a value on a property does not require the question mark. So if I wanted to set range A1 to have a different value, I can do range A1 value. Again, completely valid VBA code. This would work just fine in a procedure, but if we want to do something very simple like this, we can just use the immediate window. Let's say I want to set it equal to hello. Write this, execute this. We can see on the left side that hello has now occupied cell A1. And you can see we've used the immediate window to execute a valid line of VBA code. The important part here, if this isn't obvious, is that all of this is temporary. The immediate window is not preserved when we close the workbook. So this is just to execute a one-line piece of code. If we want to preserve an operation so that we can run it again and again, we do need to write it within a procedure. I also want to point out that there is an alternative way that you can use the question mark here in the immediate window. I'm just going to erase my work right here. Instead of using the question mark, you can use a keyword called print. And print is the exact same thing as a question mark. So if I did something like print 2 plus 3, we're going to get the exact same result. Most people prefer to use the question mark because it's a little bit lighter and shorter. It's only one character, but print does the exact same thing. We can also print to the immediate window from an actual procedure body. This is really helpful when we want to keep track of something as it's going on in our procedure. As we're executing, we may want to find out what the current value is that's being stored, let's say, in a variable, which we'll talk about in a few lessons. Sometimes we want to keep track of data that is changing throughout the process of our procedure execution. So we can actually log things to the immediate window from a procedure body. Let's go ahead and create a brand new module to store our procedure. So insert a new module. The default module name of module 1 is fine for now. And I'm going to create a procedure here, again with a sub keyword, print stuff to console. Once again, we have to add on that pair of parentheses at the end. The Visual Basic Editor will automatically add end sub for us, but you do have to remember those keywords in case it doesn't. And right here, in order to actually print something to the immediate window, we have to do this, debug.print. Debug is actually an object that's available within VBA, and print is a method on that object. Just like we have valid objects like worksheet and workbook, we have a debug object. It has two methods on it. The one that we want to focus on right now is print. And in order to actually print something, we just write it to the right of that method invocation. So for example, if I want to find out what 1 plus 1 is, I'm just going to remove this code right now. Now this is our first experience actually executing a procedure with custom code within it. When I execute this, there's nothing that's going to happen on the Excel interface, but we are going to take the evaluation of this expression, which is going to be 2, and with debug.print, we're going to print it to the immediate window. So let's execute this right here by clicking the green play or run button, and there we can see 2 is output. This is really helpful when you want to, for example, do something on the spreadsheet and then also keep track of something as a developer here in the Visual Basic Editor. We can sort of keep track of those variables in the immediate window to see how they evolve over the course of a procedure. For example, what we can do here is change the value within our range of A1. So for example, what I can do is output the current value of range A1. So I'm just going to do range A1.value. So I'm going to get the value at the very start of the procedure and output it to the immediate window. Below that, I'm going to actually change the value. Let's change it now to goodbye, another string. And after that, let's go ahead and debug print the value in range A1 again, so we can sort of confirm that it's changed from our code. In fact, let me buy a little bit of real estate here so you can actually see this code a little bit clearer. There we go. I'm also going to remove all the code from the immediate window so we don't get confused. So once again, let's just go through this line by line. We've created a new procedure with a sub keyword. It's called print stuff to console. It actually does a little bit more than that, but that's fine. We begin by getting the current value in range A1. This is just getting the value property of that object. Pretty familiar syntax, but we cannot use the question mark within a procedure. We can only use that in our immediate window. So in order to actually log this to the immediate window, we use debug.print. After that, we're going to write a value to cell A1, a brand new value of goodbye. Once that's written, we're going to once again use debug print to log something out to the immediate window, and it's going to be the new value that's stored in range A1. So let's see what happens. We begin here with hello. When we click run here, Perfect. We have goodbye right here on the left side. That's actually the second step of our procedure. But right here, hello is printing. That's this line right here. Then we're changing the content on our spreadsheet. And finally, this goodbye that we see at the bottom is this debug print invocation right here. That's all there is to cover in this lesson. We talked about the question mark. We talked about the immediate window, which is a playground of sorts where we can execute one-liners of code. And we also talked about debug print within a procedure body, which allows us to log stuff out to that immediate window, to that console within a procedure. In this lesson, we'll take a look at the message box method, which is used to display a pop-up box with a message in the Excel interface. This is really helpful for a couple of reasons. The first one is that we can use it very similarly to debug.print to see the value of something like a variable over the course of our procedure execution. The other cool thing is that we can actually use it to alert the user of some kind of message. Debug print is only available to us in the immediate window as a VBA developer in our actual editor. But with the message box, we can give the user a message that they can see in the Excel interface itself. Let's begin this lesson by practicing message box a couple of times in our immediate window, and then we'll write the exact same code within an actual procedure body. So right here in the immediate window, I'm going to type the word message box. It's a little bit abbreviated. It's actually going to be capital M, S, G, capital B, O, X, message box. And as soon as I click space here, we're going to see a little box pop up, a yellow box that's going to offer us a little bit of help in completing the method definition. So let's go into this in a bit more detail. Here we see the yellow box. This is our first introduction to the concept of parameters and arguments to methods. So methods, much like Excel functions in our Excel program, can take inputs. An input helps modify how the function or method is going to perform. For example, in Excel, we have a basic function like sum, but sum by itself can't do anything. It needs to know the values that it's actually going to add together. Well, this is very similar here in VBA. Visual Basic includes this thing called the message box, which is used to output text in a box to the user. But it has no clue what we actually want to output, the actual content of the text itself. We have to tell that method what to do in that sense. The way we do it is by giving the method inputs. Now those inputs, we use the terms parameter and argument interchangeably most of the time, but there is a difference between them. Right here, we see in this yellow box the name of all of the parameters that the message box method expects. Some of them are optional and some of them are mandatory. They're listed here in the order they have to be given to the method. So you can see here the very first parameter or the very first name that we've given to an expected input is prompt. And prompt represents the actual text or expression that we want to evaluate and output with the message box. So when I type something in here, let's say I'm just going to output the message hello. Notice that it's a string, so I have to wrap it in double quotes. Hello, or the input that we want to provide to the prompt parameter, is what we call the argument. So the parameter is the name of the input, and the argument is the actual value that we give whenever we invoke the method. So prompt, again, is the parameter, and hello in this case is the argument that we provide for the prompt parameter. And another word for any of these two words, again, is input. Hello is an input that we're giving to the built-in message box method so that it knows what to output. In this case, the other things that we see right here are all optional. They don't need to be included. So when we execute this code, this should work just fine. When I press enter right here, we're going to see this box pop up. I have it appear a little bit in the middle because I'm splitting my view between Excel and the Visual Basic Editor. But if the regular user has just Excel open, this box will appear right in the center of their Excel interface. We can see hello is listed here, the exact same message we typed out here, minus, of course, the double quotes. And we have this OK button. Once they click that, then it goes back to the same old, same old. Now, keep in mind, if we use the message box within the body of a procedure, it's going to temporarily halt or pause the remainder of the procedure. So the procedure is kind of going to wait until the user confirms with the OK button, and then it's going to continue executing the remaining code that's still left in the procedure. So the message box does pause, which kind of acts as a little bit of a deterrent to continue processing things. So it's not something that you want to use over and over and over again. But if you want the user to do something like click OK to make sure they're aware that something is going on, it can be a pretty particular tool that you can use to sort of give the user some awareness about what's going on. Let's go ahead and use message box a couple more times. So I'm going to remove all my code right here. Let's take a look as well at the yellow helper box that's appearing when we start typing. So message box, and there we go, it pops up again. So we can see here the names of all of our parameters. They're separated by a comma, and the one that's currently being entered, the one that's active, the one that we're providing a value for, is going to be highlighted in a slightly more bold, blacker font. So we can see here prompt is highlighted, which means that's the input or parameter that VBA is expecting us to provide an argument for now. So if we do something like goodbye this time, and we put a comma, just like we see here in the yellow pop-up box, the bold highlighted section will change because now VBA is expecting an input or argument to that second parameter, to that second input. Let me just erase this comma because we don't need it. Now we go back to prompt. So reading here from left to right, we can see our parameters are prompt, buttons, then we move on to title, help file, context, and then finally that as is not actually a parameter, it's just describing what is going to be the return value of this method, which we don't have to worry about for now. A couple things that I want to point out here. Notice that buttons, title, help file, and context are surrounded in square brackets. Those square brackets are a visual indicator that that parameter or argument is optional. It's not needed. You can provide it to help modify how the method is going to work, but it's not required for the method to function. In comparison, prompt does not include a pair of square brackets, which means it's mandatory. You have to put it in there or it's not going to work. Of course, that makes sense because how can you output some kind of text in a message box if you don't tell message box what that text is going to be? So prompt is the only required argument here. Let's go ahead and give this a shot. Once again, I'm going to press enter, execute this. There is our message box. It pops up. Notice it says Microsoft Excel at the top. That's just the standard title. Here is our message goodbye. And here we have the OK button. Click OK, back to normal. I want to take a little bit of time here to introduce you to a special symbol that we can use when working with strings, and it's called the concatenation symbol, and it's actually the ampersand sign, which you can access by pressing Shift-7 on your keyboard. So what the ampersand symbol does is it concatenates or combines two strings together. So for example, if I want to output a string that's going to be, let's say, my first name and my last name, I can do my first name, and then I'm going to do a space just to make sure that there's a space after my name. Then I'm going to put an ampersand, that's this symbol, again, Shift-7. And right here in another string, I'm going to do my last name. So what this is going to do is it's going to combine this string on the left before the ampersand symbol with the string on the right, my first name, a space, combined with my last name, put them all together as a common string, evaluate that expression, and that's what we're going to see in our message box. So when I execute this, there we go, the full name appears. Let's go ahead and click out of this box. Now you may be wondering, of course, what's the purpose of this? I could have just entered this as a single string, and you're absolutely correct. But sometimes we need to combine something like a user input with our own custom string. And with the user input, we're not going to know exactly what that's going to be. So we may need to use a symbol like this in order to combine things like that. Whenever one string is unexpected and the other one is actually predetermined, a symbol like the concatenation operator will come in handy. Let's go ahead and use message box now in the actual body of a VBA procedure. I'm going to remove this code in our immediate window. Once again, we have to create a module to store our procedure. Right-click on Microsoft Excel Objects, insert a module. We can leave the default name of module 1 for now. And let's just create a method here. I'm just going to say show boxes, give it a name of that. Parentheses, VBA is going to fill in the N sub at the end. And let's tab in a little bit here just so we have our body indented. That's a good practice, just so we have a visual indicator that this is the heart or content of our procedure. And let's do message box a couple times in order, actually, so we can see all of these boxes appear in sequence. So once again, message box. When we press space, we're once again going to see that yellow prompt. By the way, should have mentioned this earlier, but the yellow box here is popping up because of an option that we enabled in our Excel options a little bit earlier, a couple lessons ago. If you followed all of the configuration instructions there, you should be seeing this. If not, you should go back to that video. It's in the very first pane within our Excel options box that we enabled this feature, which can be really helpful to us as a developer because we have a good reminder of what parameters the method is expecting. So let's do a couple things here. Let's output a message box with a string of hello there. So far, we've been sticking with strings, but we can do basically any kind of data type. So let's output a number here. Let's just output the number 2. Right below, let's once again do message box, MSG BOX. This time, let's do a calculation of numbers. So let's do 3 plus 5. This is very similar to what we just did in the immediate window with the concatenation operator. VBA will first evaluate the expression. In the previous example, it's going to evaluate the concatenation of strings. In this case, it's going to evaluate the numeric arithmetic calculation. Once it's done with that, that's what it's actually going to output. So the message box here will have the value 8. And finally, let's go ahead and put a value here in range A1, just to show you that we can use the message box to output a range value. Let's say I'm going to put a string in here. Let's just call it fun. And right here in my Visual Basic Editor message box. And how do we reference range A1? We use the range keyword, open up our parentheses, reference the actual cell or range that we want to access, and then access the property value on the range object. And that's going to access the value fun and output it in a message box. So let's go ahead and click in here. We're going to execute this procedure. We're going to see 4 total message boxes appear. Number 1, hello there. Number 2, perfect naming. Let's click OK here. Message box 8, that's the sum of 3 and 5. And finally, a message box with the value fun, which is exactly what we see in cell A1. I want to conclude this lesson by tying a lot of these concepts together. I mentioned at the beginning that message box is a method. But a method on what? We know that methods exist on actual objects, but we don't have any actual object listed here. As it turns out, message box is actually a method on an object called VBA. It's a little bit confusing, I know, because VBA is also the name of the programming language that we're actually learning here. But within the context of our Visual Basic Editor, we have an object also called VBA, just like we saw an object called debug a lesson or two ago, just like we have an object called worksheet and workbook. We have an actual object called VBA, and the message box method is a method that is attached to that VBA object. So what I can go ahead and do here is just write VBA dot message box. And I'm going to do that for all of these, just so you see that it's going to do the exact same thing when we execute. So as you might guess, the reason we don't explicitly need to write VBA in front of message box is because Excel and VBA is smart enough to figure out that that's what you mean. It knows what message box is. The exact same way that it assumes when you're using range that you're referring to the active workbook and the active spreadsheet. The exact same way here, if you use message box, Excel assumes that, well, hey, I have this VBA object in the background. I know that it has a method called message box. That must be what you're using. But if you want to use explicit references like this, you're more than welcome to, if that helps you get a little bit more clarity. This message box method, again, is just a regular method on a built-in object called VBA. So when I execute or run this procedure right here, again, with that green play button, here's my first one, second one, third one, and my range A1 value of fun. The VBA object stores a lot of what we call utility functions. A utility function is one that helps the programmer be more efficient. So in addition to things like message box, the VBA object includes functions that help with time and date, mathematical operations like absolute value, even text functions like extracting characters from the left side of a string or the right side of a string. These methods are all bundled together within the VBA object, and it's mostly used by us developers to kind of help us write our code a little bit more efficiently, to have utility or speed or efficiency when it comes to writing our code. We're going to dive into the VBA object in greater detail a little bit later in the course, but that's all there is to cover in this lesson. We talked about message box, which is a method on the VBA object. It outputs some kind of value to a box that the user can see in their interface. The input that we give it, we call that an argument. An argument is given to the concept of a parameter, which is just a name for an expected input. In this case, our message box method has a parameter called prompt, and we're giving that prompt parameter various arguments. Here, we're giving it, for example, the arguments hello there, 2, 3 plus 5, etc. It evaluates that input in order to customize how the message box is going to perform, and then just outputs that value for us to see, or for the user who's running the procedure to confirm. That's all there is to cover here, and I'll see you in the next lesson. In this lesson, we'll take a look at comments in VBA. A comment is simply a line of text that is ignored whenever a procedure is run. And comments serve a variety of purposes. As developers, we can use them to offer up descriptions or explanations of what's going on in our code, either for ourselves if we come back to the code at a later date, or for other developers. We can use comments to describe the logical flow of a program, explain certain variable names or certain features that we're using. We can also simply leave metadata like the name of the procedure, who wrote it, the last time and date that it was modified. A particularly effective use of comments is actually using them to temporarily block certain pieces of code from executing. Sometimes we will have a procedure where one line of code will result in an error, and what we can do is temporarily disable it because a comment will make it just a regular ignored line of text, and that way we can sort of debug and figure out where a program is going wrong. Let's go ahead and show you how we can actually create some comments. So in a brand new workbook, in a new module, I'm going to create a procedure here, and I'm just going to call it comment example. The name is arbitrary. Let's add on those parentheses, and VBA will insert the end sub for us. And the way we create a comment is with a simple apostrophe symbol followed by the text that's going to be ignored. So the apostrophe symbol on most keyboards is found to the left of the enter key. That's this little symbol right here. And anything that follows afterwards is part of the comment, and it's completely ignored by VBA. So this is a random comment. When I press enter, it's actually going to be highlighted in green. That's the default color scheme for a comment. You may have altered this in the lesson a couple lessons ago when we talked about configuring our options, but essentially this means it's completely ignored. Regular valid code is going to be written in black, while comments are going to be displayed in green. So if we write a valid piece of code like message box 1+1, and we execute or run this procedure by pressing the green button up here, you can see that we're going to get 2, that's as expected, but this didn't create any kind of error. So VBA properly knew to ignore this line completely. The other cool thing about comments is that they can actually be written after a piece of code, so they don't have to exist on their own on a separate line. For example, I can actually add a comment to the end of this line and say a description like adds 2 numbers. Anything after the apostrophe is not going to be executed, but anything before it is totally valid. So in this case, message box 1+1 is still going to run, but this comment is not going to be processed at all. So when I execute this, we're once again going to get 2. Everything is still functional and valid. As I mentioned earlier, a really cool way that we can use comments is to temporarily disable certain pieces of code to see how the procedure would function without them. So let's say we had a piece of code like message box 3+3. Let's just pretend that this is a part of our procedure where the code breaks. What we can do is just put a comment before it, and that will temporarily disable it and ensure that it doesn't actually run. And this can be particularly helpful because let's say we want to disable this. How can we do this otherwise? Well, that means we have to copy and paste the code somewhere else, then bring it back, and so on. And that can be pretty annoying and also potentially lead to some kind of code loss. We may accidentally lose track of where our code is being stored. So a comment is a really good way to temporarily disable some kind of line so that it doesn't run. Let me go ahead and uncomment this code. And down below here, I'm going to write a couple other valid lines of VBA code just to show you how we can optimize the process of creating comments. So let's say I just have a debug print here. Let's just print hello. And let's do another message box of goodbye. Doesn't really matter. These are all just random VBA statements. So if we wanted to make all 3 of these lines comment lines, we could place our cursor in front of each one and just write a apostrophe. But an easier way is to use a comment block, which is just a helper feature in VBA. Up here on the View menu, if we look down here, we have a Toolbars option, and we have this Edit toolbar available. This is not enabled by default, but it's going to pop up. For me, it pops up right here in the top right, but it may appear for you kind of anywhere in the middle. If you want to bring it up here, just click and drag it until it pops into place on any of the toolbars up above. And right here on the toolbar, on the Edit toolbar, we have 2 buttons, Comment Block and Uncomment Block, and they work exactly as expected. So if I want to comment these 3 lines, I can just highlight all 3 of them, then click Comment Block, and VBA is automatically going to insert those apostrophes at the very beginning of the line. You can see that the code is now displayed in green, so it's random text. VBA will ignore it. And if we want to remove these comments, similar process, we just highlight the lines of code, click the Uncomment Block button, brings us back to our original state. That's all there is to cover here. Comments can be used really effectively. I do recommend writing plenty of comments as you proceed throughout the course. They can be really helpful for doing things like taking notes, explaining to yourself what a particular line is doing, explaining what a procedure is doing, why a certain decision was made. You can use them for any purpose whatsoever because VBA looks at it all equally, just text that it's going to ignore. That's all there is to learn here, and I'll see you in the next lesson. In this section, we'll cover the concept of methods, including parameters and arguments, in a little bit more depth. In this lesson, I want to focus on the idea of methods without arguments, so methods that can be invoked entirely by themselves. As a reminder, a method is simply an action that can be performed on an object. A method tells the object to do something. Now, some methods accept what we call inputs. Inputs help modify how that method is going to operate. The names that we give to the inputs are called parameters, and the actual values that we pass to the inputs whenever we call a method are called arguments. So let's go ahead and take a look at some methods that are available across a wide variety of VBA objects. And these methods do not take any arguments, so they can function entirely independently by themselves. We begin with the workbooks collection object. Let's take a look at workbooks. And I'm going to execute all this code in the immediate window rather than in a procedure because these are all, again, simple one-line pieces of code. So on the workbooks collection object, which collects all of the workbook objects in the current Excel instance, there is a method called add. The add method does not take any arguments. It does not take any inputs. It can function entirely autonomously by itself. And the add method creates a brand new workbook. So when I execute this, a new workbook is going to pop up. There it is on the left side. Simple, clean method invocation. Let me go ahead and close this. Let's take a look at a couple other objects and a couple other methods that do not require any arguments. Another option available to us. Let's take a look at a single workbook object. So if I reference the workbooks collection object and take out the only workbook I have open, which is present on my left side, on a specific workbook object, I have a method called save, which saves the workbook. Now, in order to save a workbook, we actually need to make some changes. So right here on the left side, I'm just going to write in some random values here. Let's just put 1, 2, 3. Doesn't really matter. Here we've written in a value into cell A1. And now we can see on the top here on the pane, it says methods without arguments, and the saved keyword does not appear, which means this current change to the workbook has not been preserved. But now in my immediate window, I can add on the save method, execute with my enter key, and now we can see at the top pane right here, saved appears because now the change has been preserved. So save is another method. It's available on a workbook object, but again, it is a method without arguments. The important part of this lesson is not to memorize all these methods because we're going to dive into them over and over again throughout the course. The key takeaway here rather is the fact that not all methods require inputs. Some of them can function entirely by themselves. The last method that I want to show you here is the clear method on a range. Conveniently, we have a range here in cell A1 that has a value in it, so I can reference it with range A1. And on a range, I have a method called clear. Clear predictably clears the entire contents of the cell, and that's more than just the text value. It's also the formatting, the borders, everything inside of it, so it returns it back to its original state. So when I execute this method, which doesn't take any arguments, cell A1 is now going to be cleared. That's all there is to cover in this lesson. Throughout this entire section, we're going to be diving into methods in a little bit more depth. In this lesson, I just wanted to cover the idea that methods do not necessarily have to take arguments. Some of them can function by themselves. And in the next lesson, we'll take a look at methods that do take arguments. In this lesson, we'll explore methods that accept arguments. As we know, arguments are inputs to a method that modify how that method operates. We saw an example of this earlier with MessageBox, which has a prompt parameter to which we provide an argument that reflects what it is that's actually going to be output in the message box. So some methods have arguments, some do not. And for those methods that do, some of those arguments are mandatory or required, while some of them are optional. Whenever we're feeding arguments to a method, we can feed them in one of two ways. We can either feed them sequentially in the order in which they're expected, or we can feed them alongside their parameter names, which allows us to have a little bit more freedom with how we structure our arguments. We're going to take a look at that syntax in this lesson. In addition to that, we're also going to explore the online VBA documentation. There's a lot of moving pieces to the Excel object model. There's hundreds of different objects that are available there, and there's no way that a single course or a single VBA textbook can possibly cover them all. So there's going to come a point in your journey as a VBA developer where you're going to have to look this stuff up yourself. You're going to have to explore the documentation, look for the right method, and explore its documentation page to see how it operates. And we're going to take a look at how we can do that in this lesson. So let's say a coworker comes to you and says, hey, I heard there's this functionality in VBA. There's this protect method that's available on a worksheet object. And what protect can do for us is enable password protection such that the user will not be able to enter any values into a worksheet or modify it at all unless they enter the proper password. So you might go to something like the immediate window and say, okay, well, I have my worksheets collection object. I can pull out some random worksheet object like sheet 1, and I'm going to type in protect. and put a space. And for some reason, VBA is not going to offer us some help. Maybe there's a bug in the program. Maybe we mistyped something. So we're not getting that IntelliSense feature showing up that's telling us exactly what our options are or arguments or inputs are for this protect method. So what can we do in this case? Well, we can head online to the online VBA documentation. So here I have a web browser open to Google. And so we can search for something like VBA worksheet object. We're going to see this very first result. It says worksheet object. That's exactly what we're looking for. And this is going to take us to Microsoft's official documentation page for VBA. So here we can see we have the name of the object listed above, and there's a page for every single object in the Excel object model. In fact, here on the left-hand side of this page, we have all of the objects that are available in the object model. So as I scroll down, we can see it's quite an extensive list. Right here at the top of this page, I also have a brief description of what the object actually is, what it represents. So here it says the worksheet object is a member of the worksheets collection. The worksheets collection contains all the worksheet objects in a workbook. So in case you've forgotten that, you can get help with that here. The most important part of this page, in addition to the examples we see, is when we scroll down a bit, after the events section, which we'll dive into later, we have a list of all of the methods as well as all of the properties that are available on that specific object. So let's explore the protect method, which we were just searching for a moment ago. Here it's listed under the list of methods. So when I go to this page, we're going to get a brand new page for each method. That there exists a page for every single property and method. And right here, we're going to get a brief description of what it does. It protects a worksheet so that it cannot be modified. That makes sense. Sometimes the name like this is pretty self-explanatory, but it's not always. So that's really helpful to have. Right below here, we're going to get exactly what we were looking to get in the immediate window, which is the method name followed by all of the expected parameters. So here they are: password, drawing objects, content, scenarios, etc. This method actually takes quite a large number of parameters. How do we find out what each of them do? Well, of course, we have this section called parameters where we can scroll down, and this is the most helpful part of the page because the parameters are going to be listed in the order in which they're expected. So here is password, which is the very first expected parameter. Right here, this column is going to tell us that it's an optional argument. We don't have to provide it. The method called will function if we do not include it. Right here, the data type is going to tell us what kind of data the argument is expected to have. So sometimes it may be an integer or a whole number. Sometimes it may be a string. This variant, which we'll dive into later, means essentially any data type will work. So this column here is going to tell us what kind of data type each argument is expected to be like, the actual format. And then here on the final column on the right, we're actually going to get a description of what that argument should be. So the password parameter should be a string that specifies a case-sensitive password for the worksheet or workbook. All right, so that makes a little bit of sense. So we can apply this principle back to our actual code. So let's head back to the Visual Basic Editor right here. And now we know that the very first parameter to protect is password. And whenever we're feeding arguments in, we can either feed them sequentially or explicitly specify the parameter that they're being applied to. Let's take a look at both scenarios first. The first option for us is to simply enter the argument. What VBA is going to do is say, okay, there's one argument you're passing in. I'm going to assume that you're tying it with the very first parameter expected, which is password. So if we provide a second argument, that second argument is going to go to the second expected parameter, and the third argument will go to the third expected parameter, and so on. So this will work. When I execute this, we're going to add some protection to the worksheet. So when I, let's say, click into a cell and try entering a value like 5, we're going to get this big pop-up. The cell or chart you're trying to change is on a protected sheet. Okay, to make a change, unprotect the sheet. Okay, so everything worked. So this is all functional. So this syntax makes everything work great. Let's take a look at the other way that we can write this as well. In addition to feeding the arguments in sequentially, what we can do is write the parameter name out first. So the parameter name, or the name of the expected input here, is called password. And then the way we assign an argument to a parameter is with a special syntax. It's going to be a colon symbol followed by an equal sign. And to the right of that, we actually give the argument. So the argument to the password parameter is going to be top secret. Let's say that's, again, an arbitrary string. So this syntax is identical to the one that we just saw before. The advantage with this approach is because we are writing the parameter name out explicitly, VBA can figure out what it is that we're tying together, what arguments go with what parameters, which means that we can feed our arguments in non-sequential order, and we can also skip certain parameters. So if we wanted to move on to, let's say, the parameter that would normally be expected in the 5th position, we can now just put a comma and write that 5th position parameter out and then assign it its proper argument. The associations here are being created by name, not by order. So we no longer have to keep them in order, and we no longer have to feed them sequentially. So whatever approach you prefer is up to you. This approach is obviously a lot safer and a lot more stable, and I also prefer it because it's a bit more explicit. If somebody just writes a string of top secret, we may not have an intuitive sense of what that actually refers to. Now we have a little bit better understanding because the code says the parameter name is password, and a user can probably infer that that means the actual password that's going to protect the worksheet. That's all there is to cover in this lesson. It's not really important here to memorize the protect method. That wasn't the point of this lesson. The goal here is to figure out how to use online documentation to find what we're looking for. Remember, sometimes you're going to run into an unfamiliar method or property or even an unfamiliar object, and you may have to dive into the documentation to find more information for what you're looking for. Whenever you stumble upon a method page, you're going to see a list of all of the expected parameters. Parameters, again, are the names that we give to the inputs that a method can accept. Some of those parameters are optional, some of them are mandatory. It depends on what object we're dealing with. When it comes time to actually invoke the method and pass it arguments for those parameters, there are 2 ways we can do that. The first way is to pass those arguments sequentially. They're going to be tied to the corresponding parameter in the same position. And the second way to do it is to actually write the parameter name explicitly out as we did here. That allows us to pass the arguments in any order we want, which buys us a bit more flexibility and stability. All right, that's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll explore the concept of methods that accept multiple arguments. So in the previous challenge, we used the open method on the workbooks object with only the first argument, file name. We did that so that we could open a file, and we did it sort of with the default set of options or configurations, but the open method actually accepts multiple arguments. It has multiple parameters, multiple inputs that it can accept, and we can provide different values to more than one parameter in order to customize how that method operates. Whenever we're feeding multiple arguments to a method invocation, we need to separate them by a comma. Now, there's a couple ways that we can do that, and we're going to take a look at that in this lesson. The first thing to note here is for the purposes of this lesson, I've created a new Excel workbook file in the same directory as the current file I have here. So my other file is called some random file. It doesn't contain any important content. It's just there so that we can open it, but it's not actually important. You can open whatever file you want. So in this file, which is called methods with multiple arguments, this is where I'm actually going to be writing the VBA code to open some random file. I'm going to be doing that in my immediate window. So let's begin with the workbooks open method. So workbooks, we're going to put a dot, we're going to use the open method, and then when I put a space here, we're going to see the documentation for that method. So we can see here the very first argument is the file name as a string. So it's expecting a string in double quotes that's going to represent the file name that we want to open. So we can write something like some random file.xlsx. And this will work. This is what we did in the assignment. We just fed it as the first argument. Because the arguments are fed sequentially, VBA is able to identify that some random file.xlsx is a string argument to provide to the file name parameter. But what if we want to provide another parameter? For example, the third parameter that we have here in line is called read only. That expects an argument of either true or a false. That's something called a Boolean value, which we'll dive into a little bit later. But that essentially allows us to set whether that file is only going to be readable, which means that the user can't actually edit it. What if we want to use that read only parameter, which is third in line? How can we do that? The first thing we can do is to provide the parameter names explicitly, and that allows us to actually skip arguments. We don't have to provide them sequentially. We can skip over them because VBA will be able to tie our arguments to their proper parameters with the association. So how can we do that? Well, we can do that right here by writing file name :equals. So this is the assignment syntax of an argument to a parameter name. This is the explicit way of saying when we give a string of some random file.xlsx, we want that argument to correspond to the parameter of file name. Now, file name here is first in line, so it's convenient, but this is more helpful when we actually want to feed a parameter that is not in order. So if I put a comma here, you can see the second parameter that it's actually expecting here is called update links. But that's not the one that we actually want to target. We want to target read only, and I can skip over parameters if I write them out explicitly. So instead of writing update links, I can target the read only parameter, give that a :equals to assign it an actual value, and you can ignore this syntax right now, but it's going to be a value of true. So this is going to give an argument of true, which is going to make that workbook readable and not writable. So again, the functionality of the open method isn't changing. It's still opening a workbook, right? The core heart of the method hasn't changed. But now with the additional parameters and the additional arguments or the additional inputs, we're modifying how that method operates. So let me go ahead and execute this with the enter key. You can see here is the workbook. It's been opened, and right here is some random file. It's opened everything properly. And if I try to enter text, it should prohibit us from writing. It looks like it's not, but right here it says read only. So if I attempt to save this, there we go. So now it's saying we can't save some random file because the file is read only. So it looks like read only allows us to enter text, but we can't actually make changes or save changes to the file. So everything is working as expected, as our VBA code was designed to do. So let's not save this. I'm not sure even how we can. I'm sure it just would not allow us. So let's click don't save. That brings us back here. So what can we do if we wanted to feed the arguments sequentially rather than writing the parameter names out explicitly? So let me go back to our original method invocation. So we can see file name is first and read only is third. Well, if we're going to be writing the names out explicitly, then we can feed them non-sequentially. But unfortunately, if we're just going to be feeding them kind of numerically in line, we do have to place commas to represent even those parameters that we're going to be skipping. So for example, I know that some random file .xlsx is going to be our first argument, but when I put a comma here, you can see VBA wants to move to update links, but we don't actually want to provide anything to that. So what we have to do here is just put another comma so that it skips ahead to the next parameter in line. And now, since this is focused on read only, we can provide the same argument of true. So this syntax is a little bit lighter, it's a little bit shorter, but I don't like it so much because it's a little bit dirtier. We have two commas in a row, and we're not exactly sure what true means. We may forget what this method does, and we may not be sure about what true is corresponding to, what parameter it is affecting. So even though this will work, I can press enter and we're going to get the exact same result. I really prefer the first approach of writing out any parameter names explicitly along with their given arguments. It may take you a little bit more time, but it'll reinforce in your head what it is exactly that the method is doing and what it is that you're customizing. With that said, if you're only giving a method one argument, for example, if we only wanted to feed that first argument, which is file name, in cases like this, I don't write the parameter name out explicitly because I think it's kind of intuitive. When we're calling the open method, it sort of makes sense to me that the first thing we need to tell it is what's the actual file that we're going to open. But it really is a matter of personal preference whether you want to write your parameter names out each time or feed them sequentially. It really is up to the developer and how you process these things best. There is, I think, a good middle ground, a good balance that you can strike between keeping things simple and keeping things well written out so you understand what it's doing. But you'll pick up that skill over time as you write more code. It's not really something that is teachable. It just comes with experience and practice. But that's all there is to cover in this lesson. We talked about VBA methods that accept multiple arguments. Whenever you have multiple arguments that you're feeding or multiple inputs, you have to separate them with a comma. We can either provide the parameter names explicitly, and that way we can skip certain parameters, or if we're feeding them sequentially, that allows us to save a little bit of space by not writing the parameter name, but then we do have to put fake commas essentially whenever we're going to be skipping a parameter. That's all there is to cover here. I'll see you in the next lesson. All right, so we've previously explored the online documentation for VBA objects, including their properties and methods. And in this lesson, I'm going to show you a lightweight documentation tool that's built directly into the Visual Basic Editor, and it's called the Object Browser. There's two ways that we can access the Object Browser. The first way is to click the View menu up top and select Object Browser, and when it pops up, it's going to occupy the place that's normally taken up by the code window, so here it is. And I'm just going to exit out of it here by clicking the Close Window button at the top right. The second is to use the keyboard shortcut, which is F2. That's going to bring up the Object Browser as well. Now, the Object Browser lists every object, property, and method across all Microsoft applications. So we're not actually limited to searching strictly within the Excel object model. We can look across the object model for essentially any Office application. So right here, I have a couple of results showing up, but let's go to the starting place for this object browser. So let me just get rid of my search term here. When you launch this browser for the first time, what you should see is that this is going to select all libraries. All libraries essentially means all Microsoft applications. So if you only want to target Excel and its object model, you want to make sure to select this Excel option right here. That's going to limit the search range. Now in here, in this second box below, this is where we type in whatever we want to search for. And this can be anything from an object to a method to a property. So let's say I want to search for the worksheets object, which we're all pretty familiar with by now. So when I type worksheets and press enter, or press the binoculars right here to the right, that's the same thing as searching, we're going to see a list of anywhere where that worksheets search phrase is going to appear. The very first result is actually going to find worksheets for us. This is the actual object itself. So for example, the second result is actually listing the application object, and it's telling us that it has a property or a member called worksheets, which of course is also the same thing as the worksheets object. But the search results are going to include anything, whether it's the object itself or whether it's a property on another object that represents that object that we're searching for. So we want the top result here. This is our worksheets object. And right here on the left, it's also going to appear here as the selected term right here in this classes panel. So once we select worksheets here, what we're going to get here on the right is a list of all of the properties and the methods that are available on that object. There's a couple weird symbols here, but you'll quickly commit them to memory if you use the object browser a lot. The first is, of course, this green flying book thing. This essentially means that the member that is being listed here is a method. So what I mean by member is just something that belongs to that object. So a member is kind of the parent category that includes both properties and methods. Both properties and methods are members of a given object. So the green flying book demonstrates that the current selection is a method. So for example, add is a method, copy is a method, delete is a method on the worksheets object. And anything with this hand plus the index card represents a property. So count is a property, creator is a property, and so on. And whenever we select any of these, we can actually see a little bit of information down below. For example, count is going to say it's a property, as well as the what kind of data type it is. So a long here represents a whole number data type. Now, it's not actually giving us a lot of information about what this property is doing. We're going to have to refer to the online documentation to get that. And there's two ways that we can do that. The first is once a property is selected on an object or a method for that matter, we can select this yellow question mark. And once we click it, it's going to launch a web browser that's going to take us to the documentation page for that specific property or method. So it's a really quick way to navigate to what it is that we're searching for. So on worksheets, the count property, that's the page that's going to load now. It should be opening the default web browser that you have selected on your computer. Here we're getting the documentation for the worksheets count property. It returns a long value that represents the number of objects in the collection. Makes sense. The other way to do the exact same operation is to use the keyboard shortcut F1. F1 is again going to open up a browser and load the page for that documentation. Let me just show you another example with a method. So let's say I want to find out what the delete method on the worksheets object does. Just select it with the mouse, press F1. A browser is going to open and load the proper page with that documentation. Unfortunately, if you actually need to find out what a property or a method is doing, you are going to have to refer to this online site. But the object browser is kind of a good introduction in case you want to search for something without leaving the confines of Excel, especially if you don't have an internet connection. You can sort of get a list, even if you look at some of the methods here. Even if we take a look at something like delete, or perhaps add as a better example, we can actually see some of the parameters and arguments that are available here, what their names are. So we can sometimes get a sense of how a method operates or what it does, even if we don't have an explicit text documentation for what it is. But that is the object browser. It's built into the VBE. You can use it at any time. Just press F2 to bring it up. You can search within the Excel object model for anything you want. We can search for application. We can search for worksheets, workbooks, any object at all. It's going to appear here. Make sure you select it. Here, we're going to have all the members of that object. The members include both the properties and the methods. We can select any one of those, have a brief description here, and then use that by pressing the F1 key to access the online documentation for that member. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we're going to take a look at all the ways that we can execute or invoke a procedure from both the Visual Basic Editor and the main Excel interface. I'll begin here by defining a very simple procedure. It's not going to do much of anything, just put up a message box for us to observe. So let's call the procedure annoy user, and I'm going to put a message box here that says, you ran the macro. All right, let's begin with the stuff that we already know how to do. So in order to run this macro from the Visual Basic Editor, we can press this green play button. That's our first option. This macro is going to run. Here's the pop-up box. Perfect. The keyboard shortcut for this green play button is the button F5 on your keyboard. That's a very, very quick way to run the macro as well. What about on the main Excel interface? Well, as we know, in the Developer tab, we have this button called Macros. When we click that, we're going to get a list of all of the macros that are public, which means accessible to the user in the main Excel interface. And by default, all the macros we write are going to be public. We're going to talk about how to make them private a little bit later in the course. But here is our single annoy user macro. We can just click run to run it. There, the macro runs again. As another shortcut, if you want to bring up this box, the keyboard shortcut for that is going to be Alt plus F8. That allows us to get really quick access to all of our macros. We can execute it again. Perfect. Here's a couple more ways that we can run a macro from the Excel interface. The first option is to assign the macro to something called the Quick Access Toolbar. That's this little toolbar that's found at the very top of Excel. It has common features like save and undo. If we click this little drop down to the right, we have this option here called More Commands. This will allow us to actually customize and put more commands on the Quick Access toolbar. Here on the top, instead of choosing from popular commands, we want to select this drop down and find the macros option. So here we have a list of our macros, including the one we just wrote, annoy user. Here on the right, we have all of the current icons or actions on the Quick Access toolbar, like auto save, save, undo, redo. So in order to bring this one over here, we just click this add button. It's going to show up here at the end of the list. We can, of course, move it around if we want it to appear elsewhere. Let's just leave it at the end for now. When I click OK, it's going to show up here with this default icon. So here it is. When I hover my mouse over it, it even tells me that it's called annoy user. So I can click here and it's going to pop up the box as expected. As a little bit of a heads up, if we click this drop down again, there is an option available for the Quick Access toolbar called Show Below the Ribbon. What that's going to do is move the QAT, as it's called, from the top to right below the main Excel ribbon. The reason a lot of developers prefer this option is because it gives you a whole lot of space to the right here where we can put a whole bunch of macros. It just buys you more space in general. So if you want to have a lot of macros that you can just click here and assign each one a different icon, you can move the Quick Access toolbar to the bar below the ribbon. To bring it back, you can just click this drop down and click Show Above the Ribbon, brings it back to right here. We can also assign the macro to something called a form control, which is basically just like a button in the Excel interface. Here in the Developer tab under Insert, we're going to have a whole bunch of form controls listed here, and the one we're primarily going to want to use here is this button. So once I click this, I'm going to get this cursor on screen and I can click and drag it to shape the size of the button. And once I let go, we're going to get a pop-up box that's going to ask us to assign a macro to the button that we're about to create. So I'm going to choose the macro that I want to assign to the button. So I'm going to click on Annoy User, click OK. And now we have this button. Right now it says button 2, but we can go ahead and edit the text in it. Say something like Annoy User. Let's give it a name. It doesn't have to be the same name, by the way, as the macro. We can give it something like annoy user. And then as soon as we click out, the button's actually going to be activated. So when I hover my mouse over it, I'm going to get this little pointer finger. When I click on it, there we go. Our macro is running. You ran the macro. All right. So obviously this is all very silly because all our macro is doing is performing some kind of operation of output with the message box. But you can imagine if you're building some kind of complex macro that does things with multiple spreadsheets and workbooks and adds formatting and fonts and stylings, it's a lot easier to have the user click a button like this and have a whole variety of buttons listed to the right, like a whole menu of options, compared to having to go to the macros box and find the right macro and execute them all manually. So hopefully you're starting to get a sense of how we can even customize the Excel interface to make the experience of running a macro much more seamless and easy for an Excel user. Finally, another way that we can execute our macro is by assigning it directly to a button on our ribbon. In fact, we can customize our ribbon completely, including creating new tabs and new groups of commands. So here's what I can do. I'm going to hover my mouse anywhere on the ribbon, and if I right-click, I'm going to have an option available here called Customize the Ribbon. If I click that, that's going to bring up this Excel options dialog box. And on the right here, we have a list of all of our tabs. Here we have the Developer tab, which we enabled at the beginning of the course. What I can do here is click New Tab. That's going to create a new tab right here and a new group within it. What I'm going to do is just select the new tab that's been created. I want to give it a new name, so I'm going to rename it. And let's just call it Macros. All right, here we have a new group. And what I can do here is actually add my macro to that group. So underneath this choose commands from option, I'm going to right click that or left click that and take a look here for macros. Once again, we want to filter for just the macros that are available. So here we have our macro. It's called annoy user. So we can select it right here and add it. That's going to add it underneath that new group that's been created within the macros tab. In fact, we can also change the name of the group. So let's change the name of the group by clicking that and clicking rename. In fact, it looks like we can also assign it a different an icon. So let's go ahead and give it an icon of something like an unhappy face. Why not? And let's just call it annoyance, because that's what this macro group is going to do. So, okay. So our group is called annoyance. Our macro here is called annoy user. I'm curious if I click rename here, if we're going to be able to, yep, we are able to now actually select an icon for that macro that is different from the default one that we see. So let's go ahead and select something funny here. Let's do a smiley face. All right, so I'm going to click OK. Perfect. So we now have a new tab called macros, a new group called annoyance. The macro annoy user is going to be represented by a smiley face. So I can click OK. Right here on my ribbon, we can see macros has appeared to the right of the developer tab. We can also, by the way, modify where it's going to appear in the ribbon. Doesn't really matter for this lesson. So we can click on macros. Right here we have our annoyance group, and here we have our wonderful annoy user macro. If I click this, you can see the code is being executed just like always. So here we go. You ran the macro. I think I definitely saved the best for last because this is my favorite way to run a macro in Excel. It's definitely the most cleanest, most elegant, and I think that it really, really blends well with the actual Excel experience. It looks just like a regular ribbon, and you can customize and group your macros together based on what they do. You can have, for example, a formatting group, a worksheets group, a font group, whatever you want. But in this lesson, we talked about the different ways that we can execute a macro, both from within the Visual Basic Editor and from the Excel interface. We can always run it with the play button, with the F5 command. We can assign a macro to a form control like a button. We can assign a macro to the quick access toolbar, also called the QAT. And finally, we can assign a macro to the ribbon as well. Lots of different options available for you to utilize. Choose whatever works best for you and your business needs. In this lesson, we'll take a look at the typename method. The typename method accepts a VBA object as its only argument, and it returns the type of the object as a string. I'd like to begin here with a little bit of a review. As you may recall from the lesson on message boxes, VBA includes an object that's actually called VBA, and that object packages a lot of utility functions. Utility functions are just little snippets of code that help us as developers be more efficient and productive. Message box is an example of a method that's actually on the VBA object. Now, the way it works is, to simplify things, VBA is able to look up those methods on the VBA object, so we don't actually have to include the VBA prefix. As an example, we could write VBA.messageBox, and that's totally valid syntax. We can also write messageBox by itself, and it's going to know what it is that we're talking about. Well, typename is a method that is also available on the actual VBA object. So if I type typename, we're going to see that method right here. So let's take a look at how this method works in action. What I'm going to do here is just place a question mark at the beginning because we are asking a question here. We're not issuing a command. And this method, again, accepts as its argument a valid VBA object. So let's begin at the top of our object model with application. And what it's actually going to do is return to us the type of the object as a string. So what we're about to see here is not going to be that climactic. We're actually going to get application. And just to prove to you that the VBA object is not needed, I'm just going to put typename right here without the VBA prefix, also put an application, and we're going to get the exact same result. All right, so right now this doesn't seem that cool because, well, it's kind of obvious if we're giving it application, we're going to get back application. The real use of this, however, comes whenever we're going to be dealing with dynamic data that we can't predict in advance. For example, later on in the course, we'll talk about this idea of user forms, which is essentially a dialog box that we can create that the Excel user can interact with. And let's say we have some kind of option where the user can either select a workbook from a list or a worksheet from a list. In that kind of scenario, whenever we want to perform some kind of conditional logic, which means if they select a workbook, do this, and if they select a worksheet, do this, in that kind of scenario, something like this might be really great. This is really ideal for scenarios where you might not know the exact kind of object that you're going to be working with, and you might want to take different steps depending on what the object is. So how can you figure out what the object is? Well, you can pass it in to something like type name and it will tell you. And then you could write a piece of logic that says, hey, if type name of this object is workbook, take the steps necessary for dealing with the workbook. And if type name for this object returns worksheet instead, take these steps to deal with a worksheet. So right now it's a little bit underwhelming, but I did want to make sure that you understood how this method works. So let's take a look at a couple more examples here in the immediate window. Here's a tricky one for you. What happens if I do this? Type name, and I'm going to enter application. But notice that I'm going to wrap it in double quotes. What's actually going to happen here is I'm going to get a string. What this method expects is a valid VBA object. And this right here is not the application at the top of our hierarchy. This is simply a string with 10 or so characters, right? We can tell it's a string immediately by double quotes. And strings are completely different data types than Excel objects, right? So it's actually telling us the data type of this string, which is a string. In fact, if we give it any kind of string, for example, if I put in my first name here, we're going to get the exact same thing. As long as there's double quotes, it's a string. It's a data type used for representing text or characters, and we're going to get the exact same result. As a few more examples here, if I do something like type name workbooks, we're going to get a predictable result. We're going to get workbooks. We're actually going to get a different result, something a little bit unexpected when we do something like worksheets. What we're actually going to get here is sheets. So this actually has to do with a little bit of VBA internals. As it turns out, Excel actually supports two types of sheets. Worksheets, which are the ones that we're used to with all the data and the cells and the ranges on them, as well as chart sheets. Chart sheets are the ones where you can, for example, put an entire bar graph or pie chart on a separate tab or a separate sheet in the Excel interface. And chart sheets have their own sets of methods, of course, and properties. But worksheets are falling into this clump, into this bundle of sheets. Sheets is kind of the parent, and its two children include worksheets and chart sheets. So that's why this result may be a little bit unexpected. Let me provide you with 3 more examples to close this lesson off. As we should know by now from the Excel object model hierarchy, if I do something like this, workbooks 1, what are we going to get here? Well, we're not going to get workbooks. We're going to get a single workbook. Remember, because we're extracting from that collection. So type name can be really helpful. If you forget something like that, just feed in a valid object here and it'll tell you the right answer. Similarly, if I do type name right here and I start with my worksheets collection and I extract, let's say, the first worksheet from there, we're going to get worksheet. Finally, last example, type name. Let's give it a valid range object like the range of cell C3. Close this off with double parentheses. We're going to get a range. Again, it's a little bit underwhelming now, but hopefully you can start to see the application of this when we proceed a little bit further in the course. Whenever we have some kind of dynamic object whose value we cannot predict, if we're not going to know what kind of object it is in advance, we can use this method to tell us and then react to that. That's called conditional logic. Conditional logic means based on some kind of condition. If this condition is true, if it is a range object, do this. Or if this condition is true, for example, if it's an application object, do this. Right now, we're just feeding plain Excel objects into it, and we're getting kind of predictable results. But you should see the application of this as we proceed through the course, and we're also going to use it through some other examples in some upcoming lessons. So that's the type name method. Accepts an object, gives you back a string representing the type of that object. In this lesson, I want to introduce you to some syntax tips that we can use to make our code more readable and elegant. Now, VBA greatly helps us write our code. It already includes certain built-in features to make our code more likely to be readable. For example, VBA automatically inserts spaces between operators like the plus sign and the minus sign. VBA also auto-completes certain parts of the code for us, like the end sub keywords at the end of a procedure. VBA will also adjust, for example, the casing of letters in things like our method names and our procedure names to avoid any kind of issues with case sensitivity. VBA, of course, will also scan the code for errors and alert us whenever we run into any kind of technical, syntactical issue. So VBA is automatically helping us, but there are other things that we can do just to ensure that our code looks prettier and that it's a lot easier to read as well. I'm going to go ahead here and define a new procedure. I'm going to call it do stuff. And I'm just going to use this procedure to demonstrate a couple good habits and a couple bad habits when it comes to code. So in many programming languages, we have the concept of a semicolon, and a semicolon is typically used to break up or terminate a statement. And actually, VBA allows us to use semicolons in order to execute more than one statement on a single line. For example, I can do something like this: debug print, let's output the word hello. Then I can put a semicolon, and a semicolon almost acts like a line break because it terminates the code that comes beforehand. So it sort of says, this is the end of the code that I was just about to write. This is the end of the statement that I'm about to make. So we can go ahead after a semicolon and write a brand new command. So now we have 2 commands on a single line. With that said, this is not considered best practice. The first tip I have for you is that each VBA line should consist of 1 instruction or command. So whenever you want to put more than 1 command, break them up over multiple lines, and in general, avoid the semicolon. We don't need to put the semicolon because the line break will serve essentially as the end of the statement. VBA and the editor is able to parse that as the natural conclusion of our command. Here's another tip I have for you. Let me just go ahead and comment out the code. Many times, whenever we're writing something like a fully qualified reference, for example, referencing all of the parts of the Excel object model, we're going to run into a line of code that's very long. For example, let's say I have a value here in cell B. Let's just make it the letter B. And let's say I have a value here in, actually, let me move this up. Let's put a B in B1 and an A in A1. Let's say I want to move the value B into cell A1 with VBA code. So I could write something like this. This is going to take a little bit, but we're starting with application. We're referencing the first workbook in the workbooks collection. We're referencing the first worksheet. We're getting the range of A1. We're getting the value. And we want to set this equal to the value in cell B1. So what I can do is actually copy this entire code right here, paste it to the right, and make this work. So what we're doing here is we're taking the value from cell B1, getting it, and then, of course, making that the value in cell A1. Now, this is functional, but of course, this line becomes really difficult to read. So how can we break it up? Well, we can actually use the underscore to break up lines in VBA code. So for example, right here after the equal sign, I could put an underscore and a space. I can break this up, and when I execute this with F5, we can see that B has replaced the value in cell A1. So the macro has run as expected, which means that this is not leading to an error. So essentially what the underscore does is it tells the VBA parser that we're going to create a line break that's intentional and that it should continue parsing the line as if it's still on the same line. So it's going to read this thing on the right side of the equal sign as if it's written right here. It's just a little syntactical tip that we could use to break up things over more than one line. In fact, what we can also do is create a line break after an object reference. For example, if I were to drag this line back to the one above, so let's go ahead and remove this, drag this up. Right here, I created my line break right here, but I could actually do it right here after this dot. I can put a space and a underscore, move this to the next line. Let's just go ahead and change this back to 8 so that we can make sure everything's working. When I execute this, click in here, click F5, we can see that everything is working as expected. So we can create a line break actually in a wide variety of places. We can also create a line break, by the way, after the comma whenever we are entering multiple arguments to a method. That's a very effective use case. So I'm going to be using this sometimes throughout the course when I'm going to write a line that's going to be very long and I want to cut it down. What I can do is keep the logic but break it up over multiple lines by using the underscore. All right, let's go ahead and comment this code out. And there's one more tip I want to show you in this lesson. Sometimes we're going to be dealing with text that includes a double quote. There's just one problem. VBA uses the double quotes to mean something. It means the beginning and end of the string. So what do we do when we actually want to use double quotes within a string? For example, let's say I have a quote here like, Romeo said, I love you, Julia. Let's say this is a string that we want to write into a cell. We're going to run into a problem here because we have a double quote here, and VBA is going to interpret that as the start of the string. But before it gets to this last one, what's going to happen is it's going to interpret this one as the end of this first string, and we're going to run into an error. So let's see if we can debug print this and see what happens here. Should run into an error here, so when I execute with F5, you can see variables not defined. VBA is getting confused about what this means. So what do we do whenever we have to deal with quotes in our text? The first thing I want to do here is actually get out of this thing, which is called our error handling. Whenever you see this yellow, it just means that we're entering into a debugging mode. We can click this blue square to stop that and reset our code. So right here, let's just go back to what we used to have. I love you, Juliet. All right, so this is what we wanted to do. What we can actually do is we can use a second double quote before any other double quote that needs to be part of the string. It's sort of an escape character if you're familiar with that in other programming languages. But what I mean by that is we want to ignore this double quote. The way we do that is by putting another double quote before it. So VBA recognizes two double quotes in a row as sort of a sequence that it recognizes as a regular quote. So we're not going to run into an error. So we have to put one more double quote, and that's going to be right here. So this is going to be 3 in a row, but just as a review, these two are going to translate to a single double quote because 2 in a row indicates that VBA is going to escape the next one. So it's going to understand that it's part of the internals of the string. And finally, this one at the very end is actually going to end the main string that's being output by debug print. So if I execute this, there we go. Now everything's working. We just have an extra semicolon there somehow. Let's go ahead and try this again. Let's try this. 5. There we go. So now we can see Romeo said, "I love you, Juliet" is being output, including with the quotation marks that we have intentionally put there. We simply escaped them or avoided them causing an error by placing another quotation mark before them. That's the symbol that we use. That's all there is to cover in this lesson. We talked about using quotation marks. We talked about writing one statement per line only. And we talked about creating line breaks with the underscore character, which is probably going to be the most important tip that we learn here. I'm going to be using that a lot throughout the course. That's all there is to learn here, though. So I'll see you in the next lesson. In this lesson, we'll talk about variables, which are a very important part of VBA programming. A variable is just a placeholder for a piece of data in our program. Now, what do I mean by a piece of data? Well, data can mean anything from a number to a piece of text or a string to a complete VBA object like a range or a workbook or a worksheet. A variable is just a name that we choose as a developer that points to a specific object in our program, so we don't have to reference that object over and over and over again. So if you think back a while ago when we talked about fully qualified references, for example, when we used application and then workbooks and worksheets to reference a specific range object, that process of writing out that reference can take a while to write out. It's much easier to just write it out once and assign that final object reference to a variable, which again is just a placeholder name, and then reference that variable instead of writing out the entire object reference again. So variables are just simple ways that we can refer to something in our program without having to remember exactly what a specific value is or a specific object is. So let me go ahead and create a sample variable here for you. There's actually 2 parts to a variable. The first is the declaration, and the second is the assignment of a specific value. So the declaration, which is the first step, is the part where we tell VBA that we want to allocate a piece of computer memory for a variable. We're going to say, we're going to define a name here, a specific variable, which is just a name. And we also have to tell VBA the kind of data that it's going to hold so that when we assign a value to it, VBA is prepared to store or reference that specific kind of data. So let me go ahead and create a brand new procedure here. I'm going to call it my first variable. And as soon as I add the parentheses and press enter, VBA will complete the end sub. So what I'm going to do here is write out a single variable declaration because it's a lot to take in at first. So I'm going to write it out completely and then go through it step by step. So here we go. Dim age as integer. So as soon as I do a line break, perfect, there it is. The first part here is the dim keyword, which is actually part of VBA. It's a keyword within the language. Dim is short for dimension, and that's an old school computer science term for variable. So dim always has to be written before we write out any of our variables. So if we had more than one variable, we always place the dim keyword before the actual name. So immediately after the dim keyword, we write the name of the variable. This is our own decision. This is up to the developer. And ideally, the name should describe what the variable is going to hold. So in this case, I want a variable that's going to store my age. Let's say I don't want to remember it. I just want to store it in a variable once so that I can always reference age later in the program and know that it's always going to give me the actual numeric value of my age. So age is up to me to decide. In terms of the variable name, I've chosen age. That's the second thing I put in this sequence of 4 items. Immediately after the variable name, I put the keyword as. That also is part of VBA, and that also must always be included. And finally, at the very end, that's where we declare the variable type. This means the type of data that is being stored. We have, as I mentioned, many different types of data. We have integers, we have strings, we have complete VBA objects. We have to tell VBA, in order for it to allocate memory, exactly what we plan to store in this variable. In this case, age is going to be an integer. As a basic mathematic review, an integer is just a number without a floating point component. So a number without a decimal. A whole number like 5 or 10 or 15. Earlier on, when we were looking at some of the configuration settings in the Visual Basic Editor, we enabled an option that mandates that option explicit appears at the very top of each of our modules. This option explicit setting mandates that every variable be declared before we actually assign it a value. And when we say variable declaration, that's this part. We are telling the program as a statement of fact that we are going to have some kind of variable called age in this procedure, and that we expect age to be of an integer type, a whole number. But we haven't actually assigned it a value yet. We don't know what age is equal to. We just tell VBA to spare some memory for it. Now, there are a couple restrictions that VBA places on our variable names that I want you to be aware of. The first is that variable names cannot be greater than 255 characters. You're generally not going to run into this problem with your variable names, but I did want you to be aware of it. Variable names, exactly like procedure names, cannot contain spaces. So if you have multiple words, you can stick with the upper camel case syntax, which means the first letter of every word can be capitalized, and you can use that to sort of mark where a new word begins. But you cannot have actual spaces in your variable names. Variable names also cannot contain mathematical symbols like plus or minus. They cannot contain any kind of punctuation characters like the question mark or the exclamation point. They cannot contain special characters like the hashtag, and they cannot be reserved VBA keywords like sub or end or option or explicit or worksheet. So don't create a variable called worksheet. The variable actually has to be some kind of name that isn't part of the VBA language. The variable must also be unique in the procedure that defines it, which means we can't declare another variable called age in the exact same myFirstVariable procedure. So that's going to trigger an error in VBA. However, we can have the same variable names across different procedures. So if I had another procedure below my second variable and I declared a variable called age in there, that's totally valid. And age in my second procedure can be a totally different data type. The reason we can do this across different procedures is because the variable has this concept of scope. And scope refers to the limit or the reach or the boundary in which a variable exists. And a variable only exists as long as the procedure is running. So every time my first variable is executed, it's going to create a variable called age that's going to be an integer. But as soon as that procedure is done, that variable is tossed out of memory. It doesn't exist any longer. So whenever we run a second procedure that also has a variable called age, that second variable is simply going to be created from scratch. And that process continues over and over and over again. Finally, we cannot start a variable name with a number or an underscore. The variable name can contain a number or an underscore, but it cannot start with it. So the general best practice to follow is to start your variables with a letter and just make it as descriptive as possible. It should describe the actual value that it's holding. So age is a pretty good variable name. You don't want something like num or num1. You don't just want to say it's a number. You want to describe what it actually is, what it actually represents. So now that we've declared the age variable as a type of integer, we can actually go ahead and assign it a value. The way we do that is on the line below, we write the name of the variable. This is age. This is our own custom name. We give it an equal sign, much like if we were assigning a value to a property of an object, just an equal sign. And then on the right side, we write the actual value that we want to assign to this variable. So let's make the age variable equal to 26. So what does this mean? Well, age is now a placeholder, and it's a placeholder for a number of 26. That means that I can reference the variable age anywhere in this procedure's code, and it will give me the value 26. It's a representative of that value. It's a placeholder over it. So for example, if I wanted to debug print, rather than writing 26, I can simply write age. And whenever VBA evaluates this, it's not going to print the literal string age. Rather, it's going to say, hey, you have a variable here. What is that equal to? Oh, right here, it's defined to be 26. So I know that it's a reference to that number. So this is going to evaluate to 26. So when I execute this procedure, 26 is going to print in my immediate window. Remember that age is a variable that represents a number, but we're not limited to simply outputting that variable. We can do any kind of operations that we would do with a plain number. So for example, if I wanted message box and I want to see what my age will be in 4 years, what I can do is age plus 4. The reason I can do this is because age is just a name for a number. It's a placeholder for the value that I assign up here. So when VBA is evaluating this, it's going to substitute age for the value it's assigned up here, 26. it's going to add 4 to get 30. And once it evaluates to 30, that's what message box is going to output for us. So when I execute this, a message box with 30 is going to appear in the middle right here. One last detail, VBA is not case sensitive, which means a variable with a capital A and a variable with a lowercase a are the exact same thing. VBA will generally try to correct you whenever you use the wrong case. So for example, if I try doing something like this, if I try typing age with a lowercase a, you can see it's automatically going to boost it back up to an uppercase A because it identifies that that variable exists. But VBA is not case sensitive. So in case of any kind of error, do not declare variables with the same name, but different casing. VBA will try to correct for it, but you should avoid it as a general practice. If you want another variable, find a completely different name to give it. That's all there is to cover in this lesson. Variables are just placeholders or names that we assign to pieces of data in our code. Right now, I'm sure you're not seeing the big benefit of this, but rest assured, variables are really helpful when we get to the nitty-gritty of actually accessing values on our spreadsheet, manipulating them, overwriting them. Variables help simplify the process of referencing complex objects. That's all there is to cover here, and throughout this entire section, we're going to be diving a lot into variables and the various data types that we can use in our code. It's an important foundation to lay before we start diving into the actual parts of programming in VBA itself. In this lesson, I want to explore a shorthand syntax for declaring multiple variables at once. In my Visual Basic Editor, I'm going to declare a procedure called moreVariableFun. And let's say in this procedure, I want to declare 3 variables: age, lottery number, and sheet count, and all 3 of them will be integers. The easiest way to do this is just to declare a different variable on every single line. So I can do something like dim age as integer. On the line below, I can do dim lottery number as integer. And finally, the same thing as sheet count. As a review, we always begin with the dim keyword for a dimension to declare a variable. We follow it up with the actual variable name, like sheet count, followed by the as keyword, which allows us to declare a data type that that variable will store. And finally, the actual data type itself, which again will be an integer. Now, this is completely valid VBA code. There's nothing technically wrong here. But as we can see, this takes up quite a bit of space. It takes up 3 lines of code. What we can actually do is simplify this a little bit by writing our code like this. I'm going to actually comment out the lines above so we don't run into any compiler issues. Right below, we write the dim keyword once at the very beginning. Then we write each variable declaration along with its type declaration. So dim age as integer. After each one, we put a comma to separate each variable type declaration. So age as integer, followed by a comma, then lottery number as integer, another comma, and then sheet count as integer. That way, we can place multiple variable declarations on the very same line. They also do not need to be of the same data type. In this case, they coincidentally are, but you can have a declaration of an integer, and then a string, and then some other kind of data type on the same line. The only convenience here is that you can declare them all on a single line instead of having to split them up over more than one line. Now, there's one common mistake that beginners make whenever they're trying to emulate this syntax in their code. The syntax as it's shown here is completely valid. One dim keyword at the very beginning, followed by each variable and its type declared, separated by commas. However, many times people do this syntactical error whenever they're starting out. They write something like this: dim age, comma, lottery number, comma, sheet count as integer. This is a little bit deceptive because you would think that VBAs would figure out that we want all 3 of these variables to serve as integers. But what's actually going to happen here is that only sheet count is going to be declared as an integer type. Because age and lottery number are not given explicit data types, they're going to assume a data type of a variant. Now, we're going to dive into the variant data type later in this section, but essentially it's a catch-all data type. It's a chameleon data type that can essentially serve as anything: a number, a string, an object, anything. That sounds like it's a really good thing, and sometimes it can be, but it's also very inefficient. If a variable has to be able to represent any kind of data, it has to take up a lot more memory. So we want to avoid the variant data types, the default one, as much as we can to make sure that our program is as efficient and quick as possible. Whenever we don't give an explicit data type with the as keyword, VBA will assume that that variable will store a variant data type. And in this case, even though we think that age and lottery number will be represented by this integer syntax, This as integer syntax is only being applied to sheet count. So we have two variants being declared here and one integer being declared here. This syntax can be very dangerous and can make the program much more likely to run into error. So be very careful whenever you are declaring variables on one line. You have to remember to use this syntax. One thing I like to do is to declare all variables on a single line like this, and then start consolidating them into a single line. So just place a comma at the end and then start deleting the dim keyword from the next line. And that way, if all you delete is the dim keyword, there's no way you can make a mistake because you're still going to keep each variable name and each variable declaration, which is critical. Okay, that's all there is to cover here. We talked about variable declarations, more than one at a time on a single line. That can help us save a lot of space and make our code better looking, more aesthetically pleasing. In this lesson, I want to talk about the option explicit setting. As it turns out, VBA can enforce mandatory declarations for all of our variables. This means that every variable must be declared with the dim keyword before a value is actually assigned to it. Now, we added this setting earlier in the course, but I want to explore it now in more detail because we know a little bit more about variables. So every module that we've created so far, we've seen these two words at the very top, option explicit. If I go up here to Tools and Options, this setting is enabled right here by this require variable declaration check. If we check this option, and that's what I recommended, whenever we create a brand new module, these words will be added to the top of the module. For now, I want to demonstrate how the code is going to work if we remove this option. So I'm going to uncheck this, click OK, and then I'm going to remove option explicit up top here. What I'm going to do here is declare a procedure. I'm going to call it undeclared. And let's say I have a variable here and I'm going to call it my number. And now what I'm going to do automatically is just assign a value to my number. I'm going to make it equal to 15. This is valid code without option explicit, and this is not a good thing overall. Why not? Well, for two reasons. One, we haven't been explicit about what kind of variable type my number is. And whenever there is uncertainty, whenever things are implicitly assumed, there's always a chance of greater error. The more that we explicitly declare variable types, the more that we say to VBA, this is going to be a number, this is going to be something else like a string, the less likely our code is to run into errors. From a human perspective as well, it tends to be better because whenever we read code with explicit variable type declarations, we have a better understanding of what's going on. Sometimes developers, for example, fall into a habit of using bad variable names like X or A or B. And sometimes when we're reading through code and we have no context, we see a variable called X. We don't know what kind of data type it is. We just see it being assigned. Sometimes it may be accidentally assigned to two different data types. First, it's going to be a string, then it's a number. All of those things add confusion to our code and make it more difficult for ourselves when we come back to it, as well as other developers, to understand what's going on. So being explicit about what kind of variables we're using is a good practice overall. It'll make you a better developer. Now, without option explicit at the very top, this is valid code. So I can execute this macro with the F5 keyboard shortcut. Nothing is going to happen here. But again, we're more likely to run into errors. So we want to get rid of this feature. So again, how can we do that? We can go to Tools. We can go to Options, we can select Require Variable Declaration. One thing to point out here is that when we click OK, option explicit will not be automatically added. It's only going to be added whenever we create a brand new module. For example, I can create a new module here, and there it goes, there it appears. So if you ever find it absent, you can actually manually type it in at the very top of the module. So I'm just going to add option explicit here. And now notice what happens when I try to execute the procedure again. If I click F5, we're going to get a big error box pop up, and it says variable not defined. My number has not been declared. It's just been assigned. So VBA is pointing out that mistake to us. That's really beneficial to us as developers because we have this reminder now of, hey, we forgot to declare what my number is. So we can click OK here, say, all right, let me get out of this debugging procedure. I can click the reset button right here to exit out of that little thing. And then I can say, all right, so I know I'm going to need a variable that I'm going to use here in this procedure. I'm going to call it my number, and it's going to be, let's say, an integer for now. We'll dive into this data type very shortly, but that just means a whole number. So now I've declared a integer variable. We know that my number is going to represent a number. We're now assigning a valid number. There's less chance of the code going in the wrong direction because we can't accidentally assign something like a string. So when I execute this, we have no errors, but let's say sometime later, maybe we have a long procedure with 30 lines, and I think my number is supposed to be some kind of string like hello. When I execute this, we're going to get an error. It's going to be a type mismatch, which means that the type that the variable is expecting, which is an integer, is not what we've actually assigned. And that allows us to run into these bugs earlier, figure them out, debug them, fix them, and make the code more likely to run properly when it's actually executed by the end user. Now, I do want to point out that there are some limits to option explicit. Do you remember the code that we introduced in the previous lesson where we declared multiple variables like this, dim age, lottery number, sheet count as integer? So as it turns out, this is not going to be caught by option explicit. Why not? Well, because we're still technically declaring the variables, right? The dim keyword here is going to declare an age variable, a lottery number variable, and a sheet count variable. The problem here is not with the variable declaration, it's with the fact that these age and lottery number variables are accidentally being declared as the variant data type. That's the chameleon data type that can represent any data type. But they're still being declared. They're just being declared, and VBA is implicitly assuming that they're going to be this variant data type. So unfortunately, option explicit will not catch this error. We have to be very careful here whenever we're declaring variables to avoid something like this and make sure that we always declare each data type right next to each actual variable declaration. All right, but that's all there is to cover in this lesson. We talked about the option explicit setting. It should be something you keep with you throughout your entire career as a VBA developer. It'll make you a better developer, and it'll make you a better programmer. It'll reduce the errors in your code. It might be a bit of a hassle sometimes because you're going to get started. You're going to be thinking really quickly, and you're going to just automatically assign a value to a variable. But then when you run the procedure, it's going to warn you and say, hey, I don't know what this is supposed to represent. Make sure you declare it. Make sure you tell me what kind of data it's going to hold, so then I can properly work with it. So option explicit is a setting that you should always keep in your Visual Basic editor. In this lesson, we'll talk about the byte, integer, and long data types. As a reminder, a data type refers to how a piece of data is stored in the computer's memory. We've briefly talked about the integer type of data before. That just represents a whole number. But as it turns out, there's numerous ways that we can store numbers within Excel. There are some minor differences between them that are kind of becoming more insignificant as computers grow in speed and processing power. But I did want to make sure that you understand that there are a couple options available to us and understand why these options exist. As another reminder, VBA does not explicitly require us to have variable declarations or type declarations, but these are both best practices. We always want to declare variables with the dim keyword, and we always want to tell VBA what kind of data type that variable will hold. That makes our programs run faster, that reduces inefficiency, and reduces the chances of error. And with the option explicit setting at the very top, we have mandated variable declaration, which is a good thing to have no matter where we are in our journey as VBA developers. All right, so let's begin by creating a new procedure. I'll call this one assign some values. And in the body of this procedure, all I'm going to do is just assign a couple variable values and output them with the message box method. Let's begin with byte. So I'm just going to declare it at the very beginning. I'm going to call my variable b, just something short and sweet, but you can give it whatever name you want, dim b as byte. So it's spelled B-Y-T-E. B-Y-T-E, or a byte, is still a whole number, but it's the smallest bucket for a whole number available in VBA. So a byte can store any value between 0 and 255. So it's a really small packet of memory, if you will, and so it only supports a pretty limited number of numbers that it can actually hold, only 256. But predictably, the smaller the container, the smaller the amount of memory it takes up. So the byte is the smallest option available to us as a data type whenever we want to store a whole number. Next up after the byte is the integer data type, which we briefly talked about before. That was the one I introduced at first because integer is a very common term in mathematics for a whole number, but it's also an explicit data type within VBA. So I'll declare a new variable. I'll just call it I, again for simplicity, and write out integer. So the integer data type is similar to the byte. It supports whole numbers, but the range of numbers, the total bucket of values that it can support is a little bit bigger. So this one supports any value from negative 32,768 to positive 32,767. So a little bit of a wider range if you want that kind of storage capacity. Finally, the last data type available to us for whole numbers is called long. So let me type it out here, a variable of L. Again, just for simplicity's sake, the variable name is totally arbitrary. And let's declare a long variable. And this is the biggest container for a whole number that is available in VBA. And it supports any number from negative 2,147,484,648 to positive 2,147,483,647. Of course, you by no means have to memorize these capacities. Just realize that the amount that's available grows with each data type, starting with byte as the smallest and long as the biggest, but each one supports a greater bucket of potential values. Now, this used to be a pretty big concern way back in the day, maybe 20 years ago or even further, when computers had a lot of limited memory and developers and programmers had to be very careful that they used the minimum data type necessary in order to store a value. Otherwise, the computer would simply run out of memory and the program would crash. In today's world, obviously computers are much more powerful, and we don't have to really worry about Excel running out of memory when it's doing some kind of calculation like this. It takes a lot of effort and many mistakes in order to actually crash a VBA program. You're not going to run into any kind of error if you store a small value like 5, but you use a long data type instead of a byte data type. So the best practice among the VBA community is whenever you're using a whole number, that means a number without a floating point, no decimal component, no fractional component, most people will just stick to the long data type. Why long? Well, because it's the one that offers the biggest space for your number. A long can still support any number between 0 and 255. It can support anything that an integer can support from negative 32,000 to positive 32,000, but it also has that wider range in both the negative and positive directions. So we pick the data type that kind of allows us to capture any kind of number that we want, no matter the size. Byte and integer are more limited. So you don't have to use long all the time, but that's what I'm going to do throughout the course. And what you're going to find is that that's what you find in most VBA code because it's the most flexible whole number data type that's available to us. Let's now go ahead and just assign some values to these variables. Predictably, because there are data types that are placing constraints, if you put a value that is outside of that range, you're going to run into an error. For example, if you assign b to 1,000, which is outside of the range of 0 to 255, VBA will throw an error. So the other benefit of using long is that there's less of a chance to run into problems. So let's just assign a value to b. That's our byte. Let's do 4. Let's do I, which is an integer between negative 32,000 and 32,767. Let's just do 25,000 for simplicity's sake. And for L, let's do a big number. Let's do 1 million. Pretty wonderful number for all of us. All right, and we can just go ahead and actually output some of these values. We can use the message box method. So once again, message box, let's place a space. There's our prompt parameter that expects a string of what we're actually going to output in our message box. So we can do something like B is, place a double quote there to end the string. As a reminder, this B in there is not actually referencing the variable. This is just the static letter B. What I can do here is use the concatenation operator, which is the ampersand, and then add the value of the actual B variable, and that's just going to add it to the end of that string. I want to show you an interesting functionality here that we may not have seen before. We can actually use what's called a predefined constant here to create an automatic line break. So instead of having everything written on one line in our message box, the content will be broken up line by line. And the way we do that is we write this, VB underscore, that's probably short for Visual Basic, and then new line. Capital N, capital L, no spaces. That creates a line break, but we can continue writing the continuation of the message box expression even at this point. So this is the visual representation of the text. So whenever we see this in the message box, we're going to have a line break at that point. And then we can continue concatenating. So let's say, and I is, do another space. Let's now output the value of the I variable. That's our integer. And once again, let's add another line break. VB new line, capital N, capital L. One more time, we'll put the ampersand, and L is our long. That's our largest whole number data type. Let's output the value of L. When I execute this, once again, by pressing this play button up here or the run button, the message box should appear in our main Excel interface, so it may jump out of the Visual Basic editor. So let's run this, and there we go. We have our complete list. B is 4, I is 25,000, L is 1 million. That's perfect. And that's it. So that's all there is to cover. In this lesson, we talked about the 3 data types that are available for whole numbers. B, or a byte rather, is the smallest, integer is the medium one, and long is the largest one. I prefer, and I think most developers prefer, simply using long all the time. It allows you to store just the largest range of numbers, and we don't really have to worry anymore about memory capacity like developers used to have to worry several decades ago. Computers are simply too fast and too powerful to make that any kind of issue. All right, so that's the numeric data types available for whole numbers, and we're going to continue diving into more data types as we proceed throughout the section. In this lesson, we'll dive into the mathematical operations that are available in VBA. Now, performing basic arithmetic like addition, subtraction, multiplication is a big part of every programming language, and every programming language includes a series of operators to help us perform those operations. An operator is just a symbol that does some kind of operation. For example, the plus sign is the universal operator for addition. So in this lesson, I want to introduce you to some of these operators in case you're unfamiliar with programming and you haven't seen them before. In this brand new workbook, I'm going to create a new procedure in the module I've created. I'm going to call this procedure Fun with Math. That's what we're having here. Let's just make sure it's a parentheses at the end. Perfect. All right, so I'm going to declare two variables. They're just going to be long variables, which means just a whole number data type. So I'm going to call them A and B for simplicity's sake. So dim A is long, dim B is long. We're declaring the variable. We're assigning it a data type, very important best practice. And let's just assign two values to them on the lines below. The variable A is going to be assigned a value of 4, and the value of B is going to be assigned a value of 3. And right below here, I'm just going to issue a series of debug print methods and just give them various mathematical calculations to perform so we can take a look at the operators that are available. Let's begin with addition. I'm sure we've seen this one before, but we simply write debug.print. We can give some kind of expression to evaluate. And the way we do this is simply the first value, the plus sign, and the second value. So the values on the left and the right side of the operator, the A and B, are called the operands. That's O-P-E-R-A-N-D-S. And the actual symbol that we're using is called the operator. That's what's making the impact on those two operands. So the plus symbol is the universal symbol for addition. So this is going to add 4 plus 3 together. Right below, we can subtract the two of them. The symbol for subtraction is the minus sign. So sometimes that's called the subtraction operator, just like the plus sign is called the addition operator. Right below here, we can do a little bit of multiplication. So it's going to be A. The symbol for multiplication in programming is the asterisk. So that's going to be Shift 8 on most keyboards. So this is going to multiply together 4 and 3, should give us a value of 12. And let's just do one more debug print before we run this procedure. Let's do division. The division sign is the /. So this little symbol on the keyboard should be on the bottom right of most keywords. So here we're dividing A by B, which means dividing 4 by 3. So let me just move the immediate window a little bit down so we can see the output of our work. Once again, I have my mouse in our Fun with Math procedure. I can just click this run button up here, and there we have it. 7 is 4 plus 3, that's this thing. 1 is 4 minus 3. 12 is 4 times 3, that's the asterisk operator. And here you'll notice that when we're dividing, we're getting the decimal point value because 3 does not go evenly into 4. I want to show you two more operators before we conclude this lesson. The first one is the exponentiation operator. So that's whenever you need to have a number and multiply it to the power of something. So for example, if I do debug print, and I do A, and the symbol here is the upper caret. That's going to be Shift 6 on our keyboard. So what this means, remember that A is equal to 4 and B is equal to 3. This means 4 to the power of 3. 4 to the power of 3 in mathematical terms means 4 times 4 times 4. So again, it's the first number times itself, the number of times that we see represented on the right side of the caret. That's what exponentiation is in mathematical terms. So this is going to be 4 to the power of 3. 4 times 4 times 4 should give us 64. We see a whole bunch of output because I didn't clear my earlier stuff, but let me go ahead and do that. Let's once again execute this procedure. And there we have 64 appear at the very end here. Finally, one other thing I want to show you. This is probably the most unfamiliar one for people who aren't too experienced with programming. It's called the modulo operator, or modulus sometimes. So debug.print A, and this is actually an operator that's written like a keyword. So there's no symbol for it. There is a symbol for it in other programming languages, but in VBA, we use the keyword mod, and then we actually place the second value to the right of mod. So what modulo or modulus does, it's sometimes called the remainder operator. What it does is it returns the remainder of an operation. So if we were to take A, which is 4, and divide it by B, which is 3, it's going to return the remainder of that operation. So 3 goes into 3 evenly, and then there's 1 left over if we're trying to fit 3 into 4. So the modulo of this operation is going to be 1. 4 modulo 3 means how much value is left over once we complete all the division that we can. So when I execute this, we're going to get a value of 1. So there's 1 left over when we divide 4 by 3. If 4, for example, was 7, that would be a modulo result of 1 again. If it was, let's say, 8 modulo 3, 3 goes into 6, and there's 2 left over, so 8 modulo 3 would be a result of 2. And if there's no remainder left over, then the result is just 0. So if we have a number that's evenly divisible, for example, 9 modulo 3, 3 goes into 9 evenly, so the remainder is 0, so the modulo operation returns 0. All right, that's modulo. It usually goes hand in hand with division, but it kind of is interested in finding out the remainder rather than the actual number of times that one value goes into another. So these are the basic mathematical operations that are available in VBA: addition, subtraction, multiplication, division, exponentiation, and modulo. Get familiar with some of these symbols. Try practicing them a lot. A good recommendation I have is to actually write values onto your Excel spreadsheet, then try referencing them with the range, and then trying to actually perform calculations by referencing those actual pre-existing values rather than manually defining them here in our VBA. But that's all there is to cover here, so I'll see you in the next lesson. All right, so in the last lesson, you may recall that we divided 4 by 3, and we got a floating point number as a result. As a reminder, a floating point number is just a number with a decimal or fractional component. So let me execute the operation that we did in the previous lesson in the immediate window. We took 4, and then we used the division sign, which is the /, and we divided 4 by 3, and we got this result right here, 1.33. So we have a decimal component here, so this is no longer a byte or an integer or a long data type. So the question is, what kind of data type is it? Well, as you may recall, we have a type name method available to us in VBA, and type name can accept an input and actually tell us what the data type of it is. So let's go ahead and execute that in the immediate window. I'm going to put another question mark, type name, capital T, capital N, and let's give it the entire operation of 4 divided by 3. Everything within the parentheses is going to be evaluated first, so this is going to evaluate to our floating point number, and that's the argument that we're actually going to feed to type name, and we find out that this kind of data type is a double. And that brings us to the subject of this lesson, which is the single and the double data types. Both the single and the double are used for floating point numbers. The double is actually a little bit more precise. So much like long is used universally to represent whole numbers or integers, the double data type is used basically universally whenever you need to store a number with a floating point component. It's simply more precise and more accurate, so it's very rare that you're going to see singles used in the code. Again, the only advantage to using singles is that they're a little bit less heavy on the memory, but in today's day and age, it's completely irrelevant. So we're going to be sticking with double throughout the course whenever we need a number with a fractional component. Let's go ahead and take a look at this variable declaration in practice. I'm going to define a procedure up top. Let's explore a little bit more math. I'm going to create a procedure called calculate circumference. As a reminder, the circumference of a circle is determined by the formula 2 times pi times its radius. I don't have that committed to memory. I actually have to look it up. But we can see how we can use VBA to calculate this mathematical formula for us as an example. So the first thing we have to declare here is pi. Pi is that static value of 3.14159, and it goes basically to infinity. So we can declare a variable called pi. We once again create a variable or declare it with the dim keyword, followed by the name we want to give it. I'm going to call it pi. We then use the as keyword, and finally the data type. So as I mentioned, we're going to be sticking with double throughout the course. There's really no reason to use single nowadays. On the line below, we can actually assign a value to our variable. VBA is now expecting it to be a floating point number, so it's not going to have any issues processing it. It's not the wrong data type. So let's assign it 3.14159. Below, I want to assign an arbitrary radius, and this time I can actually use a whole number. So I'm just going to use a long. That's the best data type that we have for storing a whole number. So I'm just going to call the variable radius. This time the as is going to take the long data type. And let's give the circle a radius of 5. All right, so now we have two data types. We have a double for floating points, and we have a long for whole numbers. Let's now define a circumference variable. And the circumference, of course, is going to be the result of a mathematical calculation that includes pi and radius. So what is that going to evaluate to? Well, whenever we multiply a double and a long together, the result is always going to be a double, which sort of makes sense because we want to preserve whatever fractional component is part of that number. So when we have that 0.14159 section, when that's multiplied by 5, we want to retain that fractional component rather than throwing it away. So circumference, we want to make that a double as well, a floating point number. I think I may have an extra space. Nope. All right. So circumference, let's assign that variable. It's equal to 2. times pi, and we can use the asterisk for multiplication, and we can use it more than once in an expression. So 2 times pi times radius, which is great because this is now starting to look like an actual mathematics formula, closer to an actual procedure that does something, which is great. There's 2 things that I want to do here. The first is to use debug.print to output a value to my immediate window. And I actually want to output the value of the type name evaluation of circumference. The reason I want to do this is just to prove to you that circumference is going to be a double, as we predicted it would be when we multiply a floating point number times a whole number. Below, we can actually use another method. Let's do message box, and let's do message box to output the value of the actual circumference to our Excel interface. So I can begin with a message for my prompt like the circumference is, let's put a space in here so there's a space between there and the actual value. In order to concatenate or add on a value to the string, we can use the ampersand operator or the concatenation operator. We can write the value of our variable circumference. I want to point out, just in case it isn't clear, that this circumference is what's actually referencing the variable value right here, which has a numeric value now assigned to it. This circumference is just the literal text circumference that's going to appear in the string. Let me go ahead and clear this. So we're going to see one thing in the immediate window and one thing in our Excel interface. So let's execute this with a pi of 3.14159 and a radius of 5. Our circle has a circumference of 31.4159. Take a look at it. It is a floating point number, so it is a double. When I click OK to go back to my VBE, there we have double listed in my immediate window. That's this type name evaluation right here. All right, so that's an introduction to the single and double data types in VBA. Both are used to represent floating point numbers. Stick with doubles because they are more precise and more accurate. There's really no reason to reduce memory in today's landscape. Similarly to that, you should always use long for whole numbers, or integers as they're called in mathematics. All right, that's all there is to cover here. I'll see you in the next one. In this lesson, we'll take a look at the string data type. As we know by now, a string is simply a collection of characters, and that can mean anything from letters to numbers to symbols like the exclamation point or the $sign, any combination of characters, any way that you want to represent text. A string is the best data type to do that. Now, VBA actually supports 2 types of strings, fixed length strings and variable length strings. Fixed length strings are declared with a max number of characters, so they have essentially an upper boundary or a limit. They can only hold a certain number of characters. In comparison, variable length strings can vary. That's where they get their name from. They can hold any number of characters. In fact, when they're reassigned, they can go from 5 characters to 100 characters to 0 characters, and VBA won't run into an issue. In fact, variable length strings can actually hold up to 2 billion characters at once. I doubt you're ever going to need to use that in your business needs, but just know that as an interesting fact. So let's go ahead and explore these 2 strings in the context of a procedure within my Visual Basic editor. I'll define a procedure here. I'm going to call it 2 types of strings. And at the very top here, I'm going to declare 2 variables. One is going to be a fixed length string, and one is going to be a variable length string. Let's begin with the variable length. So I'm just going to call this variable name. And the syntax is going to be the same as declaring any type of data. Dim followed by the variable name, followed by as, followed by the data type. In that case, it's string. So if we just use this syntax, this is going to be variable length, which means it can hold any number of characters. Right below here, I'm going to do fixed name, and the syntax for a fixed length string is going to be just about identical. We still write the exact same declaration. However, we tack on a little bit of extra syntax at the end. We add an asterisk, which is Shift 8 on most keyboards, and that's the same symbol as the multiplication operator. And then afterwards, we actually write the number of the max characters, so the upper boundary or the limit. What is the max number of characters that we can fit in this string? And I'm going to put that at 10, and you can put whatever number you'd like here. So what I'm going to do in both of these variables is just store my first name. My first name is only 5 characters, so both of them should handle this data type very easily. So what I'm going to do is assign variable name to my first name of Boris, and fixed name is Boris as well. And what I'm going to do is just debug print this to the immediate window, so we can take a look at how it looks. And we're going to see absolutely no difference. In this context, it doesn't matter which one we use because only the fixed length string is limited to 10 characters, but we only have 5 here, so they operate exactly the same. However, let's take a look at what happens when I give it a value that is significantly greater, like my full name, which is much more than 14 characters. It's totally fine to use the syntax again because variables are subject to change. That's why they're called variables. They vary. So you can go ahead and redefine, or rather reassign, a brand new value to an existing variable. So I'm just going to reassign a new value, and it's just going to be my full name instead of my first name. After that, I'm just going to copy this code above because I want to debug print the results as well. Remove some of these extra line breaks, and let's execute again with F5. And now we're going to see a bit of a different result. Again, here is our first output, no difference there. However, in our second example, we are crossing over that boundary of 10 characters in my fixed length string. It's limited to 10 characters. So what's going to happen is VBA is going to cut off the remainder of the string. And this can be particularly helpful. A real life scenario, for example, where you might need to use this is if you're doing something like truncation. If you have a big field of text, for example, and you only want the first 30 characters so you can cut the rest of it off, you can simply declare a fixed length string, and that can be used as a storage mechanism for something like a cell's value, and it'll automatically cut off that unneeded extra text. Now, some of you might be curious as to why this string is ending right here. After all, Boris has 5 characters, and these first 4 characters, P-A-S-K, that's only 4. So 5 plus 4 equals 9. So why are we cutting it off there? The answer is because, remember, everything in a string counts as a character, and that includes spaces in the middle. We don't see spaces, but VBA does. So this is a valid character. So 5 plus 1 plus 4 brings us to a total of 10, and at that point, VBA just starts cutting off the rest of the string. All right, that's all there is to cover in this lesson. We talked about the 2 types of strings, which are variable length, which can expand to any size, as well as fixed length, which are limited to an upper boundary or a limit, which you could set in the declaration. All you have to do there is just provide the asterisk followed by the actual number that you want to set. Throughout the course, we're primarily going to be sticking with variable length strings, just like the long data type for whole number and the double data type for floating point numbers. This is just the simplest way to deal with strings because we don't have to think about boundaries and limits. So we're going to be sticking with this syntax throughout the course, but I did want to make sure that you are exposed to both. That's all there's to cover in this lesson, so I'll see you in the next one. In this lesson, we'll talk about the Boolean data type. The Boolean data type is actually named after the English mathematician George Boole. So if you haven't heard the term before, that's totally fine. It's typically used by developers and scientists and the like. It's not really as common a term as something like integer. A Boolean is a special data type that can only be one of 2 values. It's either true or it's false. That's it. There's no other possibilities, just true or false. Booleans are a really great choice whenever you need to model a relationship that is either or. Either this or that. For example, something can be either true or false, or it can be either on or off, or it can be either present or not present. Whenever you have that kind of relationship, there's only 2 possible values, and they're the polar opposite of each other. A Boolean is the perfect data type to represent that kind of relationship. There are many properties available across objects in the Excel object model that return Booleans. For example, if we reference the active workbook, which just returns a valid workbook object. As a reminder, active workbook is a property on the application object, which returns the workbook that is currently selected or active. So if you only have one workbook open, by default, it's just going to return that one, but it's a workbook object at the end of the day. Every workbook object has a property called saved. Saved is just a reflection of whether the workbook is saved or not. So we're starting to see that relationship of either or. So when we execute this, we're going to get a return value of false. And this is not a string of false, this is a Boolean data type, and it's telling us that this active workbook is not saved, right? So it's an either on or an off switch. As another example, on every workbook, we also have a property called has password. Has password, again, is an either or relationship. A workbook either has a password or it does not. There's no other options besides that. It's not like a number where we have an infinite number of numbers, or a string where we have an infinite number of characters that we can combine together. This is just either true or false, on or off. So does this workbook have a password? The answer is false. That means it does not. So this is an example of a Boolean data type, just true or false. And just like these Boolean data types are assigned to certain properties, we can also declare variables in our procedures that hold this kind of data type. Let's take a look at that within this brand new module in our workbook. I'll begin by declaring a procedure. Let's call it my first Booleans. Let's put some parentheses at the end, line break. And the way to define a variable with a Boolean data type is the same as always. We begin with a dim keyword followed by the variable name. I'm just going to call it my bool. The as keyword to define the data type, and then we just write Boolean. So capital B, there's 2 O's in there, L-E-A-N, all right? And below, I can define a value for the myBool variable, myBool, and it can be either true or it can be false. You can even see the drop-down options appear. Notice that true or false is not going to be written in double quotes because double quotes means a string. True or false is a built-in data type, so VBA is automatically able to recognize this as a Boolean. Do not put double quotes in there. Also notice that the first letter of the Boolean, either the F in false or the T in true, is going to be capitalized. So we're setting this myBool variable to false. Let's just do another example below. Let's do something like a variable called VBA master as Boolean. Same syntax. Below the declaration of the variable, we can actually give it a value. VBA master equals true. Usually whenever we're going to be writing real procedures, something that actually has a purpose in real life, Booleans are going to be used to track the status of some kind of operation. So Booleans are kind of going to be given an initial value, and then we might perform some kind of procedure and switch the Boolean to another status if we observe something along the procedural steps that we're taking. But in this lesson, all I really wanted to cover is the declaration syntax for Booleans and give you a big picture overview of what it is. It's just a data type that represents a relationship that is either or, true or false, on or off, yes or no, that kind of deal. Many different properties on different objects have this Boolean data type, and we can also declare it just like any other data type within our code. We're going to see some examples later on in the course of how we can actually use it whenever we're doing some kind of procedures or operations with our actual worksheet content. In this lesson, we'll take a look at the date data type, which is used to represent dates and times in VBA. Now, whenever you're writing a date data type, it must be enclosed in hashtag symbols, both at the very beginning and at the very end. On most keyboards, you'll find the hashtag symbol by pressing Shift+3. And the date object is actually a pretty versatile object. It can handle a pretty wide range of years, almost 10,000 of them, going all the way back to January 1st, 100 to December 31st, 9,999. So a pretty big span of time that you can cover with the VBA date object. It's a little bit more expansive than Excel's date functionality. And the other cool thing about dates is we can declare them in a variety of formats because Excel and VBA are going to standardize them. It's able to recognize many different varieties in which we can write our dates, and it's always going to try to figure out how it can convert it to a more standardized format. Let me give you a few examples here. I'm going to create a new procedure here. I'll call it fun with dates, parentheses, close, open and close. Right here, I'm going to declare a variable. Let's call it birthday. Once again, the as keyword to declare a data type for my variable. This one is date, capital D. All right, so now birthday is expected to be a date variable. Let's go ahead and try assigning dates in a variety of formats to this variable. So I can begin with birthday. Remember, hashtag has to begin every single date that we declare. Even though we've declared the variable type, Excel needs this syntax to be able to function properly. So the first way we can do it is very much how we do it in the front end or the main interface of Excel. We can write the month followed by a /, the day followed by a /, and the year. So my birthday is April 12th, 1991. This is one way we can represent it. And remember, at the very end, I should put that extra hashtag. It's actually called an octothorpe, technically, at the very end. And that kind of encloses the date and allows the VBA interpreter to parse what it is that we're writing. So this is one way that we can declare a sample date of April 12th, but it's not the only way. For example, on the line below, I can reassign a brand new value to my variable. That's totally valid because variables vary. Their values can change. I can also do something like this. I can write 12 for my day of the month, followed by the full month written out, April, and then the year, like so. And this will work as well. One recommendation that I have for you is whenever you're writing your years, make sure to always use 4 digits when representing years. The reason for that is that Excel might get confused if you only use 2 letters, or 2 numbers rather. It might start thinking that it's in the last century or the current century. For example, if I put something like 36, Excel might think it's 1936 or 2036. The safest way to be careful is always just to put all 4 digits, and that will ensure that you don't run into any errors. Here's another way that we can write a date in VBA. On the line below, I'll do birthday. I still need to do the hashtags. Those are a consistent standard no matter how we're writing our dates, but I can also write out the full month like April 12th, 1991. Hashtag. You'll also notice on the line above, it's automatically been converted to the standardized format. And the same thing's going to occur when I press enter here. you'll notice that VBA is going to parse the way we wrote it and convert it to a standardized date. And it's configured to try to recognize as many possible date formats as it can so that it can always drive it to this standardized format. So you can either enter it in the way that it expects or enter it in any kind of conventional date scheme, and it's going to try its best to convert it. So you can see those 3 different variations have automatically been converted to the standard one right here. All right, and now we have a valid date, so we can go ahead and do something like output it to our spreadsheet. So I can do range A1 value. Let's put the value of birthday right there. Let's go ahead and run this procedure. I'm going to use my keyboard shortcut this time. I believe it's F5. Yep, F5. Let's go ahead and run this procedure, F5. And there my date appears in cell A1 in the traditional Excel format. That's the month followed by a slash, the day followed by a slash, and the full 4-digit year. I can use the date data type as well to represent times of the day. So right below here, I'm going to declare a new variable. I'm going to call it lunch. I'm still going to give it a date data type. Right below here, I'm going to assign a value to lunch. As always, we begin with the hashtag. And this time, I'm not actually going to give it a date value. I'm just going to give it a time. I'm just going to write 12:30 space PM. So that's 12:30, 0 seconds into the minute. That's what the last 2 zeros are there for. And each section, the hours, the minutes, and the seconds are separated by a colon. That's a conventional syntax, followed by a space and PM or AM. You can see there's no kind of standardization going on, but this is totally a valid syntax. And what I can do right now is, let's say, write in this value into range A2, let's say. So range A2 value, let's write in lunch in there. Let's execute this with F5. And there we can see 12:30 has appeared here as the time. What we can also do is, of course, combine dates and times. So let me declare one more variable here. Let's do sum event, also going to be a date. Let's assign a value to the sum event variable. Let me also scroll down so we can see this a little bit easier. Sum event equals hashtag, and we can combine both of these syntaxes. So I can do something like, let's do June 30th, 2015 at 9:25:36 space AM. Close everything with the hashtags. That's a pretty conventional way to write a date and a time. Now let's go ahead and write this value to cell A3, range A3 value equals sum event. Execute this. And there we see the complete date with the time written out. So this singular date object can represent date, it can represent time, and it can represent both date and time. Of course, right now we're not doing anything particularly useful. We're just kind of writing it to the sheet. But you can imagine what we can do with this feature as soon as we have something like a spreadsheet full of dates. We can take them, we can manipulate them, we can add time, subtract time, find out the certain day of the week, things like that, and then write that value back. Do some kind of processing or analyzing of the data we have using all of the date functionality that's available on this object, which we'll explore a little bit later. But that's the date data type, yet another option available to us among our many data types. And that's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the variant data type, which can be used to store any kind of data type. In fact, a variable that's declared as a variant can store a number and then be assigned a Boolean and then be assigned a string, and no errors will be raised by the program. A variant is sort of like a chameleon. It can morph into whatever data type is needed by the program. A variant is also the default data type for all variables that we declare without a specific type. So it's what VBA relies on to be able to gain versatility and flexibility with a variable that the user has not explicitly defined to have a data type. As it turns out, we can also explicitly tell VBA that we want a variable to serve as a variant data type. A common question that people have is, if variant is so flexible, why not just use it all the time for every single variable? There's 2 reasons why we want to avoid this. The first is memory allocation. So when we have this flexibility and this dynamic nature to a variable, behind the scenes, VBA needs to take up more memory to represent this data type that can basically be anything. Now, some VBA developers say, again, in today's day and age, with the speed of computers, that memory usage isn't really a big concern. With that said, even if that's true, we want to get into the practice of establishing these best practices and these good habits. The more that we explicitly use the kind of data type that we want for a program, for example, saying that a variable will be explicitly an integer or a long instead of a variant, the more that we kind of makes logical sense in our brain how the program is designed to work. The program becomes structured a little bit better and a lot easier to understand and debug, especially if you can imagine another programmer reading your code. If every single variable that we declare is just a variant, how are they to know exactly what each variable is supposed to represent? In comparison, if we tell them that something is a long, they intuitively have a sense that the variable is going to be storing some kind of number, so some kind of numeric representation. So a variant makes the program less logical and more difficult to debug later. So it shouldn't be used just kind of haphazardly whenever you want to, but it does have certain use cases. For example, whenever there is uncertainty about the data that is being stored in a variable. For example, you might ask the user for input, but you might not be sure how the user is going to give you that value. They may enter a number, they may enter a string, they may enter something else. And whenever you want a data type that is flexible enough to adjust to any kind of uncertainty, that's what variant is perfect for. Let's go ahead and define a procedure here in my Visual Basic Editor. I'm going to call it chameleon. And what I'm going to do here is just define a variable or declare a variable called a. And a is going to be a variant. Now, as we know by now, if we don't give a variable a data type, if we leave out the as keyword, VBA is going to assume that the variable is going to be a variant. So this is enough, but let's go ahead and be explicit here by writing as and writing the actual variant keyword, just like we would for any other data type. So a now is variant. It can store anything we want. So for example, I can assign a Boolean value to a. And what I'm actually going to do below here is I'm going to use debug print, and I'm going to rely on a method we talked about a little bit earlier called typename. Typename is a built-in method or function that accepts some kind of variable, and it's going to tell us what data type that variable is currently. So I'm just going to give it a. And if we execute this procedure right now with F5, we can see in our immediate window that right now a is being represented as a Boolean. Notice that we declared a right here as a variant, but variant is a flexible data type that can adjust to whatever we need it to be. So right now at this stage where a is equal to true, variant has evolved or morphed into a Boolean data type. Let's continue this process and assign something different to a. Let's now assign a long or an integer, let's say the number 5. If I repeat the exact same process and I ask for what the data type is of a at that juncture, if we execute this now, we're going to see a totally different value. We can see that now the variant has morphed from a Boolean to an integer. So it's dynamically adapting, almost like a chameleon, to store whatever is needed. If I continue this logic onwards, let's say I change it to something like a floating point number like pi 3.14. Let's just debug print that. And right below here, let's go ahead as well and give it an actual string value like hello. And once again, debug print type name, give it the value of my variable. We're going to see 4 completely different values here when I execute with F5, Boolean, integer, double string. So that's the whole point of a variant. It can adapt dynamically, flexibly to whatever we need it to store. Again, this isn't something that you should use all the time. It's a lot of power to behold, and you might be tempted to say, okay, this is great. I don't have to worry about thinking about what it is that I'm actually going to be working with in my program. However, as I mentioned, that's not a best practice for developers. You do want to think about what each variable is going to be storing. You need to think about whether a variable is necessary in your program. You need to think about how its value is actually going to be calculated. So variant is sort of like a little bit of a cheat tool. It seems like it makes things easier, but it really burdens you and makes it more difficult for you to become a better developer and actually have to more critically assess how your program is going to run. So avoid using this data type unless it's necessary, unless you can think of a situation where you're not actually going to know what a variable is going to store. And in that case, when you need that level of flexibility and versatility, at that point, you can stick with an actual variant data type. So far in this section, we've explored a lot of different data types. We've taken a look at longs and doubles and booleans and dates and variants and so on. As it turns out, we can actually declare variables that represent objects within the Excel object model. So we can actually have variables that reference things like worksheets and workbooks and ranges. The reason we might want to take this approach is because it simplifies the process of creating references. Rather than having to write out a complete reference each time, we can have a variable represent that relationship and then rely on the variable to establish that association. Let's take a look here in our actual VB editor. I'll begin here by declaring a procedure. I'm going to call it object variables. The syntax for declaring a variable that's going to represent an Excel object is pretty familiar. It's going to be the dim keyword followed by the name of the variable. Let's say here I want to represent a Excel workbook object. I have to first come up with a variable name. Let's do WB, then the as keyword. And here, instead of putting one of our familiar data types, I'm actually going to put an actual object within the Excel object model. So we know we have the concept of a workbook, so I can simply enter workbook. As another example, let's say I want to create a variable that's going to represent a worksheet object. Let's give that variable a name of WS. Once again, we're going to use the as keyword and then the type of object that that variable is going to reference or represent. So this time we're going to have a worksheet object. One more example, let's say I want to have a variable that's going to eventually be storing or referencing a valid range or a collection of cells. So let's call that variable box, and it's going to represent an Excel range object. So as, and then the exact name as it is in the Excel object model, range with a capital R. So now we've declared the variables, but we still haven't assigned them actual values. The way we do that is a little bit different when it comes to objects. We're still going to use the equal sign. However, this time we need to prefix our variable name with an additional keyword, and that keyword is set with a capital S. So let's assign the WB variable. We have to use the set keyword, and this is only when we're assigning an object. You don't need it if you're doing a plain data type like a Boolean or a long or a string. But whenever it's an object, you must use the set keyword before the variable. So set WB equal, and remember that this has to be a valid workbook object. So how can we get a workbook? Well, we know that workbook objects are stored within the workbooks collection. So if I target the workbooks collection, and let's say I take out the first workbook, which is the only one we have open here, this is a valid syntax. And what this is going to do is assign the workbook object, the only one open, to the WB variable. Now, the object that's represented on the right side of the equal sign has to be the exact type of object that we told the variable it should expect. So WB expects to be a workbook. So if we give it something like this, which is a workbooks object, this is going to throw an error when we run the macro. It has to be the right type of object. So now we're referencing a workbook. That's exactly what WB is declared as, so we're not going to run into an error. Let's say I now want to set the WS variable, which represents a worksheet, to the only worksheet I currently have, which is sheet 1. How can we do this? Well, the first way we can do it is doing something like this. Set, again, WS, that's our variable, equals, and let's say I target the first workbook I have open. Within that workbook, I have a worksheets object. That's a collection object. We can index into it to extract a specific worksheet, and that's going to get us sheet 1. Now, this is completely valid. There's nothing syntactically wrong, but if you take a look at this line and the line above, you should see some duplication, which is that we're consistently referencing the first workbook in the workbooks collection object. We don't need to do that because if you think about it, this WB variable is already pointing to that workbook. It already represents that object. So how can we simplify the syntax? What we can realize is that this is the exact same object that the WB variable is pointing to. So we can actually replace this workbooks1 syntax with WB. You can almost think of it as a find and replace operation. Whenever VBA is going to run into the variable WB, it's going to figure out what it means and what it's storing, which is going to be a single workbook object, and that's what's going to be substituted here. So hopefully this is going to give you a sense of how variables can be beneficial when they're pointing to Excel objects, which is that it allows us to write a lot cleaner code because we don't have to write those references each time. Let me give you another example with box. So let's say I want to set box to a valid range object. I can, of course, do something like workbooks. And then let's say I want to reference the first one. And then within there, I want to reference the first worksheet. And then I want to reference a range with the cell of B2. This is totally valid. There's nothing syntactically wrong with this. But again, workbooks right here is being represented by WB. But even better, this worksheet that we're extracting right here, this is already referenced by WS. WS is relying on WB's knowledge of which workbook it is, and WS is simply going one step further. So if we replace everything here, this first section right here, we can take that and replace it with WS. Because remember, WS knows what workbook it's referencing, and now the variable is just going to be substituted with that worksheet. So now our syntax is a lot cleaner and a lot lighter, and we've accomplished the exact same result. And all of these are now properly referencing the exact object types that we've declared for the variable. So we can actually do things with them. For example, with a workbook, WB is a valid workbook object. We know that a workbook object has a name property, so we can execute this and see that we're going to get the name of the file. That's proper. This is only to demonstrate that we're not running into any kind of syntactical error or any kind of bug with our code. WB is actually referencing a valid workbook object because we've extracted it right here from the workbooks collection. Similarly, we know on a worksheet object, which is what WS represents, we have a name property. That property can be given a new value to overwrite the name of the worksheet. So let's say we want to change sheet 1 to, let's say, fun times. We can execute this. When I execute this, we can see the value has changed right here in my Excel interface. And finally, let me give you one more example. We know that box represents a valid range object, specifically the range of cell B2 on this worksheet now called fun times. So what we can do is say box, that's a valid range object. So anything that we see available here is going to be methods and properties on range. We know that range objects have a value property, so we can set the box's value or the range's value to something like 5. This is cell B2, so it should appear right here when I execute this macro. And there it is, there's number 5. So we've used variables in this lesson not to store plain kind of primitive data types, smaller things like numbers and strings. We're now using these variables as pointers to refer to these valid objects in the Excel object model. As you can see here, it allows us to write code that is a lot more concise because one variable can retain a reference to its parent, for example, and know exactly what it is that it's referencing in that hierarchy. We don't have to write that fully qualified reference each time and specify where we are in the workbooks, where we are in the worksheets, etc. And right now, we only explored 3 different objects, but you can actually declare a variable to be of any Excel object whatsoever. So as we explore more objects throughout the course, feel free to experiment and set a variable to any one of those objects. You can manipulate that object and perform the same kinds of methods and access and overwrite the same kinds of properties, but instead of providing the full reference each time, you can simply rely on the variable that's pointing to that object. In this lesson, I want to take a look at default values for declared variables. So as we know, the dim keyword instructs VBA to set aside memory for a variable. As it turns out, when a variable is declared, VBA actually assigns it a default value. So before we use the equal sign and give the variable its actual value that we want to give it, VBA automatically assigns it a predefined value. And the kind of value that it grants is based on the data type. For a string variable, that's going to have an initial value of an empty string. For long and double variables, those are going to initialize to a value of 0, and Boolean variables are going to initialize to a value of false. Let's take a look at this in the body of an actual procedure. I'll define a procedure here called default values, and I'm just going to declare a couple of variables up here. Let's create a string. Let's make it the variable s, dim s as string. Let's do a long. I'm going to use L for that. Dim L is long. Let's do a double. Dim D as double. That's a floating point number. And finally, let's do a Boolean, dim B as Boolean. Short and sweet variable names. So, as I mentioned, we haven't assigned any values to S, L, D, or B. So what's going to happen when we actually debug print them out? Well, as it turns out, VBA is actually going to assign them default values, and we can take a look at what those are below. So let's output each one of those variables and execute with F5. There we go. Right here, we're not seeing anything, but that's because it's an empty string, and an empty string is represented by white space. That's the actual output of this debug.prints. That's a string. So a string variable initializes or is defaulted to an empty string. No spaces, no characters, no numbers, nothing. Any kind of numeric variable like L or D, which is a long and a double, a whole number and a floating point number respectively, those are given an initial value of 0. And a Boolean variable, here we store it in B, is given an initial value of false. So we have to be very careful here because if we're ever running into code or bugs, it might be due to this issue that we forgot to give a variable its default value, or rather our own assigned value. Many times we may be declaring a lot of variables at the top of a procedure, like 10 or so variables, and we may forget to assign a variable its initial value that we want to give it. And later on in the code, we may use it, and we may not encounter any kind of immediate bug because that variable is storing a valid value that can actually work in the context of our code, but it's not going to function as intended because the value it's storing may not actually be what we expect it to be. We're not going to run into any kind of error if we, for example, use S, L, D, or B in some kind of calculation because it does have a valid value. It's just not what we're exactly looking for. So we have to be careful. Just remember that whenever you declare a variable, it is given a default value. Empty strings are assigned to the string data type. A 0 is assigned to the long, double, and any other kind of numeric data types. And a false value is assigned to the Boolean data type. In this lesson, we'll take a look at the concept of scope, which describes the boundary or the context in which a variable is allowed to be used in our VBA program. There's actually three types of scope available: macro scope, module scope, and application scope. And again, these just define the boundaries in which a variable is available to be accessed by us. Let's take a look at the simplest example, and that should help clear things up for us. So I'll begin by declaring two procedures here. The first one I'll call procedure A, and the second one I'll call procedure B. And in my top level procedure, I'll declare a variable. I'm going to call it mynum. I'll make it a whole number, and I'm going to assign it an arbitrary value, let's say 10, and then just debug print it out to my console or my immediate window. And right here below in procedure B, I'm going to do something interesting. I'm going to try to debug print the value of mynum again. So let's go ahead and try this. I'm first going to click into procedure A and execute this. Let me see what's going on here. This is actually debug print. When I click into here and press F5, we're going to get the value of 10. Everything looks great. And you might think that when I execute my code right here, procedure B, you might think we're going to get the exact same result in the immediate window. But instead, we're going to be greeted by a compile error. We can see here variable is not defined. So when I click OK here, I'm going to be launched into this debugging mode, which we can immediately tell we're in by this presence of this yellow line. We can exit that mode by simply clicking the blue reset button. And we can see here that VBA is struggling with this mynum right here. So how come it's running into this issue even though we declared mynum up here? Well, that's exactly the answer. We declared mynum in a totally separate procedure, and variables that are defined or declared in the body of a procedure are scoped to that procedure. What that means is they don't extend outside the boundaries of that procedure. What's actually happening here is whenever we run procedure A, after all this code is processed, VBA is going to take the mynum variable and completely throw it out of memory. It's not going to exist. So by the time we get here, VBA has no clue what mynum is. That variable is scoped to or limited to or bound to the confines of the procedure in which it is invoked. That can actually be advantageous for us because we can do a brand new variable declaration in procedure B and use mynum again. So we can, for example, copy this code. And let's say right here, we can make mynum equal to something like 50. And now when I execute these two in sequence, we're not going to run into any kind of problems even though we declared the same variable twice, because each variable exists within its own boundary, within its own procedure. So when I execute this with F5, we're going to get 10. And when I execute this here, we're going to get 50. In fact, because each variable is bound to its own procedure, we don't even have to give it the same data type. It completely exists in its own separate world. So if for some strange reason I wanted mynum to be a Boolean here, I could totally do that. I can make mynum a Boolean. I could assign it to true. I can execute this right here, F5, and you can see right here, we're going to get a value of true. And VBA is not going to run into any kind of error. It doesn't care that's a long in one and a Boolean in another, because both of them exist kind of in their own sandbox, in their own playground, in their own kind of bound place where they can be used. That's what we mean by scope. It's the boundaries or the context in which a variable is allowed to be used. And this one, of course, is called the procedure scope or macro scope because it's limited to the macro or the procedure in which it is actually defined. There's actually two more available for us. So let's take a look at the second one now, which is module scope. As the name suggests, a variable that has module scope is actually going to be available to all procedures within the current module. So right now, our workbook only has one module right here, module 1. So we can declare a variable that all of our procedures can use. For example, up top here, what I can do is actually declare a variable outside of any procedure. I'm going to do it right in the module body. So for example, if I want to do mynum right here, mynum as long. What that's going to do is declare a variable mynum that is going to be available to be used by any procedure here. And it's going to retain its value even after that procedure is done executing. The one big caveat here is that we can't define or give mynum an initial value outside of a procedure. So all we can do is declare it and give it a data type, but we can't actually do something like mynum equals right here. We can only do it in the body of a procedure. But let's take a look at how we can do that. Right here in procedure A, I no longer need this code. So what I can do is get rid of this. Let's say we assign mynum equal to 10 and then debug print it. And what I want to do here is change this. Let's debug print mynum again. And let's change mynum now to another number. We have to now follow that constraint because this is the one that's ultimately going to take precedence. So it has to be a whole number. So let's change it to something like 25. Let's get rid of my output below. I'll first begin by executing procedure A. And this result should be pretty predictable. So we're going to get a value of 10. That's not a problem. So what happened here is we now have a variable called mynum. It's available on the module level. We're finally assigning it a value in procedure A, and then we're outputting it that value. Now, as soon as procedure A is done executing, mynum is still in memory. Unlike variables that are defined in the actual body of a procedure, module level scope means that the variable will be preserved. So mynum is still in memory, and it's still equal to a value of 10. We can prove that by executing procedure B. Right at this point, mynum is still going to be equal to 10, so we're going to see that number, then we're going to reassign it to 25, and then see the new value. So when I execute F5, we can see this second 10 is coming from procedure B because mynum has already been assigned that value. So what module scope allows us to do is declare a variable that is used across multiple procedures. This is especially helpful when multiple procedures are going to be modifying some kind of variable if you need them both to be targeting the exact same object or the same kind of program entity. You can declare that variable outside of a procedure to make it module level. In fact, a really good application of this may be something like a Excel VBA object. For example, you may have procedures that are acting upon the exact same range, and you may simply want to declare a variable that's going to represent that range in all of the procedures, maybe dim RNG as range, and that way you can continue to define and assign RNG throughout multiple procedures and have that single variable declaration at the top. It reduces a little bit of your duplication. The third and final variable scope available to us is application scope or global scope. And this is taking it one step further. Any variable that is declared with this scope is accessible not just in any procedure in this module, but in any procedure throughout any module within our workbook. So what I can do here is show you first the syntax, but what I also need to do before I get there is create a brand new module just to show you this in practice. So I can insert a brand new module right here. Let's go back to module 1. And there's a little bit of a syntactical twist that we have to do to make this work. Right here, when we're declaring mynum, instead of using the dim keyword, we have to replace it with a brand new keyword, which is public. Public mynum as long. So the syntax is very similar to the variable declaration. We're still going to give the variable a name, mynum, and a data type of long, but instead of dim for dimension, we're making it public, so we're writing the keyword public. So what this means is mynum will still be available right here. We can prove this, in fact, by executing these two procedures in sequence, and everything is still going to work just fine. So it has all the benefits of module level scope. But now mynum is also going to be available in any other procedure, in any other module, actually. So if I go into module 2 and I write a new procedure like, let's say procedure C, and let's keep things simple right now. Let's just debug print mynum. This is totally going to work. So when I execute this with F5, we're going to get 25 output right here. Again, let me, in fact, delete this and re-execute to show you. And the reason this is happening is because mynum is number 1 still in memory and number 2 available globally across all modules because we put that public keyword prefix right there. So mynum now, even though there's no evidence in module 2 that's available, this declaration of public in module 1 makes it available through any single module that we're going to be adding to this VBA project. Now, generally speaking, when should you use this? Generally, application level scope, as this is called, or global level scope, things being available globally everywhere, is generally discouraged because it kind of makes your code potentially a little bit clumsy and messy, where you might have to look into a different module to find out where something is declared, to find its data type. Ideally, each module should strive to be self-contained and kind of independent and autonomous on its own. So you may need something like a module level variable at the top, but you can still scroll down and see the procedures that use it. Whenever you have to start jumping around different modules, it makes things a little bit complicated. But if there's ever a scenario where you do want to make something global, just know that that is a possibility, and you could make it so with the public keyword. If you just want to make something available at the module level, you replace public with dim. And if you want something to be available simply at the procedure level, all you have to do with those variables is just declare them inside the body of a procedure right below the sub keyword, and they will only exist as long as that procedure is done running. In comparison, public level or application level variables, as well as module level variables, will continue to persist even after one procedure is done running. So they hold on a little bit longer. You may find that when you're writing your code, that's the kind of design that you may need depending on the program that you're building. But that's all there is to cover in this lesson. We talked about the 3 types of scope: module level, procedure level, and application level. Play around with this, practice the public keyword, and I'll see you in the next lesson. In this lesson, we'll take a look at how we can call or execute a procedure from the body of another procedure. So far, all of the examples in this course of procedures have been pretty simple. They've been limited to a small number of lines. But whenever we're working with real-life business logic, it's highly likely that we're actually going to be dealing with a lot of different objects, worksheets and workbooks, and code is going to expand very quickly. Many times, instead of having a huge block of code in a single procedure, what we can do is split up that code into several smaller procedures and then kind of have each procedure have its own distinct and unique purpose. This is part of the larger scheme of what we call refactoring in programming terms. To refactor something means to make something simpler and more efficient. So past the point of making code simply work, past the point of making it actually do what it's supposed to do, we can also write code in a way that is more elegant and more efficient. And breaking up our longer procedures into smaller ones is one way we can do that. So in this lesson, let's take a look at a very simple example. What I'm going to do is define a procedure. Let's call it master. And let's say right here, I have a whole bunch of business logic and it's taking up a whole bunch of space. And let's say for now, just to kind of mock a real life scenario, let's say it's just a matter of having two debug print statements. Like maybe I have debug print, hey, this is the first step. And let's do another debug print here. Hey, this is the second step. And imagine that instead of having two debug statements, we really have maybe 40 lines of code for every one of these debug prints. And what we want to do is move each one of these operations into its own separate procedure. Well, here's what we can do. We can declare those procedures. Let's say up top, I'll declare a procedure called step 1. And I'll move my debug print logic into there. And again, imagine this is 40 lines, not one. So let's put that here. And then right below here, we can have something like step 2. And usually, instead of simply calling it step 1 or step 2, you might have a procedure that is descriptive of what it is that's actually happening. So if you have a master procedure, it might call two procedures in a row that are going to describe exactly what's going on in the process. Maybe step 1 will be do something with the workbooks. Maybe step 2 will be do something with the worksheets. So right here, let's go ahead and copy this debug print code right here. Again, imagine this is 40 lines instead of 1. And now all we need to do here in master is actually get these two procedures to run in sequence. And it's a pretty simple operation. All we need to do here is use the call keyword. This is a brand new keyword that we're seeing in VBA. And we follow call with the actual name of the procedure that we want to invoke or execute. So in this case, I want to begin with step 1. So I simply write step 1. On the next line, in order to execute step 2 right after, or the second procedure, I can just write call step 2. Now, obviously, the order in which we write this is going to affect the order in which they're executed. So this one is going to take place first, followed by step 2. All right. And it's not going to proceed to executing step 2 until this entire procedure is done running. So let's take a look at this in our immediate window. When I execute this, we're going to see the procedures execute. So master right now is just kind of the container that's kind of the business flow of logic, and it's relying on two other procedures to do what it needs to do. It's a pretty simple example, but hopefully you can sort of use this to imagine how you might use this in a real life scenario that's involves a lot more of a complex code that takes up a lot more lines. You can split it up into as many procedures as you want. It's really up to you to decide what is comfortable for you, what feels compact to you. Ideally, each procedure should do one thing. If you ask yourself, what is this procedure doing? And you find yourself using the word and a lot, it does this and with workbooks, and it does this with worksheets, and it does this with the font. It's probably doing too much, and you could split up that procedure into multiple ones. Once you write those secondary procedures, all you have to do is invoke them or call them. We do that in our master procedure with the call keyword followed by the name of the actual procedure that we want to utilize. It's just another way that we can refactor or simplify our code. In this lesson, we'll talk about how we can set up procedures that accept arguments. Now, we've seen arguments before when it comes to some of VBA's built-in methods. Well, we can actually define procedures that are going to accept their own inputs as well. Let me begin here by defining a new procedure. I'm going to call it write calculation to sheet. What I want to do here is just declare a numeric variable. I'm going to call it math calculation. It's going to be a long or a whole number. And let's say I'm just going to create an arbitrary multiplication expression here. Let's do 5 times 4 times 3 times 2 times 1. Let's say I want to do 3 things here. The first thing I want to do is to log this message to the immediate window or the console with debug print. The second thing I want to do is to output it with our message box. And the third thing I want to do is to actually write it to the sheet in cell A1. Now, this is a very simplified example because all of these things are pretty simple one-line bits of code. But you can imagine if our macro starts to get really, really long, for example, 50 lines, 30 lines, we may want to split it into multiple procedures. That way, we can encapsulate related clumps of code together in a separate procedure and then simply invoke that procedure from our main procedure, as we saw in the last lesson. So let's say I want to do three things here again: log, output, and write. Let's define a procedure to do each one of those things, and then I'm going to actually invoke that procedure from within write calculation to sheet. So right here, I can define a procedure called log message console. I'm going to open my parentheses. Here's my end sub. And here we run into our very first question, which is, how is log message to console going to have access to the thing that it needs to actually output to the immediate window? We know that we have debug print. Debug print accepts a value, but where is that value going to be coming from? We know that our variables within a procedure are scoped within that actual procedure. So the math calculation here, let me actually change this typo. Math calculation here is only available within write calculation to sheet. So how can we give it to log message to console? Well, we can actually pass it in as an input or as an argument. So let me just write out the procedure invocation first. Log message to console. We know that we're going to have to give that procedure its argument, which is going to be math calculation. So how can we actually tell log message to console to expect a single parameter or argument? Well, all we have to do is just define it within the parentheses. Now, the name of the parameter that we give here, of course, does not have to match the variable that's being passed in. This variable is, remember, just a name for some kind of mathematical value. It's just a number. Here, we're actually defining the name of the parameter or the name of the input that we're expecting. So I can just call that something like value. This can be anything: value, number, even input. The only other thing we need to do here, though, is to tell VBA not just the name of the parameter, but what kind of data type VBA should expect. The way I do that is the same way I declare variables. I use the as keyword, a space, and then I declare the data type. So our value is going to be what kind of value? It's going to be a long. So now we've told log message to console that it's going to expect a single input or parameter. We're going to call that value. Math calculation is going to be the argument for that input. It's going to be a long or a whole number. Now that we have it, we can go ahead and output it to the immediate window with debug print and value. Let's go through this process a few more times. Right below here, I want to define a procedure that's going to message box the value out to the user. So what I can do is just write a procedure like output message to user. And right here, again, we have to define the input and or the parameters, it's also called. And because, remember, all of the procedures are separate entities and they're all scoped differently, including the parameters, not just the local variables, we can actually give the input or parameter the same name as we did to the procedure above. We can call it value. It doesn't have to be value in either case, but why not keep it the same? Keeps things simplified here. So value is once again going to be a long. Once I close this, VBA is going to complete my end sub. In this case, I'm going to just message box the value. Now, again, this procedure doesn't actually do anything until it's invoked, until we actually use it. So here in write calculation to sheet, what I can do is actually write output message to user. That's what I actually want to use. Open my parentheses, pass in the same argument of math calculation. Close this. It looks like VBA is actually adding an additional space here. Totally fine. It's just correcting our syntax. This should all be valid. And let's do one more example. In fact, if you want to practice this yourself, you're more than welcome to pause the video and try. What we want to do in our third and final procedure is take in the value and simply write it to cell A1. How can we do that? Well, we define a procedure, write value to sheet. It's going to take an input. Let's call our input value once again. Is it going to be a different data type? Nope, it's still going to be a long. All right, what do we want to do here? Let's target range A1. Let's write in the value, and I'm just going to do range A1 value equals value. Totally valid syntax, remember, because this value represents the argument that's being passed in. This is just evaluating to a number, while this value is a property on the range object. Last thing we need to do, of course, is to actually write the invocation right here, write value to sheet. I'm going to do the right syntax here and actually offer a space here. Once again, we're going to pass in math calculation. And that's it. So hopefully you're also starting to get a sense of how refactoring into multiple procedures can help you make code that's a little bit leaner. You can see that because we've refactored all these operations to separate procedures, this one isn't that long anymore. Granted, all of these things are still one line, so it would have been the same number of lines, but you can imagine if this represented some kind of step of sequences that was something like 5 lines or 10 lines, we can make our code a little bit more concise by refactoring things into separate procedures. That way it's just more lightweight for each procedure. Each one's kind of its own self-contained box of functionality, and we don't have one super long procedure that becomes hard to interpret. Let's go ahead and see what happens here. Obviously, these are going to be executed in sequential order, so they should happen in the order in which they're written. So I'm going to press F5. First thing that's going to happen, we have our debug print. It happens right here. Remember, that happens instantaneously to the immediate window. Then it moves on to the message box. That's why this thing pops up. The message box actually puts a pause on everything. That's why we're not seeing the value here in cell A1 yet. Once I click OK, there it is. And that's all there is to cover in this lesson. We talked about creating procedures that accept arguments. By the way, of course, this might seem obvious, but you're not limited to longs. You can put whatever data type you want in here. You can put strings or Booleans. You're also, of course, not limited to single inputs or single arguments. You can, of course, just define multiple ones. All you have to do here is just simply put a comma and declare the next parameter. Again, just give it the name, the as keyword, and the data type, and then you can use 2 parameters, 3 parameters, as many as you want in a procedure. That's all there is to cover here. I'll see you in the next lesson. A few lessons ago, we talked about variable scope, which defines the boundaries or the context in which a variable exists. In this lesson, we're going to talk about procedure scope, which defines where a procedure can actually be called from. Let me begin by giving you a few examples. So far, all of the procedures that we've written throughout the course have been public. This means that they are easily available. They're available both within the Excel interface. We can access them from the macro dialog box. They can be invoked with something like a keyboard shortcut, and they're also available for other procedures within our module to use for their own sake. So for example, if I declare a procedure here, I'm going to call it implicitly public, and I'll explain why in just a second. Let's say I make this procedure do something very simple, like message boxing out the value of 1 plus 1. By default, all procedures are public, which means they are going to be available in the Excel interface. So if I go to my macros dialog box right here, we can see implicitly public written out here. The reason it is implicit is because the public nature of it is assumed, because that's the default nature of VBA. What I can actually do is explicitly declare a procedure as public. So I can actually use a keyword here called public right before a basic procedure definition. So I can create a new procedure called explicitly public. Let's make it do the exact same thing, just message box 1 plus 1. And let me just explain what we did here. These two procedures are identical, not just in what they do, but in their procedure scope as well. So this keyword is not needed here because it's going to be assumed. So both of these procedures are going to be public. Both of them are going to be available in our drop-down list. The user can activate or call any one of them, either one of them. They're both public. The reason why some developers prefer to add this extra word in here is because it makes it a little bit more clear once we start writing private procedures as well. It makes it more clear which ones are public and which ones are private. There's kind of a consistent naming scheme where if we're going to label which procedures are going to be hidden away from the user, we might as well label those procedures that are going to be accessible by the user. So sometimes, even though this keyword is not necessary because the default behavior of VBA is to make a procedure public, some developers prefer to put this so it's a little bit more kind of written out and well documented. So now let's talk about private procedures. Private procedures are only visible to the procedures in the exact same module. They cannot and should not be called by the Excel user. They cannot be executed from the main Excel application. If you look at the macros dialog box, any private procedures will simply not show up. So why do we need private procedures? Well, they exist only to be invoked by other procedures. For example, if we want a procedure that's going to abstract away the complexity of a procedure, for example, we may want to take some code from a really long procedure and put it elsewhere so that we kind of have a box to contain it, and then we can simply call that procedure. That second procedure that's going to be holding together that clump of code doesn't need to be accessed or used by the user. It only exists to give us utility as a developer to make our own process of categorizing and organizing our code simpler. In that case, we may want to label some procedures as private if we don't want the user to be able to use them. They only exist for our own benefit. So let me give you an example here. Let's say I want to do some kind of operation here, like writing a value to a range right here. And let's say I don't want the user to actually be able to do that. So how can I do that? I can declare the procedure to be private. Instead of the public keyword, I begin with the private keyword. So I can do private sub. Let's call this one explicitly private because we're explicitly writing the private keyword and preventing it from being accessed by the user. The syntax, the logic, all of the basics of VBA code are going to be identical. So here we can put any kind of valid VBA code. So I'm going to do something like range a1.value. Let's just put in something like the keyword private stuff. Now, the big difference is here, because we put the private keyword, this macro and only this macro is not going to be available. So we can see explicitly public shows up. That's because it has the public keyword in front of it. We see that implicitly public shows up. That's because the default scope of a procedure is public. That's why the public keyword is technically not needed. However, as soon as we add the private keyword right here, this explicitly private sub will not show up. So the user has no way to access it or run it. So let's go back into our Visual Basic Editor. And now we have access to this private procedure within any of our other public procedures. So what I can do here, for example, is say I want to invoke explicitly private. So I can do that several ways. The first, of course, is simply to do explicitly private. So I can invoke this procedure, and the user is only going to have access to this public one. But whenever they execute this, the code is going to go ahead and call this one. And after that's done, that's when it's going to output message box 1 + 1 to the user. It looks like whenever we're getting some kind of error here, it looks like we might have to add an extra keyword here, which is going to be the call keyword, call explicitly private. And that, I think, should work. Let's also remove the parentheses. Okay, so this syntax is valid. So let's go ahead and use the call keyword. That's just a way to say run a procedure or execute a procedure. Then we're going to put the name of the private procedure that we want to invoke. That's going to be this one right here. The user, again, has no way of accessing this. So let's go back to our Excel interface. Let's go to macros. Let's run our explicitly public procedure. Let's run it. All right. So here we see the first thing that's happening is the value is being written to the range. That's private stuff. Now, remember, the user has no way to execute this on their own. They have no clue that this procedure exists as a private one on the Visual Basic Editor. This part is the second part of explicitly public, which is the message box. So everything is working as expected. That's all there is to cover in this lesson. Again, whenever you want to split up a procedure into multiple procedures and you want to abstract away some of the complexity of a procedure, many times you don't want the user to be able to have access to any of those procedures that are sort of acting as helpers or procedures that just take care of one small step along the way. You don't want the user, for example, in this case, to be able to write a value to range A1. So what you can do is make some procedures in your module private, which means that the user will not have access to them. Only other procedures within the exact same module can call or invoke those procedures. And that will help you make your code, again, more lighter, more leaner, more efficient. And rather than having really, really long procedures where you're not sure what's going on, you can refactor different sections, different blocks of code into their own separate procedures, each of which does only one small thing. And that way you just have a much more optimal, easy to read code base. In this lesson, we'll take a look at the exit sub keywords. Exit sub is used to terminate a procedure before it reaches its natural conclusion. Now, usually exit sub is paired with what we call conditional logic. Conditional logic essentially means code that only runs if a certain condition is true. So exit sub is a really ideal thing to use, for example, if all of the prerequisites for our procedure to run properly are not in place. For example, we ask the user to enter some kind of value and they do not enter a value. In that case, there's no point running the rest of the procedure, so we can terminate it early. The reason I wanted to introduce these keywords now is because they are directly tied to the concept of a procedure, which is what this section is focused on. But we're going to do a review of these concepts a little bit later in the course as well and dive into the actual conditional logic part of it. For now, let me show you how exit sub works in action. So what I'm going to do here is create a procedure called exit early. It's going to be as simple as can be. I'm just going to have a couple debug print statements here, debug print 1 and debug print 2. And right below here, I'm going to do a line break and just do a couple more, debug print 3 and debug print 4. Now, of course, if I run this procedure normally with F5, we're going to get all of these 4 numbers printed. That's expected. However, as I mentioned, we can introduce 2 new keywords called exit sub. And exactly as the name would suggest, exit sub exits or quits or terminates the procedure, the sub, at this point of execution. So VBA is going to read these 2 lines and execute them. It's going to get to this, and none of this code will execute. So when I press F5, we're going to see 1 and 2. Notice that 3 and 4 do not appear. And that's basically all there is to cover in this lesson. 2 keywords we put in our middle of our procedure if we wanted to terminate prematurely before it reaches its natural conclusion. Again, a lot more powerful when used with conditional logic, but we'll take a look at that a little bit later in the course. I'll see you in the next lesson. In this lesson, we'll take a look at constants, which are values that cannot change while the macro is running. So far, we've been exposed to variables, and variables, as we know, can actually have their values changed throughout the process of a procedure. We haven't seen too many examples of this, but I assure you later on in the course, when we start diving into things like iteration, which means going through rows one at a time, variables will come into play a lot because we're going to be taking, for example, cell values and consistently reassigning them to a variable. Row 1 to a variable, then row 2 to a variable, then row 3 to a variable, etc. So variables, as the name suggests, can vary. They can change. Sometimes, however, in a program, you're going to need to store a number, for example, or a string or something that is constant, that is unchanging. For example, you may have a tax rate in an accounting spreadsheet, and that tax rate is going to stay constant for the entire duration of the procedure. In those cases, you can use something called a constant, and as the name suggests, a constant is simply a different type of variable, you can say, even though it can't vary, but it's a different way that we can assign a value to a given name in our program, but that value cannot change. Once we assign a value to a name, it is there for the entire duration of the macro's execution. So let's take a look at an example in my Visual Basic Editor. I'm going to define a new procedure called fun with constants. And as we know by now, if we wanted to declare some kind of variable, we would simply use the dim keyword. Well, in order to declare a constant, we simply swap the dim keyword with the const keyword, C-O-N-S-T. So C-O-N-S-T. So one example of a constant that I can think of is pi in mathematics, which is 3.14159. That value is unchanging. So if we're going to have a variable called pi, there's really no reason to ever reassign anything besides an initial value to it. So I can do something like const pi, and let's say I'm going to make it a double, a floating point number. And one of the other things that's interesting about constants is whenever we declare them, we can actually make the declaration and the value assignment on the same line. We can't do that with regular variables. So instead of simply writing pi equals on the next line, I can put an equal sign right after that declaration and give it its initial value, like 3.14159. And this sort of makes sense because the reason we can assign a value is because a constant's value never changes. It just needs a basic starting point, and that's never going to change. So we can simply assign it wherever we declare the constant in the first place. Now, there are some conventions when it comes to naming constants, and it depends on what developer you talk to. Some people prefer to put all of their constant names in uppercase. Some people prefer to prefix their constants with a lowercase letter c, C for constant. So as an example, let's say I want to have a constant that represents the total number of months in a year. I can have something like const, let's say C months, and that will be, let's say, a long or a whole number, and I can assign it to 12. And as I mentioned earlier, maybe I'll have something like a tax rate that's going to be used throughout the procedure many times, and I can declare it in a constant just for easy reference. So I can do const something like C tax rate as a double, and maybe our arbitrary tax rate is, I don't know, 0.0825. And these constants now are unchangeable. So if we try to accidentally give them a brand new value, VBA is going to throw an error. For example, if I later on in the procedure say, okay, well, now my tax rate is going to be something different like, I don't know, 10. And as soon as I execute this, we're going to run into an error right here when VBA is going to say compile error, assignment to constant not permitted. So it's a constant. You can't assign anything new to it. What is originally assigned must stay constant. It must stay the same. Let's go ahead and quit our debug mode by clicking the blue reset button at the top right here. And the last thing I want to show you in this lesson is the familiar protocol that we can use to make a constant available to all procedures in a module, as well as available across the entire collection of modules in a workbook. So as we talked about a little bit earlier, if we declare something outside of a procedure in a module, it will be available as a module scope. So it can be accessed by any of the actual procedures in that module. And if I do something like that here, for example, I want to have a string, and I'm going to call that string job title. The interesting thing here is that if I do this outside of a procedure, I can actually assign the initial constant value outside of the procedure. So I can do something like VBA developer. This is not possible with a basic variable, which requires us to actually assign that value in the body of a procedure. However, a constant needs something to begin with because it's unchanging, it's kind of everlasting. So we can assign that outside of any procedure. And now if I want to use this not global, but module level constant, if I have a procedure here, for example, occupation, I can actually reference it from within. So I can do something like, let's do debug print and write something like I am a, and let's concatenate job title. And even though job title is not declared with an occupation, it's going to have access to it because it's available on the module level. So when I execute occupation, we're going to get I am a VBA developer. in order to make a constant available across all of the modules in your workbook. And again, a sample case for this may be something like a tax rate for an accounting application that is going to stay constant. What you can do is just simply declare that tax rate once as a globally available constant, and it's going to be available in all procedures, and you don't have to keep reassigning it over and over. The way you declare it so that's available across the entire collection of modules in a workbook is simply by prefixing this const with the keyword public. We ran into this a couple lessons ago. It's pretty similar. Public simply means publicly available, available everywhere. So if I now go ahead and take my occupation procedure, I'm going to cut it, and I'm going to create a brand new module here, module 2, insert module. I'm going to put it right here. Even though job title is defined in module 1, it's still going to be available here because it is publicly available. It's globally available. So when I execute this, we're going to still get I am a VBA developer. And you can imagine here, again, if we're doing some kind of worksheet calculation with a number that we need that is consistent, or some kind of string we need that's consistent, or some kind of Boolean setting that we need, we can just simply declare those as a globally available constants and have access to them in whatever module we need. That's all there's to cover. In this lesson, we talked about the idea of constants. Those are declared with the const keyword, C-O-N-S-T. You can assign it an initial value, but you cannot assign it a secondary value. That's why it's a constant. Its value cannot change. It remains static and unchanging. You can simply limit a constant to the body of a procedure, that is module level. You can also, procedure level, or local scope. You can also allow it to be used by any procedure in a module. You simply have to declare it outside of a procedure. And you can, of course, make it globally available as well by prefixing it with the public keyword. In this lesson, we'll talk about predefined constants in VBA, which are also called enumerations. The idea behind an enumeration is tying together a name with a value, or associating a concept with a given number. A good real-life example that I can offer you is ordering food in a fast food restaurant. When you walk into a restaurant and you say something like, "I'd like the number 2, what does that mean? Well, it means that there's some kind of association between the value 2 and some kind of concept or entity. So for example, the number 2 in a fast food restaurant might mean the big burger combo with fries and a soda. It also works in reverse. You may walk in and say, "I'd like the big burger combo," and the waiter or waitress might be able to interpret that as the number 2. So whenever we're associating a name with some kind of value, a number with some kind of concept, we call that an enumeration. Enumerations exist in VBA to help us as developers, and the best way to demonstrate this is with an example. So, as we know, spreadsheets have this concept of orientation. In fact, here in the Excel interface, on the Page Layout tab, we have this orientation option, and we have one of two options, portrait or landscape. We briefly discussed this, I believe, in an assignment in the past where you had to record a macro to change this option. So let's think about the concept of orientation. We have a property on something called a page setup object, which we'll explore very shortly, that allows us to set the orientation of a spreadsheet. But what kind of value is the orientation? Is it a Boolean? Well, not really. Yes, we do have two options here, portrait or landscape, but it's not so much true or false or on or off. It's more just a set of predefined options. It's either portrait or landscape. It's not really a true or false. We also can't really associate a portrait with a given number. We could technically, but what does that mean to us as developers? If we say portrait is equal to the value 5 and landscape is equal to the value 10, and that's how we know which one we're referencing, that doesn't really make a lot of sense to us logically. This is a perfect case for enumeration. We can define essentially a predefined set of values like portrait or landscape, and each one of those values can tie together to a number, and that number is actually what VBA is going to use internally to process our request. And that way, we don't actually have to memorize the concept of relating numbers to portrait or landscape. We just have to identify whether we want portrait or landscape, and that given name will correspond to a given value that VBA can then use. It's a little bit of a confusing concept, so let's explore this actually within the VBA documentation. I'm going to open up my browser here, and I'm actually going to search for right now the worksheet VBA object. We're going to dive into the documentation before we write any of our code. Here is the documentation page for the worksheet object. And on every worksheet object, there exists a property called page setup. So I'm just going to scroll down here until we get to our properties, not our method. So properties, let's look for page setup right here. There it is. So page setup is a property that actually gives back to us a page setup object, yet another object in our Excel object model. Here in our page, we have, of course, the description returns a page setup object that contains all of the page setup settings for the specified object. Pretty generic documentation, but we can click here. So we're continuing to traverse the Excel object model. Here we're going to get to the page setup object, and this represents the entirety of our actual page setup. So that includes everything from like the left margin, the right margin, the margins, things like the footers, all of that stuff that relates to how that page looks, especially when it's printed. There is a property on the page setup object called orientation. So here it is, orientation. This is how we're going to be altering whether the spreadsheet is going to be in landscape or portrait format, which again is going to affect how it looks when it's printed. And here's a good example. If we take a look at the code here, we see that we're targeting a worksheet, we're targeting the page setup object, we're targeting the orientation property, and here we're setting it to something interesting, Excel landscape. Notice that this isn't a string. We know that automatically because it's not wrapped in double quotes. So what is Excel landscape? Well, it's the idea of an enumeration. This is some kind of name that corresponds to a given value. How can we find out what that is? Well, right here we see that we can use the orientation property to return or set an Excel page orientation value. So what is this thing right here? Let's go one step further, continuing to traverse the object model. And here's where we're actually going to get to the Excel page orientation enumeration again. So what are we doing here? We have a convenient table that corresponds or relates the idea of a name with a value, right? So behind the scenes, whenever we're going to give a name, VBA is going to be able to translate it to a value. And why is this advantageous? Well, because as developers, we don't have to memorize these values. These values are kind of random, right? How do we associate the idea of a landscape with number 2 and a portrait with number 1? We really don't. The VBA community or the developers have just arbitrarily decided that those two values are going to represent those two settings, and we're going to use those two numbers, or rather the code is going to use those two numbers to set some kind of internals of Excel to give that given appearance. But for us as developers, we don't have to actually associate or memorize these values. All we have to do is use the given names, and VBA will translate these names into their numeric values. That's the whole idea of an enumeration. Remember, a name tied to a given numeric value. This is like the Big Burger combo, and we're tying it to number 2 on the menu. So now we can go ahead and see this concept in action in our actual Visual Basic editor. So let's go ahead and define a procedure. I'm going to call it change orientation. Now, in order to get VBA to help us with our actual enumerations and our predefined constants, it's a good idea to define variables that represent Excel objects. That way, IntelliSense can figure out what object we're referring to and show us all of its properties and methods. So what we actually want to target here is the page setup object. So the way I can do that is declare a variable. Let's call it PS for page setup, and we're going to do as page setup. Remember, whenever we're declaring a variable to be an object, whatever's after the as keyword can be any object in the Excel object model. Worksheet, worksheets, workbook, etc. Page setup, as we just saw, is a valid object that's nested within a worksheet. So let's go ahead and set that page setup object. So remember, whenever we're assigning a value to a variable that holds an object, we need to start with the set keyword, set PS. And now I need to target a valid page setup object. Well, we know that exists on an actual worksheet. So we can target a worksheet like worksheets. Let's target sheet 1. As a reminder, whenever we use this syntax, we're automatically going to assume the active workbook, or rather VBA will assume that. That means the workbook that is currently activated or selected. In this case, we only have one open, so by default, it will be the active workbook. All right, and here on a worksheet object, which I've taken out of the collection, we have a property called page setup, which returns to us a valid page setup object. So we've defined that variable, and now whenever we go to PS and place a dot, the IntelliSense is going to show us all of the properties and methods that are available on a page setup object. We, of course, are looking at orientation. So when I do orientation and I do equal, here's where VBA is going to be really helpful. It's going to show us all of the predefined constants or enumerations that are available. Notice here that the values of these constants are irrelevant. We don't know which one of these is represented by number 1 and which one of these is number 2. We have access to that in the VBA documentation, but it doesn't really matter because as developers, we don't have to think about it. We don't have to memorize it. It's abstracted away. That complexity of associating numbers with what is going to happen on the spreadsheet in terms of orientation, the Excel VBA code is going to take care of all of that for us. All we have to do here is just provide the right constant, the right name, and the code under the hood will take care of the rest of the process for us. And the great part about the names is that they're a lot more logical. The number 2, again, doesn't mean anything. However, something like Excel landscape is kind of logical to us as users. We can associate it with, that means we want the orientation to be of landscape. So let's say I select landscape right here. So I'm just going to select tab. That should lock it into place. Let's just double check that our orientation right now is set to portrait perfectly. Perfect. So what's going to happen here is we're going to change the orientation from the default right now, which is portrait, to landscape. And we're going to do that using this predefined constant or this enumeration. All right, let's go ahead and execute this, F5. Now we're not going to see anything visibly, but if I go here in orientation, we can see that it's been swapped to landscape. Let's go ahead and switch that back to portrait. I'm just going to remove this value right here. Once again, type an equal sign, and there again, we're going to see 2 values. Now, kind of as an obvious reminder, depending on the property that we're going to be accessing, we're going to see a different set of available predefined constants or enumerations. It all depends on the property that we're adjusting. There are enumerations related to navigating across the worksheet. There are enumerations related to charts and tables. They're all just predefined options, predefined values that map or relate to a given name. That allows us to not have to think about the number and only have to process the name that we need. So what do we want to do now? Well, we want to change the orientation to portrait. We can safely guess as a developer that Excel portrait is the one that corresponds with the portrait orientation. We can select that. Again, under the hood, behind the scenes, Microsoft's code will translate this to a number. It's going to know what to do with that number in order to turn the orientation of the worksheet into a portrait. So when I execute this, F5, check here, the orientation has been changed back to portrait. That's all there is to cover in this lesson. We talked about the idea of predefined constants, also called enumerations. We're going to be seeing this concept a lot throughout the course. Again, these constants exist whenever we have a value that's a little bit difficult to represent with something simple like a string or a number. We could, of course, tie together the idea of an orientation with a number, but what would that mean, right? What the heck does a number 2 mean when it comes to portrait? We're really just trying to represent a limited set of options, kind of a list of possible values, but a number isn't really perfect. A string is kind of functional, but again, typing in a string like portrait doesn't always work. What if the user enters a typo, things like that? So the reason that these constants exist, these enumerations, is so that we have these predefined things that we as developers can use that are less likely to run into errors. And behind the scenes, VBA will just translate these names to given values, and it knows what to do with them to accomplish the effect that we want. That's all there is to cover in this lesson. I'll see you in the next one. In this section of the course, we're going to take a deeper look at many of the objects within the Excel object model, starting with application at the very top. Application, of course, is concerned with top-level global application-based settings, kind of the universal settings that are going to stay constant no matter what workbook you're working with or what worksheet you're working with. Most of VBA programming boils down to identifying the right object in the hierarchy and then issuing it the right message, the right method, if you will, giving it the proper command to do what it is that you want. So let's begin here by declaring a procedure. We're going to call it Fun with Application. And we're just going to take a look at a couple properties and one method that's available on application. So I'm just going to do a bunch of debug prints here. The first one I want to show you is application.name. This is actually going to give us the name of our application, which of course is going to be Microsoft Excel. On application, we also have a convenient property called path. Path is actually going to give us the installation directory of the Excel application as a whole. So not the location of the workbook that we currently have open, but the actual Excel core functionality that's created by Microsoft. So Excel on my computer is installed in this directory, program files, Microsoft Office root Office 16. This can be particularly effective if you want to find the location of a given program, not just Excel, but let's say another Microsoft Office application. All right, we also have a convenient property available on application called version. Now, when we talk about Excel kind of in conventional business terms, each version is given a popular name that is year-based. So for example, Excel 2013 or Excel 2016. But behind the scenes, Excel also has a numeric version number, kind of a more technical name for it behind the scenes. And Excel 2016 has the version number 16. Now, you may be asking, what's the point of this? Well, a good scenario that you can think about is having to build code that is going to run in any version of Excel, including previous versions. And let's say you want to run a feature that is only available in a newer version of Excel, like 2016. You might have to write some conditional logic, which just means logic that follows multiple branches or multiple directions. You might have some kind of logic that says, if we have a version of Excel like 2016 or greater that has a specific feature that we can also use in VBA, let's go ahead and use that feature. Otherwise, if the version is less than that, we have to go ahead and write a different branch of logic, a different set of steps to take in order to account for that feature that we don't have access to in an earlier version of Excel. So this can be particularly helpful when you want to find out what version of Excel you're working with, and as an extension of that, what features you actually have access to. One more property I want to show you here in this lesson, and that's going to be the application username property. This is going to show you the top level user that's registered with the application. And of course, for me, it's just me. You can see right here, Boris. All right, so these are the 4 properties that I want to show you on the application object. There are more. I just want to show you some of them to kind of get you thinking about what is available in an application. Again, these are not workbook or worksheet specific. These are top level global universal properties across the entire application. One cool method that's available on application, I'm actually going to execute it right here after saving my work, is application.quit. And predictably, what this is going to do is quit or terminate the entire Excel application. Notice here that I don't have to prefix this method with a question mark in the immediate window because I am issuing a command. I'm not asking a question. And quit is going to just exit the entire application. Keep in mind that if you have some unsaved changes in your workbook, it will still prompt you with the standard save as dialog box that says, would you like to save this workbook? I think it shouldn't do that here because I have saved, so it should just take us straight to our desktop. So I'm just going to press enter here and we should quit automatically. And there we go, we're taken straight to the desktop, and that's it. That's all there's to cover in this lesson. We talked about the application object and some of its properties, including name, path, version, and username. And we also took a look at the quit method, which terminates the entire application. And throughout this entire section, we're going to take a deeper look at some of the other objects within the Excel object model, including the workbook, worksheet, and more. So I'll see you in the next lesson. In this lesson, we'll take a look at the display alerts property on the application object. This property actually allows us to enable or disable alerts within Excel. What is an example of an alert? It's simply one of those dialog boxes or pop-up boxes that appear from time to time to warn the user of something, to alert them of something. One example is the save box, which appears if you attempt to exit a workbook without saving. So for example, if I write a value here in my Excel workbook, and I attempt to quit the workbook, this box that pops up here is one example of a alert in Excel. I'm just going to go ahead and cancel out of here. And sometimes when it comes to writing VBA, it may be beneficial for us to disable alerts temporarily while the procedure is running to make the entire process as smooth as possible for the user. Remember that whenever an alert pops up in Excel, what it's actually going to do is halt the execution of the macro, so temporarily pause it mid-execution. So for example, if we have a macro that attempts to close a workbook and the workbook is not saved, the user will still be prompted with that box that we just saw, would you like to save? And that's going to pause the macro temporarily while it's running. And that sometimes is a little bit of an uncomfortable experience for the user because they still have to click around and they still have to think about something. Sometimes it is beneficial to make it as simple as possible for the user by making them simply execute the macro and taking care of all of those decisions for them, just assuming a default, for example. So sometimes it depends on how you want to build the application and what it is that you're trying to do, what your business goals are. But sometimes we simply want a macro to be the final end-all be-all, and we want to make sure the user takes the minimum number of steps necessary, and we just kind of go forward with whatever it is that we want to execute. It's in those kinds of situations that it's beneficial to temporarily disable alerts at the beginning of the macro so that Excel doesn't annoy the user with any of them. And then at the end, when all of our code is done executing, we simply re-enable the alerts to bring them back and so that the user has them in their standard Excel user experience. Here's how we can do something like that. Here's what I want to do with our code in this lesson. I currently have two workbooks open. One of them is the application object right here, and one of them is this second workbook called the report. The second workbook is not relevant here. I simply want two workbooks open because what we're going to do in this macro is close one of them. And if I only have one workbook open and I close it, then that's going to close the entire Excel Visual Basic Editor as a whole. And I just want it to stay open so we can see the impact of our code. So this report simply exists just so this example can work. So I'm currently in the module 1 code for the application object, and I'm going to write a procedure here, and I'm just going to call it close workbook. And we're going to go ahead and try to close the workbook that we're currently on, which is the application object, even though it's going to have content that is not going to be saved. And what we're going to do is avoid that save box that pops up that we just saw a moment or two ago. So what I want to do here is, first of all, I'm going to write the code to actually close the workbook, and we want to find out what that workbook is first. And I'm pretty sure it's just going to be workbook number 1 here. So I can do a quick search here. In here, I can find the first workbook in my workbooks collection, find its name. Okay, so that's the application object workbook. That's the one that I actually want to close. So what I'm going to do here is right here, I'm going to do workbooks 1.close. That is the method available on a workbook object to close it, right? It doesn't close the application Excel. That's the application quit method. This just closes a specific workbook that we have open. All right, so right now, as I mentioned, we have a property called display alerts on application, and it's a Boolean. It's actually going to give us a true or a false, and it's both readable and writable. So what we can do in the immediate window is find out what its current value is. And that is right here, display alerts, and it's currently set to true, which means alerts are enabled, they will be visible. So what I want to do at the top of the procedure is temporarily disable them. So I'm going to do display alerts, and I'm going to set this to false. Setting it to false means that alerts will not be displayed. It disables them, it turns them off. So this means when this, not this procedure, but rather this line of code within the procedure runs, our alerts are going to be disabled. So any dialog boxes or alerts that are associated with this close operation, such as that save, will no longer be displayed. They will simply be skipped. So if the user hasn't saved worked, not a problem. We're simply going to not display that alert and simply force the closing of the workbook, basically a not save operation. So what I want to do at the very end of the procedure is, after all my actual macro code is done, or the core of the code, I want to go ahead and re-enable display alerts just to make sure we don't lose that functionality in Excel, because since this is a global application-wide setting, we're going to disable alerts everywhere, and we don't want to do that. We just want to do it for the purposes of this operation. We then want to make sure we bring things back to their original shape, bring the configuration back to its default, just so that we don't break anything. Right, so it's going to be pretty simple. We're going to disable the alerts. We're going to close the workbook, no matter whether it's saved or not saved, and then we're going to re-enable alerts. So let's take a look at this in action. I'm going to clear this right here. I'm actually going to save this just so we have this code for later, but after I'm done saving the code right here in the Visual Basic Editor, I'm going to go back out into my worksheet right here and make some kind of change, like hello. All right, so I'm going to enter that. My workbook is now unsaved. I'm going to go into this code right here and execute close workbook with F5, and you can see it's going to close that workbook exactly as expected. You'll notice even though we had unsaved content, which is that hello, we were not prompted with the alert that said, would you like to save, because we temporarily disabled it. You'll notice the Visual Basic Editor here is still open because we still have our report, which is the other one that I had open, but everything worked as expected. We were successfully able to close a workbook without displaying alerts. And obviously that's just one example of an alert. There are many others in Excel. Whenever you create new worksheets, there's an alert that pops up, many other operations. So if you want to make the process of something as simple as possible for the user, and you don't want them to confirm something, and you don't want them to be taken out of the process, you don't want to halt the execution of a macro, this is a pretty popular paradigm to follow in your code, to have a procedure that does something, and then before you're about to do it, you temporarily disable those alerts by setting display alerts to false, and then at the end of the macro, when you're done doing anything that might enable an alert, you bring things back to their original shape by writing application.display alerts equals true. That's all there is to cover in this lesson, and we're going to talk about this property a couple more times throughout the course. You're going to see some more applications of it. So I'll see you in the next lesson. In this lesson, we'll take a look at the count property on both the worksheets and workbooks collection objects. We'll begin with worksheets, and the worksheets count property is pretty simple. It's simply going to give you back an integer value that represents the total number of worksheets in the currently active workbook. So right now I have one workbook open. There's only one sheet in here, sheet 1. So if I go into my immediate window and I find my worksheets collection object, and I go count, I'm simply going to get a value of 1. If I create a few more worksheets in here just by clicking the plus sign, here's a couple more, and I get the value of the property again, we're now going to have a total of 4 worksheets in this currently active workbook. An important caveat to remember here is that Excel actually has 2 types of sheets available. The first is a worksheet, which is what we see here on the left, which is just used for data. And the second type is actually something called a chart sheet, which is what we use whenever we want a sheet to hold, for example, an entire bar graph or a pie chart. In this case, we don't have any, so all of the sheets that we have here are worksheets. But there is a property available called sheets, and this will give you the total amount of total sheets, which includes both worksheets and chart sheets. So right now, because we only have worksheets, the value is going to be the exact same. But if we were to have 4 worksheets and, for example, 2 chart sheets, this would give you 6, while worksheets count would give you strictly the number of literal worksheets or data sheets. All right, now let's go on and move on to the workbooks count property. That's going to give you the total number of open workbooks in the Excel application. So if I get my workbooks collection object and get count, we're still going to get 1. I'm going to go ahead and create 2 new workbooks just so we can simulate multiple workbooks being open. So I'm just going to press Control New here a couple times. There's my new workbook, and there's another new workbook. So now if I go back to my immediate window in my Visual Basic Editor and I re-execute this, we're going to get a new value for the property, and that is equal to 3. This, again, is the total number of workbooks that are currently open in Excel, so the count of workbooks. Pretty simple. All right, that's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, I want to offer a review of the workbook's open method, which opens another workbook, and the path property on a single workbook object, which tells us the path or the file location of a given file. So what I want to do here is write a basic macro that's going to offer a different workbook than the one we're in. I'm currently in a file called the workbooks object, and in the exact same directory, I have another Excel file called report.xlsm, and I want to go ahead and open it here, as well as talk about some of the quirks or problems you might run into whenever attempting such an operation. So what I'm going to do here is create a procedure called open some file. And I believe there was actually a challenge earlier that you tackled where you had to deal with this method, the open method on the workbooks collection object. And sometimes when you're dealing with files in the exact same directory, if you simply give the name of the file you want to open, that's going to work sometimes. But sometimes Excel and VBA are known to run into an error where it's going to be unable to figure out exactly where the file that you want to open is located. And the only way to remedy that is to actually provide the full path. So the exact location on your computer where the file is located, even if it's in the exact same folder as the workbook is from which you're running the macro. So what we can do here is do a couple of tricks to find out the current location of this file, the one that we're in right now. And because we know the file that we're trying to open, which is report, is in the same directory, we can then concatenate that file name to our current directory to get the full path to the file that we want to open. It's a little bit of a confusing concept, but hopefully it'll make more sense as we type it out. So the first thing I want to do is actually get the current location of the file that we're in. So on any workbook object, we have a property called path, which is going to give us the exact directory or path to our current file. I can show you this in our immediate window. So as a reminder, the workbook that is currently open and selected is the active workbook, and this is a regular workbook object. And on that, we have a property called path. Path is going to give us the entire path to this file. So this file, the workbooks object right here, is located within this directory structure. Notice that it doesn't actually give us the file name. It just gives us the path all the way to the current directory where the file is in. So what I can do is get access to this path in the context of my procedure and then concatenate on the name of my file that I want to open to the end of it. So here's how I can do something like that. I'll first declare a variable. I'm going to call it file path. And it is just going to represent a path, so it's going to be a string. And I can go ahead on the next line and assign it to what we just did in the immediate window, simply do the active workbook and get its path. So now I'm going to have this string assigned to the file path variable. On the next line, I can go ahead and try to open my report workbook. I'm eventually going to want to assign this to a variable, and the open method on the workbooks collection is actually going to return the open workbook to me as an object. Because I want to store that in a variable, I'm going to declare that workbook variable up front. So I'm going to do dim WB as a workbook. So now we're going to have a WB variable, and as a reminder, whenever we're assigning an object to a variable, rather than simply using the equal sign, we also have to use the set keyword. So I'm going to do set WB, and I'm going to set that equal to the open method on the workbooks collection. So as a reminder, the open method on the workbooks collection is going to open a brand new workbook, and then it's going to return a single workbook object to me, which I then want to assign to the WB variable, and then we're going to have access to it and can do all kinds of things to it. So here's where it gets tricky. Right here, we talked about this method a little bit previously. We have the first argument, which is a file name. It's expecting the actual name. And sometimes if you were to do simply something like report.xlsm, it's not guaranteed to work. So the best thing that we can do here is prefix this or prepend it with the full directory. So the way we can do that is like this. Right here, before, I'm actually going to write file path. which is going to give me the exact path, the directory to where I am. But there's one more thing we have to do, two more things actually. The first, of course, is that we have to concatenate. We have to add on report.xlsm to the end. And you'll also notice here that if I were to simply take this and paste it right at the end, we're not exactly going to get what we want, because we actually need to place an additional slash in order to indicate that we're actually in that directory. So the path is going to give us the directory that we're in, but it's not going to add that last slash. So we have to add it manually right here before report. And now we're going to tell VBA, get the current file path, which is this thing right here. And then to the end of it, you want to concatenate this slash. And then report.xlsm, we have to make sure we close that open method call. As another reminder, we have to do parentheses whenever we're going to assign the return value of a method to a variable. So that's why we're using the parentheses for the open method. And this is just the first argument right here. We're just providing this concatenated string to represent the file path. All right, so that should do it. WB is now going to store the report workbook, assuming that it's been properly opened. And we can verify this by doing something like this. We can say message box, you've just opened. And to this, we can concatenate something like wb.name. Our report workbook will now have a name. And we can also alert the user to its path of our newly opened workbook, rather. So we can do the same path property that we saw earlier. We can say the file location of what you just opened is, and we're going to concatenate to the end of that wb.path. The exact same path property that I applied to the active workbook, we're now just getting that property off the workbook that we just opened, which is going to be report.xlsm. All right, so let's go ahead and see if this works. I'm going to save this and press F5 to execute. All right, and there we see report.xlsm open. This is just a random file. You can see we have this message box pop up. You've just opened report.xlsm. That's coming from our very first message box. This is getting the name property of this workbook. And then OK, and now we can see the file location of what you just opened is right here. This is using the path property of this new Excel workbook that we just opened. So just to clarify, the name and the path properties that we just used are coming from this report workbook that we just opened. They're not coming from this application object workbook where we actually wrote our macro code. All right, so I'm going to go ahead and press OK, and that's it. That's all there is to cover in this lesson. We did a quick review of the open method on the workbook's collection object, as well as the path property on a workbook. The open method is used to open a brand new workbook. In fact, you can do much more complex operations like open every single workbook in a given directory on the computer. That's a much more complex operation, but you can sort of imagine the kind of scenario where this might be helpful. Perhaps you're going to have a directory of, let's say, revenue reports, one for every month of the year, and you want to iterate or go through each one of them, open them up one by one, and perform the exact same process in each. That's the kind of scenario where you might need to open a workbook, and that open method will help you do that. All right, that's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at the close method on the workbook's collection object. This is not to be confused with the close method on a single workbook, but it operates pretty much the same way. When you call the close method on the workbook's collection, it closes every single open workbook in Excel. So here in my Visual Basic Editor, I currently have two VBA projects listed right here on the left. That means I have two workbooks open. The first one is report, and the second one is the workbooks object. And I'm just going to write a procedure here in the second workbook right here, the workbooks object, which is going to be responsible for closing everything. So I'm going to call this procedure close everything. And just as a reminder, whenever you're doing something like this, it might be a good idea to disable your application alerts before you do anything. This just ensures that the user isn't prompted with any annoying dialog boxes. So I'm going to do application.display alerts, and I'm going to set it equal to false to disable it at the very top of my procedure. I'm going to copy and paste this below, set it equal to true right here. And then right here, we're going to do workbooks.close. So we're calling the close method on the entire collection. If you wanted to target a specific workbook, all you have to do is just wrap a parentheses after here and specify the index position or the name of the workbook that you want to target. In this case, we're targeting the entire collection. So every single workbook, in this case, the two that we have open, will be closed. Let's go and save this and see what happens when we press F5. And there we go. You can see we've actually closed all of the workbooks. There's nothing even showing up here. If I close this, that brings us back to Excel. And we can see there's not even any workbook open in Excel. We're just getting this gray screen, which is sort of like a pending screen that says, hey, you have Excel open, but you don't actually have any workbooks open inside the application. That's all there is to cover in this lesson. So I'll see you in the next one. All right, so in previous lessons, we took a look at how we can open and close an existing Excel workbook. And in this lesson, we'll see how we can create or generate a brand new workbook using VBA. So let's dive right into it. In my Excel Visual Basic Editor, I'm going to create a brand new procedure. I'm going to call it Create New Workbook. And the way we do that is by referencing our workbooks collection object, the entire collection, not just any one workbook. And we have a convenient add method on that workbooks collection, and this will do it. We're not even required to put in any arguments here to make this work. So let's go ahead and execute this with F5, and we're going to see right here on the left side, we can see that this workbook has been created, and we can also see it right here. This book one that's been generated is a brand new Excel workbook. Now, nothing has actually happened inside here. We haven't written anything to it. We haven't even saved this brand new workbook, but now it has been generated. So this add method on the workbooks collection is equivalent to pressing Control N in your main Excel interface. It just creates a brand new unsaved workbook. By the way, this method, the add method that we see right here, is going to return back to us the workbook that's just been created. So if you want to store it in a variable so you can continue to, for example, access its properties or call methods on it, all you have to do is declare a workbook variable and then set that workbook variable to the return value of this method invocation, and that'll get you that actual specific workbook. There's one property I want to introduce you to here that is related to the process of generating a brand new workbook, and that is the Sheets in New Workbook property on the application object. This is actually both a readable and a writable property. So we can take a look at it right here. Application Sheets in New Workbook. And this is actually a perfectly named property. It reflects how many sheets a brand new workbook will have. So if I execute this now, we can see it's currently set to 3, but I can very easily overwrite this. So right here in my procedure, if I wanted to generate a workbook that, let's say, had 2 worksheets instead, all I have to do is reference that Sheets in New Workbook property. And then instead of reading it, all I have to do is write it. Again, we can just set that property with an equal sign. Let's say I want 2 worksheets in my new workbook. When I press F5, we're going to see this new workbook appear. And here we can see it has sheet 1 and sheet 2. I can go ahead and close it and try with another example. If I want it to instead be 10 worksheets, I can go ahead and execute that. And you can see all automatically here they've appeared. But just to prove it to you in the Excel interface, here is my new workbook, and it has 10 total worksheets. So you can modify that application property, Sheets in New Workbook, to set how many sheets will be present whenever you invoke add and actually generate a brand new workbook. There's one more thing that I actually want to show you, so I'm going to get rid of this thing right here. In addition to simply invoking workbooks.add, what we can actually do is feed it an optional argument for a parameter called template. And this is the easiest way that we can create a copy of an existing workbook. If we want to create a brand new workbook here, but we want it to contain everything that another workbook has, we can actually feed in that workbook that we want to make a copy of as the first argument here. And we're going to basically follow the exact same syntax that we did with the open method, where we have to provide the path to the workbook, including its entire file name and directory where it is located on your file system. So I'm currently in the exact same folder where I have an Excel workbook called Report, and let's say I want to make a copy of that workbook. I have to get the actual path, and I know that it's in the same directory as this workbook, so I can do something like this. I can get my active workbook, which is this one. I can get its path. This is going to give me the actual string that represents the current directory where this workbook is located, and I can concatenate onto this a string. Remember, just like in the last couple lessons, this is going to give me the directory. I still have to append a backslash here so I can go into the current directory where I am in. And then I could write the name of the Excel workbook that I want to make a copy of, the full name, including the extension. Watch out for that extension because it's actually going to be pretty troublesome if you're trying to open the right Excel file, but typing in the wrong extension. It's just going to say, hey, I'm not able to find this file, and you might be confused for a while. So this should do it. So let's go ahead and see if this works. I'm going to press F5, and we're going to create a brand new workbook right here. And you can see it's actually going to get the name Report 1 rather than Book 1 or Book 2. So it's going to take the name of the file that it's making a copy of and then just append a numeric count to the end. So our file is named Report, so this is going to be Report 1, Report 2, Report 3, etc. And we can see right here all that workbook contained was report in cell A1, and you can see that data has been copied over in this new copy. So we've successfully copied the report XLSM file in this brand new workbook that's been generated. And just to show you an alternate syntax, as a reminder, every argument that we feed into a method invocation is associated with a corresponding parameter. The parameter that we're actually feeding this string argument to is called template. So we can actually write it in right here, template colon equals. The exact same syntax, just if you want to be a bit more explicit, this will also work. So when I press F5, there we go. We create a brand new workbook. You can see it's still called report 1 because we haven't saved the previous one that we just opened. We just kind of threw it out there, threw it out of memory. So you can see we've made a successful copy. All right, so I'm going to close this, and that's all there is to cover in this lesson. We talked about the add method on the workbooks collection object. That allows us to generate a brand new workbook from scratch. You can very easily make a copy of an existing workbook simply by feeding the path to that workbook that you want to copy as the first argument here. And if you also want to modify the number of sheets that are going to exist in a new workbook, you have to modify the sheets in new workbook property on the top level application object. That property is both readable and writable. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the save as and save methods on a workbook object. They predictably allow us to save both a brand new workbook and an existing one that has had changes made to it. So let's go ahead and create a procedure in this lesson. We're going to create 2 brand new workbooks from scratch. We're going to save both of them on our local file system. Then we're going to make some changes to them, save them again, and then close them. We're going to do this all within the context of a single VBA procedure. So it's going to be a more complex operation than the ones we've done so far in this lesson. So let's begin here by creating a new procedure. I'm just going to call it create and save 2 workbooks. All right. First thing I want to do here is actually modify our sheets in new workbook setting on our application object. I want every single newly created workbook to have exactly 2 worksheets. So I'm going to do application.sheets in new workbook. This is a readable and writable property, so I can simply set it equal to 2. The next thing I want to do is actually declare 2 variables which are going to represent the 2 workbooks that I'm going to create. I'm going to use these variables to store those workbooks so I can later reference them very easily and invoke additional methods on them. So I'm going to call my variables W1 and W2, and they're both going to be Excel workbook objects. So W1 as a workbook object and comma W2 as another workbook. This is a shorthand syntax for declaring 2 different variables on 2 different lines. All right, so now we're ready to actually create 2 brand new workbooks. We know that we can use the add method on the workbooks collection. And this add method is not just going to create a brand new workbook, it's actually going to return it back to us as the return value of this method. So we can actually assign the variable, either W1 or W2, to this invocation, and it's going to then represent the workbook that we get back. Now remember that whenever we assign an Excel object to a variable, we have to prefix it with the set keyword. We can't just use the equal sign. So set W1 equal to the return value of this, which is a brand new workbook. We can do the exact same thing here to W2. Now this is going to create 2 brand new workbooks. This is equivalent to pressing Control plus N twice in our Excel interface, but it's not actually going to save them locally to our file system. In order to do that, we have to use the save as method on a workbook object. This is the first method that I want to introduce you to in this lesson. So let's go ahead. We're going to do W1.saveAs. Right? So whenever you create a brand new workbook, you can't just call save on it because save is equivalent to pressing Control plus S. You can't really save it unless you've actually saved it first with the save as. The equivalent thing in Excel is whenever you press save for the first time, it's going to bring up that dialog box that's going to show you where you are and allow you to choose a file name and a file type. Before you can even do Control S kind of automatically, you have to save it once in that initial format. That's the exact same thing that we're doing here. So this save as method, we want to take a look here at the 2 first parameters, which are file name and file format. File name is going to represent the actual name that we want to give to the file, and file format is going to be an enumeration that's going to represent the exact type of file that we want to save. We can save as a macro-enabled file, as a plain XLSX, as a CSV, etc. So what I want to do here is I want to give these workbooks 2 names. The first is going to be red, the second is going to be blue. And usually the way this works is if you just give the name of the workbook, for example, red.xlsm like so, it should save in the local directory or the directory in which the current active workbook is located. So if I run this macro right here, it should save my red file in the exact same directory as where this workbook is located, this workbook being the workbook object.xlsm, which we can see right here. However, I have had some issues in the past whenever I use the syntax. Sometimes it's just finicky and sometimes it results in an error. So the easiest way to make this work is to actually make sure that you're specifying the exact path where you want to save, even if it's in the same directory. So what I want to do here is I want to rely on, again, getting the path of the current workbook. And I actually tried active workbook first, but that also didn't work. There was some kind of issue. So an alternative here that worked for me is instead of using active workbook, we can actually use this workbook. And this is basically the same thing as active workbook. It's going to reference the workbook that's directly attached to this actual macro, while active workbook will target the workbook that is currently activated or clicked on or selected in the case that you have multiple workbooks open. In theory, active workbook should work here, but for some reason it wasn't working for me, but this workbook does in this case, so I'm going to use that. It still represents the exact same single workbook that we have open now, and it's going to have the exact same properties as any other workbook object. So on our current workbook, we want to get the path property, and that is going to give us, again, the complete path to where our current file is. I can, in fact, show you this in the immediate window. If I simply do this workbook.path, we can see this is where my thing is saved, and this is going to give me the directory. So what I have to do here, again, just like we did a couple lessons ago, is not just concatenate the file name, but concatenate a slash. So we're actually creating a slash right after this directory and then saving it within the current directory. And that should do it for red. Now, the second argument here is going to be file format, which is the exact type of file that we want to save it as, and this expects an enumeration. The one we're looking for is Excel Open XML Workbook Macro Enabled. If you look at the online documentation for the save as method, it's very easy to find a specific page that will give you all of the possible options, but for now, you can just trust me on this. I'm going to use my IntelliSense feature here by pressing Control plus Spacebar, and I'm going to type in Excel Open XML. And I want this one, workbook macro enabled. This saves it as our XLSM file format. Simply putting it as part of the string name right here that represents the name is not good enough. We actually have to manually tell Excel how to save this workbook. All right, so that should do it for workbook number 1. We can go ahead and copy this code below because the only thing that's going to change is the actual workbook that we're calling it on. We want to call it on W2 this time, and we want to give it a different name to avoid any accidental overwrites. We're going to call this one blue. All right, so now we've generated 2 workbooks and we now saved both of them. Let's go ahead and make changes to both of these new workbooks. So I'm going to do W1 first. Let's target the first worksheet in this one. Let's target a random range here like C3, and let's write in a value here like red with an exclamation point. All right, I can then do W2 here. Let's target another worksheet here. I know I'm going to have a second worksheet because I mandated in the very first line of the procedure that all newly created workbooks will have 2 worksheets exactly. So I know I'll have reference to a second worksheet here. Let's target a totally random range again, E5, and let's write in the value blue right here. And just like with the regular Excel interface, these operations here are synchronous, which means they occur one at a time in order, in sequence from top to bottom. So just because we've saved the workbook here, that does not mean that these changes will be preserved. You can imagine it as if we created these brand new workbooks and then written some kind of thing in our Excel interface. We still have to press Control S again in order to actually force Excel to save and commit those changes. So after we've made these changes to the worksheets, we can now introduce you to the second method that I want to show you, which is the plain save method. So this is the exact same thing as pressing Control S. Whenever you have an existing workbook and it already is saved on your file system and you simply want to change the changes that you've made to it, either locally in the interface or with VBA, you can use the save method on the workbook object. We want to do the exact same thing to workbook number 2. And now that these changes are done, we can go ahead and close both of them. W1 close, and let's do W2 close again here as well. And just to avoid any kind of potential errors, what I want to do at the very top here, just for safety, is use our familiar display alerts property on the application object. Let's set it to false at the very beginning, and then let's go ahead and set it back to true at the very end. This may not be necessary here, but it doesn't hurt, and it's a good chance to tie together all of the concepts that we've introduced so far in this section of the course. So that should do it. We have created 2 brand new workbooks. We have assigned them to variables. We have saved them both as red and blue as macro-enabled workbooks. We've then made some changes, saved those changes, closed them, and that should do it. So I'm going to save this, press F5. We might see a couple quick blurry things popping up on screen, and that's just going to be the macro going through its motions. Perfect, there we go. And now it's all gone. We have almost no evidence that this macro ran. We don't have any open workbooks right here. But if I go back into my Windows Explorer, Here's the current directory where I have the files for the course. And here you can see we've generated blue and red. And if I open blue right here, we can see here on sheet 1, we should be some values written in, maybe sheet 1 or sheet 2. It's actually on sheet 2. It's the second workbook we saved. So here we have blue right here in cell E5. And if I go ahead and open red, which was the first workbook we saved, here in red, we have it written right here in cell C3. So everything has gone as expected. And notice as well that we have 2 sheets, both in red and blue. All right, so that's all there is to cover in this lesson. We talked about a lot of things, but we primarily talked about the save as and save methods on a workbook object. They both save changes. You want to use save as whenever you've created a brand new workbook or whenever you want to make a copy of an existing one. It saves a brand new file. It's the same thing as pressing Control S when you have a brand new workbook and it hasn't yet been saved. We have to provide it with a file name. It's a good idea to provide the full path if you want to make sure that everything is going to be as stable and less likely to run into errors as possible. And then we also talked about save, which is what you can call whenever the workbook already exists and you just want to commit some changes. All right, that's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the activate method on a workbook, which effectively makes it the active workbook. This is the exact same thing as clicking into it in the Excel interface. It makes it the active or the highlighted workbook. And as we know, we have an active workbook property available on our application object, and that's what's going to be assumed whenever we reference something like a sheet or a range. We're always going to have the assumption of the active workbook if a workbook is not explicitly specified. So let's take a look here. I'm going to use the 2 files that we created in the last lesson, red and blue. I'm going to open them and then I'm going to make some changes to them. But I'm going to open them, and rather than referencing them explicitly, I'm going to make each one active first of all before I make the corresponding changes. And you can see how activate can be helpful in that sense. So what I want to do here is create a new procedure. I'm just going to call it make changes to workbooks. Let's review a couple of the concepts that we introduced previously. I want to declare 2 variables to represent the 2 workbooks that we're about to open. I'm just going to call the variables the exact same names as the workbooks, so red and blue. Dim red as workbook, and then blue as workbook as well. And we can go ahead and set each of these to the return expression, not of the add method anymore, but rather of the open method on the workbooks object, which allows us to open a single workbook and then returns that actual object. So I'm going to follow the exact same logic as we did in the last lesson. I'm going to actually reference the explicit path of this workbook, which is the workbook object. It's actually its name. I want to get the directory in which it's in and then concatenate the name of the workbook that we want to actually open, which is in the exact same directory. So this workbook.path, that's going to give me the actual directory, and I want to concatenate on to the end of that a slash, and then actually open my red.xlsm file, which is in the current directory. I can go ahead and copy this code below, and of course, the only thing I'm going to change here is I want to save it to a different variable this time. This is blue, and I want to open the blue file rather than the red file. All right, so we've opened these 2, and let's say we don't know which one is currently active. Let's say we want to write something to range A1. How do we know which workbook is actually active? Well, one thing we can do is explicitly use the activate method to make sure that one workbook is now the specifically active one. Now, we could, of course, be even more explicit and literally write red, and then we know that any changes will be made to the red workbook. But the activate method is just another way to simulate that exact same process. It kind of behaves more like a user will. A user will click from workbook to workbook, and that's exactly the kind of action that we're simulating here in the Visual Basic Editor. So on my red workbook, if I'm not sure if it's the currently selected one or the active one, I can simply call the activate method on this workbook. That's the exact same thing as literally clicking into it with the mouse. So now it's active. It becomes the property of the active workbook property on the application object. So if I reference active workbook now, I'm 100% certain that it's going to reference the red workbook instead of the blue workbook. That is now guaranteed because of the activate method. There's no chance for error. We have the exact same logic when we talk about this concept of the active sheet. We haven't talked about this one as much throughout the course, but active sheet represents the currently selected worksheet within the currently active workbook. So we could do something like worksheets here and target a specific worksheet by name or by its index position, but we may just simply want to target the one that's currently selected, that the user is currently on. And we can always get that with active sheet. So it doesn't matter if our workbook, which is red in this case, opens to sheet 1 or sheet 2 or sheet 3. Active sheet will always target whatever is currently active. So once we're on that one, we can go ahead and target something like, let's say, range A1. We're going to write in another red. And we can go ahead and do something like the exact same logic for blue. So now that we're on red, we need to switch our focus to blue. So on blue, I can call the activate method. So now we're going to switch our focus to the other one. And now we can apply the exact same logic. You can hopefully start to see the effectiveness of this. Right now, we're going to be writing different values to each, but if there's some kind of operation where we want to do the exact same process to 20 workbooks in a row, and it's literally the exact same thing step by step, we can simply go through each collection of workbooks or worksheets perhaps, simply make each one the active one, and then repeat the same code or the same logic, and it'll simply be effective in that way because it's going to apply the same procedure or the same set of rules to every item in a collection. So activate can be really effective in those situations. Right now, I just want to target range A1 on my blue workbook, the active sheet on that one, and I can do this to be another blue. Cool, so now we can go ahead. I'm actually not going to close this or save this. I'm just going to leave it open so we can see that the results are live. I'm going to save this and I'm going to press F5 to run it. And now we can see Excel is going to open those two workbooks. I can take a look here. Here is red and here is blue. We can see that red should have another red written, and you can see it is effectively done that. We can see that represented in cell A1, and it's done it on sheet 1. So one thing I'm actually curious about is I want to go ahead and activate sheet 2 and save the workbook in this state. And then I want to close it. We'll come back to that in just a second. And right here, I want to also take a look at blue. We can see another blue has been written here. So everything is effective here. We haven't explicitly mentioned either the red or the blue. We just activated them, which ensured that the active workbook and active sheet properties could target exactly what we wanted it to do. So in this workbook, what I want to do is also switch over to sheet 2. So now on both of these workbooks, we've changed the active sheet at the moment of save. So now, in theory, if I rerun this macro right here, we should be able to repeat the exact same logic, but now we're going to write another red and another blue into the second sheet in each of those respective workbooks. So when I execute this, let's see what happens. Because we did that, if I go to red, we can see that another red is now written in cell A1 of sheet 2. So whenever you save and exit an Excel workbook, it's going to preserve which was the currently active sheet. And because we used active sheet here, rather than an explicit reference to a specific worksheet, it simply targeted that one dynamically. So sometimes you may want that kind of logic where you may want to target whatever workbook is open or whatever sheet is currently active, just do it on that one. That's specifically really effective when the user runs a macro from a specific workbook or a specific sheet, and you may not know exactly where they are, but you know that wherever they are currently in their Excel interface is what you want to target. It's in those kinds of situations that properties like active workbook and active sheet can be really effective. But that's all there is to cover in this lesson. We reviewed the open method on the workbooks collection object, and we also took a look at the activate method on a workbook. It makes a workbook active. It makes it the currently selected one. It is the exact same thing as clicking into it with your mouse. In this quick lesson, I want to go over the workbook close method, which we briefly introduced a few lessons ago and kind of glossed over. The close method closes a single workbook. So what I actually want to do in this lesson is pretty similar to what we did in the last one. I just want to open our red and blue workbooks, write some values, and close them. And I want to show you how we can actually consolidate the close operation as well as the save operation. So I'm going to go ahead and copy our procedure code from a lesson or two ago. And I'm going to call our new procedure right here, close workbooks. I'm going to keep the first 3 lines here. What we're doing here again is declaring 2 variables, red and blue. Each is going to store a workbook, and we're opening the red and blue workbook and storing them in those variables. I'm going to go ahead and try a different syntax here from the last lesson. I'm no longer going to use activate. I'm just going to manually target some of the ranges on my worksheet. So instead of doing active workbook, what I can do is actually literally target red. This is just an example of an alternate syntax. Whenever you're programming, you often have many different ways that you can solve a problem. And instead of targeting active sheet, I can literally target something like worksheets 2. And let's say range A2 this time. And let's just do something here like red is awesome. It really doesn't matter. Just something random and arbitrary. I'm going to do the exact same logic with the line below. I'm going to get rid of this activation. I'm going to replace this with blue. And let's target, again, worksheets 2. Let's say again, range A2 again. And let's do blue, blue, blue. Doesn't really matter. So in the past, what we did is we actually called the save method and then we closed. Well, we do have a convenient method called close, and it actually takes a parameter called save changes, which allows us to close and also save the workbook. This is very similar to exiting a plain Excel worksheet, and then pressing that yes button whenever it gives you the dialog box to confirm. So we talked about this idea of close a few lessons ago, and we kind of glossed over it, but close actually does have that first parameter of save changes, and that expects a Boolean argument, either true or false. True if you want to save the changes, false if you do not want to save them. So what I can do here is actually just show you this side by side. I'm going to call close on red, and I'm going to say that I want to save those changes, but on blue, when I call close, what I'm going to say is that I do not want to save those changes, so I'm going to make this false, which in theory means that this line right here should not be there. So we shouldn't see blue, blue, blue because those changes are not going to be written. All right, so you can always just do red.close, you can do red.save, red.close, and then blue.save, blue.close, or you can put save changes in as the first parameter here, the second thing you write on the line following the close method, and it will accomplish the exact same result. So let's go ahead. I just want to make sure red and blue are not open first. Let me go ahead and close them. We can save, let's not save those changes yet. Get rid of blue right here. And I can go ahead and execute this from scratch. Let's go ahead and open those workbooks. All right, so now the entire thing has executed. I can now open red and blue. And as I recall, on red, we should expect to see changes on sheet 2. So when we open red, here we have red is awesome in cell A2. Everything is exactly as expected. Perfect. So we've closed it and we've saved those changes. Now if I open blue to sheet 2 again, we can see here on sheet 2, nothing has been written in cell A2 because those changes have not been preserved. So it is still in the exact same state or shape as it was at the conclusion of the previous lesson. That's all there is to cover in this lesson. We talked about the close method in a little bit more detail, particularly the save changes parameter, which expects a Boolean argument. If you give it a true, it will save the changes, and that will allow you to avoid using an additional call to the save method on a workbook. There are many different ways to accomplish the exact same thing in Excel. That's really the bigger takeaway here. And there's nothing wrong or right about one specific solution. It's whatever makes sense to you, whatever is cleanest, whatever is more optimal, whatever makes the best sense to you. Go with that approach and commit that to memory, practice that over and over, and you'll find that it will typically work. Nobody's going to judge you if you do 2 lines instead of 1 line. It's just whatever works for the given situation. That's all there's to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the add method on the worksheets collection object. It creates a brand new worksheet in the current workbook. So in my Visual Basic editor, I'm going to define a new procedure called generate new worksheet. And in here, all I'm going to do is reference my worksheets collection object and call the add method. It can be invoked by itself with no parameters or arguments, but we are going to dive into some optional parameters in just a bit. So the way this works is that if we simply invoke this, it's going to add the worksheet before the currently active sheet in the workbook. So right now, as we can see here on the bottom left corner of my Excel interface, sheet 1 is currently active, which means whenever I generate a new worksheet, it will be added before sheet 1. So when I execute this with F5, you can see the new sheet has been added and it's been placed in front of sheet 1. So it's always going to be in front of or before the active sheet. As another example, I'm going to make sheet 2 right here at the end, my active sheet. So when I rerun this macro, it should place it before the active sheet, which is going to be right here in between sheet 1 and sheet 2. So when I execute this, there we can see sheet 4 has been added and it's been placed right before sheet 2 and right after sheet 1. So whichever one you currently have selected or activated in the Excel interface, this method call will place the new worksheet before that. How can we modify that? Well, that's where our optional parameters come in. So the add method has 2 parameters. One of them is before and the other one is after. You cannot use both of them. You can only use one of them in a single method invocation, and both of them expect a worksheet object that specifies which worksheet you want to create. Do you want to place the new one before or after? So as an example, let's begin with before. What I'm going to do is just give the parameter of before. And here I can provide a different worksheet and the new one will be placed before this argument. So for example, I have sheet 1 right here and it doesn't matter which one is currently active. So I'm just going to select a random one. Let's say I want to place my newly created worksheet before sheet 1. In that case, what I can do is target sheet 1 with something like this, worksheets, sheet 1. So now I'm using the syntax to extract a specific worksheet using the name of it. So when I execute this with F5, There we can see sheet 5 has been created and it's been placed in front of or before sheet 1. And you can use, of course, any kind of syntax that you want to reference this worksheet. So if I wanted to use a numeric reference, I certainly could as well. So for example, if I scroll back here, I now see that sheet 5 is number 2 in sequence. So if I wanted to create something before sheet 5 or before sheet 2, I could simply replace this with number 2, execute this with F5, and now we can see my new sheet. Sheet 6 has been placed before what was formerly sheet 2, which is actually the second sheet in order, which was sheet 5. All right, and the exact same logic applies when it comes to creating things with the after parameter. What I want to do here, though, is just delete a couple of these so we don't get too confused. I'm just going to reduce it to a couple options here. So let's just delete all of these, maybe get down to 2 worksheets. I'm going to delete this one as well, sheet 3, and let's also delete sheet 4. All right, so now we're down to simply 2 worksheets, sheet 1 and sheet 2. Again, it doesn't matter which one is the active one if we're using the before or after parameter because we're going to explicitly specify where to place the new worksheet. So right here as another example, I'm just going to comment this. And this time I'm going to invoke add on worksheets, but rather than providing it with the before parameter, I'm going to provide it with the after parameter. Takes the exact same argument, a valid worksheet object. So right now, if I want to place my new worksheet after sheet 1, I can do this. Worksheets, let's say sheet 1, targeting it by its name, and this will create it right in between. We can see sheet 7 has been placed after sheet 1. Similarly, if I want to provide a numeric argument, let's say I want to place it now after sheet 2, which is going to be the third sheet in line, I can say after sheet 3 is where I want to add my new worksheet, and then it's going to be the 4th one in sequence. So right here, sheet, the new one that's been created right here that we can see highlighted has been placed right after what is sheet 3. All right, now an important thing to note here is that it's going to follow the traditional Excel naming scheme. So it's just going to go sheet 1, sheet 2, sheet 3. If you want to change this, what you can do is assign this method invocation to a variable because, of course, this is going to return back the brand new worksheet object. And then you can modify the name property on that worksheet if you actually want to rename it. But that's all there is to cover in this lesson. We talked about the add method, invoking it by itself, as well as invoking it with the before and after parameters. Now, before we conclude, I want to leave off with an interesting point, which is what if I wanted to write a more dynamic macro that would automatically add a worksheet to the end of my list of worksheets, but I didn't want to manually specify the explicit last position. For example, right now I have 4 worksheets. So of course I could say, put my next worksheet after worksheet 4. But what if I had 20 worksheets or 10 worksheets or 100? What if I wanted to write a macro that would be dynamically able to figure out where to put my new worksheet and guarantee that it would always be at the very end, that it would always be at the very end of the list of worksheets that I have listed here in my bottom left? How can we dynamically figure that out? That's going to be the problem that you're going to tackle in your very next challenge in the next lesson. In this lesson, we'll take a look at the visible property on our worksheet object. The visible property allows us to hide or unhide a worksheet. Now, it includes all of the standard functionality that we have in our regular Excel interface. For example, if I hover my mouse over any one of these sheets and I right-click, we have our familiar hide and unhide options. And if you've never used these before, all they do is hide a worksheet. So it doesn't permanently delete it. It just hides it in this kind of temporary box. And then if you right-click here and say unhide, you can find the worksheet that you just hid or any number of them and then unhide them again, and they'll pop back up into view. Now we have all this functionality available in VBA, and we also have a more powerful option which allows us to hide a worksheet and only permit it to be visible again if another piece of VBA code allows it to be unhidden. In other words, we can hide it but prohibit the user in our actual Excel interface from unhiding it. So let's take a look here in my Visual Basic Editor. I'll define a procedure and I'll call it hide some sheets. All right, so let's take a look at a couple of the different ways that we can set the visible property. It's actually a pretty powerful, flexible property, and it accepts a wide variety of inputs. So let's target a worksheet. Let's say worksheet number 2, which is going to be sheet 2 in my list. And we're going to access the visible property, and it can be overwritten. And one of the first things that we can give it is actually a Boolean argument, either true or false. If we make this false, what it's going to do predictably is make the sheet invisible or not visible, which means it's going to be hidden. So when I execute this macro, we're going to see sheet 2 disappear from view in my bottom left corner of the Excel interface. So let me go ahead and press F5, and now we can see sheet 2 is completely absent. We can change this back to true. The worksheet, again, is not permanently deleted. It's just hidden. It's just kind of hiding there behind the scenes. If we want to bring it back here, we can simply set this to true, execute again, And now sheet 2 has appeared once again in my worksheet. But we're not strictly limited to a Boolean argument. We can actually provide the visible property a bunch of enumerations. As a reminder, enumeration is just a combination of different constants that we can use to represent different numeric things behind the scenes. So let's take a look at that. So what I'm going to do here is actually reference each one of my worksheets, and I'm going to assign each one of their visible properties a different value for the enumeration. The first one that we have available to us, if I show my IntelliSense by pressing Control plus spacebar, is Excel sheet visible. And this is the exact same thing as setting it equal to an argument of true. This makes it visible or guaranteed to be present in our actual workbook. So this would not change anything because all of our 3 sheets are currently visible. All right. Now our second option is the corresponding one, which is equivalent to false, and that's going to be Excel sheet hidden. What this is going to do is hide the worksheet. So this is the exact same thing as giving an argument of false. So you might be thinking, what's the point of these enumerations? We've covered all of our bases with true or false. Well, it turns out there's actually a third option available to us, a third enumeration, a third constant, that's an even more severe or strict form of hiding. And it's going to be this one. So let's do worksheets 3. And I'm going to set the visible property to Excel sheet very hidden. So this is kind of a funny name. It's very hidden. What does that mean? This is actually an option that's not available to us in the Excel interface. What this means is that the sheet will be hidden and the user will not be able to unhide it from the Excel interface, which means the only way that they can unhide it is by running some kind of macro that will reveal it again. In other words, this is basically VBA exclusive, which means we hide the sheet and there's no way without running additional VBA code that the user can ever access it again. In comparison, this hidden one will hide it using VBA, but the user can still unhide it using their traditional clicking syntax in the Excel interface. So let's take a look. What we expect to happen here is that nothing will happen with sheet 1. Both sheet 2 and sheet 3 will disappear, but we're only going to be able to get sheet 2 back. So let's go ahead and execute F5. All right, so sheet 1 is gone, and if I right-click here and go to unhide, you'll notice this list will only show me sheet 2. That's because I use the enumeration Excel sheet hidden. That means the sheet has been hidden, but the user can still bring it back. They can press OK. But notice sheet number 3, which we set to very hidden, is not present here. There is no way the user can get it back unless they run some other additional macro that then sets worksheet 3 to a visible property of either true or Excel sheet visible. So that's the whole point. If you truly want to hide something from the user but not permanently delete it, that's a really good way that you can utilize Excel sheet very hidden. So I'm going to go ahead and press cancel just so that we leave things in the original state. And that's all there's to cover in this lesson. We talked about the visible property on a singular worksheet object. We can give it a wide variety of data types or values. The first is a bunch of Booleans, true or false. True is going to make it visible or present in our Excel interface. False will hide it or make it invisible. We also can provide it a wide variety of enumerations, either Excel sheet visible, Excel sheet hidden, or Excel sheet very hidden. That's all there's to cover in this lesson, so I'll see you in the next one. All right, so now let's take a look at how we can copy a worksheet, either to a brand new workbook or to our current open workbook. So what I'm going to do here is put in a random value in cell A1, just literally the word random, just so we can make sure we're properly copying the contents of a sheet. And I'm actually going to begin here in the immediate window before we write any procedure. So on any given worksheet object, for example, worksheets sheet 1 is going to target the only visible worksheet I currently have open. There is a copy method. Now, if we invoke this without any additional parameters, it is going to copy the worksheet, but it's going to do that in a brand new workbook. We can take a look at this. I'm going to press enter. You can see Excel has opened a brand new workbook. For me, it's going to be book 3, but for you, it's probably going to be book 1. And we can see the value random has been copied, so everything looks great. And of course, if we wanted to keep this, that's totally fine. We could just save this brand new workbook and work with it. So I'm just going to go ahead and close out of here. Most likely, though, I find that you're typically going to be copying worksheets to the exact same workbook. So let's see how we can do that right here. It's a pretty simple, intuitive process. I'm going to go ahead and define a new procedure. I'm going to call it copy worksheet. And I'm once again going to target sheet 1. In fact, let me alternate my syntax here and simply target the first sheet, which is going to target sheet 1. I'm once again going to do copy. This time, all we need to do is provide either a before parameter or the after parameter. We've dealt with this before, I believe, when we were dealing with the add method on the worksheets collection. I believe that's correct. So, yep. So the exact same signature is applied to the copy method as the add method. So we have a before parameter and an after parameter, and they both expect a worksheet argument. You can't do both, but you can do either one. And it's going to determine where in our current workbook we're actually going to copy our this worksheet in terms of placement. So where do we want to put it after it's been copied? Well, right now we only have one worksheet, which is sheet 1, so we can clarify whether we want the new one to be placed before or after it. So let's begin with let's say the after parameter. So what I'm going to do is do after. And remember, this expects an argument of a worksheet object, not just the index position. So if I want to extract the exact same worksheet that I have now, I can do worksheets1. So what I'm saying here is get sheet 1, get its contents, copy it, and then the copy, place that after sheet 1. So it should appear right here to the right. Let's go ahead and execute with F5. And we can see sheet 1 along with this parentheses that indicates it's a copy has appeared right here. And we can, of course, do the exact same logic, but using the before syntax. So what I'm going to do here is comment this out. And let's say I now want to place it before sheet 1. What I can do is do worksheets. I can target sheet 1 in any way. I'm just going to do by name now, sheet 1. And I want to copy it, but I'm going to provide it the alternate parameter, which is before. It also expects an argument of a worksheet. And so I can give it once again, sheet 1. Or worksheets number 1, and this time it's going to place it before sheet 1. The advantage of this approach, of course, is that we don't have to worry about what is the currently active sheet or the selected sheet. It's just going to follow this explicit logic of copying sheet 1 and then placing it before sheet 1. So when I execute this, there is our new copy, and you'll notice it's been placed before sheet 1. So you can apply before or after any worksheet that you want in our list, and it's going to make a copy and place it there. We can see it is the copy. In fact, we have the word random right here. All right, that's all there's to cover in this lesson. If you want to copy a sheet to the current workbook, just provide that before or after parameter. If you want to copy it to a brand new workbook, just do copy by itself, and that'll do it for you. I'll see you in the next lesson. Okay, so now we've covered how we can hide a worksheet and how we can copy a worksheet. In this lesson, we'll talk about how we can delete a worksheet from the workbook. Pretty simple. It's just going to be the delete method. So what I'm going to do is create a procedure here. I'm going to call it delete worksheet. And let's go ahead and target a worksheet. Let's do something like the first one we have right there, which is our copy, sheet 1. And this one. Doesn't really matter. We can target it by name or we can target it by its index position. And I'm going to go ahead and call the delete method. There is one important caveat, as you can probably guess by the fact that I made a couple line breaks here, which is whenever you delete a worksheet, it's going to prompt you, or Excel is going to prompt you with that would you like to delete box. We can see it right here. If I try to delete this right here, let me go ahead and press delete. This little box that pops up, this is an example of an alert. We saw a couple examples of this earlier, for example, when we made some changes to our workbook but didn't save them. This is an example of an alert. And yeah, we could run this macro and it would work and the user would just have to click delete. But as we know, we want to automate as much of the process as possible to make it as simple to use as can be. So I'm going to cancel out of here, and we're going to use our familiar tactic at the very top. I'm just going to write application.display alerts, and I'm going to set that equal to false. That will ensure that none of those alerts pop up, allowing the deletion process to proceed as smoothly as possible. I can then go ahead and at the very end of all of my procedure work, I can set this back equal to true just to make sure that we don't kind of disable it all across Excel, and that the regular Excel functionality will continue to work as soon as our macro is done running. Let's go ahead and try this. We should be able to delete that that worksheet that's at the very beginning of our list. So I'm going to press F5. And there we can see it's disappeared, and now sheet 1 is present. We can go ahead and target another one. So now I want to target this one right here, that other copy that we made in the last lesson. This time around, I'm going to copy it based on its index position, which is going to be number 2. I'm going to go ahead, save this, execute, and press F5. And we can see it's now been deleted. Notice that the hidden worksheets are not being targeted, by the way. That's all there's to cover in this lesson. We talked about the delete method. You can just invoke it as is on a single worksheet object. You don't need to feed it any additional parameters. Just remember that if you want the process to be as smooth as possible for the user, it's a good idea to disable alerts before you do it and then re-enable them after you're done actually deleting the worksheet. In this lesson, we'll take a look at the move method on a worksheet, which allows us to move it around, much like you can do by simply clicking it and dragging it in your Excel interface. Now, unfortunately, I only have one sheet currently visible because we went through a whole bunch of processes of hiding our worksheets a few lessons ago. So I'm just going to go ahead and unhide the remaining 2 worksheets that I have here. So what I can do is target my worksheets, let's say number 2, and I'm just going to set visible equal to Excel sheet visible. That should unhide sheet 2, and I want to do the exact same logic for sheet 3. All right, so now we have 3 sheets, and we can go ahead and proceed. So what I'm going to do here is just buy myself a little bit of space and write a new procedure, and I'm going to call it move worksheet around. It's going to be a pretty simple method call. I'm just going to target a sample worksheet. Let's say we're going to start off with sheet number 2. So I can target it as always anyway, either by name or by index position. Let's go ahead and target it by index position number 2. And I'm going to call the move method. And exactly like the copy method, exactly like the add method, the move method accepts either a before or an after parameter, which allows us to specify where it is that we want to move it. And before or after both expect a valid worksheet argument. So you can't just give it a number, you have to give it a valid worksheet. So let's say I want to move sheet 2 after sheet 3. So what I can do is write after, and then I'm going to write worksheets, and I'm going to actually target sheet 3 this time by name. So what we're going to do is we're going to target sheet 2 right here. We're going to move it, and we're going to clarify that we want to move it after this worksheet, sheet 3. So when I execute this, we can see now sheet 2 has been placed after sheet 3, which moves it forward, and we've sort of swapped these positions around. Right? Pretty much the exact same rules and logic applies if we want to move it before something. So let's say I now want to take, let's say, sheet 2 again and move it before sheet 1. So I want to take it from the end all the way to the beginning. I can target sheet 2. Worksheets, this time I'm going to use the name, sheet 2. The move method, this time I'm going to do before, give it the colon equals, and I want to move it to the beginning. This time I'm going to target the first worksheet in line, which I can target with sheet 1, but I also like to use the index position here because if we do worksheets 1, that always guarantees that we're going to target the very first one in line. So this is a very simple syntax that you can use to always move it before the very first sheet that is in your sequence. All right, so we're going to take sheet 2, move it to the very beginning. Let's try this. And there we go, sheet 2 appears right here in the middle. If I now want to move it, let's say in the middle of these two, sheet 1 and sheet 3, I can either do after sheet 1 or before sheet 3. Those two will have the exact same effect. All right, that's all there's to cover here. We talked about the move method. It has a very similar function or method signature when compared to the copy method and the add method. Simply give it a before or after parameter and give it an argument of a valid worksheet, and it will move that worksheet around. In this section of the course, we're going to be taking a look at the range object, which is the most popular object in the Excel object model. A range object is a grouping of one or more cells in a single worksheet. So to clarify, Excel does not have the concept of a cell object. Rather, a cell is just a range that targets only one cell. The range object is kind of the catch-all tool that we use to target anything from one cell to a clump of cells to all the cells on a single spreadsheet. A range is built around A1 notation, which is a technical term for a concept that we're actually pretty familiar with. A1 notation simply means that we refer to a column with a letter and we refer to a row by a number. So A1 comes from the top left cell in a worksheet, which is right here, cell A1. We use the letter from the column and we use the number for the row, and that represents how we're targeting the address of a cell. As we know, the range object is a property of the worksheet object. The worksheet object is nested under the worksheets collection. The worksheets collection is found within the workbook object. The workbook object is nested within the workbooks collection, and that collection of workbooks is nested under the application object, which sits at the very top of the Excel hierarchy. A range can provide a qualified reference, which means we can tell it specifically what workbook to use and what worksheet to target in that workbook, but we can also target a range without mentioning any of those characteristics. A range without a qualifier will assume the active workbook and the active sheet. The active workbook, of course, is the workbook that is currently active. It's the one that we're clicked into, that's selected within our Excel application. The active sheet is whatever sheet we currently have selected within that workbook. So for example, in this Excel workbook, I have two sheets, sheet 1 and sheet 2. The one that is highlighted, the one that is activated, is called the active sheet. So sheet 1 is the active sheet. Now we have to be careful here because there's actually two types of sheets available in Excel. A regular spreadsheet, which is the one we see right here, or a data sheet. And the second one is called a chart sheet, which is used to render a chart, like a pie chart or a bar graph. In that case, those chart sheets don't actually have a range property on them. So if the active sheet is a chart sheet, then the range property will not exist and we're going to run into an error. So whenever we have the potential to run into that error by having chart sheets, it's a better idea to include explicit references to the actual sheet that we want to target. In this course, we're not going to be diving into charts until much later, so we don't have to worry about that right now. All of our sheets are going to be data sheets, spreadsheets, so whenever we use range, we can be certain that we're not going to run into that bug. In this lesson, I want to dive into the select method, which simply selects or highlights a range on the worksheet. This can be a particularly useful tool when you want to double check that the reference that you're providing to a range is proper and that you're targeting the right thing. So let's take a look. I'm going to define a procedure here called highlight range. And we're going to do some pretty simple statements right here. But again, this is just to get us thinking about what a range can hold. So of course, a range can select a single cell. So for example, I can do range right here, target a cell like B5, and let's execute the select method on the range. All that's going to do is highlight the cell. So when I execute this, we can see the little green box has moved to cell B5. Whenever we select a range in Excel, we actually get access to that very same range with a property called selection. So right below here, what I can do is target selection, which right now is cell B5, and let's say write a value into there like hooray. So I'm just going to execute this, and we're going to see that that value is going to be populated in cell B5. Now, right now, you may be looking at this and saying, what's the point of this? Can't I just do range B5 dot value equals hooray? And the answer is you absolutely can. But imagine a macro that you'd be running where you want to ask the user to actually select some cells. So you want the user to actually do the highlighting. What you can do is target that highlighted collection of cells with something like selection. And that allows us to be very dynamic. Our macros no longer even have to reference any specific range because we're going to dynamically be able to figure it out by what the user has selected. So whatever is currently selected, for example, this selection or this selection, this is going to be represented by the selection keyword or property within VBA. So range actually offers us a wide variety of syntactical options to refer to a cell or collection of cells. So we know here that we can select a single cell by just writing it in as the A1 cell reference. What we can also do here is actually specify a range or a collection of cells with a colon. So if I want to target, for example, cells B3 through E9, I can write it like that. That's going to select that entire range of cells. We can also separate these arguments and put them in as two different arguments to that range. So what we can do here is write our first argument, which is going to represent the top left corner of the range that we want to target. And the second argument is going to represent the bottom right corner of the range that we want to target. So we're basically creating almost like a square where we're specifying the top left and the top right. It is going to result in the exact same thing. So we can see here we're selecting the exact same box. Two different ways to accomplish the exact same task. We can also use the range syntax to reference a whole column or a whole row. So for example, if I want to target all of column E, what I can do is just write E through E. Then when I execute this, I'm going to select just that column. If I want to target more than one column at a time, for example, let's say I want to target B through F, I just begin with my first column, colon, my ending column. That's going to select all of the columns there. I can do the exact same syntax for rows, but instead of providing letters, of course, I provide numbers to represent rows. So if I want to target, let's say, row 3, I can just do row 3 through row 3. That's going to target that. And let's say I want to target rows 7 through 12. It's just the beginning row, a colon, the ending row, and that's going to select that entire range of rows. Here's another cool feature that's available with range. We can actually make up a range of different non-contiguous cells. What that means is the cells don't have to be connected to each other. That's what non-contiguous means. So, for example, let's say I wanted to select cell A1 and then another clump of cells like B2 through, let's say, B3. What I can do is actually put a comma after my initial reference and then put the other reference that I want to target. So when I execute this with F5, you can see we're targeting both cell A1 right here, as well as all of the cells in B2 to B3. Let's add another range here. Let's say I want to target something completely far away from those. Let's say cell D9 through G15. When I execute this, you can see we're going to target those three non-contiguous ranges, and all of the familiar syntax is going to apply. So once we have those selected, we can use the selection to write in a value to all of them. For example, let's do hooray again, hooray. Execute that. So now we can see we've targeted these separated ranges and performed some kind of identical process on them. It doesn't have to be writing a value. We can, for example, perform some kind of formatting process or call some kind of method on all these cells. The range object does not actually have to be cells that are strictly connected to each other. They can be separate like here. All you have to do is separate those range references with a comma in a single string using the familiar colon syntax, and that way we can target these non-contiguous ranges. That's all there is to cover in this lesson. We talked a little bit about the range object and the select method, which simply selects a range or highlights it so we can see it in the interface and confirm that it's the proper thing that we're referencing. Once it's selected, of course, it also becomes referenced by something called the selection property. So selection right here is the same valid range object, and then we can invoke whatever methods we want or use whatever properties we want on that range object. Again, the advantage of this is we can allow the user to select something first and then ask them to execute a macro that's going to target their selection. That way we can target a dynamic range. We also talked about the many different arguments that we can give to the string to target a range. We can target a cell, a clump of cells. We can target a column, a row. We can even target non-contiguous ranges. There's a lot of power in this simple range syntax. That's all there is to cover here. And throughout this section, we're going to be diving into a lot of different things related to range. It is the most popular object available in the Excel object model. Most of our operations in Excel deal with data, writing it, manipulating it, etc. And that takes place in the range object. So that's to be predicted. I'll see you in the next lesson. In this lesson, I'll dive into the differences between the value property and the text property on a range object. So what I'm going to do here in column A is write a whole bunch of different values. I'll begin with just a regular string of hello. Then I'm going to do a regular number like 10. Below here, I want to do something interesting. I want to store a currency, so a amount in dollars. So what I'm going to do is just enter a number like $9.99. But once that's entered, I'm going to select from this dropdown here and change the format from a regular plain number to a currency. So now we're going to see this little dollar sign appear in front of it. And finally, what I want to do here is to store a date. So I'm just going to enter my birthday, 4/12/1991. And then what I'm going to do is highlight this. It's already been recognized as a date by Excel, but I want to represent it in a different format. I want to represent it as a long date, which is going to include the day of the week as well. Now let's transition to the immediate window in our Visual Basic Editor, and we can take a look at the differences between the value property and the text property. So let's begin one cell at a time. For a plain cell that just has something like text, the value property and the text property are going to return the exact same thing. They're just going to give me the value or the text that's being stored within that cell. The same rule applies whenever we have a plain number like 10 in cell A2. So if I take a look at the value of that, we're going to get 10. If I take a look at the text of that, we're going to get 10 as well. Here's where it actually starts to get interesting, which is cell A3. Because in cell A3, we have the concept of a currency. Behind the scenes, a currency is just stored as a regular plain number, right? So if we take a look at the actual value, the value property returns the actual representation of the data. So behind the scenes, the only thing that's really being stored in the cell is $9.99. The dollar sign and the idea of currency is kind of like a visual add-on that Excel adds for the user so they have a little bit more context. But there's no difference behind the scenes as far as how Excel is storing this data behind the scenes, kind of the operations that Excel does under the hood. So when I take a look at the value you can see being stored in that cell is $9.99. That's no different than if I literally wrote $9.99 in the cell, the very first example. However, if I take a look at the exact same range, but this time I target the text property, we're going to get the literal text representation that exists in that cell. So the actual thing that the user is seeing in the Excel interface. That's the benefit of text. Because if we only use value, we're going to lose potentially some of those aesthetic details. That is how the cell appears in the actual interface. Let's take a look at another example with dates. So in cell A4, I have a date. And if I take a look at the value here, I'm actually going to get the way that VBA represents dates, which is just going to be the month, then a slash, then the day, then a slash, then the year. So notice that the representation of the day of the week, Friday, is not present, and neither are the commas. This is the way that VBA stores all of its dates internally. We took a look at that whenever we created the date data type way back when a couple sections ago. However, if we use the text property on the exact same cell, we're going to see that that's going to give us the way that it's actually represented as text in that cell, which is the Friday with the commas, etc. So as we've seen so far, sometimes the value and text properties will both return the exact same result, for example, hello and 10, but sometimes they're going to return completely different answers because how Excel stores data is not always the same as the way that it presents data in the Excel interface. That's the big difference between text and value. Value is going to give you the data as it's stored, while text is going to give you the data as it's presented in the Excel interface. Over the next two lessons, I want to introduce you to a different way of thinking about cells in a spreadsheet. So far throughout the course, we've relied on a specific notation for cells that we've called A1 notation. A1 notation simply means that we use a letter to represent the column and a number to represent the row. For example, cell C4 or cell F2. The reason it's called A1 notation is because the top leftmost cell in our spreadsheet right here is cell A1. So the top leftmost cell and the way that we reference it is also where the notation gets its name. But this isn't the only way that we can actually think about references within our spreadsheet. If you take a moment to think about it, there's a lot of logical jumps that we make in Excel. For example, if I was working with a coworker and I had a value here in column A, and I said, put a value in the column that's 2 to the right, the coworker would intuitively understand that I mean column C. But how are they doing that? Well, they're looking at it from a logical perspective. But from a computer perspective, from a programming perspective, it doesn't really make sense because our column is A, and how do you represent the idea of 2 to the right of A, right? A is a letter. So if we were to try to express this as a mathematical operation, it would be something like A plus 2, which doesn't really make any sense. So as you might guess, behind the scenes, Excel is actually looking at column A as column 1. If we look at that column as column 1, it becomes a lot easier to perform some kind of mathematical range movement. If we want to move 2 columns to the right, it's as simple as saying, we're in column 1, let's add 2, we're going to get 3, and so our final destination is going to be column 3. Believe it or not, behind the scenes, that's how Excel actually works. So what we see up here with these letters is actually just a mask. It's a layer above Excel's actual mathematical model. This is just presented to the user to offer a little bit of simplicity. But behind the scenes, the columns are also represented as numbers, and that's exactly what R1C1 notation is. R1C1 notation is just a different way of thinking about range references. In this notation, we use a number to represent both the row and the column. The reason it's called R1C1 is because in this syntax, the top leftmost cell right here is row 1, R1, and the column is column 1 or C1. So that's where we get the name R1C1. As it turns out, we can actually enable a setting in Excel to bring us into this view of R1C1 where all of our columns will be represented as numbers. So we can see how Excel is actually working behind the scenes. Pretty simple. All we have to do is go into File right here, then Options, and on this Excel options box that pops up, there's going to be a Formulas tab. And under this section, Working with Formulas, we have an R1C1 reference style button. If I click that and then click OK, you'll notice that the columns are now going to be represented as numbers. Now, this doesn't just change the visual look of Excel, it also changes how we have to write formulas within our actual cells in our spreadsheet. So for example, let's say I put a value right here. In row 4, column 2, let's just say I write the value hello. Let's say I want to reference this value from another cell. Let's say any random cell like right here in row 10, column 8. Well, normally I would write something like row 4, column 2 in the actual A1 notation, which would be B4. But now we don't have the concept of B, so something like this is simply not going to work. We basically turn that option off when we enable this R1C1 setting. So the first thing that you have to know about R1C1 is that the way that we reference a absolute cell, so a kind of a deterministic reference to an explicit specific cell, is by writing the actual numbers after the R and C letters. What I mean by this is if I want to reference that cell, I begin with the letter R, that represents the row that I want to capture. And in this case, it's row number 4. And you can see that the blue highlighting box has now appeared to show exactly what it is that I'm targeting. After that, we put C, that represents the column. And then after C, we put the actual number of the column that we want to reference. So in this case, it's going to be column 2. So if we have a syntax like this, equals R4C2, row 4, column 2, that's going to get us the value hello. So that's how you make absolute references in R1C1 notation. The real benefit of R1C1 notation, however, comes from relative references. Let's just dive into a few examples in this lesson, and then in the next one, I'll show you an actual example with a real life problem that you might face. So what I'm going to do here is just clear this content, and let me go ahead and place a random value in one of these cells. Let's just say row number 6, column number 4. I'm just going to write a value like 5. And what I want to do here, after I just make it a little bit more definitive, let's bold it, center it both ways. Let's say I want to reference this cell from a bunch of cells around it, but this time I don't just want to use the absolute reference of R6 C4. I want to target it relatively from where I currently am. So for example, let's say I'm going to start in this cell right here, row 4, column 4. The syntax is going to look like this. I'll begin with my equal sign, and I'm still going to begin with my R here. And what I need to do here is I need to move downwards. And the way I do that is with actually square brackets. So I can't just write number 2 here, because if I write number 2, then it's going to interpret it as row 2. But if I put square brackets, the number in here represents the number of rows that I want to move downwards. So if I put 2 here, what this means is 2 down from the current row. So now you can see we're highlighting the proper row, row 6. Now, how do I stay in the same column? Well, if I just do C by itself, we could do something like write the manual reference of C4, but there's really no need to do that because it's going to be less dynamic. If we write just the letter C, the way this works is it's going to know the column you're in and it's going to substitute it. So just the letter C means the current column. So this syntax is, again, going to go 2 rows down, same column. And it's going to reference the value in that cell. So we're going to get a 5 in there as well. We've copied that value. Let's take a look at another example. This time I'm just going to navigate a little bit below, maybe 3 cells below. And once again, we're going to begin with an equal sign, just to do a few more practice runs. We're going to begin with R, but this time we want to navigate upwards relative from where we are. So we know that whenever we want to navigate, we always have to do the square brackets, otherwise it's going to be a literal reference. But this time, if we put a positive number, we're going to move downwards. So in order to move upwards or backwards, you actually have to provide a negative number. We want to move 3 rows up, so we have to provide a value of -3. Once I close this, you can see the right row is highlighted, and now we still want to stay in the exact same column, so I can just put the single letter C, and that's going to target the 5 in this cell and represent it right here as well. 2 more examples. Let's attack this number from both the west side and the east side. Let's say I start right here in row 6, column 1. Once again, we're going to put an equal sign. Now this one is a little bit different because now we have the situation reversed. We want to get the value that's currently it's number 5, but we want to stay in the current row. So now when I write R, I'm not actually going to write anything afterwards, neither a number nor a square bracket with a number, because that would be either an absolute reference or a relative movement. In this case, I want to stay in the exact same row. So this is done. However, when it comes to columns, this time around, I do need to provide something to columns in order to actually move to where I want to go. And again, I can provide C4 here to target column 4, but I want this to be dynamic. So how can I actually move? Well, I want to move 4 columns over, rather 3 columns over, from column 1 to column 3. And then it simply becomes a mathematical calculation. If I want to end up in 4 and I'm currently in 1, I have to move 3 over. So I can provide a positive value of 3. 3 in square brackets when it comes to columns means rightwards. And when I execute this, we're going to get the exact same result. One more example right here. Let's say I move somewhere immediately to the right of my original cell. Same idea. We're going to use R here to stay in the same row. We're going to use C, and we want to move now backwards. And it's the exact same logic as moving upwards when it comes to rows. Whenever we want to move leftwards with columns or backwards, we have to provide a negative argument. In this case, I want to move 1 to the left. And again, the way you can think of this is I'm in column number 5. How do I get to 4? 5 minus 1. So you can think of it as a mathematical expression like Excel does. And when I execute this, we're going to get the exact same value. So in this lesson, that's really all there is to cover here. We talked about the R1C1 notation and the different ways that we can reference cells within R1C1 notation. We talked about absolute references. In that case, all we do is we just write R followed by the number of the row, and then C followed by the number of the column. We can also leave either R by itself or C by itself. That's going to reference the current row and the current column. And finally, we have that square bracket notation, which is a dynamic relative movement. So a positive value for rows means downwards, a negative value means upwards, and a positive value for columns means rightwards, and a negative value means leftwards. It's a lot to take in, so I recommend you do an exercise like this. Just put a value somewhere randomly in the sheet, find some random cells around it, and see how you can navigate to that cell. In this lesson, we kind of take a look at some of the basic examples, but try an example where you have to provide negative arguments to both R and C, or positive arguments to both, or swapped arguments, negative, positive, positive, negative, etc. In the next lesson, we're going to take a look at how we can apply this to a real-life math problem, or a real-life Excel problem, rather, and you'll see some of the benefits of R1C1 notation, especially as compared to A1. I'll see you there. All right, let's now take a look at how we can use R1C1 notation in the context of a real-life Excel problem. Let's begin with something basic like a two-column sum. So right here in column 1, I'm just going to populate a few numbers, 1, 2, 3, 4, 5, and right here to the right, let's do a couple more, 6, 7, 8, 9, 10. And let's say in column 3, I just want to do the sum of the numbers that are 2 to the left, or rather the cells that are 2 to the left. How can I accomplish something like that? Well, we begin with the equal sign, of course, and then we're going to need the sum function. And let's open it up. And let's say I just want to feed these arguments with the colon syntax, so from this cell to this cell. How can we accomplish something like this? Well, I have to begin by targeting the cell that is 2 to the left. The way I can do that is I know that I want to stay in the exact same row, so I can keep the R by itself. I then use my C syntax, and now in order to navigate or move, I have to provide my square brackets. So I want to move 2 to the left, 2 columns to the left. So I have to provide a -2. Again, as a reminder, if you're starting in column 3, the way you get to column 1 is by subtracting 2. So you can put a -2 there. After I close the square brackets, I can put a colon. That's going to delineate where the beginning of my range begins and the end of my range. So now I have to put the endpoint. So it's still going to be the same row. So I'm just going to use R again. It's going to be, again, the C, and I once again have to use the navigation syntax, which is the square brackets. But this time, I want to move only 1 column leftwards or backwards. So it's going to be -1. And if I close this and then close the sum formula, we're going to get the right result, which is 7. Now, here's the beauty. You can probably recall what this would look like in something like A1 notation, where if we were to just drag this formula down, each cell, Excel would figure out the right letter references and the right row references and stuff like that. So let me actually show you how this would look in, let's say I'm just going to copy it down right here and go back to our original Excel view. So if I go to File, Options, and Formulas, and R1C1 Reference Style, we can actually see right here that our formula is being copied down A1 through B1, A2 through B2, and this is all great. However, you'll notice that each cell is actually containing a totally different formula. Here's the beautiful part about R1C1 once I go back to that option. We can actually, if you think about it for a moment, what you'll realize is that the formula right here applies to every single cell, right? Because no matter where we're starting from, let's say we start somewhere here, the logic is the same. We want to take the sum of the whole range from 2 columns to the left to 1 column to the left. So as we drag this down, let's say we complete it all the way to here. If I navigate through these cells, you'll notice that the formula is actually not changing, right? So it's a lot more intuitive now because we don't have to actually look at that dynamically changing value of the column or the row. Now it's the exact same formula. This is exactly how Excel is able to figure things out behind the scenes. So this is one benefit of something like R1C1 notation, is that we have a lot more consistency now in our formulas. It's a one way of writing things and it just logically makes sense. Let's take a look at another example with both relative and absolute references. I'm going to transition here to sheet number 2. And let's say I want to write a basic spreadsheet to calculate the tip that I want to pay on a restaurant bill. So I can do something like this. I'll have a column here called price, and a column called tip, and a column called total. And in this column, I can just have a random list of numbers. This represents my total restaurant bill. Let's just do something like this. And let's say the tip is going to be determined by a percentage, which I'm going to place in this cell right here. And let's say I want to tip 15%. So I'm just going to put 15%, put that in here. So this is actually an example that's going to require us to use both absolute and relative references using R1C1 notation. So the first thing I have to do is to calculate the tip, which of course is the price times the percentage. So how can I do something like that? Well, I can begin with the equal sign. The first thing I want to do is reference the price, which no matter what cell I'm in here in the tip column is always going to be 1 column to the left. So I want to stay in the current row no matter which cell I'm in, but with the columns, I want to navigate 1 to the left or 1 backwards. The next thing I want to do is to take this number, this value, in this case 10, and multiply it here with the asterisk times the value that's in this cell. However, this is an absolute value because no matter where I am in these cells, I always want to make sure I'm referencing this one, row number 1, column number 5, right? Because this is a static fixed value. It's not dynamically changing. It doesn't need to change row to row. We always want to make sure we're targeting this cell. How can we absolutely target a cell? Well, if we don't use square brackets and we use R followed by a number and then C followed by a number, that is an absolute cell reference. So we want row number 1, R1, and column number 5. R1, C5, no square brackets, and no R or C by itself. This is an absolute reference to that cell. So when I execute this, we're going to get 1.5. That's exactly right. That's 15% times 10. We can go ahead and drag this down. And again, you'll see the beauty here is that this formula is still not changing because the logic is always the same. Take the value 1 column to the left, multiply it by the static value in this cell right here. Right now, the next thing we have to do is to just add these two numbers together, and we can use the exact same logic we just saw on sheet 1. So we can do something like this. We want to do the sum. In fact, let's do something different. Let's just do the plus symbol right now to vary things up a bit. I can say, all right, stay in the same row, go back 2 columns to the left, and let's add, stay in the same row, and go back 1 column to the left. All right, I'm going to get 11.5. That's the right answer, 10 plus 1.5. I copy this down. Again, as I scroll down through these cells, keep your eye on the formula bar right here. You'll notice the R1C1 formula is not changing. This is a pretty powerful feature, and not just here in actually Excel. I know there are some developers and even Excel users who keep R1C1 notation on all the time because they just think it makes it more intuitive. It's more mathematical. You can think of both your rows and columns numerically. But even if you're going to be sticking with A1 notation in your Excel interface, this kind of thinking as far as navigation, thinking of 2 cells down or 3 cells to the right, relative references, this kind of thinking will help you a lot when it comes time to write your macros, because many times you're going to be doing some kind of process in coding where you're going to be in one cell, you're going to need to use that cell's value to perform some kind of calculation, and then, for example, paste the new calculation 1 cell to the right or 2 columns to the right. And having the perspective of being able to look at this grid kind of in this intersection of a row and a column is going to be a lot more helpful and beneficial when you're figuring out where to paste that value compared to thinking about it in terms of letters, right? Because column A, column C, how do you move from here to here? Do you have to like concatenate a number to a letter and in a range reference? It becomes a lot more complicated. It's a lot easier when you think of everything as just being referenced by a number. Before we conclude this lesson, what I want to do is make sure we bring us back to A1 notation just so you don't freak out and wreck anyone else's experience with Excel if somebody else is using the program. Again, as a reminder, we can go to File, we can go to Options, and then in this box there is a Formulas tab, and we can just uncheck R1C1 reference style. And this will take us back. And again, this will not only fix just the columns, it's automatically going to fix all the references is in here. So these are all the exact same formulas that we wrote. The reason, again, that Excel is really easily able to convert back and forth between those two is because behind the scenes in the actual code base, Excel is using R1C1 notation for all of its navigation and movements and that kind of stuff. That's all there is to cover on the topic of R1C1 notation. So I'll see you in the next lesson. All right, so a couple lessons ago, we talked about the value and text properties, which allow us to get or set a cell value or the actual displayed text. And in this lesson, we're going to take a look at 2 more properties that we can use to actually get or set a value in a cell. And those 2 properties are formula and formula R1C1. Let's begin with the read-write formula property, which can be used to set a cell to use an actual formula. For example, in the Excel interface here on the left-hand side, I have 2 values here, 3 and 4. And let's say I want to write in a sum function in here, but I want to do it using VBA. Here's what I can do. Let's begin by declaring a procedure. I'm just going to write it, write formula. And what I want to do here is reference my cell of range A3. And this time, I'm going to use the property formula. And formula, I'm going to use the equal sign to set a value for that property. And this is still going to be a string. However, in this string, I can actually write the equivalent Excel formula that I want to use. So in this case, I want to use the sum. So I have to begin with the same syntax I would use in the main Excel window, equals sum. And now I can write a formula like A1 through A2, close my parentheses, and it's the exact same as writing it manually right here. So when I execute this formula, this procedure with F5, we're going to get the right value of 7, and right here we can see that that has been written properly into the formula bar. Let's take a look at the actual differences again between the value, text, and formula properties, just so you can get a sense of how this data is actually being stored under the hood. So let's just write out a procedure here called, let's say, get cell formulas, or let's say get cell values is a better name. And right here, I'm just going to use a bunch of debug prints. Let's get debug prints range A3 value. Let's go ahead and copy this and just replace those property values at the end. Value, text, and then let's take a look at formula. So when I execute this with F5, you can see that value and text are both going to give me the exact same result, which is 7. The advantage, of course, of formula right here is that it's actually going to give me the formula that was used as the basis of calculating that cell. We can't see this right here unless we click into the cell and actually take a look at the bar here, but we can extract it right here with the syntax when we're using the get property, when we're getting the property value rather than setting it. And of course, we can do anything we want with this string, such as manipulate it or the like. So again, these properties all serve a different purpose, depending on whether you want to get the actual value that's stored in a cell, the actual number, the displayed text, or the actual formula in this case that's being used to calculate the value that's being displayed in that cell. Let's take a look at one more example. Here on sheet 2, I have a different data set. It's pretty simple, just 3 columns worth of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say I want to do the exact same thing as I did a moment ago. I want to write the sum formula here. However, this time I want to do it using R1C1 notation. Even though we don't have that setting enabled right here, we can actually use it within our VBA code. And you can see some of the simplicity of that in just a second. So let's go ahead and define a new procedure here. Let me just create some space. And I'm going to call this one calculate totals. My sheet 2 is now going to be my active sheet, so I don't have to explicitly reference it. I can just go ahead and target my range. And I want to make sure this formula is populated across all of these 3 cells, so I can target range A4 through C4. So in my string here, in my double quotes, A4 through C4, this time around, I want to target the formula R1C1 property. And as you may recall, perhaps you may not, this is actually the property that the VBA macro recorder uses whenever it's actually recording your macros. So this is the default thing that it uses behind the scenes. So if you don't remember the syntax from earlier in the course, feel free to watch that video and you can take a look at how VBA does it behind the scenes. So this is actually going to take another string, but this time around, we're still going to be using sum. This time around, we're actually going to be providing the arguments in R1C1 notation. So the beauty here, again, is that we can provide a single formula here because, again, R1C1 is the same formula no matter what cell you're starting from. If we had to do this manually and we had to figure out, hey, A1 through A3 or B1 through B3, we'd have to make our code a lot more elegant and it'll be a lot more difficult to put together compared to an R1C1 formula, which is going to be pretty simple. No matter what cell we're in row number 4, we just say, hey, we want the sum of the 3 cells above it. So the way we can do that is we stay in our current row, which is always going to be row 4 for all of these 3 cells. And we want to take the sum from the starting from the row that's 3 above, which is row number 1. So from where we are now, we can move 3 rows up, again with that negative notation. And we want to stay in the exact same column. So I'm just going to put a C here. And we want to sum from that value all the way to the row that is 1 above. In that case, that's going to be row 3, and still stay in the same column. And then the last thing we need to remember to do here is to actually close the sum function. So again, what this is going to do, just to give you an example, let's say we are targeting this cell right here. It's going to go 3 rows up, which is right here, and take the sum from that to the row that's 1 row up, which is number 6 in this case. Take that sum, calculate it, and write it into here. So we can go ahead and execute this code. Let's press F5. And we can see everything is being written. Even though we used formula R1C1 right here, we can see that it's using plain A1 notation right here in the main interface. But the beauty of this is that we don't even have to think about the letters anymore, whether it's B1 or C1 or A1. We can just think about the formula, rather, the relative formula, and this singular formula will apply across the entire board. That makes the process of writing these values and these calculations a lot easier. Believe me, these kinds of references with R1C1 notation really shine when it comes to challenges like this. That's all there is to cover in this lesson. We talked about the formula and formula R1C1 properties, two more properties in addition to value and text that are available on range objects that we can use to actually set the value in a cell or set the presentation value in a cell, etc. Play around with these two. These are pretty popular in professional VBA code, especially when we're doing a lot of repetitive operations, for example, repeating the same thing like we are here in row 4, or for example, moving downwards in a column and performing some kind of consistent calculation on every single cell. It's very easy to write one R1C1 formula and have it do the exact same thing everywhere where it's needed. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at the offset property on a range object. The offset property is used to perform navigation or traversal. We start at a given range, then we specify how many rows or columns we want to move, and Excel will move that range to somewhere else in our worksheet. Let's take a look here in the immediate window. Let's begin by targeting cell A1. That's going to serve as our starting point. So I'm going to say range A1, and let's just call the select method so we can highlight it in Excel. There it is, our top left corner of our worksheet. So let's go ahead and use the offset property. When I open the parentheses, the tooltip is going to tell us that the offset property expects two arguments. The first is row offset and the second is column offset. And this represents how many rows we want to move and how many columns we want to move over from where we're starting from. A positive value for the row offset argument means that many rows downwards, and a positive value for the column offset property means that many columns to the right. So for example, if I want to move 2 rows down and 0 columns over, I can write 2 rows down, comma, 0 columns over. So if I use select on this resulting range, that's what we're going to get back, a brand new range. You can see we're going to end up with a range of cell A3. That's because we started in cell A1, then we moved down 2 rows and 0 columns to the right. We can, of course, move to the right as well. So let's say we start in cell A1, we want to move 0 rows down and 5 columns to the right. If I execute this, we're going to end up in cell F1. We can, of course, combine positive values for both the row offset and column offset arguments. So if I want to move 2 rows down and 3 columns to the right, I can do that. And this will take us from cell A1 to cell D3. Now, what do we do if we want to move upwards or leftwards? In that case, we need to provide negative arguments. We provide a negative integer for the number of rows that we want to move up and a negative integer for the number of columns that we want to move to the left. So we have to start somewhere else compared to our top left corner, which is sort of a boundary in the window. So let's start somewhere like cell C5. And let's say I want to move now, let's say -2 rows, which means 2 rows up. So let's take a look at where that gets us. We're starting out in cell C5, and we're going to end up in cell C3. So here's where we started from. An argument of -2 means 2 rows upwards. That's going to take us to cell C3. Similarly, if I want to move to the left, what I can do is move to the left with a syntax like this. This means 1 column to the left of where we're starting from. So from cell C5, that's going to take us to cell B5. We can, of course, combine negative row offsets and negative column offsets if we want to move both upwards and leftwards. So for example, let's say I want to start in cell, how about F8 right here? So let's do F8. And if I want to move 5 rows up, I can provide -5. If I then want to move 3 columns to the left as well, I can provide an argument of -3. And that's going to take us to cell C3. Here's the coolest part about the offset property. So far, we've only been taking a look at a single cell, but as it turns out, we can target a range of any size, including a range with multiple cells. So for example, let's create a 3x3 range at the very top left of our spreadsheet. So if I target something like A1 through C3, that's what that range looks like currently. It's selected there in the interface. What I can do is call offset, and let's say I want to move this 10 rows down and 3 columns to the right. When I select this to take a look at where we're going to end up, we're going to get the exact same range right here. So the shape, the dimensions as far as the number of rows and the number of columns has not changed. We've retained the shape of the range, we've just moved it, we've traversed it from its original starting point, however many rows and columns we specify with the offset property. And again, we can also provide a negative argument here as well if we want to move this entire range upwards or leftwards. That's all there's to cover here. The offset property is very, very popular among developers because many times we're going to be iterating. We'll dive into that a little bit later in the course, but many times we're going to be iterating, which means going through a collection of values, for example, in a column, and doing some kind of calculation to that value and then pasting that somewhere else that's kind of parallel to where we're starting from. So for example, we may be iterating in column A right here through a bunch of values, and we may want to paste the calculation to the right of it. And the offset property makes that very easy because wherever we currently are cell-wise, we can use offset to automatically end up in the right position, for example, to the right or to the left or upwards or downwards. It's a navigational tool that's very powerful. We'll dive into some of these concepts a little bit later, so we're going to be coming back to offset many times throughout the course. But that's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the resize property on a range object. Just as the name suggests, the resize property changes the size of a range based on the location of a single cell. Let me go through a couple examples here in the immediate window. Let's begin by targeting a cell like C2, so range C2. So an important thing to realize about the resize property is that it's always going to include the actual cell itself where it's starting from. The resize property expects two arguments, one to represent the number of rows that should be included, and two, the second argument, to represent the number of columns that should be included. So if we're starting in a single cell and it's included, if we put an argument here of 1, 1, that basically means just the current cell. So if I do select here, because the resize property will return a brand new range object to us, we can see that's simply going to target cell C2. Let's take a look at a couple more examples here. Remember, the first argument here is the total number of rows that we want to be represented in the final range that we're going to be delivering here. So if I want to instead have 3 rows represented, starting from cell C2, what this syntax is going to do is it's going to start at cell C2, and from that single cell, it's going to resize that range to be exactly 3 rows and 1 column, but starting from C2. So if we take a look at this, we're going to get this entire range represented. Again, the original cell where we're starting from is included. So it's not 3 plus the cell where we're starting from, it's 3 including the cell where we're starting from. This is targeting, again, 3 rows, 1 column. What if we wanted to instead target 2 columns? Well, it's as simple as replacing this second argument. So what this is going to do is target 3 rows, 2 columns, including the cell from which we're starting from. So we're resizing from a single cell to a range that now represents this 6 total cells, 3 rows by 2 columns. As I mentioned, the resize property returns a new range object, so all of the available functionalities, properties, and methods are all there and present for you. So for example, let's say I want to start at range C2, but I now want to target, let's say, a 4 by 5 block from that position. Again, I can do resize, let's say 4 rows, 5 columns. That's going to give me a new range object. And let's say I want to write in the same value into that entire block that I've just created. I can do something like this, the value 25. Now we're going to get this written output right here. So again, just to show you this, because this original selection is still highlighted, we're starting here in C2 right here. And then we say we want to resize from that cell 4 rows and 5 columns. So starting from here, 1, 2, 3, 4 is 4 total rows. And starting from that top left cell, 1, 2, 3, 4, 5. That's how we resize. It's now going to give us back a brand new range object. So pretty handy property to have in your tool belt. The resize property changes the size of a range based on the location of a single cell. By the way, if you feed the range, the original one, a clump of cells, for example, if this was something like C2 through, let's say, something crazy like H17, the actual result would not change at all because it's always going to use the top left cell as the starting point. So it's really meant to be used with single cells. Once you have that starting position, you simply use the resize property and specify how you'd like to expand it or resize it. Just give it the rows and the columns. If you want to stay in the same row, you just do an argument of 1. If you want to do the same column, you just do an argument of 1, or rather, if you don't want to expand it. So don't be afraid, as we just saw a couple moments ago, an argument of 1, 1 simply means the current cell, and we can expand it in whichever direction we want. We don't necessarily have to expand it in both the rows and columns direction as we did here. That's all there is to cover here, so I'll see you in the next lesson. So far throughout the course, we've been using A1 notation whenever we've referenced a range object. It doesn't matter if it's one cell or multiple cells, we've always used a letter to represent the column and a number to represent the row. Well, now the time has come for us to explore an alternate syntax that we can use to select a range object, and that's the cells property. The cells property actually relies on R1C1 notation, which, as we just learned, relies on a number for both the row and the column. Let's take a look at this in action in the immediate window. Cells is actually a property on the top level application object at the top of the hierarchy. So if I write out application, I'll see that cells is immediately available here and I can use it like this. However, as we know by now, application many times is not necessary as a prefix because VBA can figure these things out. So I can actually just write cells by itself, and by default, this is going to target the entire spreadsheet, so every single cell on it. In fact, I can prove this by using select. So you might wonder how we're able to use select, and the answer is cells right here is going to return a valid range object. So simply by writing cells, this is a range object for every single, the collection of every cell in the worksheet. So all of my range properties and methods are available here, including select. So I can write select here, and that's going to highlight every single cell on my worksheet right here. Of course, the more powerful way to use this property is by providing it a value for both the row and the column. The way we can do that is by feeding it a pair of parentheses. And right here, VBA is giving us a hint, row index and column index. And this represents, of course, the row and the column that we want to reference. So let's say I want to reference row number 2, column number 5. I can just enter that, and that's going to give me a range object that represents that one cell. I can call the select method on this, and we're going to see that that's cell E2. Even though we still have A1 notation enabled on our spreadsheet, we can still use cells right here in VBA. And again, this is a completely valid range object, so I can do whatever I want with it. For example, with this range, I can use the value property to set that cell to a value of 25. When I execute this, it's going to be the exact same as writing range e2.value equals 25. It's just an alternate way to reference a cell, but using row and column numbers. Now, cells, unfortunately, can only accept a row number and a column number. So what do we do whenever we want a range with multiple cells within it? Well, we have to use the familiar resize property because remember, that starts off at a cell and is able to expand to include a much larger range. So remember, for example, if I do something like this, cells, let's say something a little bit closer to the beginning, like cell 2, 1 is going to represent row number 2, column number 1, so cell A2. Once I have the cell, this is a valid range object, so I can use the resize property and then expand that to a larger size. For example, I can do 4 rows downwards and 5 rows to the right. And when I highlight this, we can see that it's done exactly what I expected. We're starting out right here in cell A2, row 2, column 1. We're going 4 columns down and then 5 columns over. And again, resize is also giving me back a valid range object. We're continuing to get back range objects every single time we do some kind of operation here. Cells is giving me a range object. I'm using a resize property on that range object to get back another range object, and then I'm using a method on that. I can just show you another example here. We have the value property available on a multi-cell range as well if we want to overwrite all of the cells. So I can give it a value here like fill, and it's going to write it in all of those cells. That's really all there is to cover here. It's a very quick introduction to cells, but I promise we're going to review this concept a lot as we proceed throughout the course because cells really becomes much more powerful when we have to do multiple operations over, let's say, a range of cells. For example, when it comes to iteration, which is the process of going over one cell at a time. For example, going through every value in column A, performing some kind of calculation, and then writing the result in column B. For that kind of process in VBA, using a syntax like this that uses row and column numbers makes things like mathematical addition, calculation, subtraction a lot easier. We just saw an example a few lessons ago when we talked about R1C1 notation, how it's a lot easier to navigate across columns when you think of them numerically rather than alphabetically. And I assure you that this syntax will pop up a lot of times as we proceed throughout the course, and you're going to see more of its use cases. But for now, you can practice using it just by yourself whenever you're writing some kind of macros on your own. Try to replace your range references that use A1 notation with cells references that use numeric references for both rows and columns. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll talk about the current region property on a range. It returns a range that is bounded by or surrounded by or enclosed by any combination of blank rows and blank columns. Unfortunately, when it comes to real-life data, it's not always going to be picture perfect. There's going to be gaps and missing spaces and missing columns and missing rows. For example, you may have data that looks something like this. I've created these 4 separate blocks or ranges of cells, and let's imagine they all have valid pieces of data, but they are surrounded by these unfortunate white cells, these blank cells. How can we actually select the actual enclosed range? For example, just the blue cells, or just the green cells, or just the red cells. For something like that, we can use the current region property. Let me show you how this works in the immediate window. We're not going to actually be writing any procedures throughout this lesson. So let me go ahead and pull this up, and we're going to write all of our code right here. What current region is going to do is look for the boundaries of a given range. So no matter where we start, it's going to move in all 4 directions, north, south, east, west, and look for wherever that range concludes. And of course, the conclusion is wherever it runs into an empty cell. So for example, if I begin at range B2, and I access the current region property right here, that's going to give me a brand new range object, and I'm just going to call the select method on it just so we can activate it and see it in actual action. So when I execute this, if we take a look on the left-hand side, we're actually going to get cells A1 through C3. So what's actually going on here? We're starting out in cell B2 right in the center. And just like I mentioned, you can almost imagine Excel as going in every single direction up until it reaches an endpoint or a border. So it's going to go up, it's going to reach the top of the spreadsheet, there's no endpoint there. Same thing with the left side. It's then going to move all the way down to here and see that we have some values on row 3. And it's also going to move to the right to column C and see that we have some values here. And as long as it's not going to run into any kind of blank cells, it's going to close off the entire section, the entire range. It doesn't matter, by the way, if this is range of B2 or if we start in something like cell A1, that's going to give us the exact same result. Or, for example, if I start in cell C3, that's going to give us the exact same result. It's simply going to find the boundaries or the borders around that cell that we pick as our starting point. The same rules will apply in any of these 4 boxes. For example, if I go ahead and select a cell in the green box, like let's say cell A7 on the bottom left, and I select that, that's going to select the entire green box. It's again going to look for the limits or the boundaries of that collection of cells up until it reaches the blank values. Similarly, if I target something in the yellow box, for example, let's say cell G2 right here, that's on the right side of my yellow box. That's going to be able to figure out the entire boundaries of the yellow box. Finally, if I pick something in the red box, like let's say the left-hand side of E6, if I do E6 and I activate this, we're once again going to get the entire red box. It's found the current region of that cell. Now here's a challenge for you. What happens if I select a range that's actually going to include a couple of blank cells? For example, if I select the entire range of all of my boxes, A1 through G7, and on that range I select current region, what do you think I'm going to select here? What's actually going to happen is it's going to move in a direction of upwards and leftwards and select the first inner range that represents a complete box or a complete region. So in this case, if we target the entire range, it's actually going to highlight the blue box at the top left. It's going to look for the first enclosure of cells anywhere within this range that we've given it. It's going to look for it from the top left perspective. So it's going to find the first one that is the most to the top and the most to the left. As another example, let's say I'm going to select right here cells E1 through G7. So this, in this scenario, is selecting this entire clump of cells right here, the yellow box and the red box. In this case, it's going to move, again, upwards and leftwards. In this case, there is no leftward motion, but if we select the entire thing, what it's actually going to select is just the yellow box. That's the general direction in which it's going to move, upwards and leftwards, in its search for some kind of range object that is enclosed by a blank cell, some kind of defined space of valid values that is enclosed by blank cells. Hopefully this gives you a sense of what the current region property is really helpful for whenever you have a sea of values and maybe some of them are clumped together and they're surrounded by blank cells and the data isn't in perfect order. The current region property allows you to dynamically figure out where one range ends and sort of select all of the cells that are contained within it. Pretty powerful feature. Go ahead and explore it some more in your free time. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the end property of a range object, which simulates the press of an end key and a directional arrow on your keyboard. Now, the end feature is not something that everyone is familiar with in Excel, so I want to begin by offering a brief review of this concept in the actual Excel interface. I'm going to click into cell A1, and on most keyboards, you're going to have a key called END, E-N-D. I'm going to click mine, and as soon as I press it on the bottom of Excel, we're going to see this update that says End Mode. What this means is that Excel is expecting us to press one of the 4 directional arrow keys, up, down, left, right. And what it's going to do is move in that direction. Now, when we have a spreadsheet like this that's completely empty, pressing an arrow key like down is going to move all the way down until it reaches the end or conclusion of this worksheet. So right now I'm in cell A1 in end mode, and when I press my down arrow key, I'm going to go all the way down to cell, or row rather, 1,048,576, still in column A. What if I want to use this exact same technique to move to the right, so the bottom right corner of the spreadsheet? Again, I press the end key. That enters us into end mode. I then follow that with an arrow key. So for example, I can press my right arrow key. That's going to take me to the bottom right corner of the spreadsheet. If I want to go back up, I press end, followed by the up arrow key. That takes me to the top right corner. And if I want to end up back where I started, I can press end. And from right here, I can move leftwards back to cell A1. An important thing to note here is that this is the standard behavior in an empty worksheet, but it's going to work a little bit differently if we have cells full of valid data. For example, I'm just going to create a couple cells here of random values. It doesn't really matter what they are. Let me, in fact, put a couple more right here. And the way this is going to work, we're once again going to start in cell A1, but if I press the end key right now and press down, it's not going to move to the bottom of the entire spreadsheet. It's going to move to the bottom of the current range, which means the last cell that has valid data. So if I press down right now, that's going to take me to cell A8. If I press end and down again, well, that's going to bring me back to the bottom of the worksheet. I'm just going to come back up by pressing end 1. That this time is going to take me to cell A8. So the similar behavior, but in reverse. It's not going to take me to the top of the spreadsheet. It's going to take me to the last cell that has valid data in it. So as another example right here, if I go into, let's say, cell A3, and I press end and I press right, it's not going to move to the right end of the worksheet. It's going to move to the right end of the range that I'm currently in. If I press end down, that's going to take me to this cell. If I press end left, that's going to take me to this cell, and so on. Hopefully this is a good enough explanation, and now we can go ahead and translate this type of behavior into VBA code. What I actually want to do here is to write a procedure that's going to write a value into each of our 4 corners. The northwest corner, cell A1, the southwest corner, which is the lower left corner, the southeast corner, which is the lower right corner, and the northeast corner, which is the top right corner. So just like we navigated it just a minute ago, I want to do that exact same thing, but using VBA code, and I want to write actual values into those cells. So let's go ahead and write our procedure right here. Let me actually bring down the immediate window a bit. And I'm going to call this procedure change corners. Now we can begin with a simple reference to cell A1, range A1, and we can just give it the value of a string of top left corner. This is a pretty simple one. And so what we need to do here is we're always going to begin with a valid range. It doesn't really matter where we begin, but for the purposes of this exercise, I'm always going to stay consistent and start with range A1. That's the most logical step. Before I proceed here, actually, I do want to make sure that I clear everything right here, just to ensure we don't run into the problem that we just saw, where we have valid range data right here. So I'm just going to clear all this data right here. We have a completely blank spreadsheet, and we are good to go. So let's talk first about writing a value in the bottom left corner. So we have to simulate going down. That's pressing the end key and then pressing the down arrow. How can we simulate that behavior in VBA? Well, I can put the end property right here, dot end, and this is going to expect an argument, and it's actually going to be a predefined constant or an enumeration. Remember, these are values or keywords that are built into Excel, and they're going to evaluate into numbers on the back end when VBA is actually processing our code, and that's going to allow it to figure out what it is that we want to do. So there are actually 4 enumerations available in this total category called Excel direction, and those are Excel down, Excel up, Excel to left, and Excel to right. It's a little bit confusing because left and right don't follow the exact same naming scheme, but down and up are pretty simple. It's just going to be Excel followed by down or up. So if I want to move downwards and simulate a down arrow press, what I can do is give it the enumeration Excel down. We see them all listed right here. So I can press tab to lock this into place, close this, and this is going to take us to the actual range. So this is going to return back to us a brand new range object of a single cell, the bottom left corner of our spreadsheet. I can attach the value property right here, and let's write in bottom left corner. All right, it's going to be the exact same process when we want to access the top right corner of the spreadsheet. We're going to start at cell A1. We're going to use the end property, but we have to give it a different constant so it knows which direction to move. This time we want to move to the right, and it's not going to be XL right. I know it's a little bit confusing. It's actually going to be XL to right. It's a little bit of a different naming convention. I don't know why. Perhaps there's a technical reason for this, but two of these enumerations have one way of being named and the other two have another. So when it's moving leftwards or rightwards, it's going to be to right and to left. So XL to right, otherwise this is going to take us in the exact same logical direction. It's going to take us to the right, and once we're at the top right corner, we can access that range's value property and write in top right corner. All right, accessing the bottom right corner from our original starting position is going to be a little bit more difficult, but totally doable. So we can actually approach this in one of two ways. I'm going to write out both just for this example. Let's begin by moving downwards to the bottom left corner and then moving rightwards to the bottom right corner. So I can begin with an end and give it XL down. This is going to take us all the way to the bottom left corner of our spreadsheet. And what I can actually do, because this returns back to me a valid range object, which has its own set of properties and methods, I can continue chaining on additional end properties, right? Because this is evaluating to a completely valid range object. So on this range, I want to do another end. And this time from the bottom left corner, I want to move to the right. This is going to take me to the bottom right corner. And so I could write in my value in that range, bottom right corner. You can probably guess the syntax for the alternate approach. If we're starting at range A1, we can move, instead of downwards, we can move all the way to the right. So XL to right is going to take us to the top right corner of the spreadsheet. That's going to give us a range object. We're going to use the end property on that range to move downwards. That's going to take us to the exact same destination, the bottom right corner. We can do dot value and write bottom right corner. And that's going to write the value in there. And that's basically all there is to it. So let's see if this works. I'm going to click into here, press F5 to execute. All right, so top left corner, let's now use the end arrow key and actually press down so we can see what happens here. There is our bottom left corner, end right. There is our bottom right corner with its value, and end up, and there is our top right corner with its proper value. And that's all there is to cover in this lesson. We talked about the end property, which simulates the press of an end key and a directional arrow on the keyboard. This is a common feature in Excel, but not everyone is aware of it, so I wanted to give you a brief introduction or review of it. You just access the end property on the range object when it comes to writing it out in VBA, and you give it one of these four predefined constants. They're part of the Excel direction enumeration. Four possibilities: XL down, XL up, XL to left, XL to right. It's going to move in that direction. Again, on a blank spreadsheet, it's going to have this approach, but if you're dealing with cells full of data, it's going to move to the last cell that actually has valid data, so watch out. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the count and count large properties on a range object. They work in the exact same way. They return the number of cells that are contained within that range. The count large property can simply handle much greater and larger numbers. Now, an important thing to note here is that the cells themselves in the range do not need to contain content. It's literally just a count of the total number of cells. For example, I'm going to stick to the immediate window here. If I want to target this range A1 through C3, that's going to represent this range right here, this 3x3 range. If I access the count property on that, I'm going to get 9. There's going to be 9 total cells within this range. It doesn't matter, again, if there's actually values in some of them and no values in the other ones. What's going to happen here is it's just doing a literal count. And we're not, of course, limited to strictly a range that is just small like this. We can target an entire column or an entire row. For example, I can do something like this, the range of all the cells in column A. I can just do A through A. And if I do this, we're going to get a count of 1,048,576, which is the total number of rows as well, or the total number of cells in a single row. I can similarly get the total count of cells in a single row. For example, I can begin at cell A1 and go all the way to the top right of my spreadsheet. That's going to be cell XFD1. XFD is the final column in my worksheet. So if I do this, I can get a count on that, and we can find out that within a single Excel spreadsheet, we have a total of 16,384 columns. Now, when do we want to use the count large property? That's whenever we want to deal with something that is very, very large and staggering. We're talking huge numbers. So for example, let's say I want to find out the total number of cells in this Excel spreadsheet. If I take all the cells across all the columns and the rows, how many total cells are there? Well, I can do something like this, columns A through XFD. So take the column at the most left and all the way to the column at the most right, column XFD. If I try to do count on this, I'm actually going to get an error in VBA. It's going to be this overflow error. And what that essentially means is that there's not enough memory in the implementation of this count property to actually figure this out. That's not a problem though, because we can actually access count large. And that should give us the value that we're looking for, which is this. Let me see if I can probably figure this out right here. This looks to me like 17,179,869,184 total cells. So within a single spreadsheet in Excel right now, we're dealing with potentially 17 billion cells. Pretty staggering number. And you'll find out that if you actually multiply the total number of rows, which we have right here, by the total number of columns, which we have right here, it's going to give you this exact same result. It's the total number of cells within the worksheet. That's all there is to cover in this lesson. We talked about the count and count large properties. They're both read-only, so you obviously can't overwrite them. They can target anything from one cell to a clump of cells to an entire column, an entire row, or an entire spreadsheet, and they simply return the count of how many cells are present in that range. In this lesson, we'll take a look at the row and column properties on a range object. Both of these are read-only properties, and they return a long data type, a whole number that represents either the value of the row or the column. So these are both working in R1C1 notation, which we explored a little bit earlier in this section. Let's begin with a simple one-cell example. In my worksheet, I have highlighted cell C4. Let's go ahead and target it here in my immediate window, range C4. If I access the column property on this range, it's going to give me the numeric value of the column. This is column C, which of course is column number 3. Similarly, if I ask for the exact same range as row property, I'm going to get a value of 4. It is in column 3 and row number 4. What's going to happen if I expand this to a much larger range? For example, I'm going to start in the exact same cell, C4, but I'm going to go all the way to something like J26. Well, as it turns out, we're actually going to get the exact same result. We're going to get a column of 3, and if I go ahead and copy this example right here and paste it below and move this column around and switch it with row, we're going to get 4. The way this is going to work is that VBA is going to move to the top leftmost cell of the range. So even if we start at C4 and move down all the way to J26, it's still going to keep C4 as the main point of reference and take the column and row of that cell. So it doesn't even matter how large the range is, whatever cell we're starting from as our top left corner is what's going to serve as the basis upon which these numbers will be calculated. One final thing to point out before we conclude this lesson, I know it's kind of obvious, but these values 3 and 4 are relative to the entire worksheet, not relative to the range. So what that means is this is the number of the column within all of the columns in our worksheet and the number of the row within all of the rows in our worksheet. It is not relative to the entire range, right? So it's not counting, for example, column C as column 1 in this case. Rather, it's counting column C as column 3 amongst all the columns within the spreadsheet. It's kind of an obvious thing when we're staring at it here, but there are ways in VBA to have the opposite effect where we count the leftmost side of the range as column 1 and the top left cell as row 1, etc. But in this case, it is relative to the entire worksheet. That's all there's to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at the rows and columns properties on a range object. Now, I don't want you to confuse these properties with row and column from the previous lesson. We talked about that, and that returns a single number that represents the row or column in the top left cell of a range. In comparison, rows and columns, these plural properties, will return back a range object that represents one or more complete rows or columns. So whenever you want to target a range that's going to occupy an entire row or an entire column, this is a really effective way that you can target that. Instead of writing a syntax that's going to be like range A1 all the way to range whatever is the last cell on the top right of the Excel spreadsheet, that's not the most effective way to target an entire row or an entire column. We can use this simplified syntax. So let's go ahead and explore some of these concepts in our Visual Basic Editor. I'm going to declare a procedure here called target stuff. There's a lot of different syntax options to explore. So the first one I want to introduce you to is simply writing rows and columns without any kind of reference. It turns out that rows and columns are actually available as properties on the top level application object. So here's rows and here's columns. And of course, whenever we do something off of application, we don't literally have to write it out, so we can just write rows by itself. And this is going to give us back a kind of proto-range object, if you will, that is going to represent every single row within my actual spreadsheet. So what I can do is call a method like select, which is available on a range, and it's going to select every single row within my entire spreadsheet. I can do the exact same logic with columns, and we're going to get the exact same results. So when I click out of here, execute this, there you can see we're selecting everything here. And in fact, what we can do here with the helpful debug print is actually call the count property on any range object, and that's going to actually tell us how many rows are being represented and how many columns are being represented. An important thing to see here is that we're not literally counting the total cells within the range, we're actually counting the total number of rows within the entire spreadsheet. So if I do debug print rows.count and debug print columns.count, we can see here we have 1,048,576 rows represented in the entire spreadsheet, and then 16,384 columns. All right, this is pretty cool. It's pretty cool to highlight everything in the spreadsheet all at once, but there may be some better use cases for this property. This really becomes much more powerful and handy when you can actually use it to target a specific row or a specific column as a whole. So here's a syntax that we can use to do that. Let me just go ahead and comment this out because we won't need it later. So if we write rows and we actually provide parentheses after, we can use those parentheses to target a specific row or column index. So for example, if I want to target row 2 as a range, I can simply write in the number 2. And if I do that, you can see I'm now going to be targeting row 2. If I want to target more than one row at a time, what I can simply do is provide a string argument, because the colon argument here will only work for letters. It's not going to actually work for numbers, so we can't do something like this by itself, but we absolutely can do it as a string. So what this means is select rows 2 through 5. That colon means through, starting from 2, ending at 5. If we do this, we can go ahead and select more than one row at a time. And we can use the exact same syntax to target one or more columns. And with columns, it's actually a little bit more expansive because we can either use letters or numbers. So I can either target a column with a number, like here is column 4. There we go, we're targeting column 4, column D. We can also target a column with a letter. For example, here is column E. Perfect, column E. And of course, we can target more than one column at a time. Let me, in fact, shift this over. I think we got shifted over a bit. But if I wanted to target, let's say, columns B through D, I could simply write columns and write B through D, and that would give me the entire range of those 3 columns. There we are. All right, so the last thing I want to show you in this lesson is how we can use rows and columns on a specific range. Right now, we're calling it globally on the application object, but we can actually target a specific range. And what it's going to do is allow us to kind of target a column or row within the context of a specific range. So let me give you an example. Let me target a range. Let me do it right in the middle of the spreadsheet. Let me do something like B4 through, let's say, D12. Let me go ahead and select that range. So that's what that looks like. It's that little rectangular thing. And what we can do here is we can actually use the rows or columns properties on here. And what I can provide to this thing is actually an argument as well. So what I'm going to do here is write columns 2. So what is this going to do? This is actually going to target the second column, but within the context of my range. So columns 2 does not mean column B. In this context, within the range, it actually means column C. And it's not just going to be boxed in by the column, it's going to be boxed in by the lower boundary of the range, which is row 12, right? So what I'm targeting here, as I can show you with the select, keep this shape in mind as I select and execute this procedure, it's actually going to target just that specific column, the second column, within the context or confines of that original range, right? And if I wanted to, for example, target all of these cells within the column within that specific range and write in some kind of values, I can do that. All right. And we have a very similar syntax here. If I target range B4 through D12 again, we have a very similar syntax for rows. So here's my entire range. And if I want to target only the fourth row within this range, if I do rows 4 here, right? This is not going to literally target row 4. It's actually going to target row number 7 because 7 is the fourth row within my range of B4 through D12. So if you can imagine row 4 as the first one, the top of my range, this is going to be the fourth row starting from that top, which is going to be row 7. And I can select it, for example, here, and now we're going to target it. And we can, of course, target those micro ranges and do whatever we want to them. So I can write in a value here like, micro target. Execute that. And there you can see we've actually selected a column. That's the code from earlier. We've selected column 2 within our range. And then we've also written in micro target in row number 4. All right. So that's all there is to cover in this lesson. We talked about the rows and columns properties. They're available at the top level on the application object, in which case they can be used to target all of the rows, all of the columns, or a specific subset of rows or columns, which you can target with a parentheses syntax. Simply provide either a number or a string to target more than one at a time. And then we also talked about rows and columns as applied to a range object. It sort of makes that range object the context or the box in which the columns and rows will be calculated. So you can use the column syntax to target a specific column relative to the range that you've selected, or a specific row relative to that range that you've selected. All right, so far we've talked about the row property, the column property, the rows property, and the columns property. I have 2 more to add. I know it's a lot, it can get confusing, but all of these are helpful in the right situation. In this quick lesson, I want to introduce you to the entire row and entire column properties. And predictably, these begin with a single cell, and they are used to create a new range that represents the entire row where that cell is located, or the entire column where that cell is located. What I can do here is simply click into a random cell, let's say cell C3 right here, and I'm just going to review a couple properties here in my immediate window just so we have a better understanding of how all of these properties work in tandem. So first of all, on a range, we can either select this with range C3, or what we can actually do is use the convenient active cell property. Again, this is going to select the currently active cell, which is whatever the user has currently highlighted or selected or made active on their sheet. So this is automatically going to be a reference to cell C3 or whatever cell is currently clicked into. This is a valid range object. It's just referenced by active cell. So on this range object, we have an address property. That's going to actually give me the address of the cell. We can see cell C3 right here. On a range object, we also have a row property that's going to give me the row number as a number. So that's going to be row number 3. We also have a complementary column property that's going to give me the numeric value of the column. Column C is column number 3. And here's where I want to introduce you to these 2 new properties. On this range object, in fact, this time we won't need a question mark, we have an entire row property, and that's automatically going to give us back a brand new range object that represents the entire row in which that cell is located. So we're now in row number 3, but we're only in one cell. So when I do entire row, it's going to figure out we're in that row and select the entire row as that range object. I can prove this by simply tacking on that select method on that new range, and you can see it's going to highlight this entire thing. I need to also click back into, let's say, another cell right now. Let's say right here. And let's show you the complementary example, which is going to be entire column. So now active cell is going to be column number 5 or column E. So if I select the entire column from that single cell, that's going to give me back a brand new range for all 1,048,000, I think it's 756 rows. It's going to select the entire column for all of those cells. And so now if I do select, we can see we're going to get the entire column highlighted right here on the left-hand side. That's really all there is to cover in this lesson. The entire row and entire column properties are really quick ways that we can begin with a single cell and use that as the basis to select an entire row or an entire column for some kind of additional operations on that much larger range object. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at a popular community convention for getting the last row of data in a worksheet. So far, all of the data sets throughout the course have been perfect. There's been no missing gaps, no missing cells, no blank values. That's not always the case when it comes to real-life data. Often real-life data has improper calculations or missing cells or missing values. We have an example right here in the Excel interface. I have a column A with a bunch of numeric values, and we can see that it's filled with gaps. We have missing cells right here and here, also right here as well. Let's say the challenge now is that I want to write a value to the row below the last row. So in this case, it would be row 15. How would I be able to get to the last row of valid data in this spreadsheet? In this case, it's row number 14. Well, typically, if we have a perfect range, if we have a range without any missing cells, we would be able to do something like the end property. We could click into this cell, then press end, then press the down arrow key, and that would take us to the end of that range, which of course wouldn't have any blank cells. Unfortunately, in this case, that strategy is not going to work because when I press end down, we're going to go to the end of the current range, and that's cell A3, because it's going to look for the next blank cell. And we can't ever predict exactly how many blank cells or gaps we're going to have in our data set. So what solution can we implement here? Well, we can attack this problem from the opposite direction. Rather than beginning at the top of our spreadsheet and going end down, what we can do is start at the very bottom of our spreadsheet. I'm talking all the way at the bottom left corner. So essentially A plus the last row, which is 1,048,576, something like that. If we start at the bottom left cell and we press end up, that will take us to the last valid row of data. Let me just show you an example right here. I'm going to navigate all the way to the bottom. Here I am at the bottom of my spreadsheet. Here I have all these blank cells, but that's totally fine because when we use end, it's going to go to the next cell that has valid data in it. So if I press end and press up, that's going to take me to row 14, which is the last row of data. And we can emulate this exact same logic in VBA. And this is the most effective, most foolproof way to get the last row of data when you're not certain if your data set actually has gaps within it. Let's take a look within my Visual Basic editor. Let's write a procedure here. I'm going to call it find last row. And the first thing I'm going to do is actually declare a variable to store the integer that I'm going to be using to store my actual result. So I'm going to call that last row, and it's going to be a whole number. And now what we can do is assign last row. And here's going to be my logic here. I'm going to use the familiar cells property. And we're going to have to provide two values here, one for the row and one for the column. We know that the column value is going to be column number 1. But what do we provide for the row value? Well, we want to get the very last row in my spreadsheet. Now, I could write that in manually, but the reason that's not a good idea is because it's not backwards compatible. In fact, earlier versions of Excel have less rows. So if we put something like 1 million here, not all versions of Excel have 1 million rows. So it's going to trigger an error if used in earlier versions. That's not always the biggest of concerns, but there is a more elegant solution to this problem. As you may recall, we have a property here on rows called count. And if we simply do it on rows without selecting any specific rows, it's going to get us a count of the total number of rows in this spreadsheet, 1,048,576. Or if it's ran in an earlier version of Excel, it's going to get us that number, but it's going to calculate it dynamically on the fly. And what we can do is that number of rows also represents the last row, right? If there are 1 million rows in a spreadsheet, then the number of the last row is 1 million. So what we can do here is to dynamically calculate the last row. That's going to be a number, and that number is actually what's going to be substituted here as the first argument to cells. That's going to determine the rows dynamically. So this is going to give us the last row in the spreadsheet. I want to target the first column. So now with this syntax, I've targeted the bottom left cell of my spreadsheet. Now that I'm at the bottom left cell, what I can do is use the familiar end property. I have to provide that argument of the enumeration of which direction I want to move. If I want to move upwards, we have to provide the predefined constant XLUP, XLUP. Now that's actually going to get me to the range. So this is actually going to get me to cell A14. That's a range object, which is no good because last row is expecting a whole number. But once we're on a range, we can actually get the row number on a range object by using the row property. And that's the entire syntax. Start at the bottom left, and navigate up with the end arrow key and the end key, and then press arrow key of up, or simulate that action in VBA. Get to a range, take that range as row property to get the numeric value of the row, which is going to be 14. And afterwards, we can just output it to make sure we're correct. We're just going to do debug print last row. So let's go ahead and run this. When I execute this with F5, we're going to get 14. Let's just try a couple more times. Let me create a couple gaps here and then put another value here, like hello. When I execute this again, let me just clear this content. Click in here, press F5. Now we're going to get 17. Perfect. Let me write in a couple valid values, a couple invalid cells. Let's do something like 3 right here. Now we should get a totally different result. It should be 23. Execute this again, and it's working exactly as expected. Perfect. That's really all there is to cover in this lesson. Of course, if you want a nice challenge for yourself, what I recommend is writing the procedure yourself to get the last data column. So not the last row, but the last column of data in a worksheet. It's a very similar thought process. You're going to have to go all the way to the right side of the spreadsheet, then navigate leftwards, but otherwise the logic is the exact same, and it'll give you a good chance to practice the syntax. Otherwise, this is the most effective way that we can get the last row of data. That's a very common convention because we usually have to get to the last row of data, then perform our next steps below it. For example, add the next row or add the next tabulation, all of those results. So very popular convention in the VBA community to get the last data row is to use the syntax. Go ahead and practice it, and I'll see you in the next lesson. In this lesson, we'll take a look at the fill down method on a range object. The fill down method populates a formula or a value downwards based on a given cell value. We use this feature a lot when we're working with Excel, and we can emulate it using VBA. I'll begin here in my sheet by populating column A with a list of numbers. Let's just do 1, 2, 3, 4, 5. And let's say I wanted to take the square of each number in column B. There's a built-in function in Excel called power. Power accepts 2 arguments. The first is the actual number. We're just going to reference cell A1. And the second is the power that we want to raise each number to. So if I want the square of the given number, the power is 2. So this is going to be 1 squared. And we can now replicate this formula downwards in one of 2 ways. The first is to click the bottom right corner and simply drag it all the way to the bottom. As soon as we let go, Excel is going to replicate the power formula for every cell below. The better way to do it, I'm just going to remove my work, is to click into the main cell, hover your mouse over the bottom right corner. You're going to see this little black cursor pop up. And if you double click that, it's going to extend the formula to the next blank cell. So the exact same functionality, but if you have a really long list of records, like 1,000 rows, and you don't want to drag down, this is a much more efficient way to accomplish the same thing. But this is called the fill down operation because we're taking a value or a formula, the one that we have in cell B1, and we're filling it down to the remaining cells in that same column, right? We're replicating the same functionality as we have in the current cell. And VBA can do that exact same thing for us. So what I'm going to do here is remove all this content below. We still need an actual cell with a formula. So if you need to code this from scratch in VBA, you're going to need to use something like the formula R1C1 property on a range in order to target the very top cell and actually manually set the formula that you want to use, because we need that as a basis in order to actually perform the filling down process. Now let's go ahead and actually write this formula. So in my VB editor, I'll create a procedure called fill cells. And here's what I'm going to do. It's a 1-line procedure, pretty simple. We want to target a range, and here's the tricky part. We don't just want to target the blank cells, we want to target the blank cells and the cell that includes the formula. So that's cell B1 for me. So I want to begin with cell B1 and go all the way to B5. So once again, I'm starting with the cell that actually has the valid formula, and then I'm ending at the cell that represents the last cell that I want to paste the formula to, or the last cell that I want to fill down the formula to. Then once I have that, the only thing I need to do is call the fill down method, capital F, capital D, fill down. Take a look on the right, or rather the left side when I execute. There we go. The exact same thing has happened. We have taken the formula in cell B1 and filled it down all the way till cell B5. Let's take a look at another example here on sheet 2. I'll begin here by writing a list of first names and last names. I have a little bit of formatting left over here. So I have a list of first name and last names. Let's just make this US presidents. So I'll fill this in with George Washington, John Adams. Let's do Thomas Jefferson. And let's say I want to have a third column that represents the full name. So how can I create this operation? The first step, of course, is to always write the actual formula that you want to use in the top cell. So there is a concatenate formula in Excel, or rather a concat one. They look pretty identical to me. I think there might be some small differences between them. But concat accepts a list of arguments, and it just concatenates all of them or adds those strings together as one. So we want to target the first name column, or the value in cell A2. We then want to actually add a space to make sure that those 2 strings are not kind of clumped together. Then we want to actually add the value in cell B2, and we're going to get the full name of the president. Now, of course, if we want to copy this formula down, if we want to fill it down, again, it's simply a matter of double-clicking in the Excel interface. But what if we want to emulate this functionality in VBA? Well, what we can do here is practice our coding. So once again, I'm going to create a new procedure. I'm going to call it populate presidents, just so we have more practice with the syntax. Once again, we use range. We target the range that we want to work with, and we have to include the cell that actually includes the formula. So that's cell C2. We then specify the cell we want to go up to. That's going to be cell C4. Finally, once that's complete, we call the fill down method, execute that. Same thing, the formula has been filled down to the specified cell. All right, so that's how we use the fill down method. It works the exact same way as it does in the Excel interface. This is a very, very common feature among users, so it's really great when it's used right here. Instead of, for example, iterating with a for loop and manually calculating each cell, what you can do is just write a formula in the top cell of a column and then use this thing, and that way the process should be a little bit quicker because it just replicates that logic for every cell. You don't have to repeat that looping and going through everything, every record one by one. So it's a really great shortcut. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the replace method on a range object. The replace method works very similarly to how find and replace works in the main Excel interface. We first identify a range to search in, we then identify what we're looking for, and then we tell VBA what to replace it with if it's able to find something within the range. So just like find and replace works in our main Excel window. So let's demonstrate this with VBA code. I'll begin by populating a list of values in column A. So let's just do a bunch of numeric values here. Let's pretend that these are the rows of some kind of report that we're getting. And let's say that some of these rows have blank values in them. So I'm just going to delete some of these numbers randomly. It doesn't really matter which ones we target. So let's imagine this is our report. And let's say what we want to do is target that range of cells from A1 to A12 and replace any blank cells with the value missing. How can we accomplish this? Here in my VBE editor, what I can do is create a procedure. I'll call it replace blanks. I first need to specify the range in which I'm searching. So let's begin with the range keyword. We're going to be targeting cells A1 through A12. So we're selecting that entire box right here. Then we want to invoke the replace method on the range object. The replace method, as we can see here, expects two arguments. What and replacement are the names of our parameters. What represents what it is that we're searching for, and that can be anything from a string to a number, whatever we want to specify to look for in that range. And then the replacement argument specifies what we want to replace any matches with. So whenever we find something that we specify with what, that's what we're going to be replacing with whatever we put for replacement. So let's begin here by typing the what parameter. This is what I'm looking for. I'm looking for an empty cell, which can be very easily represented with an empty string, just two double quotes with nothing between them. I then want to put a comma to move on to the next parameter. The next parameter I have right here is going to be replacement. Once again, colon equals, and this is what I want to replace that with. So what do I want to replace any empty cell with in this case? Let's replace it with the keyword missing. So missing in double quotes, just like that. And when I execute this with F5, we can see that the blank cells have been replaced with the keyword missing. Let's go ahead and take a look at yet another example of this method. Let's say I now want to replace the keyword missing with the phrase not found. Again, what I can modify here is the what parameter. This is what we're searching for in order to replace. I want to search for the keyword missing. And what do I want to replace it with? I want to replace it with the string of not found. And again, this replacement can be anything. It doesn't have to be a string. It can be a number. It can be whatever you want. So let's execute this, and we should see the missings convert to not founds. There we go. To finish off, I just want to show you how flexible these parameters are. As I mentioned, they don't need to necessarily take strings. They can take other data types like numbers or integers. So for example, let's say I wanted to target all occurrences of 2 in this spreadsheet. In fact, let me add a couple instances here just so we can verify that this works. I'm going to put a 2 here and a 2 right here below. What I can do here is replace this what. Let me just click out of here. Let me replace this what with the number 2 rather than the string 2. It's going to find all occurrences of the number 2. And what do I want to replace it with? Let's replace it with some kind of other number. So let's replace it with something like 20. So I've replaced my string arguments with numeric arguments. So we're going to search for all occurrences of 2 and replace it with 20. This should occur 3 times. So let's execute with F5. And there we go. 2 has been converted to 20. And this 2 right here has also been converted to 20, and this one right here. It looks like something interesting has happened here as well in row number 12. It looks like what happened here is this used to be the number 12, and VBA identified the value 2 within the value of 12, and so it took that and concatenated on 20 where the 2 used to be. So you have to be pretty careful here whenever you're doing something like this. But it will replace all occurrences of the number 2 anywhere that's able to find it. So in theory, if I run this again, we have a 20 right here, and because it has a 2, this should be replaced by another 20, bringing this to 200. So let's take a look at what happens when I execute this again. Exactly. So it's going to look for any occurrence of the number 2, even if it's a number rather than a string, and it's going to replace it with the replacement, which is 20. So you have to be a little bit careful here. This was a bit surprising even to me. But that's the replace method on a range object. Expects 2 arguments or 2 parameters called what and replacement. What is what we're searching for. Replacement is what we want to replace it with. In this lesson, we'll take a look at the text to columns method on a range object. This is the exact same functionality that we have available to us in Excel right here under data. This text to columns feature, one of the most popular features in Excel. Now, if you're unfamiliar with text to columns, what it does is it takes a single string or a single cell, and then it separates it into multiple strings based on the presence or occurrence of what we call a delimiter. And a delimiter is just a special character. So let me go ahead and show this in practice, and then we can sort of walk through what it is that we're going to be doing with our code. So I'm just going to put a bunch of names here, 4 names on 4 different rows here. And it's going to be first name, comma, last name, comma, age. So John, comma, Smith, comma, 35. This is very similar to how we might receive data if we have something like a CSV file, a comma separated values file. Let's say here I have a second name like Christy, comma, Johnson, and her age is 48. Brian, comma, Carter, 22, and Dustin, comma, Lance, 15. So this is very similar to how we might get data in a CSV file, let's say from something like a website server. And what the text to columns feature in Excel allows us to do is to say these different values are delimited or separated by the presence of a comma. So what we ultimately want to do is to separate all of these values wherever we see a comma occurred. So our ultimate end goal is a result that looks like this. John in one cell, then Smith, then 35, and repeat that whole process for every cell. Just separate by a comma into multiple cells compared to our original one. So how can we execute this with VBA? Well, let me go ahead and remove this code. I'll define a procedure here. I'm going to call it separate text. The first thing I'm going to do, of course, is to target the actual range that I want to perform the operation on. So we're going to target range A1 through A4. The method itself is called text to columns. Both of the T's and the C in columns are capitalized. Let's take a look at some of the parameters we have here because there are a lot. The most important one here is the first one, which is destination, which is going to represent the first cell that we're going to paste the first value to. Text to columns is going to create multiple cells of data, right? Because wherever we have a comma, we're going to create a split. We need 3 total cells here, one for John, one for Smith, and one for 35. The destination here represents the top cell where we're going to start placing the results in. So in this case, let's say we want to start putting our stuff in cell C1, then we're going to put C1 as the top, as the result or the argument for this destination parameter. So we're going to do destination. And what we actually have to give it is a valid range object, not just a string of C1, but a range of C1. So that's where it knows where it's going to paste the results. What I'm going to do here is just put a comma and an underscore that allows us to break up our code into multiple lines. Let's take a look at some of the other parameters here if we can. Let me see if I can bring them up. There we go. So what we can actually see here is there's a wide variety of parameters here like tab, semicolon, comma, space, etc. And these are all parameters that expect Boolean arguments. Essentially, we need to designate something as the delimiter, as the special character or symbol that VBA is going to use to split these characters by. And all we need to do is pick one. So in this case, we do have here, right here, a comma parameter that is just like tab or semicolon or anything else. We just have to pick out the right one and give it a Boolean argument of true. So what I'm going to do here is I'm going to do comma, colon equals true. So with this syntax, we're both identifying the comma and we're saying that that's the one that we want to use as the delimiter. And that should do it. We're going to target cells A1 through A4. We're going to separate the text within them by a comma, and the results we're going to start pasting in cell C1. So let's see what happens when I execute this. There we go. So John, Smith, and 35 have been moved right here to C, D, and E. Notice that cell C1 is where the beginning of the paste started, and the same operation has occurred for everything right here in our original cells. Let's take a look at another example with another delimiter. So what I'm going to do here is just copy this original example, copy it down here to cell A6, and this time, instead of separating everything by a comma, I'm just going to separate everything by a space. There might be an easier way to do this, of course, with something like find and replace, or even the replace method that we talked about. But just for the sake of simplicity, I'm going to go through manually and just replace all of these commas with spaces. Right? And our syntax here for our method is going to be very similar. We're just going to need to replace that comma delimiter with something else. So let me go ahead here. I'm just going to click out of here. Let me go back to my code. I'm going to comment out my original code because I don't want it to run accidentally. And this time we want to target a different range. So once again, range. What are we targeting? We're targeting cells A6 through A9. Close the double quotes, close the parentheses. We're going to call the text to columns method. First parameter we want to give is destination. This is going to expect a range object. This is where we're going to be pasting it. Again, this represents the top left cell of where we want to start the paste operation. So this time we want to start in cell C6. That's to right of John Smith. So let's put cell C6 here. Once again, let's put a comma and an underscore. This is just so I can break this up into multiple lines. If you can fit everything on one screen or one line, by all means, you can just continue typing without placing the underscore, or rather the underscore, that's what it is. All right, so next up, we see some additional parameters here. This time, we don't want to target the comma parameter. We want to target the space parameter because that's the delimiter. That's the special character that symbolizes a break in our string. That's where we want to break things up. So space colon equals true. Again, space, comma, semicolon, whatever delimiter we choose, there's going to be a parameter for it, and we just have to give it a Boolean argument of true. That should do it. So now we should see the exact same result as we have here, but this time we're going to split by spaces. Here we go. There we go. Exact same result. There's one more example here that I want to show you, and it's how we work with a delimiter that is not present in our list of parameter options. So let me go ahead and copy this code one more time. And imagine now that for some reason we have data where all of the values are separated by this vertical pipe symbol. On most keyboards, you can access this by just pressing Shift plus the backslash key, which is right above the Enter key on most keyboards. So we have this vertical pipe, and the list of parameters doesn't actually include this as an option. So I'm going to show you how we can create essentially a custom text to columns operation with our own custom delimiter. The basic syntax is going to be the same. It's still going to be the exact same method call, but it's going to be a couple different parameters that we're going to use here. So let's target our new range. Our new range is cells A1 through cells A14. Close the double quotes, close the parentheses. Let's invoke the text to columns method. Destination parameter colon equals where do we want to paste it? We want to put it in range. Let's put it in cell C11. I'm going to use the underscore to create a line break. Here we have a list of all of our available delimiters here, tab, semicolon, comma, space, but we don't have any kind of vertical pipe. So what do we do here? We actually need to use two parameters here. The first one is going to be other. We see other here in our list of parameters to the right of space. Other is going to be a parameter that expects a Boolean, and that's where we're going to tell VBA that we are expecting a delimiter that is another delimiter, something that's not currently listed in our list of parameters. So we have to give that an argument of true, but we still haven't told it what that actual delimiter is, and that's signified with the parameter called other char. Char here is short for character, so it's asking us for the other character that we would like to designate as the delimiter. So of course we need to provide this an argument. This is just going to be a string, and what I give the string is the actual delimiter, so I'm going to put the vertical pipe. So again, we need both of these parameters whenever we're doing some kind of character that's not common or that's not present here in our list of parameters. Otherwise, it's going to work the exact same way. It's going to look for the presence of this custom delimiter, split it up at that point, and then start to pasting in cell C11. So let me click out of here for now. Let me go back into here. Let's click F5. And there we go. The exact same result has occurred. We've now delimited by a custom character. And that's all there is to cover in this lesson. We talked about the text to columns method. The text to columns feature is one of my most favorite features in Excel. So it's really cool that we're able to emulate it exactly as it works on the front end in our actual VBE, Visual Basic Editor. Pretty cool, pretty powerful feature. Very common when you're working with something like CSV data and you need to separate data that has commas in between. That's a very common format that files come in. Many people like CSV files because they're much more flexible compared to Excel files, which require Excel to open. CSV files can be opened by a lot more variety of programs, including spreadsheet analysis programs. So this is a very, very popular feature, and VBA can help you automate the process of splitting up your comma delimited or space delimited or tab delimited text with this text to columns method. In this short lesson, we'll take a look at the worksheet property on a range object. The worksheet property on a range returns the worksheet object to which the range belongs. It's kind of an interesting concept because throughout most of the course, we've been looking at the Excel object model from a top-down view. We've always started at the parent object and proceeded downwards, kind of following that nested structure until we arrived at the object that we're looking for. Well, this is one example in which we can traverse the Excel object model upwards. We can start with a range object, and then we can find out what worksheet it actually belongs to. So here I have a brand new workbook, and there's only one sheet here. It's called Sheet 1. So what I can do here is define a new procedure. I'm just going to call it Discover Worksheet. It's going to be very, very simple, this lesson. All I want to find out is the name of the worksheet to which a specific range belongs. So I can use message box here. And let's say I want to target a random range like C5. Again, this is going to target the active workbook and the active sheet, but right now we're only targeting the range. So let's say we don't know the name of our worksheet. Well, what I can do is target the worksheet property. And what this is actually going to return to us right now is a worksheet object. And remember, we can't just message box out a worksheet object because it's an entire custom data structure. We need to actually access one of its properties in order so that we have some kind of string to actually output with message box. So now we've proceeded upwards. We've began with the range and we've gone one step up to the worksheet that contains it. On every worksheet object, we have a name property, and this will tell us the name of the worksheet, which should be Sheet 1. So when I execute this method, or this procedure rather, there we go, Sheet 1. That's all there is to cover in this lesson. I just wanted to show you a different way of thinking about the Excel object model. We know that we can proceed downwards the Excel object model, but as it turns out, we can also proceed upwards in some circumstances. We can access certain properties that will allow us to find out where an object is nested. Just like in this scenario, we were able to use the worksheet property to find the worksheet object under which the current range is nested. In this lesson, we'll take a look at the sort method on a range object, which allows us to sort a range, either alphabetically or numerically, either from lowest to highest or highest to lowest, or alphabetically or reverse alphabetically. Any options that we have in the Excel interface that allow us to sort, we can replicate using VBA. Let's take a look. The first thing I want to do here is to set up our data set. We're going to have a name column and an age column, just so that we have a collection of strings and a collection of integers. So right here, I'm going to set up a column header of name. Right here, I'm going to make a column header of age. And let's just come up with a couple fake names. So let's do Jack, Bobby, Sally, do Billy, and then let's do another Jack, just so that we have duplicates here. And here, let's set up a couple values for ages. So let's do 15, 45, 35, 28, and let's do something like 21. Okay, so in my Visual Basic Editor, I'm going to define a new procedure. I'm going to call it sort columns. And the first thing we have to do is target the column that we want to sort. So the way we can do that very simply is just using the columns property. This is available directly off of application. Let me just double check that. Application columns. Yep. So columns is a property off of application, and we can give it as a string a reference to a specific column. In fact, what we want to do is target all of the content within, let's say, column B. So what I can do here is do this, columns B through B. So the reason I want to introduce this syntax this way is because whenever we're going to introduce multiple column sorts, I want you to start thinking in terms of the syntax of writing the starting column, colon, the ending column. So even though we're only targeting column B this time around, I find that this syntax is the most consistent and the most flexible, and it'll kind of remind you of how you should write this syntax whenever you're referencing either one or more columns. All right, so we're targeting column B here, and I want to call the sort method on that column. So we're not getting the pop-up here, But there are a couple parameters that are available to the sort method. The first one that I want to look at is key 1. So key 1 is actually going to specify the range that we're going to be sorting within our selection. So in this case, it's a little bit confusing because our selection is the entirety of column B, but we're also going to be sorting column B. The reason that we need to write both of these things, and I'm just going to write it out right here, range is going to be B through B, is because sometimes we're going to be targeting a larger range, for example, a range of 5 different columns, but we only want to sort, let's say, by the values within one of those columns, and that's what key represents. It's what we're actually going to be sorting by. In this case, we're only looking at a single column and we're sorting by that column, so the key parameter is essentially the same thing as the range that we're selecting. So in this case, it's the same thing. The next thing that I have available to me here, I'm just going to put a comma and then an underscore to allow ourselves a line break. We have an order 1 parameter. And this accepts a predefined constant, either Excel ascending or Excel descending. And this is going to define how that sort is going to take place. So for now, I'm going to put Excel ascending. And what this means is that everything will be sorted in ascending order, which means from the lowest to the greatest if it's a number, or alphabetically if it's a string or a bunch of characters. So here in my age column, we have the smallest value 15, and then 21 and 28. So it should be sorting in that order, from the smallest value to the greatest value. There's one more parameter that I want to add here, so I'll add another comma. And there's a parameter here called header. Header allows us to specify whether the column that we're targeting begins with a header value. In this case, we do. That value is age. That is just the information about what that column contains. We don't want age to be included in our sorting mechanism. In this case, it's not really going to be that much of a problem potentially because we're comparing numbers to strings. But if you think about something like column A where we have name, we don't want the sorting algorithm to actually think that name is one of our values and put it somewhere in between our results. We want it to recognize that it's part of the header and that VBA should ignore it when doing the sorting. So the header should stay in place and it should sort the values below the header in that column. So the way that we tell it that we do have a header in this column is by writing Excel, yes. Obviously, if we want to sort a column of just values, we want to tell it that it doesn't have a header. We just write Excel, no. All right, so this should be good. So what should happen here is only the values in column B should be sorted. So let's take a look at what happens when I execute F5. We can see that the values are now in sorted order, 15, 21, 28, 35, 45. Perfect. And of course, if I want to sort it in descending order, which means from the greatest to the lowest, I can change this from Excel ascending to descending. When I execute this, we're going to get 45 at the very top and 15 at the very bottom. Now, this is, of course, just an introductory example. We can quickly see the problem with my code as it stands, which is that we've sorted the ages in column B, but we've completely ignored the relationship with the values in column A. So this is all messed up because the relationship or the connection between the name, the person, and their age has been messed up. So this obviously is just to demonstrate how we sort one column. In the next example, we're going to move on to showing how we can sort by multiple columns. So let's just pretend that these are now the proper ages for our names. So Jack is now 45, Bob is now 35, and so on. Let's just pretend that this first example was just to give you guys an explanation of what's going on. So now let's go ahead and sort more than one column at a time, or keeping track of those values so we don't lose them like we just did. So I'm going to begin with columns one more time. This time, I'm going to select the entire collection of columns that I want to target. So let's select columns A and B. So A through B. The first thing before the colon is where we're starting. The column after the colon is where we're ending. So we're targeting the entire range of columns A through B. Let's call the sort method on it. All right. Now here's where key 1 actually has an impact. When we write key 1, this is going to be the range that we actually want to sort by. But we're not going to lose track of the entire column collection. We're just specifying what we want to sort by. So for example, if I want to sort now by name alphabetically, I can say that I want to sort by the range of A through A. So what this is going to do is it's going to sort by our names, Jack, Bobby, Sally, etc., but it's not going to lose the connection with the age. So the age will be moved around whenever those names are flipped around in order to match that sorting algorithm. So now we've connected those two columns together. The relationships are not going to be lost. All right, so let's put a comma here and an underscore to break up the line. Once again, we have to put an order 1 parameter. This is going to specify how we actually want to sort. Let's sort our names alphabetically, which means ascending. So I'm going to do Excel ascending. And once again, let's also put the header parameter. This allows us to specify that the name at the top is an actual header, so we can ignore it. It's not going to be accidentally sorted between the names. Let's execute this, see what we get. All right, so as you may recall, there was a Jack there at the very top, and they had a age of 45. So that relationship has been kept. You can see that the original values that were assigned to those names are still there. We haven't lost it. So both columns have experienced change. However, the basis for that sorting has been column A. We can see that now Billy, which is the very first alphabetical thing in sequence, is now at the very top. That age has been kept. And Sally, which is the last name alphabetically, is now at the bottom, and her age of 28 has also been retained. And we can prove this one more time. Let's just memorize this connection of Sally and 28. If we want to sort it in reverse alphabetical order, we can change this to Excel descending. And when I execute this, Sally should be at the very top. There she is. And her age has also been moved up with her. So that relationship has been retained. Obviously, if we want to sort by the age column now, but keep the relationship with the names, all we have to do is change this argument to key 1. We're still targeting columns A and B, but if we want to sort by age, we're going to target range B through B here. I think that's pretty obvious. All right, now let's move on to the most advanced example, which is sorting by more than one column at a time. Let's say I want to sort first by the name and then by the age. For example, we have a Jack here, and Jack, there are 2 Jacks and they have different ages. So let's say I want to sort the names alphabetically, so we're going to do from the lowest to the greatest character, but the age I want to do reverse, so descending, so we're going to have the highest age to the lowest age. All right, so here's how we do that. We're going to begin by targeting the same columns as always, columns A through B. We're going to call the sort method. Our key 1 parameter is going to have the same thing. We're going to have a range. Now, what do we actually want to sort by? Well, we want to sort by both. So how can we do this? Well, key 1 represents the first range that we're going to sort by. That's kind of one of the most confusing parts here is you may have been looking at this and asking, why is there a key 1? Well, because we may want to sort by more than one key sequentially. Key 1 is the first thing that we want to sort by. So the first thing we want to sort by is the name. So we're going to specify range A through A. Let's put a comma here, an underscore right here. As we mentioned, we want to sort those names alphabetically, so we can do that Excel ascending. All right. And then what I want to do here is I want to now sort by the age after I've done sorting by the name. So there is predictably a key 2 parameter, all right? And key 2 expects an argument that is the range of the second set of values that we're going to be sorting by. So after we're done sorting by the name, we want to sort by the age, which of course is column B. All right, I'm going to put another underscore there, break up another line. And there is, of course, a corresponding order 2 parameter that specifies how we want to sort the second key. So this time the age. How do we want to sort the age? We want to do it from the oldest age to the youngest age, so Excel descending. So now we're varying up the sorting mechanism here, or the algorithm. Finally, we do want to still provide a header, and this is going to be universal, so it's going to apply to both of our sorted columns, name and age. So we just want to give it a standard Excel yes. So before I execute, let's do a quick review here. We're going to sort the names in column A. We're going to do it in ascending order. So the names are going to be from the start of the alphabet to the end of the alphabet, alphabetical. We're then going to sort by the ages in column B. Those are going to be descending, so the greatest age to the smallest age in order, and then the header, of course, is included here. Let's execute this and see what happens. All right. So has this worked as expected? Well, we can see the names are alphabetical, but whenever we come to something that's a duplicate, for example, Jack, now VBA is able to sort as well by the age. Remember, the age is only going to be sorted by if there is a duplicate in the name, right? Because this is the first thing that it's going to be sorting by, so Billy is going to come before Bobby. But once we come to Jack, that's where it's going to dive into the order 2 in order to figure out how it's going to sort by that second key. So this Jack has an age of 45, and this Jack has an age of 15. So when it comes to sorting by age, we've specified Excel descending, greatest to lowest. So this one is going to show up first. So everything has worked as expected. If I wanted to do this in reverse, so let's say I want the names to be alphabetical, but I want the youngest age to show up first, I'd have to change this to Excel ascending. That way the numbers are going to be ascending, or smallest to greatest. So now the Jacks are still going to be in order. However, we can see that the numbers have flipped around and 15 shows up first. That's all there is to cover here in this lesson. We talked about the sort method, which is able to sort a range object by one or more columns. We first target the columns. We should use the columns property to do that. After we call the sort method, we use the key and order parameters. The key is used to actually specify what column within that range we're going to sort. Obviously, if it's only a single column, the key is going to be the exact same thing as our columns. But as we saw here, whenever we're targeting a range of more than one column, we can use key to specify which column within that range we're going to use as the basis of our sorting. The order parameter is used to specify whether it's ascending or descending, which means smallest to greatest or greatest to smallest. Whenever we have more than one column that we'd like to sort at a time, we can do key 1, etc. And finally, we have the header parameter, which is used to specify that our columns have a header, and that value should not be included whenever it's determining the basis for sorting. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we're going to take a look at the font property on a range object. The font property actually returns a brand new object called font, and the font object stores properties that are related to the actual aesthetics of the font of the cell. So things like whether it's bolded or italicized or underlined, things like the font size, the actual font itself, the color of the font, anything related to the styling of the cell, that's all found in the font property on the range object. So let's take a look. Here in cell A1, I'm just going to put in some random text. I'm just going to write VBA developer. It doesn't really matter what we write. And right now, we just have the default Excel settings. So this is going to be Calibri, font size 11, nothing is bolded, italicized, or underlined. Pretty standard Excel font. So right here in my VBE, I'm going to define a procedure. Let's call it modify font. The first thing I want to do is actually target the range. So I'm going to declare a variable. I'm going to call it R, keep it short and sweet. R is going to be a range object. Whenever we assign a value to a variable that expects an object, remember we need the set keyword. So set R, let's set that equal to a range. What range do we want to target? Cell A1. Of course, if we want to target more than one cell, you're more than welcome to. Just give it that colon and specify the range of cells that you want to target. Okay, so R is our range, and on every range, we have a font property. This is a completely different VBA object. It's called the font object. So if I put another dot there, here we have all of the properties that are related to that font object. Here are all the ways that we can customize what the font looks like. So here we even see things like strike through, subscript, size, tint and shade, underline. Everything that we have available here in the Excel interface is available through us here as well in the Visual Basic Editor. But again, everything here has to be done through code. It can't be done visually. All right, so let's explore some of these properties. If we want to set the boldness of the range, there is a bold property. And bold actually expects a Boolean, either true or false, because bold is not some kind of scale. It's just yes or no, true or false. So let's say we want to make this VBA developer bold. We just write true. When I execute this with F5, we can see it's become bold. Also available on the font object is an italic property. This is going to be a Boolean as well, true or false. So if we want to make it italic, we can execute like so. There it is, italicized. If I want to make it non-italic, I can turn that off with false. There it goes back to being standard. All right, so bold and italic, both are properties on the font object. Both expect Boolean values, true or false. There is also an underline property on the font object. It's a little bit more complex because it actually expects a predefined constant. So there's actually different types of underlines that are available. It's not as simple as bolding. For example, in certain forms of accounting, there is such a thing as a double underline. We have the concept of a single underline, which is just the basic way we do it. In fact, if we go here to the Excel interface, you can see that the B for bold and the I for italic is just plain buttons. But here on the underline option, we have this drop down, and there's actually a couple different options available: underline, double underline, etc. So instead of giving a Boolean here, we can actually give a predefined constant. One of them is XL underline style single. And this is going to make a single underlined cell. So when I execute this, we can see it's been underlined right here in the cell. I'm assuming the way to make it double is just replacing the single with double. Execute that. There we go. There's now 2 lines. So because this isn't a simple choice of either yes or no, like bold or italic, we actually have a wide variety of options available here. Not really wide. There's only 2. But because there's more than one, we can no longer represent that data type as a Boolean. So we need one of the Excel predefined constants to actually set the underline qualities of the range. On a font object, we also have, of course, a size property. This is the size in pixels of the font. So predictably here, this expects a whole number, an integer, a long, if you will. So if we want to change the font size to 48, it's just the size property, give it a whole number, execute this, and there we go. We've changed the size to something much bigger. If we wanted something like much smaller, 36, execute this. Same deal, we can now modify the size of our font. If we want to modify the font itself, there is a property on the font object called name. It's as simple as providing it a string this time around, because remember, a font name is just a collection of characters, so we have to represent it with a string. And then we just give it the name of the font that we want to use. So if we want to use Arial, just type in Arial in double quotes, execute that. There it is in Arial. If we want Times New Roman, just enter that as a string, Times New Roman. There's Times New Roman. If I want my favorite font, Comic Sans MS, there we go, turns that to Comic Sans MS, okay? So one other thing that I want to show you in this lesson, which is color. Of course, color is a very important part of how a cell looks. So we have on font, we have a property called color. The interesting thing about color is that it can actually accept a wide variety of inputs. The first option that is available to us is one of Excel's predefined colors. And the way we do that is there is a VB followed by a certain color name. So very popular colors like red are predefined. This is kind of like the default Excel red. And when we execute this, we can see that it's going to resort to this standardized color. I may be mistaken, but I believe these are the colors that are predefined right here. So the standard colors like VB red are defined. I think VB blue is another option. We can give that a shot. So this is a list of just predefined Excel colors. So it's not guaranteed that your color may be represented. There may not be something like a VB gold, but whenever you need some pretty conventional, pretty common standardized Excel colors, this is one of the ways that we can provide a color to a cell. Now, this is actually a pretty limited range of color options that we have. So the more effective way to do it is to use a function here called RGB. RGB is a pretty common thing among designers, but what it stands for is red, green, blue. And essentially what this function expects is 3 integers, 1 to represent how much red content we're going to have, 1 to represent how much green content, and 3, the third integer is how much blue content we're going to have. And the values that we can provide here is any integer between 0 and 255. So that's a total of 256 options. So that actually gives us a whole huge palette of colors, because if we have 256 options for how red something is, 256 options for how blue something is, and 256 options for how green something is, that's a total of more than 16 million possible combinations that we can choose here. So whenever you want any kind of font color, you have 16 million options to choose from, which should be more than enough to fit your designer needs. So just to show you how this works, the higher number we give, the more that color is going to be represented. So if we want something that's pure red, we can just put 255, that's the max value, and then we can leave 0 green, 0 blue. This is going to be a color that is going to be pure red. If we instead give this a 0, this is a 0 for the redness, and we give this 255, this is a color that's going to be pure green. So if I execute this, we're going to get a color that's pure green. If we put instead a 255 for the last number, which is the blue content, that's the B in RGB, this is going to be pure blue. And of course, we can mix and match. So we can have something that's midway red with maybe a little bit of green with maybe a lot of blue. And we're going to get some kind of combination there that's going to look a little bit on the purple side, right? So this is how we can come up with all of these custom colors. We have more than 16 million combinations. Many times, if you're working with something like hexadecimal codes, which is more common in HTML, there's many different online converters where you can pick a color or convert a hexadecimal number to an RGB equivalent. It's just sort of like mixing paint together. We need a little bit of red, a little bit of green, a little bit of blue, and we can combine that to make a whole bunch of different colors. And that allows us a much wider palette than just the predefined Excel constants like VB red and VB blue. But that's all there is to cover in this lesson. We talked about the font property on a range object. The font property returns an object of its own. We call that font. That font object has a whole bunch of properties on it: bold, italic, which expect booleans. We have underline, which expects a predefined constant. We have size, which expects an integer to represent the size of the font in pixels. We have name, which represents the actual font that we want to use. We can use anything that we have available to us in Excel. We have the color property. The color property actually expects a wide variety of inputs. We can give it a predefined Excel constant. We can give it an RGB function here, which is going to evaluate to some kind of color. You can give it a value for red, green, and blue from 0 to 255. And there's even more properties available on font that we didn't discuss for more complex operations like striking through things, subscripts. Those are all more advanced operations, but I trust that if you understand these concepts, you can dive into the documentation and take a look at some of those additional properties yourself. That's all there is to cover here. I'll see you in the next lesson. In the last lesson, we took a look at the font property on a range object. The font property returns a font object, which allows us to modify the look and feel of the font of a cell. Well, we can also use VBA to modify the background styling of a cell or range, and that's what we're going to explore in this lesson. I'll begin here by defining a procedure called paint with colors. And what I'm going to do here is the same thing as in the last lesson. I'm just going to define a variable to store my range object. So div r as range, and let's set r equal to some range. This time around, I'm actually going to use the cell syntax just to break things up a bit, keep things exciting. And let's reference something besides cell A1. So let's say we want to target cell 43, that's row 4, column 3, so that should be right here, should be cell C4 right here. Okay, so what can we do with this range object? Well, range objects, in addition to having font properties, have a property called interior. And interior, you can think of that as being the background of the cell or range. So on interior, that's a separate object. We have a whole bunch of properties available here. And we have a similar property to font. We have a color property, and this is where we can actually set the background of a cell. So we have a whole bunch of options available to us here, including all the predefined constants we took a look at in the last lesson. So for example, VB red, VB blue. We actually have an option here of VB magenta. You can take a look at what that looks like, but the syntax here is just referencing the interior object on a range, referencing its color property. Here we're giving it a predefined constant, F5. We can see we've colored that entire background of the cell. All right, so this is not the font. So the font is not going to be affected. It's still the standard black for now. You can see that if I even type a value in here, hello. The font size, the font weight, the font family, none of that is affected. This is strictly the background of the cell, which is called the interior. So we can give it a predefined constant. And in addition to VB red, VB blue, VB magenta, we have a couple other options like VB black, VB green, VB yellow, VB cyan. That's another interesting one. Let's take a look at that. You can find a list of these predefined constants if you just Google them very quickly. You'll be able to find a short list if you just want to use some of these predefined colors. Now, just like we saw in the last lesson, we can actually use the RGB method, which again stands for red, green, blue. It expects arguments of how much red to put in, how much blue, and how much green. Again, from 0 to 255, 0 being none of that color, 255 being the max. If we want something that's black, by the way, that's going to be 0, 0, 0, none of each. So if we take a look at that, that's a cell that's entirely black. If we do all 255, that should be a cell, if I remember my color theory correctly, that's entirely white. Exactly. So that's kind of the standard, all white. And then we just specify how much of each color we actually want. So if we want to have, let's say, a mix of red, green, and blue at equal amounts, that's what that color is going to look like. Looks like it's kind of a darker gray. There is one other way to add color to a cell that I want to show you. I'm going to have to introduce some advanced concepts here, but you don't have to really worry about them. Just a little bit of syntax to show you all of the colors that we have available to us. So let me go ahead and clear this up. What I actually want to do here is, don't worry about what I'm doing here, but what I'm going to do is create what's called an iterator loop, which means I'm going to go over a whole bunch of values. I'm actually going to go through the values 1 to 56 to show you how this works. Don't worry about the syntax if you haven't seen it so far. We'll discuss it in greater detail throughout the course. Just focus on what I have written here in between this block of that begins with the word for. So what I'm going to do here is I'm actually going to iterate, which means go from the cells from the top to the bottom, and I'm going to target the cell in the first column, column A, and on my interior object, which again belongs on every single range, I'm just going to go through the cells like this: A1, A2, A3, A4. Each one of these is going to represent a specific range object. That's the range object whose interior I'm going to be targeting here. So on the interior object, we saw that we have color. We also have a property called color index. And color index actually accepts a numeric value. It can accept a value from 1 to 56. And these are, again, a list of predefined Excel colors. So some of the most common colors used in Excel, each one of them has a numeric value. So what I'm actually going to do here is go through 56 cells in column A and paint each one of them with a different color. So you can take a look at what these 56 colors are all at once. And then I'm also going to put in each cell the actual number of the column, of the color rather, so you can have a reference to that. So let me just finish up the syntax. This is going to be equal to I, which is the number I'm iterating over. And then the last thing I want to do is actually put the number in the cell. Again, if you haven't seen the syntax, don't worry about it. What I'm just doing here is allowing us to see all of these 56 colors at once instead of having me manually write 56 different color numbers out. Let's take a look at what this looks like. There we go. So what I've done in each cell is I've used a predefined color and I've written the number that color is. So this red, for example, is color index number 3. If you were to take this syntax and instead of putting I here, you were to put number 3, you would get this red. Number 4 is this green. Number 5 is this blue. All the way down, this is kind of the standard palette, the color index palette as it's called. We have a total of 56 colors, and these are kind of the predefined Excel colors. I'm pretty sure, I wouldn't be completely certain, but I'm pretty sure it constitutes most of the colors that are found here. Definitely all of the standard colors. We can see sort of the standard red and green and blue are the ones that we're seeing down here. All right, so that's another way that we can set the background of a cell. We can use the color index property and give it a numeric value 1 through 56. We can also give it one of those predefined constants. We can also use RGB, which is by far the most flexible and powerful way because, again, if we have 256 combinations for red, green, and blue, we have more than 16 million possible combinations. I think the actual number here is actually 16,777,216. So a whole bunch of options available to us if you want to use RGB and you want to have a really custom aesthetic scheme to your documents. But that's how we set the background. And of course, we can combine the interior property on a range with the font property and the font object. That way we can set the font as well as the background. Just remember that those are two completely separate components. You can sort of think of it as the background is the interior and the foreground, what's in front, is the font. And we can modify each of these completely in VBA. Again, all of programming is just figuring out what object we want to reference, what properties we want to affect, and what values we actually want to give them. It's as simple as that. All right, so we took a look at the range interior property in this lesson. That's all there is to cover here, so I'll see you in the next one. In this lesson, we'll take a look at the column width and row height properties on a range object. And just as the name suggests, these allow us to set the width of a column or the height of a row for any range object in VBA. For this lesson, I'm not going to write a formal procedure since most of our code will just be one-line snippets, so I'm going to stick with the immediate window. And there's actually two different syntax options that are available to us in order to change either the column width or the row height. So let's explore the first one. The first thing I need to do is to target a single cell in the column that I want to change the width for. So let's say I want to target cell A1 because I want to change the width of column A. So I can target any single cell in column A. It can be A1, A2, A5, doesn't really matter. Once I have that range, on my range object, I actually have a property called entire column. This is a bit of an interesting property because the entire column actually selects a brand new range object that represents the entire column that range is found in. So for example, if I just select A1, you can see that my cursor is now going to be selected with this cell. If I change this to entire column, this is still going to be a valid range object. The only difference now is that it's going to select the entire column. And that's exactly what we want to target because we're not changing the width of any one cell. If you think about it, we're changing the width of an entire column that cell belongs to. So once we have the entire column selected as a range object, we can use the column width property on that range. And this just expects a number that represents the width, I believe in pixels, that we want to set. What we can actually do here is take a look. If we right click on any of the column headers and take a look at column width, it's going to tell us what the current value is. So this column is a width of 8.43. So if we want to do something like roughly double it, we can set this to something like 17, and that should double the width of that column, column A. When I execute this, you can see it's been expanded in size. If I want to make it something smaller, it's a matter of changing the number around, and that makes it smaller. Let's check if this actually accepts floating point numbers. Let's say if I do something like 7.5, that works as well. So the number can be anything from a long, which means a whole number, or a floating point number with a decimal point. Okay, so that's our first option for changing the column width. There's another option available to us. On my application object, which sits at the very top of the Excel object model, we have a property called columns right here. And since it's at the very top, we don't actually have to reference application. We can target it directly. What columns allows us to do is to give it an input, for example, a string that represents the column or columns that we want to select. So if I do something like columns, let's do B now, column B. If I execute select, this is a shorthand way that we can select a single column. So we don't have to target a cell and then use the entire column property. We can just use columns to target a specific column like so. And so again, this is returning a brand new range object to us that represents every single thing in that column, column B. We can use the column width property on this. Let's set this to something like 40, give it a nice big width. And there we can see we've expanded the width of the column. If we want to affect more than one column, by the way, all we have to do is use that colon syntax. So if I want to target, let's say, columns B through E, so that's a total of 4 columns, B, C, D, E, I can just target it by writing a colon, starting with the first column, the colon, then the end column. Execute this. This should make all of them equal to 40. If I want to make that a little bit smaller, let's say 10. There we can see we've shrunk them all at the same time. The process for changing the height of a row is very similar. I'm going to show you both options. The first, again, is to select a single cell in that row, then select the entire row. So I'm just going to switch things up right now by using cells instead of range, just to keep things exciting. So let's say I want to change row number 8 right here. So this is going to be row 8. I can target any cell in that row. So let me just click out of here. For example, cells H3 is going to select cell number C8. That's in row 8. What I can do once I have a single cell is use an entire row property, very similar to entire column. This is going to return to us a new range object that represents the entire row. So once I have the entire row selected, there's a property called row height instead of column width. Otherwise, it's the exact same. We just give it a number. How tall do we want the height to be? Let's check the default right now. So this right now, if I highlight this, click this, row height, right now it's set to 15. So if I want to set this to something like 45, that should make it 3 times as tall. There we go. The row is now 3 times as tall. And the alternate syntax for this is very similar to how we use columns here. There is a property on application also called rows. For rows, instead of giving it something like a letter, we can give it a number. So if I want to target, let's say, row number 5, I can do row number 5. Once again, this selects the entire row. We can validate this by using the select method. There it is highlighted for us. Once it's selected, I can use the row height property on it, set it to something interesting like 20. There we've expanded the size. It's not really that visible, so let's make it something bigger. Let's do it 50. There we go. That's a much bigger row. If I want to target more than one row at a time, I can still use rows, but this time around, I have to give it an actual string. The string is going to follow a very similar syntax where we begin with the starting row and we end with the last row. So if I want to start from row number 2, go down to row number 5, I can just do 2:5. That's going to select the entire range of rows. I can validate that right here with select. And on this, I can apply the row height property and set that to something that we want. Let's say we want to make it 75. There we can see we've expanded the height of all those rows 2, 3, 4, 5 to be a height of 75. That's all there is to cover in this lesson. There are 2 different approaches here that we can use to target an entire column or an entire row to adjust the relative width or height. The first is to select any single cell within that row or column and use either entire column or entire row. That's going to give us a brand new range object. We can then use the column width or row height property on that. The second option is to use the built-in rows or columns properties. Those are available directly on the application object. Those allow us to give inputs of either the letters that represent the columns or the numbers that represent the rows. It automatically selects that entire column or row, so it's kind of a shorthand way of doing it. And then we just use the familiar column width or row height property to accomplish the same effect. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the autofit method on a range object. The autofit method changes the width of a column so that it captures all of the text within it. Now, this is actually a very popular functionality in Excel's main interface. If you've ever had a cell that has way too much content in it, what you'll notice is that the content will actually escape the boundaries of the cell, but the column width won't be extended. Now, there's 2 things we can do here. Most people know that we can click and drag this to whatever width we want it to be so that it can capture all the content. But a better approach is just to hover our mouse between columns A and B until we get this black cursor. And if we double click, Excel will automatically expand the column width so that it captures all of the content. So it's going to be as long or as wide as it needs to be so that that content doesn't escape the boundaries. And that's the exact same functionality that the autofit method offers us in VBA. So what I'm going to do here is drag this back so that the content is not perfectly captured within the cell. And in my Visual Basic Editor, I'm going to define a method called expand widths. And it's pretty simple. We're going to use the columns property that we saw in the last lesson. It's just going to be columns. This is a property on the application object. We saw in the last lesson how we can give it a single argument of a string that represents a column. We can actually also give it a numeric argument. I didn't mention that last time around. So if we wanted to target column A, we can either do this or number 1 because that's the first column in line. I'm going to stick with the string of A, and it's as simple as calling the autofit method capital A, capital F, execute this, and the column width will expand to include the entire text. Just to show you again, we're going to drag this back to its smaller width. Let's change this to column 1. Same result, F5, it's going to expand to the width. What if I want to target more than one column? Well, let's go ahead and drag this back and let me copy and paste this content to B1, C1, D1, E1. So now all of these cells have content that is kind of stretching past its boundaries. Well, whenever I'm using this syntax, I have to use actually a string representing the column numbers, so A through E. So we're just going to use a colon in between the starting column and the ending column. And what this will do is auto-fit every single column within that collection that we've given it. So columns A through E will be expanded. Their widths will be expanded to fit the content. F5. There we go. We can see A has been expanded, B has been expanded, and now all of the content fits snugly within those boundaries. That's the auto-fit method. This is a functionality that is available to most Excel users. I'm not sure how many people actually know about it, but it's a very, very cool feature because you don't have to click and drag. You can just double click and Excel will take care of that hard work for you. But we have that exact same functionality in the Visual Basic Editor. So if you don't want to use the column width property to guess what the size will be, and you automatically want to guarantee that it's going to capture whatever the cell is holding, you can just use the auto-fit method. In this lesson, we'll take a look at the clear contents, and clear formats methods on a range object. And as the name suggests, all of these methods deal with clearing something from a range. The clear contents method clears a formula and a value from a range, but it doesn't change any of the actual formatting or any of the visual aspects of the range. The clear formats method clears the formatting of the range, but not the actual values or formulas. And finally, the clear method is the big catch-all method. It does everything. It clears the entire object, meaning the values, the formats, the notes, everything. So let's take a look here. I'm going to populate column A with a whole bunch of values. Just let's do 1, 2, 3. And I'm going to color each cell a little bit differently. So let's just put some kind of styling in here. I'm going to use light blue. Cell below, I'll do something like light green. And the cell below, let's do something like light orange. These colors are just random. They don't really matter, but they serve to demonstrate how all of these methods work. A couple other things I want to do. Let's go ahead and bold the number 1 in cell A1. Let's go ahead and italicize number 3 here, just so that we add a little bit of formatting to the content of our cells, all right? Let's take a look at what this does here. I'm going to create a method here, or rather a procedure. I'm going to call it clear stuff. Clear stuff. Let's begin with the clear contents method. So I'm going to target range A1 through A3. I'm going to use clear contents. As the name suggests, clear contents removes the actual cell values, whatever we have written inside them, but it doesn't remove the formats. So when I execute this, you can see 1, 2, and 3 have been removed, but the actual cell backgrounds have stayed in place. And that includes not just the actual color of the background, or the interior as it's called, but also things like the border. So if we add a border here, let's just do it right here. And let's add a thick outside border to this cell right here. If I execute this again, you can see that the border is going to remain in these cells. Let's just go ahead and put the values 1, 2, and 3 back into those cells. I'm going to comment out this code so we can do a side-by-side comparison. And the other method that's available to us here, once again, range A1 through A3, the other method is clear formats. Clear formats is the opposite. It clears the formatting of a cell, but not the actual content. So 1, 2, and 3, those numbers will stay in place. But if I execute this, you can see the entire format of the cell has been removed. That includes everything from the bolding and the italicizing, that includes the background, and that includes the border. So anything related to the visual aesthetic or the look of the cell, that's going to be removed by clear formats. So let's go ahead and bring those formats back. You can't actually Control Z after a VBA operation. So I'm going to have to go ahead and just populate these cells with a couple more cell backgrounds. So it doesn't really matter what we choose here, as long as they're all a little bit different. Let's once again make one of these bold. Let's make one of these italic. Let's also add a border to all of them, just so we can validate everything. So we talked about clear contents, that clears the contents of the cell. We talked about clear formats, that clears the actual look and feel of the cell. And of course, we have a method here called just clear. And clear is essentially a combination of these two. It clears everything. So as soon as we execute this, the entire cell will go back to its original shape. It's not going to have a background or a border or any bold or italics or any values. So clear clears everything. You can think of it as the simplest and shortest method, clear for kind of a blanket clear across the entire thing. So when I execute this, we're going to go back to the spreadsheet the way it was. So we started with a blank spreadsheet and we end with a blank spreadsheet. Pretty romantic there. All right. So that's all there's to cover in this lesson. The clear method, the clear contents, and the clear formats method. Each one targets a different aspect of the range. Clear contents targets the values or formulas within a cell or range. Clear formats targets the aesthetics of a cell, its look and feel. And clear targets everything, just gets rid of everything possible in that cell. Values, formulas, formats, notes, borders, everything. All right, that's all there's to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the delete method on a range object, which predictably deletes the cells in a given range. Let's begin by populating a few values here in my Excel spreadsheet. I'm just going to spread them out over a couple columns and a couple rows. So let's just write a couple numbers here, 1, 2, 3, and 4, 5, 6, and let's do 7, 8, 9 right here. And I'm going to be sticking with the immediate window because all of these steps are pretty small and lightweight. All right, let's begin with one way that we can reference our rows and columns, which is using the rows and columns properties. You may recall a syntax like this. We can do something like rows, and we can provide a string here to represent the rows that we want to target. So for example, rows 4 through 5, and I can do it like this, 4:5, the beginning row and the final row in double quotes. This is actually going to give me a range object. I can prove that by calling the select method, and there we have our rows. And what I can do on this range is call the delete method. And this is going to operate exactly like a delete operation works in Excel. So if I were to right-click right here and click delete, what would happen is rows 4 and 5's contents would be deleted, and row number 6 would be shifted up, and that would become row number 4. So we can keep our eyes on the numbers 7, 8, 9, and those should appear in row 4 as soon as I execute this right now. There we go. So they have been shifted upwards. Everything works as expected. We can also perform the exact same logic when it comes to columns. So what I can do here is just add a few more numbers here, 10, 11, 12. Let's say I want to target 2 of these 3 columns. Instead of using rows, I can use columns. Here, I can similarly open my parentheses, provide a string, and feed in my starting column and my ending column. So let's say I want to delete columns B through C. And of course, this doesn't have to be limited to 2 columns. It can be 1 column, 5 columns, whatever you want. You simply put the starting column and then a colon and then the ending column. If it's only 1 column, then it's just going to be the same letter. For example, B:B would only target that single column B. In this case, I'm going to target columns B and C. That's going to select the entire range of those 2 columns. We can see that highlighted right here. I can call delete. And of course, just like in Excel, when we right-click here and click delete, what's going to happen is column D is going to be shifted to the left. So those 2 values, 9 and 12, should now appear in column B. So when I execute this, we're going to get a predictable result. There we go. Pretty simple. Let me go ahead and clear this code up. And the next thing I want to show you is what happens when we actually call delete on a single cell object. Usually in Excel, we're going to be deleting whole rows or whole columns at a time. And if you simply want to clear a cell, there are convenient clear and clear contents methods that we've talked about a little bit previously. So usually you're not going to be deleting a cell. You're usually going to be deleting an entire column or row. But I did want to show you the syntax if you did want to delete a cell, because there's an additional argument that we have to feed to the delete method. What I'm going to do here is just write out a couple more values here. Let's do 1, 2, 3, and 4, 5, 6, and let's do 7, 8, 9 right here. And let's say I want to target this cell right in the middle, the one that's at C5 that also conveniently has the number 5. So what I'm going to do here is I'm going to target that single cell with my range property. So range C5 in quotes, and I'm going to call delete here, but this time I need to provide it an additional argument, and this is actually going to be an enumeration or a predefined constant. As a reminder, those are those built-in constants that are available in VBA so that VBA can translate our commands. So if I put a space here, unfortunately, IntelliSense is not helping me with options, but there is an option available here called XL to left. What that means is that the cells are going to be shifted leftwards. So what I mean by that is if we take a look at this 3x3 grid, what's going to happen is the number to the right, which is number 6, is going to be shifted to the left to fill the gap that was created by the removing of number 5. So let's execute this, and we can see that 6 has moved to the middle. So what's happened is we've deleted this cell, and Excel has shifted this content on the right side to the left. That's what it means when we say to the left. Let me go back and bring this to its original state of having a 5 in the middle and a 6 to the right of it. Let me just click in here, 5 and 6. And the other option that's available to us when we delete instead of XL to left is actually going to be XL up. What that means is whenever we delete a cell, we want it to be replaced by the value that's immediately below it. So we want to take the value below it and move it up. That's why it's called XL up. So in the previous example, we took this value and moved it here. In this example, we're going to take this value and move it up. So we're going to take 8, and it's going to take the place of the removed 5. So when I execute this, We can see the 5 has been removed, we've deleted it, and that 8 rather has been moved up to fill its place. So those are two common predefined constants, moving things leftwards with XL to left and moving values upwards with XL up. Remember, it's relative to the cell that's going to be actually moved into that position. It's not where you're starting from. We started in that center, but the enumeration here specifies the path for the cell that's going to be taking the place of that. So XL to left means the cell to the right is going to be moved to the left, and XL up means the cell below is going to be moved up, right? So it's from that position. But that's all there is to cover in this lesson. We talked about the delete method on a range. It deletes the cells and shifts the cells around it. We can call it on rows or columns. That's usually the most conventional use of deletion in Excel. Whenever you want to completely remove a column's contents or a row's contents, it might be more effective to delete that row or column rather than clearing its contents. It's just more safe and immediately removes not just the content and the format, but just the entire row entirely. So that's a very common user case. So it's highly likely that you want to emulate it in VBA. In addition to columns and rows, we also talked about how we can target a single cell range, call the delete method on that as well. In that case, we do want to provide an enumeration. XL to left and XL up are two examples that we can use there in order to shift the cells. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the range copy and range cut methods, and they operate the exact same way as the copy and cut functionality works in the actual Excel interface. So I want to begin here by creating a range of values right here starting in cell A1. It's just going to be a bunch of random values. So let's just do 1, 2, 3, and maybe 4, 5, 6, 7, 8, 9. Let's go ahead and try to copy this range of cells using VBA. I'm going to write a procedure here in my Visual Basic Editor. I'm just going to call it copy and cut cells. And we can actually copy and paste in a single method call. So I'll begin by referencing the range that I want to target, A1 through C3. I'm going to invoke the copy method, and it's actually going to take a single parameter, which we can see right here, and that is destination. And predictably, destination expects a new range object, which is going to represent where it is that I actually want to paste the contents of my original range to. So where do I want to paste cells A1 through C3's copy? So let's say I want to paste it in cell D8 through, in this case, F10. I can write the entire range, so I can do something like this, range D8 through F10, and this will work. We can go ahead and run this macro when I press F5. We can see that the contents have been copied. Copy, as a reminder, means completely copied, so the original cell range is not removed or cleared. So here we have our copy, and we've targeted a range with the exact same width and height as the original one. But as it turns out, we don't even need to target the entire proper range. We can simply target the top left cell. This is the exact same way that it works in Excel. For example, right here in Excel, if I simply copy this range and press Control-C to copy, we can see that little border appear around it. And if I were to simply click into something like cell D8, just the top left cell, and press Control-V, we can see the paste operation is going to paste the entire original range. And the same logic applies here. So I'm just going to comment this out and copy this code below. And if I simply write here the top left cell, we're going to have the exact same result. We're going to see all of them have been copied. In fact, if we accidentally miscalculate and provide a larger range than is needed, for example, D8 through, I don't know, Z26, in that case, we're still going to get the exact same result. We're just going to copy it directly to that proper range. Let's now go ahead and take a look at the cut method on a range object. I'm just going to go ahead and clear this content and comment out my code right here. Cut is going to work in the exact same way as copy. As a reminder, though, whenever you cut something, it doesn't just paste the original range to its destination, it also removes the original range. So it's kind of like a movement of the data to somewhere else in the worksheet. So I can begin by once again targeting cells A1 through C3, but this time, instead of invoking the copy method, I'm going to invoke the cut method. And as we can see, it has the exact same function signature. That means it takes the exact same parameters. In this case, it's just destination. Destination is going to expect a single range object. And again, destination here, we're simply writing out the parameter name, but we don't have to do that. So we can go ahead and paste this, let's say somewhere like B13. Once again, when we provide this range, we can just provide the top left cell. And when I execute this, we're going to take the cells in A1 through C3 and cut them to right here in cells B13. So when I execute this, see what's going to go on. Looks like it's a little bit of a pause. There we go. So here is my 3x3 original range of values, and we can see it's also been removed from its original position. So it's been cut and moved rather than copied and moved. That's all there is to cover in this lesson. We talked about the copy and cut methods on the range object. They both take a parameter called destination. Destination expects a range object where you clarify where you'd like that data to be pasted to. If it's copy, it will be copied and the original data will not be replaced. And if you cut, it will paste, but it will also remove the original range that you targeted. That's all there is to cover here. So I'll see you in the next lesson. In this lesson, we'll take a look at the paste special method on a range object. Paste special allows us to paste in a special manner, much like we can in the main Excel interface. For example, if I have a cell here with the value number 1, and I go ahead and copy it with Control-C, whenever I right-click here and I look to paste, there are actually more options available than simply copying over the value. We can copy over formatting, we can copy over validations, we can copy over column widths, a lot of special cases like that that make the paste a little bit more precise or special. And we're going to take a look at that in this lesson. Let's begin by simply using the paste special method. So this is going to be an alternate syntax to the copy method that we saw in the previous lesson. I'm just going to keep this value here in cell A3, and I'm going to write a new procedure here called copy and paste range. Now we know in the last lesson that on a range object such as A3, we do have a method called copy, and we do have a destination parameter there that we can use to specify where we want to paste it. But that's not necessarily the only approach that we have. We can actually call copy here without giving it a destination parameter. And what that's going to do is simply copy it to our clipboard, much like we would do if we pressed Control-C on our keyboard. That doesn't mean we're actually pasting it anywhere. We're just holding it in memory. Once we have this copied, what we can do is target a brand new range where we want to paste. For example, let's target cell C3. And then we can use the paste special method on the range that we actually want to paste into. And by default, this is going to be a standard paste. So when I execute this, we're going to get a value of 1. And in this case, that works just fine. But of course, paste special shines when we have to perform some kind of special operation. A really great example is pasting values. Many times, one of the most common operations in Excel is whenever we're copying a cell that has a formula, we don't actually want to copy over the formula. We just want to copy over the final calculation or the final value. Let me give you an example here. If I have two values here in column A, let's say 3 and 5, and right here below, I do a basic sum function, and I add the two of them up. By default, if I click into here, we're going to see the formula itself, sum A1 equals A2. So if I copy this with Control-C and paste it, let's say right here with Control-V, we're actually going to get 0 because what Excel is going to do is copy over the exact formula itself, sum, and then move the range references over respectively. So if we have A1 through A2, it's going to look for the sum of C1 through C2, which of course are blank cells, which results in 0. So what we wanted to do here, of course, is not simply to paste the formula. We wanted to paste the final calculation, which was 8, without actually deleting it here. So of course, in the main Excel window, what we can do is right-click here and click this special 1, 2, 3 icon, which means just paste the values. And when we paste the values, we're just going to get 8. We can in fact see the difference because right here in the Excel formula bar, we have the number 8, but if I click into this cell, we have the full formula written out. We can emulate this exact same functionality right here. In order to do that, all I need to do when I invoke paste special is to give it a special enumeration. As a reminder, an enumeration is just a collection of predefined constants that allow Excel to modify how it performs an operation. And what we have here is all of the enumerations that represent the different ways that we can paste. So if I just take a look at some of them here, you can see that we can paste just the column widths, we can paste the comments in a cell, we can paste the format of a cell, things like its font style, its border style, etc. All of these are different enumerations that you can dive into in the official VBA documentation. The one that I actually want here is called paste values. And notice as well, by the way, that all of these begin with XL. So if I type XL paste values, that's the one I want. That's the exact same thing as pasting values in the Excel interface. This is going to copy over the actual calculation in the cell rather than the formula that was used to calculate it. So this is emulating the exact same thing we just saw. Let me go ahead here and just clear this so we can see this in action. The cell is now blank. When I execute this with F5, we're going to get a value of 8. And when I click into here, we can see it is actually 8. It's not the exact same formula. So everything is exactly as it is on the main Excel interface. And again, this is not simply limiting to pasting values. We can also paste formats, conditions, all that kind of fun stuff. It just depends on what it is that you want to do. And at that point, you have to find the right enumeration to accomplish that. That's all there is to cover in this lesson. We talked about the paste special method on a range object. It works without any kind of parameters. If it does, it's just going to be a standard default paste, the same way that Control V works, the same way as providing a destination parameter to the copy method works. But really, paste special shines when we give it a parameter to work with. In fact, that parameter is called paste, and that specifies how we're going to paste it. That paste parameter expects an enumeration, and that enumeration will clarify exactly how it's going to perform the paste process. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, I want to introduce the parent property, which is actually available on all major objects in the Excel object model except for application. What's really cool about the parent property is that we can use it to traverse the Excel object model upwards instead of downwards. The parent property on a given object will give us that object's parent, or the thing immediately above it, the parent object that is containing it or enclosing that object as a property. Let's take a look here in the immediate window. What I want to do here is actually start at the bottom with range and use the parent property to navigate all the way up to the application object at the top of the hierarchy, which again represents the entire Excel application itself. So I'm going to begin with a sample range like range A1. And on a range object, I have a parent property. This is actually going to give me the parent of a range, the thing above it that's enclosing it, which is, of course, a worksheet object. Now, by itself, this syntax is not going to work. I can prove that by pressing enter here. We're going to get this error, runtime error 438, object doesn't support this property or method. All this essentially means is we are properly referencing an actual worksheet, but we can't simply output the value of a worksheet because that's a complex object. VBA has no clue what to actually show to the user. We need to actually choose a property that we're going to output here with the question mark. So there are two ways that I can prove that this is an actual worksheet. The first is by wrapping this entire expression in my type name method. Remember that that's going to give me back a string that represents the type of object that this is. So I'm starting in a range, I'm getting that range as parent, and the type of that object is a worksheet. And the alternative thing that I can do here is once I have the parent of range A1, what I can actually do is actually choose a property on that worksheet. The simplest one, of course, is name. And we're going to get sheet 1. That's exactly the sheet that I'm currently on. Perfect. So let's continue this process upwards. What I can do is this. I can do range A1. Parent, this is giving me a worksheet object. I can tack on a parent property right here as well. The reason I can do that is because every single object in the Excel object model, with the exception of application, has a parent. So once again, I can wrap this in a type name, and we're now going to get the parent of a worksheet, which of course is the workbook. A workbook is containing a specific worksheet, right? So we can also call the name property on this workbook. Remember that a workbook has a name property. The only difference there is that that property is not overwritable like it is for a worksheet. So when I execute this, we can see that this is the name of my workbook, my entire Excel file. Notice here I kind of glossed over this a little bit, but we're not getting the collection object. So the parent of worksheet is not going to be worksheets, which is the collection. Rather, it's going to be the workbook. It's kind of the literal enclosure around it. And if you think about it, a workbook is containing a worksheet. Worksheets is kind of just the intermediary middleman. We do have to reference it when we're traversing down the Excel object model, but the thing that's actually enclosing a worksheet is a workbook. We can continue this process by going further up. So right here, I'm once again starting at range A1. The parent property is going to give me the parent of a range, which is a worksheet. The parent property of that is going to give me the parent of a worksheet, which is a workbook. And the parent of a workbook, of course, is going to be the entire Excel application. What I can do one more time is to wrap this in a type name rather, and close my parentheses here, and we're going to get the application. And of course, application also has a name property. That's going to bring us to essentially the end of all the content here. If I remove this, we now have the application object referenced. And what I can do is get the name property, and there we have it, Microsoft Excel. That's all there is to cover in this lesson. So much of this course has been focused on traversing the Excel object model downwards that I thought it'd be interesting to kind of summarize and finalize everything by showing you how we can proceed upwards. So we can begin with a range and use the parent property. And that's just not available only on a range. That's available on workbooks, worksheets, almost every object in the Excel object model, all the way up to application. And we can continue this nested process to continue climbing up this ladder back up to the very top where we finally reach application. So good summary of everything that we've learned so far. That's all there is to cover here, so I'll see you in the next lesson. In this section of the course, we'll take a look at conditionals. So far, all of the procedures that we've written have been pretty cut and dry. All the code within them runs no matter what. In this section of the course, we're going to add a bit more complexity to that logic. We're going to write code that is capable of taking multiple directions based on a certain condition. So when I use the word condition, what I mean is some kind of evaluation or expression that's going to give us a true or a false value. We can test if something is true, and if that's the case, we can proceed in one direction, we can execute a certain number of steps. And if something is false, we can do something completely different. And that allows our code to be a lot more dynamic and flexible. The heart of all conditional programming is the idea of Booleans, which we've explored a little bit before. A Boolean is simply a value that is either true or false. Another way to think about it is on or off, yes or no. It's either this or that. And that's exactly the way that we want to structure our code sometimes. Go down one path if something is true, go down another path if it's not. Before we get there, though, I want to take this lesson to review some common Boolean expressions and some of the operators that we can use for things like comparison, equality, inequality. This is going to help lay a very strong foundation where we actually start diving into writing some of these conditional statements in our procedures in the follow-up lessons. We'll begin with the less than and greater than sign, pretty simple mathematical stuff, but let's go ahead and quickly review it. The less than sign is this symbol on the keyboard. We can check in this case, we're asking a question if 3 is less than 5. That's going to evaluate to a yes or no, a true or a false. In this case, yes, it is true that 3 is less than 5. If I reverse this around, if I do something like 5 is less than 3, of course, that's going to be false. That's just one example of an expression that evaluates to a Boolean. We also have the complementary symbol, which is the greater than sign. So we can do something like, is 8 greater than 5? That is true. Is 8 greater than 10? That, of course, is false. Same deal, just returns a valid Boolean number to us. We also have the less than or equal to and the greater than or equal to operators. So if I want to check, is 8 less than or equal to 8? That, of course, is equal to true. Is 8 less than or equal to 9? That is also true. What about 7? Nope. That's going to give us a false. And the symbol works exactly the same way in reverse. We can check if 10 is greater than or equal to 10. That answer is true. As soon as we climb up to 11, it's no longer equal to, it's less than. So we now go back to false. So less than, greater than, less than or equal to, greater than or equal to. There's two more I want to talk about here. The first is the equality operator. The equality operator is actually going to be the equal sign. This is a little bit different from other programming languages where it's usually two equal signs. In VBA, the assignment operator, which is used to assign a value to a variable, the equal sign, is actually the exact same operator that's used to compare whether two values are equal. So if we want to check if 10 is equal to 10, we simply write 10 equals sign 10. And it's going to return a true or a false depending on whether these two values are equal. So is 10 the same value as 10? The answer there is true. Is 10 the exact same value as 11? That answer, of course, is false. We also have a special symbol here called the inequality operator, which returns true if two values are not equal. So for example, if I want to check, is 10 not equal to 20? It's this little symbol right here. It's essentially the less than sign immediately followed by the greater than sign together as one. This is the inequality operator. So it is the inverse of the equality operator. It returns the opposite result. So in this case, it will return true if 10 is not equal to 20. 10 is not equal to 20, so that's going to give us a true. If I'm checking instead if 10 is not equal to 10, it is equal to 10, so therefore this is going to evaluate to a false. We can use both the equality and inequality operators with string data types as well. For example, I can compare a string like hello to another string like hello, and this of course will give us a value of true. These two strings are equal. I can compare hello to a string of goodbye, and that of course is going to give us back a false. The important thing to keep note of here is that case sensitivity matters. So uppercase letters are not the same thing as lowercase letters. If I do hello, for example, and I compare it with hello with a capital H, that's false. Those two strings are not equal. Those H's are kind of what distinguish them and make them different. The other thing to watch out for here, of course, is spaces. So even if I have hello here, but I have a space at the end, this is an extra character. A space is a totally valid character in VBA, so these two strings are not equal. The inequality operator can also be used when it comes to strings. Again, let's just compare hello with a capital H with hello with a lowercase h. Again, what I want to do is use the less than sign followed by the greater than sign. This thing right here is the inequality operator. It also returns a Boolean. It returns a true if the two operands, which are the values on the left side and the right side, it returns a true if the operands on the left and right side are not equal to each other. It is the opposite of the equality operator. It returns true if the two are unequal. So is hello with a lowercase h equal to hello with a capital H? The answer is no, they're not equal, so this should return a true. If I replace the h back to its lowercase form, now we're asking, is hello the same thing as hello? They're both identical, or rather, is it not the same thing? The answer to this is false, because they are the same thing, so the inequality operator will return that. All right, so this is just a quick overview to review the concept of Boolean expressions. A Boolean expression is just some kind of statement that evaluates to a Boolean value, true or false. We took a look at some of the symbols and operators we can use: less than, greater than, less than or equal to, greater than or equal to, the equality operator, which is the equal sign, the inequality operator, which we see right here. These are all different expressions that return a Boolean value, and we're going to use that Boolean value as kind of the barometer or the condition by which we're going to decide whether some block of code is going to execute or not. So let's go ahead and quiz ourselves on these concepts, and then in the lesson after that, we're going to show you how we can actually write our first if statement, which will allow us to write conditional logic. Okay, so now that we've got our Boolean expressions down, we can go ahead and proceed with writing our very first if statement. Let's dive right into it. I'll begin with the procedure here. I'm just going to call it my first if. And what I'm going to do here is I'm going to introduce a new keyword. It's called if. And right after if, we want to put some kind of expression that's going to evaluate to a Boolean. Now, I'm just going to do a basic mathematical operation like if 5 is greater than 3. But what we put here can actually be anything in the world that evaluates to a Boolean. So we can, for example, put an object property, because certain object properties evaluate to a Boolean value. Anything at all that's going to give us a true or a false is a valid thing to put here after if. And after the if and after the condition, as it's called, we put a then, create a line break here, and write end if. So it reads almost a bit like English. We're saying if this is true, then execute everything that we're going to place within this body here, and then close the if statement with the end if. So whenever we write an if, we always have to provide an end if, just like whenever we create a procedure with sub, we have to provide an end sub. Same kind of logical idea here. We're basically saying if this is true, then anything that we find within the body here, we're going to execute. So let's go ahead and execute something. I'm going to put a basic message box out here. Message box, yay, it's true. All right, and this is a valid procedure, so we can go ahead and run this. When I press F5, you can see yay, it's true is going to pop up for us in the Excel interface. The reason that happened, of course, is because this evaluated to true. Now, let's say I change this to an actual condition that evaluates to false. Let's say I now change this to 5 is greater than 8. What's going to happen now? Well, if the if statement evaluates to false, if this conditional is going to evaluate to false, then nothing within the body of it is actually going to execute. This whole body, and right now it's limited to a single line, but it can, of course, be as many lines as we want. The entire body, the entire block, is only executed as long as the if statement evaluates to a Boolean value of true. This time, this Boolean expression is going to evaluate to false, so no part of the body is actually going to run, so this procedure is going to do nothing. When I execute this, F5, 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 nothing is happening at all. Before we wrap this lesson up, I do want to show you one shorthand syntax that we can use. I'm not going to use it a lot throughout the course because I prefer this syntax. I think it's a little bit more logical. But whenever we have a simple one-liner like this, and what I mean by that is that the body of the if statement is only a single thing, a single command that we want to do, what we can actually do is remove the end if and bring that single expression right here, the message box, onto the same line. This is only possible if what we want to do within the body of the if statement is a single command. As soon as it expands to more than one command, we have to use the traditional if, then, and end if structure broken up over multiple lines. But this will work exactly as the previous example did. So right now this is not true, so nothing will happen here. But if I change this to something else, let's just do a equality operation now with strings. So if hello is equal to hello, the exact same kind of Boolean expressions that we talked about in the previous lesson. We can use less than, greater than, equal to, not equal to, less than or equal to. All of the things we discussed are completely valid things to put here in the condition. It just has to be some kind of expression that evaluates to a Boolean. In this case, this is true. Hello is equal to hello, which means this single line of outputting the message box will take place. I'm going to press F5. There we see our message box. Let's come back. And that's it. That's all there is to cover in this lesson. We talked about the if-then structure. We write the if keyword. We follow it up with a conditional, then the then keyword. We do a couple of line breaks. That's going to constitute the body of our if statement. We always conclude with an end if, and anything between the if and the end if will only execute if the thing following the if statement, the conditional, evaluates to true. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the else if and else statements, which allow us to add more complex conditional logic to our procedure. I'll begin by writing in a value in cell A1. I'm just going to write in my name. Let's make it Boris. And let's just make sure here on the Home tab that this font is currently set to Calibri. So here it is. Calibri is the default font in Excel. So this is going to work as expected. So what I'm going to do here is write a macro that's going to change the font size and then change the font, but I'm going to add a little bit more conditional logic to change the font depending on what the current value is. What I want to do is if the font is Calibri, I want to change it to Times New Roman, and if the font is Times New Roman, I want to change it to Calibri. So let's take a look at how we can do that. So I'll begin with a procedure. I'm going to call it change font. The first thing I want to do here is target my range. So I'm going to define a variable. I'm just going to call it RNG for short. That's going to be a range object, so as range. Whenever we set a variable value that represents an object, we have to use the set keyword, so set range. Let's target our range of cell A1. That's going to be the cell we want to target. That's A1 notation, literally cell A1. Right below here, I actually want to define a variable that's going to represent my font object. As a reminder, the font object is found directly on a range object as a property. So I can declare a variable. I'm just going to call it ft. That's a short variable name, short and sweet. And that's going to represent a font object. A font object is yet another object in our Excel object model. And what we can actually do is this, set ft, because it's an object. And on my RNG variable, which represents my range object of A1, I know that I'm going to have a font property, which represents the font object. So now I've referenced that object directly that's on my specific range. So now we don't have to write out this very long qualified reference. We can just target this variable, and that's going to represent my range's font, specifically my range of A1's font. Okay. Why don't I begin here by setting the size of the font to something a little bit larger? No matter what, we're always going to make sure the font is going to stay the same size. So let's change the font size to 24. As a reminder, this size property is on the font object. So the reason I'm able to have this syntax is because ft has been assigned to the font object on the range object. Otherwise, I'd have to do rng.font.size equals 24. All right, so right below here, we're ready to write our conditional logic. So what I can do is begin with an if statement. We want to reference our font object. That font object has a name property. That name property is going to return to us a string that represents the name of the font. So what I want to do is use my equal sign, the equality operator, to check for a specific font as a string. So I can check for the font Calibri. All right, so we write if, we follow it up with a condition that's going to evaluate to a Boolean. This will evaluate to a true or a false. We then add a then and an end if. And again, whatever we write in here will only execute if the font's name is Calibri. So if the font is Calibri, what do I want to do? I want to change the font to something different. Let's do Times New Roman. All right, so let's go ahead and see if this works. Right now, this is Calibri. When I execute this, this should change it to Times New Roman, F5. There we can see the font name has changed, and we've also changed the font size to 24. That's this line of code right here. So all of this works pretty well, but as I mentioned at the very beginning, what if I wanted the macro to be a bit more complex? If it's Calibri, I want to change the font to Times New Roman, but if it's Times New Roman, I want to change the font to Calibri. One option that I can use is to simply copy and paste this code below, but that's not really effective. It's kind of inefficient because the concept that we're dealing with here is fundamentally the same. We're still dealing with a font change. So there's an available conditional that we can put in VBA, and it's called the else if statement. It's basically another if that we're going to put after our main if, and it's only going to be accessed and checked if the first if evaluates to false. Let me go ahead and write it out, and then I'll explain it in more detail. So right here, I'm going to create a line break before the end if, and then I'm going to write else if. Else if, no space, but the E is capitalized and the I is capitalized. And what I want to put in here is another condition. It's going to operate exactly like a regular if statement. It's just another else if. So I can say if the font name is Times New Roman, and I obviously want to put a condition in here that is going to be different from the one that I put in my first if. I still need to add a then keyword at the end. I do not need another end if. This end if will serve as kind of the definitive end of this entire block of code. So only one end if. And in here, I'm just going to put what I want to happen if the font name is equal to Times New Roman. In that case, I want to change it to Calibri. So what's going to happen here? What's going to happen here is VBA is going to read through this code line by line, and it's going to get to this if statement. If the if statement evaluates to true, if this is true, then this block of code, the body as we call it, will execute. However, when this if statement evaluates to false, immediately VBA is going to jump to this section of the code. So the body of the first if statement is going to be ignored because it's invalid, and we're immediately going to jump to this else if, which is going to evaluate a totally different condition. In here, we're comparing to a totally different string of Times New Roman. And if this one is true, then we're going to execute this body and completely ignore the one above. So we've kind of structured this logic to now have two pathways. There's two branches. There's two different directions that our code can go. It can change the font to one of two things depending on the current state of one of two things, which is the current value of the font. So as I continue executing this macro, we should see that the font here is going to change. Right now it's Times New Roman, so it's going to change to Calibri, but the next time I run it, it's going to change back to Times New Roman, then back to Calibri, then back to Times New Roman, and so on. So here we go, F5, there we go, F5, there we go, F5, there we go, F5, there we go. You can see the macro is now a lot more dynamic. It's changing the font based on some existing condition, and we've enabled that by using the else if statement. Now, there is no actual limit to the number of else if statements that we can put below our original if. So I can add two more else if statements and compare to two other totally different fonts. That's totally up to us. One general recommendation, one best practice, is to put the if statements in order of the most likely probability and then descend downwards to the least likely probability. What you want to do is reduce the total number of checks that VBA is going to make, because what happens is if the first if statement evaluates to true, if this line is true, then the rest of the else ifs will not evaluate at all. VBA is going to look for the first exact match that evaluates to a Boolean of true, and that body, that block of code will execute. No other else if statements will. So in order to reduce the number of checks, you want to put the most probable or most likely thing at the very top. So that way we reduce the total number of calculations that VBA has to do. All right. There's one other thing I want to introduce you to in this lesson. We talked about else ifs, and I'll leave you to figure out if you want to add a few more on your own terms. By all means, go right ahead. It's the exact same syntax. You just structure another else if right here at the very bottom. But there's one other thing I want to show you in this lesson, which is the keyword else. You always put the else keyword at the very end of an if block. It doesn't necessarily require an else if. You can just do an if followed by an else. As we all know, we can do an if by itself. But an else is sort of a catch-all that represents something to execute in case anything above has led to a false. So in other words, if we evaluate the font and we see that it's not equal to Calibri and it's not equal to Times New Roman, this else block essentially will always execute. It's something that we don't need a Boolean for because it represents a series of statements that will always execute. It's sort of like saying, if this, do this, else do something else. And that something else will always execute if we use an else statement. So what I can do here is I can say, if our font is not equal to Calibri, which is our first if statement, and if our font is not equal to Times New Roman, if those two conditions aren't met, what I want to do is I want to change the font to, let's say, my favorite font, Comic Sans MS. All right, so I'm going to put that as a string. So this is going to execute if and only if any if statements and else if statements above it have all evaluated to false. So this is a last case scenario. So because right now we're only going to deal with Calibri and Times New Roman, this else statement will never actually be hit right now because it's always going to be one of these two. So as I execute this, we're not going to see any results with Comic Sans MS. I'm just executing this macro over and over and over again. But as soon as I change this font to something that's not one of these two, for example, let me just go here and pick a random font. It doesn't really matter. Let's just do Tahoma. So now it's Tahoma. What's going to happen when VBA processes the code is it's going to check Tahoma. Is that equal to Calibri? Nope. Is Tahoma equal to Times New Roman? Nope. It gets to the else statement. There's no more conditionals to evaluate. There's no more Booleans. Automatically, whatever is in the else, if you put an else, will execute. So then the font name will be changed to Comic Sans MS. So when I execute this macro, we should see this change to Comic Sans MS. That's all there is to cover in this lesson. We talked about the else if statement, which is put right underneath an if statement. We can put as many else if statements as we want. We want each one of them to check a different condition from the if statement. And just like with the if statement, we define a body or a block of code that will execute if the else if evaluates to true. We also talked about the else keyword, which allows us to kind of have a fallback of code to always run in case any of the if statements or else if statements evaluate to a consistent stream of falses. That's all there's to cover here. A good challenge for you is to apply these concepts in action. So I recommend perhaps writing another else if for the font name, checking for, let's say, Comic Sans MS and changing it to another font. Another cool thing you can do here is apply an if statement to the font size. So an idea for you, for example, is to say, if the font size is 24, change it to 72. If the font size is 72, change it to something else like 12. And maybe if the font is any other font size, change it to something like 24. So practice writing the if statement, the else if statement. Don't forget the then keyword. Don't forget the single end if at the end. Have fun with it, play around with it, and I'll see you in the next lesson. In this lesson, we'll take a look at the select case construct. Select case is a very effective way to replace multiple else if statements. So when you're noticing that you're writing and stacking a lot of else ifs on top of each other, and they're all basically checking the same thing, just differing in the value that they're checking, that's a perfect situation to introduce a select case. It buys you a little bit of space when it comes to stacking all of these possibilities one by one. So here in this brand new workbook, I've written the letter A in cell 5D. This is just a random cell and a random letter. And what I want to do is get the value of the cell and dynamically react to whatever that value is by just message boxing something out. This is a really arbitrary, simple example, but it should serve to demonstrate the point. So I'll begin by creating a new procedure. I'm just going to call it fun with select, sub, fun with select, open it up. And the first thing I want to do is actually get that value from the center of my spreadsheet. So I'm going to create a variable. I'll call it current value. It's going to be a string. And we can set current value equal to range. We want to reference D5. That range object has a value property. So now current value is storing the value A. So if I wanted to follow an if or else if approach, I could do that. I could say if current value is equal to this, else if current value is equal to this, else if current value is equal to this, else if current value is equal to this. And I could repeat that over and over again, but that code would get pretty long pretty quickly. So select case allows us to have a shortcut whenever we have that kind of situation where we basically just need to check the value of one variable, for example, and compare it to a wide possibility of scenarios. So what I do here is I write the words select case, and then I put whatever it is that I want to check the value of or compare to. In this case, I want to compare to the value that's stored in my current value variable. So you can sort of think of this like saying if current value equals, but we're still leaving off the right hand side because we're going to present below here several cases. In case this is true, do this. In case this is true, do this. In case this is true, do this. So we're sort of stacking these ifs and else ifs together. Whenever we use select case, at the very bottom here, we have to write end select. Just like we do end if or end sub, we need to put an end select at the end of our select case. So right here, what we do is we write the keyword case, and then following that, we write the actual case that we want to compare current value to. So for example, I can compare current value to a case of A, which is what it currently is. What I then do is I put a line break and indent and write what I want to happen if current value has a value equal to A. So if that's the case, what do I want to do? I can do a message box and say something like, hooray, it's A. All right. Right below here, I can put another case like if current value is equal to B, what do I want to do? I want a message box. Yay, it's B. All right, so this is the same thing as saying if current value is equal to A, message box this, else if current value is equal to B, message box this. But this structure allows us to continue going, especially if we want to compare current value with, let's say, 10 different types of values. This ends up being the most concise way to do it. So let's take a look at what happens here. My current value is currently going to be A. So this case is going to evaluate, and this message box is going to be what's output. So let's see what happens here. F5. Hooray, it's A. As soon as I change this to a value of B right here, what's going to happen now is this case is no longer going to pass. And then we're going to get to this second case, B, and this message box body, that's what's going to actually be output. So we should get a different value this time around. Yay, it's B. What's really great about this approach is that we can actually combine multiple cases on the same line. So if we want the same result, depending on a certain condition, for example, if we want to do something if the value is either B or C, and the result is always going to be the same, let's say a message box of whoopee, let's say we want to do that if it's B or C. You don't actually have to do a separate line and do case C and repeat the message box. You can just put a comma here and specify that second case. So we can do something like if it's B or C, if the current value is equal to either B or C, this is going to execute. So when I execute this, F5, we get whoopee. If I change this to C right here, click out of the cell, execute this again, we get the exact same value. And we can continue stacking these, by the way. We can put an extra comma, do like a value D, same thing. This is starting to buy us a lot of space because we no longer have to do an else if equal to C, an else if current value equal to D. We can sort of stack them in the same line if they all expect the same output, given that that condition is true. Now, if we want to add an else statement or the equivalent of an else statement, something to execute in case nothing above it has evaluated to true, what we do here is we simply write case space else, and this will execute if none of these conditions are true. So if the current value is not equal to A, B, C, or D, this is what's going to be hit. In here, we can do something like message box, yay, I'm some other letter. Again, this is all just silly fun. This isn't a real example, but you get the point. We can check, for example, if a cell's value is equal to something, do one thing, otherwise do another thing, and so on. So right now we have a value of C, so it's not going to work. But if I change this to Z and click back into here, we're going to get a value of yay, I'm some other letter. If I change this to something like R, click out of here, go back to VBA, execute this. Yay, I'm some other letter. And again, this else statement is going to capture every other possible scenario as long as it's not one of these. We can also use the select case to specify a range of numbers. Let's create a new procedure down here a little bit below. I'm going to call this procedure time of month. I'm going to use a little bit of an advanced concept here, but I trust that you're going to get it. I'm going to declare a variable here. I'm going to call it day of month. It's going to be a long, which is just a whole number. And we haven't dived into VBA functions yet, so you're going to have to trust me on this, but VBA actually has a collection of functions that we can use within the language. And one of them is called now. Now is going to get us the current time of day, so the current actual date and time. This is going to be different for you, of course, because you're watching this in the future. And then we also have a function called day, which is going to return us a number that represents the date or the day of the month that it is. So I'm recording this on the 19th of December, so this is going to evaluate to a value of 19. It's going to give us a whole number that represents the day of the month. Don't worry about this for now because we're going to dive into this a little bit later. Just realize that day of month is now storing the actual day of the month, which is a number. And let's say I want to output a different value depending on what day of the month it is. I don't want to do a select case and do something like if it's equal to 1, 2, 3, 4, 5, all the way to 31. That's going to take a lot of select cases. There's a much simpler way to do it. So what I can do here is write select case, day of month. Remember to close things off with end select. And now I'm checking the day of month again. So this is the value that I'm comparing to. But rather than writing case followed by a singular value, what I can actually do is specify a range of numbers. So what I can do is do 1 space 2, just like we're writing a for loop, and then the endpoint. So if the value of day of month is any number from 1 to 10 inclusive, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, then this case statement will evaluate to true, and anything that I put here in the block will execute. So I can message box something like, it's the first third of the month. All right. Right below here, I can repeat the same logic. I write case. I then write a range of values to check between. So between 11 and 20, I can message box something like middle of the month. And in this case, I want to do something that's a little bit more flexible. And some months have 30 days, some have 31, some have 28. And I could write a bunch of different scenarios here, but the easiest way here is just to write a case else, because that's going to account for every other scenario after 20. And I can do something like message box end of month. All right, now this macro is always going to function the same for me when I execute it today because the day is not going to change. But right now I'm on the 19th, so day of month should hit this case statement. This is where it's going to value to true. So this message box is what we should get, middle of the month. So when I execute this, we're going to get middle of the month. Of course, if you're watching this video at some other point, either the first 10 days or the end of the month, you're going to get a totally different message box value, but that's totally cool. That's exactly how the case statement is supposed to work. We're now writing code that is dynamically reacting to a certain situation. It's not just always executing no matter what. We're actually flexibly creating paths for the code to follow depending on certain conditions being met. There's one other syntax I want to show you in this lesson, which deals with mathematical operations like less than or greater than. We can use the same symbols we're used to right after the case statement. So for example, if I want to check if this value, instead of being 1 to 10, if I just want to check that it's less than 11, what I can do is I have to add an is keyword, so it reads more like English. If the day of month, the case is less than, let's say 11, this creates the exact same result. So we're taking the day of month, and now we're saying if the case or the scenario is such that the day of month is less than the value 11, we're going to message box this value. And I can repeat it right here by saying if this case is less than 21, we should have the exact same result. So we should still have the same output of middle of the month. Let's take a look at 5. Yep, middle of the month. So this is the exact same thing that we just wrote. It's just an alternate syntax. Remember that if you're using less than or greater than, less than or equal to, greater than or equal to, you have to write that is keyword. If you're writing a range of values, you just put the first number followed by the to keyword, followed by the last number, just like we saw in the previous example. But that's an introduction to select case. It's a really effective tool to use, especially when you start writing multiple else ifs and you start noticing that you're going down a path of comparing a singular value to several different possibilities. Switch to a select case. It's much more optimal. It's cleaner. It allows you to put multiple conditions on the same line to save yourself a lot of space. Really a pretty advanced programming concept, but one that can save you a lot of time and space. That's all there's to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the and or logical operators. So far, whenever we've structured a conditional with the if keyword, we've always relied on one condition. If this thing is true, execute the body, and if this thing is false, then don't execute the body. However, we can actually build more complex logic. We can check with the and keyword whether more than one condition is true at the same time. We can also check with the or keyword whether either one of two or more conditions is true. So not both of them that have to be true, but either one. Let me show you a couple examples here. What I'm going to do in my spreadsheet is just write two values in cells A1 and B1. My first one is going to be name, and my second one is going to be age. Right here in my Visual Basic Editor, I'm going to write a procedure, and I want to call it bold headers. And predictably, what this procedure is going to do is bold both of the headers in case two conditions are met. So typically, if I wanted to check one condition, I could write it like this. Let's say if range A1 value is equal to name, then I have to remember to put my then keyword, close this off with end if, and then right here, I can go ahead and select those two cells. Let me do it in a slightly different way than we're typically used to. Let's begin by targeting range A1. You may recall the resize property allows us to resize that single cell. I want to resize it by one row down, 2 columns over. So this is going to select A1 through B1. And then on that new range object, I have a font property. That's going to give me a font object which has a bold property. That expects a Boolean value, either true or false. And if I set it to true, this is going to make that content bold. So I'm going to bold the headers of my columns. However, this is only checking one thing, right? This is a singular thing that's being evaluated here. Range A1's value is equal to name. What if I also want to check that range B1's value is equal to age? How could I do that? The and keyword allows us to chain together multiple conditions in the if statement. And it's actually pretty simple. It reads just like English. If this is true, and then we're going to put the word and then on the right side, we're going to put the next thing to check. So if that's true and range B1's value is equal to age, and then we follow it up with the regular keyword, this is going to do what we want. It's going to check two things. One, that the range A1's value is name, and two, that range B1's value is equal to age. Both of those conditions have to be true in order for the body to execute. So if either one of the conditions is not met, or if both of the conditions are not met, this whole body will not execute. Let's take a look here. When I execute this code, right now we do have those values, so when I press F5, we're going to get them both bolded. However, let me go ahead and mix things up. I'm going to unbold this. I'm going to change this to lowercase n name. Now, when I try executing this with F5, I'm not going to have anything happen. I'm pressing F5 over and over. Nothing's happening because one of the two conditions has not been met. In fact, the second one doesn't really even matter because when we get to this first one, it's going to compare the value in A1 to the name string right here with a capital N. It evaluates to false. And if either one of these two conditions is false, the entire thing must be false as well. That's the rules of AND logic when you specify that everything must be true. And similarly, if I change this back to a capital N, but I change this to a lowercase a, age, this will also not lead to any executing code, any bolding, because now my first condition here is evaluating to true. That's fine. So VBA is going to evaluate whatever is on the right side of the AND, but this unfortunately is going to evaluate to false. And again, in an AND statement, if either one of the conditions is false, no luck, not good for us. And kind of again, to reiterate, we may also have a scenario where neither one is true. In that case, of course, nothing is going to execute as well. Neither one of the conditions is true, so the entire if statement can't evaluate to true as a whole. Let me go ahead and change this back to capital letters, name, and age. And then the other keyword I want to show you in this lesson is going to be the OR keyword. Exactly as it may sound in regular English, this one is a little bit different, but you can probably understand the logic. What this is saying is if either one of these conditions is true, it doesn't have to be both, but it could be both. It could also be either the left one is true or the right one is true. It doesn't necessarily have to be the case that both are true. This is an OR statement, right? Either this or that has to be true. If that's satisfied, VBA will execute the code. So in this case, we have an example where both of our conditions are met because name and age both match. So this will execute. We can see our bolding here. However, this time around, if I unbold this and I change this to a lowercase n name, this time around, we're still going to get the proper bolding. And the answer is, the reason why that happens is because this time around, this is going to evaluate to false. Range A1's value is no longer equal to name with a capital N. However, range B1's value is still equal to age with a capital A. So this side is going to evaluate to true. In an OR statement, both conditions do not necessarily have to be true. Either one or one of them has to be true. And in that case, this will execute. And again, the same logic will apply. If I change this around, if I do this to name and change this to age, let's go ahead and click here, execute with F5. Again, there's going to be bolding because this time this condition is going to be true. So it doesn't even really matter whether this one is true because in an OR statement, as long as one is satisfied, the whole thing will execute. And of course, if neither one of them is true, let's say name and age in this case, now we have two lowercase characters. Here we're checking for two uppercase characters. Neither one of these conditions is true now. So now the body of this will not execute when I press F5. Actually, I have to make sure I unbold it. Then I execute F5 here, and nothing's going to happen, of course, because neither of these two conditions is evaluating to true. Now, AND and OR logic can be a little bit complex, so in the next quiz, you're going to be able to tackle some of these logical operations, for example, combining Booleans in your head and figuring out whether true and false is equal to false, or true or false, things like that. So these are difficult concepts when you're beginning with programming because they involve a little bit of logical thinking, but the concept here is actually pretty simple, where it's just going to be checking more than one condition at once, either with an AND or an OR. With an AND, we require that both of those conditions must be true. With an OR, either one or both. And by the way, in this lesson, we took a look at two conditions side by side, but we're not limited to two. We can actually string together ANDs and ORs immediately after each other, so you can check three conditions at a time where all of them must be true with AND, or any one of those three can be true with OR. It's up to you and up to whatever program it is that you're designing. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, I want to introduce you to the NOT operator, which is used to negate or reverse a Boolean value. I want to show you two examples here in the immediate window, and then we'll dive into an actual procedure with a real-life use case. So here, what I'm going to do is just put a question mark. And again, the keyword here is not, and it expects a Boolean afterwards. So if I put something like true here, that is a valid expression. So what not does is reverse the Boolean. So what is something that is not true? Of course, that is false. So it takes the Boolean and gives you the inverse, the opposite, the other one. Similarly, if I have something that is not false, That's going to give me a value of true. Pretty simple, okay? Now let's take a look at this in the context of an actual procedure. Let's say I want to write a procedure that's going to emulate the bold functionality in Excel. So for example, if I have a bunch of cells here, let me just put in a couple words here, hello, goodbye, and then let's say something Excel. We have a functionality here in Excel where we can highlight a selection or a clump of cells, and we can press Control B, and that's going to bold it. And if we press Control B again, that's going to unbold it, right? That's actually more complex than it looks. Let's say I wanted to code something like this in an actual VBA procedure. Let's say I did something like this. I'm going to begin with a procedure here, and I'm going to call it bold selection. And as a reminder here, we have a property available called selection, and selection is automatically going to reference the range that's currently selected by the user. So it could be one cell, this is a selection right now, this is a selection right now, or this is a selection right now. The same way that we select something before we press Control B, that selection, that highlighted clump of one or more cells is what we call a selection, and it's automatically referenced here. This is a valid range object, which means it's going to have a font property. A font property is going to give us back a font object, and on that font object we have a bold property, and that's going to accept a Boolean, either true or false. So let's say I wanted to make this bold, right? So I could set it equal to true, and now this procedure is pretty simple. It looks like it's going to work because it's going to take my selection and it's going to make the entire thing bold. And at the first execution, of course, it's going to work. We're going to highlight this. This is now our selection, and now in here I can press F5, and our selection is bold. Well, here's where we're going to run into our first problem. What happens when I press F5 again? I expect it to go unbold, right? Go back to normal style. However, I'm not going to see that result. And why not? Well, because we have the same command every single time we're executing the procedure. Make the font bold. So what we have to do now is apply some conditional logic. We have to say, if the font is not bold, then we do want to make it bold. And if the font is bold, then we want to make it not bold. Take the opposite. So we could take a long-winded path. For example, we could do something like this. We can say, I'm going to declare a variable here. Let's call it F, and that's going to represent a font object. Remember, font is a property on a range, but it also is a complete object within the Excel object model. So I can make it a font object. And then I can set F. Remember, we need the set keyword before any variable that's going to store a VBA object to selection dot font. Remember, selection is a range object. We're getting the font property, which is the font object off it. So we're storing it in the F variable. And then we could write some expression like this. If F, which is our font object, bold, and you could check if this is equal to true, but this is not really necessary because remember, this is going to give back to us, we're getting a value now, the bold property. This is going to give us either a true or a false. And so we already have a Boolean here that can properly evaluate. We can say if this is true, if bold, then we're automatically going to have an if true here. So we don't even need to compare it, right? As long as this evaluates to some kind of Boolean expression, either a true or a false, we're totally fine just writing it like this. So we can write if it's bold, or rather, if that property gives us a value of true, put an end if here. If it's already bold, then we can take that object, take the bold property, and set it to false because we want to unbold it. Else if it's not bold currently, what we want to do is make it bold. So we can take the bold property and put it to true. So we kind of wrote a little bit of logic here. The reason, again, that we assigned to this F variable is to simplify the process of writing this out. This could, of course, simply be selection.font.bold, but in order to cut down the repetition a little bit, the duplication, we did this structure, right? And this should work. So now, if I highlight this selection again from scratch, and I go in here and I press F5, it's now bold, so it should be not bold. I press it again, it's now going to be bold, and I'm going to execute a couple of times, and we can see it's properly switching. So this is totally valid. But notice that in this case, we have 6 total lines. Actually, it looks like even more. 7 total lines with a blank line, 8 total lines to write this procedure with this kind of logic. The not property actually allows us, the not operator rather, allows us to make this a lot simpler and sweeter. In fact, I can do it in a single line. Here's what I can do. I'm going to leave this here so you have it for reference, and I'm going to write another procedure here called bold selection 2. And here's what it's going to look like. We know that we have selection. That's our range. We have a font property, which is also a font object. We have a bold property on that font object. That's either a Boolean. So if you think about what we want to do here, we want to take the current value of this exact same property and invert it, negate it, right? We want to take whatever it is and give us the opposite. If bold, then not bold. And if not bold, then bold. Well, we know that we have selection.font.bold, and that's going to give us the current value. Remember again that the right side of the equal sign is evaluated first. So before any of this stuff happens, we're going to evaluate this. This is going to give us the current state or status of the boldness, whether it's on or off, true or false. And then all we have to do is just negate it, which we can do with not. So again, it's a really confusing syntax because we have just about the same expression on both sides, but I want you to think of it first on the right-hand side. Ignore this entire part of the equation. We're first beginning by getting the current value of the bold property. It's going to be either a true or a false, which reflects the current state of the boldness. We're then going to negate it. It doesn't matter whether it's a true or false because we're going to get the opposite. We saw this example right here. Not true equals false and not false equals true. We don't know what this is going to evaluate to, but we know we're going to get the opposite with the not keyword. Once we evaluate to the opposite, we're going to get either a true or false again, and that's what we're going to assign to the bold property again, the inverse of what it currently is right now. It's a lot to take in, but hopefully the basic gist of this makes sense. So now we have our selection highlighted. I can execute F5 over and over again. And you can see we've emulated the design of Excel's bold functionality, but we've done it in a single line of code. Compare these two examples, and you can see one is obviously a lot more tighter, more efficient, and more elegant than the other. That's really all there is to cover in this lesson. We talked about the not operator, which is really great for negating a Boolean value. It takes the Boolean value, gives you the opposite. If true, then false. If false, then true. It can be really great when you want something like this, an on-off switch that alternates between one of two values, on or off, true or false, yes or no. For something like this, where you want to bold something or then not bold it, or it can be any kind of example like that when it's one option or the other. Something like negating the current property is a really, really good design pattern. Just makes it look really elegant and really short and sweet. That's all there is to cover in this lesson, so I'll see you in the next one. In this section, we'll be covering one of the most fundamental concepts of programming, which is iteration or looping. Looping refers to the process of repeating a block of instructions multiple times. And when I say a block, I just mean a grouped collection of code. So a loop can be thought of as a method that performs a task more than once, much like you would go around in a loop around something like a track, or just like that expression is used in everyday life. To loop is to do something over and over and over again. And an iteration is the technical term that represents one single cycle of the loop. So we may have a loop that runs 4 times, and each one of those 4 times is called an iteration. Now, there's 2 kinds of loops in VBA. There are fixed iteration loops and indefinite loops. A fixed iteration loop executes a specified number of times, and we kind of hard code that value into our code. For example, let's say we write a macro that's going to create a report for us in our spreadsheet. And every time we run the macro, we always want to create 5 new worksheets. Well, rather than writing that code 5 times, we can create a loop that says, do this operation once, the create of a worksheet, but do it 5 times over. So we don't have to duplicate a single line 5 times. We just have to tell VBA to do a single line 5 times over. In that case, the number of times we want to perform an action is fixed, it's static, it's constant. We sort of set it in place, and as long as our report doesn't change, we can keep that number every day. So that's a fixed iteration loop. The number of iterations is fixed in place. The alternative option there is an indefinite loop, which executes a flexible number of times, and that flexibility, that number of times that it has to run, is dynamically determined by a logical expression. For example, imagine we want to perform a process on a spreadsheet. We want to do some kind of repetitive operation on every single row, but we don't know how many rows we're actually going to have to deal with on a day-to-day basis. Perhaps one day we'll have 100 rows, the next day we'll have 200 rows, and the day after that we'll have 150. We can't hard code any single value because we might miss some rows someday and not miss them the other day, and etc. We need to be able to have code that is dynamically able to figure out how many rows we have, and that number of times run a certain procedure or run a certain loop, run that number of iterations. In that case, the loop is indefinite because it's not predetermined. It's being dynamically calculated at the moment that it's being run. There's no better way to test these concepts than to see them in action. So in this brand new workbook, I'll begin by creating a new procedure. I'll call it first loop. The first thing I need to do to create an iteration is to create an iterator variable. This is a variable that's going to keep track of how many iterations I've currently done of the loop. So I'm going to declare a long variable. As a reminder, a long is just the largest type available for whole numbers. and I'm going to call my variable I. So dim I as long. I is a very common convention in computer programming circles for two reasons. One, it's pretty logical, I for iterator, and two, it's short and sweet. It's to the point, doesn't take up a lot of space. You can choose whatever variable name you want, but I is a very common one. Now here's the part where we get to something that's actually new. This is the for loop. And I'm going to write out the syntax here, and then I'm going to explain what it's doing. So I'm going to write the for keyword. I'm going to use the I variable that we defined on the line above, an equal sign, a number, the to keyword, which we haven't seen before, another number. I'm then going to skip 2 lines here and write next I. So what's going on here? What we're doing here is we're saying we want to start off the I variable at a value equal to 1. You can almost block out this for part at the beginning and this to 5 part at the end, and just think of this expression. This is almost like we're assigning an initial value to the variable. So we're starting off I at 1, but we're doing something special here with the for keyword. We're saying that we're going to expect I to increment 1 by 1. So it's going to go from 1 to 2 to 3 to 4, and where is it going to stop? That's what we say when we say the to 5 part. That determines the endpoint. That determines the point to which it's going to go. So what we're saying here is for the values where I is going to be 1 all the way to the point that I is equal to 5, whatever is placed here in this block, in this body between the for and the next I, that's what's going to execute. So this loop is going to happen over and over again. It's going to happen with I having a value of 1, with I having a value of 2, then 3, then 4, then 5. Then it's still going to execute the body when it's 5. Then I is going to go to 6. And when it goes to 6, it's no longer within this range of 1 to 5. And at that point, the for loop will conclude, and it's going to continue on with the rest of the procedure. Finally, right here, the next I simply means as soon as this block of code is done running, as soon as, for example, I is equal to 1, we execute some kind of process in the middle here, simply increment I to the next value. So that's what next I means. So next I is the code that's going to take I from 1 to 2, then from 2 to 3, then from 3 to 4, etc. So we know that I is incrementing 1 by 1, and we can actually output the value of I to see it as it's dynamically changing. So right in the block here, I'm going to indent. That's a best practice just so we have a visual sense that this belongs to the for loop, as it's called. I'm just going to use debug.print. And what I want to output is the actual value of I, our iterator variable. So remember, at the very first loop, I is going to be equal to 1. We're going to execute everything within the body, which is just this debug print statement. We're going to output the value of 1. Then we're going to go to this next I. It's going to increment I to its next value, which is 2. And then this loop begins all over again. It comes back to the for part. It checks if I falls in between the range that we've defined, which is 1 to 5. And both of these numbers, again, are inclusive. And it's going to say, okay, so 2 is still within the range of 1 to 5. That means I have to execute the body one more time. So then it's going to debug print the value of 2, then move back to the next I, which is going to increment it to 3, then move back to the top and continue that procedure all the way up until it gets to 6, because 5 is still a valid value. So 5 should be the last value that we see outputted here. So when I run this with the F5 keyboard shortcut, there we can see the values of the I variable being output right here. In fact, what I can do just to show you at the very end, I'm actually going to use debug.print one more time to output the value of I after the loop is done. Unlike in other programming languages, the iterator variable is still preserved here. So as soon as this loop is done, I still exists as a local variable within this procedure scope. And we can take a look at what I is equal to here. And remember that it's actually going to be 6. It's not going to be 5. Because whenever it's equal to 5, it's going to execute. It's going to output 5. That's what we see right here. It's then going to increment to 6 right here. It's then going to go back to the top of the for loop. At that point, 6 is no longer within this range. So the for loop will conclude. It's done. But I is still equal to 6. So that's what we're going to see output by this debug.print. If I get rid of all my existing code, execute this with F5, we can see 6 is coming out here. That's coming directly from this line at the end of our procedure. So how can we apply this concept to our actual Excel interface? Well, as you might have guessed, this can be used to dynamically refer to things like rows or columns, because our iterator variable I can dynamically reference, for example, a row. So let's take a look at that right here. Right below the debug print, what I'm going to do is I'm going to use the cells property. Remember that cells, unlike the range, expects numbers. It expects a number to represent the row and then a number to represent the column. So if I give cells an argument, instead of giving it an actual number, I'm going to give it I. Remember that I is a dynamically changing value. It's going to be 1, then 2, then 3, then 4, then 5. What we can do is dynamically reference a specific cell on each iteration. So let's say I always want to target the dynamic row, 1 through 5, and then let's always stick with column 1, which is going to be column A. And what I'm going to write into here is just the value of I. So what's going to happen here, let's just go through it step by step because this is a very important part of programming. On the very first loop, I is going to be equal to 1. So you can think of I as just a variable that represents that number. So right here, I is going to be substituted for 1. So this is going to reference cells 1 of 1, which is cell A1, and it's going to write the value of I, which is 1, to that cell right here. Then we're going to increment I to 2 with next I. When we repeat the block, cells is now going to reference a different value of I. It's going to be cells 2, 1, which is going to be row 2, column 1. So that's cell A2. And the value that we're going to write in there is going to be I again, which is 2 this time around. Then we increment I to 3, and that process begins anew, and we repeat it 5 times over. So let me go ahead and clear this. Let's execute this code again with F5. We can take a look at our front end or our Excel interface, and there we go. We've dynamically iterated from 1 to 5. We've always referenced the specific dynamic row that we were iterating over. We're staying constant in column 1, and then we're dynamically writing the value that we're iterating over in there. Here's another way that we can look at it. This is a little bit of a different approach. We can delete our work, and instead of always referencing column 1, we can always reference column I. So now both the row value and the column value will be dynamic. They'll be changing from 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5. So we're going to have a little bit of a diagonal pattern as we navigate here, and as VBA is going to write these values to our spreadsheet. So let's go ahead and execute this code. And there we can see we've written it out. We start with 1, 1, then I is incremented to 2. We're referencing cells 2, 2, cells 3, 3, and so on. We are, of course, not limited to simply iterating from 1 to 5. We can iterate from any number to any number. So for example, if I delete all of my code here on the Excel interface, delete all my output in the immediate window, I can output a value, let's say, from 3 to 11. So what's going to happen here is instead of starting at a value of 1, I is simply going to start at 3. It's going to go to 4, to 5, to 6, all the way to 11, and then conclude when the I is incremented to a value that is no longer in that range, which is going to be 12. So now if I execute this, you can see right here we're going to get a value from 3 all the way to 12. You can see this 12 is actually coming from the debug print. And right here on my Excel interface, if I scroll a little bit, we can see that we're creating the exact same dynamic effect all the way to 11, where both the row and the column number is being dynamically represented by I. Let's conclude this lesson with one more example of a for loop. I want to show you how a for loop can help you do something like mathematics. I'm going to create a new procedure below. I'm going to call it sum to 25. What I want to do here is I want to get a sum of all the numbers from 1 to 25 inclusive. Well, what can I do to accomplish that? I can iterate from 1 to 25 and simply add all of those numbers to a rolling sum. So right here, I can begin by declaring a total variable. This is going to represent my sum. I can make this a long because it's going to store an integer value or a whole number value. Right below, I'm going to define a I iterator variable, also going to be a long or a whole number. The first thing I want to do is make sure that our sum starts at a valid value. So I'm just going to give it a value of 0. Just for simplicity's sake, there may be a default value assigned to a long data type of 0, but let's just be safe and sound here and actually start it off at 0 explicitly. Then once again, we're going to write our for loop. We're going to begin with the I keyword, an equal sign, give it its initial assignment. Let's start I at 1. Then the to keyword, we want to go from I to what? Let's say 25. Right below here, I want to create a couple line breaks and write next I. And as we saw up here, the block or the body of the for loop is not limited to one line. It can be 2 lines, 3 lines, 4 lines, 5 lines. It can even invoke a different procedure. It can do whatever it wants. It's just going to execute that body that number of times. So right below here, what I want to do is I want to get total, which is our total, and I want to add I. And if that happens right now, we only have an assignment. So we're going to reassign total from 1 to 2 to 3 to 4. That's not what we want. We want to take the current value of total and then add I to it. So the very first loop, total is going to be equal to 0. We're going to add the value of 1, which is going to be a total of 1. The next time around, the total is going to be equal to 1. We're going to add the next value of I, which is equal to 2, for a total of 3. So 3 is going to be overwritten to the total variable. Then we're going to You repeat that process all the way until we get to 25. Finally, when we get to the end, we can, let's do message box this time. We can message box the value of total, take a look at what the value is of all the numbers from 1 to 25 summed together. Let's execute this with F5, and there we can see the total is 325. So that's a quick introduction to for loops. Again, they loop from a specific number to another designated number. They have a range. As long as that range is satisfied by the current value of the iterator variable, which we've represented by I here, as long as that is satisfied, the body or the block of code within the for loop is going to execute. So we can use this to dynamically reference specific cells on the worksheet, specific columns. We can use it to do basic math like this, and so on. We're going to have a lot of practice with the for loop, so don't worry if this is a lot to take in. We're going to repeat this code over and over and over again until we commit it to memory. But that's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at the step keyword, which is used to specify the interval of each iteration. So we don't necessarily have to iterate in intervals of 1. We can actually increment the iterator variable by more than 1, or even proceed in a negative direction. Let me show you a couple examples here. What I'm going to do is define a procedure. I'm going to call it step by step. And let's just review the code from the previous lesson because it's a lot to take in. We always begin with an iterator variable. I'm going to keep mine named I. It's going to be a long, it's going to be a whole number. And in the last lesson, we did something like this. We iterated from, let's say, an I of 1 to an I of 20. We put a next I to make sure that we increment at the end of every conclusion of the body of the for loop. And within here, we specify what we want to do that number of times. In this case, 20 times. We can debug print the value of I, and we should get 1 through 20 in the immediate window. There it is. Perfect. So you can see here we're incrementing or iterating with by a value of 1. So I is climbing up by 1 each time it goes through the loop. Well, as it turns out, we don't actually have to go by a value of 1. We can go by any value. Right here, after the number, we can put the step keyword, and we can put a number that specifies how much the iterator variable is going to be incremented by. So if I do something like step 1, that is the default. That means I is going to move in steps of 1, from 1 to 2, from 2 to 3, from 3 to 4, and so on. So if I were to execute this procedure again, we would see the exact same result as we just saw. But if we use the step keyword, we can customize the argument that we give afterwards to clarify how it's going to proceed, the intervals that it's going to jump by. So if instead of incrementing by 1, we wanted to increment by 2, we can put a 2 here. What this is going to do is jump from 1 to 3, then to 5, then to 7, then to 9, and keep going all the way up. So it's actually going to get all the way to 21 again because the last value it's going to output is 19. It's then going to increment to 21. 21 is no longer going to be in our range, and then the for loop is going to conclude. So when I execute this with the F5 key, there we can see we're beginning with 1 at the very top here, then we're proceeding in increments of 2 all the way to 19. I'm just going to remove this code right here and show you a different example. If I instead increment by 3, we're going to start at 1, then go to 4, then 7, then 10, and so on. Let's execute this again, F5. There we can see we're beginning with 1. We're ending all the way at 19. That's the last one we get to before we jump outside of our range. But the value of I at the end, that means is going to be 22 because it's going to be incremented one more time to 22. That's going to fail the for loop check, and that's going to be when the for loop concludes. Let's take a look now at how we can apply this concept to our actual Excel spreadsheet. This is a pretty cool operation. What I want to do is I want to take the first 100 rows in my spreadsheet, and I want to color every second row yellow, the entire row. Let's pretend we're designing a report, for example, and we want to alternate the color of every alternating row. So every second row, we're going to have a color of yellow. How can we accomplish something like that? Well, let's begin by defining a procedure. I'm going to call it color every second row. Same syntax as always. So what I'm going to do is begin with my iterator variable, I. Once again, we can declare the exact same variable name as we have in the step-by-step procedure because all of these variables are local. They're tossed out as soon as the procedure is done running. Right below, I'm actually going to define a variable to represent my range because as I iterate over each row, I want a variable that's going to represent that entire row, and that's going to represent a collection of cells, which is a range object. And I'm just going to call that range R to keep it short and sweet. Right below here, let's actually define our logic. So we'll begin with a for loop, our I variable. Let's kick it off at number 2 because I want it to be the even numbered rows. So 2, 4, 6, 8. And let's go all the way to 100. Now, if I were to just keep this code, this is equivalent to a step of 1, so it would go from I of 2 to 3 to 4, and then would color every row, which is not what we want to do. We want to color every alternating row, so we need to make sure we skip a row in between, and we can do that by iterating in sequences of 2. So I is going to go from 2 to 4 to 6 and so on, and we're going to skip all those odd numbered rows in between. We have to remember here to put a next I at the very end. That's going to make sure that we're incrementing I properly. So what can we do in here? Well, here's what I can do. We know that we can use the cells keyword to reference a specific cell. And of course, it expects the row as the first argument. And the row here is going to be dynamically populated by the I variable. And what we can do here is just select column 1 for now. This is just selecting a single cell. We want to select the entire row. And you may recall that there is a property available on this resulting range object called entire row. So what this is going to do is it's going to begin with cell 2-1, which is going to be row 2, column 1, which is cell A2. So it's going to select this, then select the entire row like so. And what I want to do right here, even though we can continue chaining operations just to keep things simple here, I want to assign this entire row that we have right now to our R variable, which is a valid range object. Remember, when we're doing this, we need to use set, because set is required whenever we're assigning an object value, and only an object value. If it's a regular data type, we can use just plain assignment. But right now, we want to set the R range object to this entire row that we have highlighted here in gray. And right below here, it's simply a matter of referring to some of the properties and objects that we are already pretty familiar with. So we know on every range we have an interior object. That interior object has a color property, and we can assign a value to that color property. And let's just assign a default available VBA color, which is VB yellow. And that's it. That's all there is to it. We're iterating from rows 2 to 100. We're technically iterating actually from I of 2 to 100. We're then using that dynamic value to reference specific rows, but you get what I'm saying. So we're going to reference row 2, row 4, row 6. We're going to set each one of those rows equal to the variable R, and then we're going to set the interior of that row to VB yellow. Then when we increment I to 4, this entire block is going to continue over and over and over again. We're going to select a different row each time and perform the exact same process. So let's take a look. I'm going to put my mouse cursor in there, press F5, and there we can see every alternating row has now been colored with the VB yellow color. That's all there is to cover in this lesson. The step keyword, it's used to specify the interval at which each iteration is going to increment. As it turns out, we can even give it a negative value. We'll take a look at that in a couple lessons. But we can use it to customize how we increment. We don't have to proceed in sequences of 1. We can proceed in any interval that we want, 2, 3, 4, 5. And as we can see here, we can combine these concepts with actual access to the cells and ranges of our worksheet to customize things like styling, to perform alternate operations on alternate rows, etc. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll talk about iterating backwards, or in other words, starting our iterator variable at a higher number and decreasing it until it gets to a lower number. When might we want to use this in the context of our Excel spreadsheet? The perfect use case for this is whenever we need to delete rows. So what I'm going to do here is I'm just going to define a column of random values. Let's just populate it with random numbers for now. So I'll put a 1 in here, a 2 in here. I'm going to click this and drag this all the way down to, let's say, row 15. And then what I'm going to do is I'm just going to replace some of these numeric values with the keyword delete. It doesn't really matter what we put in here, but what I want to do is some kind of marker that's going to indicate that a row should be deleted. Of course, whenever you're writing business logic for your own spreadsheets, it might be that the row or cell is empty. It might have some kind of value. It might be an invalid calculation. For this case, just for simplicity's sake, we can pretend that the delete keyword means that the entire row should be deleted. So what I want to do here is I want to make sure that we have 2 deletes in a row. I'll explain why in a second. Let's put a couple more deletes just scattered throughout here. All right. So we want to write a macro that's going to iterate across these rows and delete whichever rows have the value delete in column A. So you might think that we can just write a regular for loop that's going to go from row number 1, or a value of I equal to 1, all the way to row 15, which we can dynamically calculate, and delete that way. And that'll work sometimes, but it's not going to work all the time. It's actually going to run into an error. And let me show you what's going to happen. Let's say we get onto row number 2. We're using a variable of I equals 2. Let's say we reference cells. That's going to be able to give us the row 2, column 1. So we'll do something like cells I, comma 1. That's going to reference this one. We're going to be able to select that row and delete it no problem. So imagine we're going through our macro or our procedure and our I is equal to 2. What's going to happen is this first deletion is going to work, but whenever we delete, everything is going to climb up one row. And at this point, delete is still present again in cell A2 because it's the delete from the line below. But our I variable at this point has completed the entire process of the for loop, the body of the for loop to be more specific. So I at this point is going to increment to 3 and then move on to the cell below. So what's going to happen is whenever we have more than one delete criteria in a row, it's actually going to skip the second one because it's going to essentially accidentally pass over it because the deletion of a row is going to move everything up while our I variable is not going to be aware of it and simply increment to move on to the next row. Let me just go through that example one more time because it's a little bit of a complex procedure. The very first time, let me just write it over here. Let's pretend our I variable right now is equal to 2. I'm going to put it in bold right here. So when we get to row 2, we're going to be able to select this row and delete it. Now, when we delete a row, nothing happens with our I variable. I is still equal to 2, right? Because it's a value that's stored exclusively in our procedure. It has no knowledge of the actual Excel interface. So I is still equal to 2, and then I is going to be incremented to 3. It's going to move on to this row because this is cell 3-1, and this delete that was there, that was moved up, is no longer going to be caught, and we're accidentally going to miss a row. It's for that reason that we have to make sure that whenever we're deleting values, we're going to actually move from the bottom all the way to the top. This is a constant. So whenever you need to delete rows from a worksheet, you always start from the last row and you proceed to the top one. That way, for example, when we get to this row, even if we have, well, even a better example is right here, even if we get to this row and we delete it, when we move up, we know that we're going to capture each delete in sequence. We're not going to have the problem of cells accidentally moving up and being accidentally not caught by our iteration. So let's write the actual procedure that's going to iterate from the bottom up and delete all of the deletes, all the rows that have delete in the spreadsheet. So I'll begin by running a procedure. I'll call it delete rows. Put an end sub right there. Perfect. The first thing I want to do is to actually find out the last row. We can declare a variable for that. Let's call it final row. It's going to be a long, it's going to be a whole number. You may remember this syntax from a few sections ago, but it's going to be final row equals. We're going to use the cells property to return a range of a specific cell, and we want to reference the cell at the most bottom left of our spreadsheet. We can get the very last row in our spreadsheet with rows.count. That's going to return us a number that's something like 1,048,000 something. Then we'll reference column A or column number 1 with number 1. So this is going to return us the bottom left cell of our spreadsheet. At that point, we want to use the end property. We want to give it an argument of X cell up. This is going to simulate clicking the end key and pressing the up button, which is going to take us to the very last row with data in our spreadsheet. To be more specific, the cell that has that data in column 1. And then once we have that cell, which in this case is going to be cell A15, we actually want to get the numeric value of the row, which we can extract with the row property. So this is going to make final row equal to 15, but it's only going to be 15 in this case. What's really great about this code is if tomorrow we have twice as many lines, it's going to dynamically set final row to whatever is the last row with data. Our next step is to actually write the iteration, which is going to go from row 15 or the final row all the way to the first row. So right here, we can begin by declaring our iterator variable. I'm going to stick with I again. Let's make it a long. Our setup is going to be a little bit different this time. This time, we're going to dynamically assign I its first value, which we know should be the final row, which is 15. So we can actually just write final row here. Remember that a variable is just a placeholder for a value, and final row in this case is going to be equal to 15. So we can start out I at a value of 15, and then we want to go all the way to row number 1. That's going to be the last row that we want to work with. There's just going to be one problem here. This is not going to work by default because, of course, we're starting I at 15 and we want it to go to 1, and we can't do that because the default behavior for a for loop is to iterate the iterator variable by 1, which would take 15 to 16 and then run into all kinds of problems because we actually want it to move in reverse. So the way we solve for this problem is we use the step keyword, but this time, instead of giving it a positive value, we want to give it a negative value. And the negative value represents how much we want to decrement or decrement I as we're proceeding through each section of the for loop. So let me conclude this with the next I. So what's going to happen here is I is going to start at 15. The entire body or block of the for loop is going to execute whatever we put in here. And then once that step is done, we're going to decrement I by this value. So I is going to go from 15 to 14 to 13 to 12 to 11, all the way down to 1. And of course, if we wanted to decrement in a different interval, for example, decrease it by 5 each time so that we can go from 15 to 10 to 5, etc., we would just put -5 here. So what do we want to do here? What we want to do here is first check the value and see if it's actually equal to delete. So we can do cells. We know that I represents our row. We know that the column that we are always checking in is column 1. And what we actually want to do is wrap this in an if statement, because our deletion is going to be based on a conditional statement. Only if the value is delete in this cell do we want to delete. So if the current value in column 1, column A, is equal to delete, make sure it's case sensitive. We'll put an end keyword here. Remember that we have to close this off with an end if. So we're specifying within each iteration, we're going to check the current value in the cell. So it's going to proceed like this on the left-hand side. If it's equal to delete, well, then we want to select that cell. Same thing as the code above. We want to select the entire row. We have that property available on a range object. And on that, we also have a delete method that's going to delete the entire row. So what's going to happen here is we're going to begin at 15. 15 is not equal to delete, so we're going to decrement by 1, move to a value of I of 14. That's going to reference cells 14.1. This cell, it is equal to delete, so this is going to execute cells 14.1, select the entire row, and then essentially perform the process of deleting. And what's going to happen again when we get to cell number 3, or row number 3 rather, this is going to delete. It's not going to be a problem because 4 is going to move back up. We're not going to have any kind of issues. And then when we proceed to row 2, that process is going to repeat. And even if you have more than 2 deletes in a row, if we have as many as we want, we're not going to run into any problems. So let's go ahead and execute this code and see if it works. Everything looks good to me right here. So F5 to execute this. And we can see all of the deletes have been successfully removed. And you can even see that the 2 deletes in a row, which were rows 2 and 3, have had their values removed. So let's just give you an example here. We have a whole bunch of deletes in a row. What's really great about this macro, of course, is that it's dynamically able to figure out the final row. That's what we have right here. So we can continue running it even if we have a smaller data set than we started with. So right now we're going to start at the final row of 9. It is delete, it is delete, it is delete, it is delete. It's going to continue deleting that all the way. So it should only see these 4 numbers at the end. We're going to execute this. There we go. Let me just show you again. Let's just put delete here, delete here. Doesn't really matter how many of them we have in sequence or separate from each other. No problem deleting them. That's all there is to cover here. In this lesson, we talked about using a negative argument to step, to the step keyword. That allows us to actually decrement I as we proceed to the for loop. So if we ever want to do something in reverse order, we want to take I from a bigger number to a smaller number in a certain interval, we can use the step keyword with a negative argument. We are not limited to -1. We can provide -3, -5. We can do whatever interval we want to use. And the primary use case for this is whenever we want to delete rows. The reason we want to do that is because if we proceed downwards when deleting rows, we might miss specific rows as they move up. Because our I variable is still going to stay the same and it's not going to be able to realize that rows have moved up. This problem will be avoided if you loop from the bottom all the way to the top. So remember, whenever you are deleting rows, always move from the very bottom to the top. We also did a quick review of how we're able to get dynamically the last row of data. We just assigned that to final row by using the cells property to reference the most bottom left cell of a spreadsheet. We then use the end property to simulate a end key press and going all the way up, which will take us to the very last row of data dynamically. We're getting that row, and that way this macro stays pretty flexible. You just saw a couple examples where no matter how many extra rows of data we had, it was able to perform the process as intended. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at another available loop in VBA, the for each next loop. And this is a pretty powerful and pretty common loop. So as we know by now, there are a lot of collection objects in VBA. We have workbooks, worksheets, etc. Collection objects are objects that collect other objects within them. What the for each next construct allows us to do is to iterate over each object within a collection. And the best part about it is that the developer does not need to know how many items are actually in the collection. Now, we could use a plain for loop. For example, we could start an iterator variable at something like 1 and go to the maximum number of worksheets and use that dynamically changing iterator variable to access a number or a specific index position within a collection object. But we don't have to. That's such a common operation in VBA that the language offers us a predefined loop that does that for us. Let's take a look here in the code editor. I'll begin by defining a procedure here called for each loops. Give it the parentheses, there we go. And I'll start here by defining a variable called WB. And WB is actually going to represent a workbook object. So this is going to be a object type of data type. And here's what the for each loop looks like. We begin with the for keyword just like last time, but this time, instead of using an iterator variable, we use another keyword in each. And then we're essentially going to use the variable that we defined above. So I'm going to use WB in this case, and you'll understand why in just a second. Followed by the in keyword, and then after the in keyword, we list some kind of collection object. So it has to be one of those plural objects that represents a storage of multiple objects. So for example, we have a workbooks collection object, which stores all open workbooks. So what this is going to do for me is actually iterate over every single workbook within that workbooks collection object. WB here is going to represent what we defined above, a workbook, because that's the type of object that's stored in this collection. So right below here, I'm just going to create a line break, and this time I'm just going to write next WB. So the syntax here is very similar to the iterator variable. You can think of myself as incrementing here, but instead of navigating over just a bunch of numbers from 1 to 2 to 3, we're actually going to be traversing objects. So every single workbook object, for each one of those, we're going to do something. That's what we're going to specify here in the body of this block. But we're going to take a collection object and go over each one of the things within that collection objects. The name that we choose for it is totally up to us. Right here, I did WB, but this can be X, it can be Y, it can be some workbook. Whatever name you want to give it, I just like to keep it short and sweet. I declared a variable here called WB to represent that. WB is going to be a bunch of workbooks, singular workbook objects, one by one. And what we can do here is work with each one of those workbook objects. And even if we have 5 workbooks open, 10, or 1, like in this case, this for each loop will dynamically react to that length and go over and repeat this process of the loop for every single object. So for example, let's begin by simply printing out the name of each workbook that I have open. WB represents my workbook object. Every workbook object has a name property. So when I execute this with F5, you can see the only workbook I currently have open is the for each next construct, as we can see right here. But if there was more than one workbook open, this line of code would execute for every single one of those objects. Let's take a look at another example that will show us how this can dynamically react to however many objects we have in a collection. I'm going to loop over now every single worksheet that we have in our workbook. Right here on the bottom left, you can see I have 3 worksheets, A, B, and C. So we first have to think about what kind of object we're going to be iterating over, and the answer here is worksheet. So I'm going to define another variable here called WS, again, short and sweet, WS for worksheet. I'm going to declare the actual data type, which is going to be a worksheet object. Right below here, we begin again with for each, and here we're going to use the variable that we defined above. Sometimes if this is confusing, you can start with the for each statement first, and that'll give you a sense of what it is that you're actually iterating over, and then you can declare the variable type for that above. So for each worksheet in what? In a collection object. So the thing that comes after the in keyword always has to be a collection object. Worksheets is a collection of worksheet objects, which is what we're iterating over. For each one of those, no matter how many we have, 3, 5, 10, 1, VBA is going to be able to dynamically iterate over all of those. So right here, I'm just going to put next WS, again, moving on to the next work sheet in this case. And again, just to reiterate this concept, WS here, or worksheet, is an object. Unlike the iterator variable we saw in the last couple lessons, which is a number, this is a valid VBA object. So we can access its properties, we can override its properties, we can call methods on it, etc. So for example, what I can do here is, let's begin with the debug print operation to check out the worksheet's name. And then what I want to do here is actually do something on each worksheet so we can actually make sure that this stuff worked. So what I can do is reference each one of these worksheets. It's going to be A, then B, then C. And on each worksheet, I can take a range of A1, and let's write in the worksheet's actual name, again, WS name, into cell A1. So what this should do is it'll begin on worksheet A, it'll write in the name of the worksheet A into cell A1. It's then going to move to the next worksheet in line, which is B, and then on cell A1 of worksheet B, it's going to write the name of the worksheet again, which is B, and then repeat that exact same process when it gets to worksheet C. So let's go ahead and delete this stuff right here and execute our macro with F5. All right, here we have all of our outputs. Here are the A, B, and C coming in from this debug print operation right here. And we can see here on worksheet A in cell A1, we have the name of the worksheet, worksheet A. On worksheet B, if I scroll up, there's B in cell A1. And on worksheet C, if I scroll up, here is the value of the worksheet name in cell A1. So we have dynamically iterated over each one of these worksheets. In fact, I can prove this to you by actually creating a whole bunch of extra worksheets here. I'm not even going to change their names because the code will be able to dynamically work. So I'm going to remove my output from the immediate window, execute this. And now we can see on each one of these worksheets, starting with sheet 5, the name of the worksheet has been written into the cell A1. Same with sheet 4, same with sheet 3. The whole point of this, the whole cool part about this is we don't even have to know how many worksheets we have, or for that matter, how many objects we have in our collection. We just need to be able to use the for each loop, and VBA will take care of that thinking for us. It's just going to iterate over every single object in that collection, and we can perform the exact same kind of operation on each object. In fact, we can even nest some kind of if statement and use that if statement as the determinant to figure out whether we do want to perform a procedure on some kind of object. So for example, we can iterate over all of our worksheet names and only perform this process if the worksheet name starts with the letter S, let's say. And that way we can again dynamically react to any number of objects, but perform some kind of if or comparison within to only execute some steps on some objects within that collection. So it's a very, very powerful thing. We have to think a lot less compared to the iterator variable, but it's a pretty powerful feature of VBA. That's all there's to cover here. We're going to chip away at this concept in the next lesson, where we'll see how we can utilize this with the concept of a range and its collection of cells. In this lesson, I want to explore the concept of using a for each loop over a range of cells. So in this brand new workbook, I have 12 values in column A. It's just the months of the year. And let's say what I want to do is to write the uppercase version of the month, so January in all capital letters, for example, in column B. And I want to do that for every single value in column A. So I could do a standard for loop that we introduced a few lessons ago. I could define an iterator variable of I, set it equal to 1, go all the way to 12. That would work, and that's a totally suitable solution, but there's an even more elegant solution that we can do with the for each. Let me show you how it works right now. In my VBE, I'm going to define a new procedure called capitalize months. And I know that I want to reference the range of cell A1 to A12, so I can actually just write it out here so it's easily available. And what do I really want to do over this range? What I want to do in this range is iterate over every single cell within it. Well, if you think about it, every single cell within a range is actually another range object itself. A1 is a range, A2 is a range, A3 is a range, and so on. So whenever I use for each with a range, VBA is smart enough to figure out that I actually want to go over every single cell within it. It's especially very simple when it's something like a column because it's just going to proceed from the top all the way to the bottom. But even if I have a multi-cell range, for example, let me go ahead and highlight this range right here on the worksheet. Even if I have a range like this, we can iterate over this cell by cell, and the Visual Basic logic will simply iterate cell by cell in a row direction. So C3, then D3, then E3, then F3, then it'll move on to the next row of C4, D4, E4, and so on. And we can use this idea to essentially iterate over every single cell and not even worry about how many cells we have to iterate over. So right here, I know that I'm going to need a for each. And I know that I'm going to be iterating over every single cell. That's a good name to pick. Again, this is just a variable name that is up to the developer, but what I'm iterating over fundamentally is a cell within the range. So I can do something like this, and then I want to make sure I do two things. The first thing is write the value next cell at the end to make sure I move on to the next one. And finally, of course, now that I know that I'm representing a range, I want to make sure I declare that cell variable before I use it. That's just best practice. So now I know the cell variable that I'm using in the for each loop is a range object. So again, this is a little bit of an interesting phenomenon because we're iterating over a range, but every single thing within that range that we're iterating over is also another range object. We have a collection here in a way that is a collection of objects that are also the same object. It's kind of interesting. So what do we want to do here? Well, what we want to do is each cell here represents a valid range object. We can use the offset property. Remember, offset is used to select something relative to where we are right now. And what we want to do is, let's say we start in cell A1, we want to move one cell to the right. So that's going to be 0 rows down, one cell to the right. That's what we can use the offset property for. Let's assign it a value. And what do we actually want to assign the value? We want to take the current value in the cell, for example, A1's value is January, and we want to uppercase it. You may recall that we have this uCase built-in function, which allows us to uppercase the value. We know that cell represents our entire cell of A1, and we can just extract the current value from it. So this is going to be January the very first time around, then February, then March, and so on. We're going to take that value, we're going to uppercase it. The right side is going to evaluate before anything else happens. Once we have the uppercase version, we're going to take our current cell, we're going to move one column to the right, 0 rows down, and we're going to write that uppercase value in the cell to the right. So this should be good to go. I'm going to press F5 to execute. Let me just actually click out of this thing. Let's go ahead and do F5, and it's worked exactly as expected, completely, perfectly worked as expected. Let me show you another way that we can go ahead and complete this exact same process. I'm just going to remove all of my code here in column B. We can actually make this a little bit more dynamic by replacing range here with the keyword selection. Remember that selection is a dynamic property that refers to whatever is currently selected or highlighted on my spreadsheet. So for example, this is a selection, this thing that we see in gray, and then I've selected this thing right here. And if I've clicked into a single cell, then that's my selection. What I can actually do is highlight a selection like this one. And what VBA is going to do is iterate over every single cell or range in that dynamically selected selection. So if I highlight everything from cell A1 to A12, click into here and execute this procedure, the exact same result is going to happen. I'm going to have the capitalized versions of the months populate in column B to the right. I want to conclude this lesson by showing you how this iteration will work if we have something more complex than simply a single column, as I mentioned earlier. So I'm just going to define another procedure here. I'm just going to call it sample iteration. Doesn't really matter. And I'm going to basically copy the code that I have up here because I want to do the exact same thing. And for each cell in the selection, let's make sure we put a next cell at the end. What I simply want to do is output with debug print. Each cell or each range has a property available on it called address, which is just going to return the actual A1 notation for that cell's address in the worksheet. And I can use this to demonstrate how it's going to iterate over each one of the cells in my selection. So for example, if I have this selection of 2x4 or 4x2, and now I'm going to click into here, press F5, we're going to see the order in which it's iterating is D4, E4, F4, G4. So it's going to move horizontally among the cells in a row. And once it's done with that horizontal traversal, it moves on to the next row and begins that process anew. Predictably, if we have only a single column, let me execute this and remove all the code down here. In that case, it's simply going to iterate downwards along that column. So here is D6, D7, D8, and so on, moving down. And predictably, if we have a single row like so, what it's going to do is just iterate from left to right across that row. So in this case, we're going to have a D2, E2, F2, and G2. This is actually left over from the end. So here's the code from the procedure that we just executed. It's going to move left to right and then from top to bottom if we have a range that is more than kind of a single column or a single row. That's all there is to cover here. We talked about how we can use the for each loop to iterate over a range of cells. Remember that every single object within a range is technically another range, which allows us to have full access to a range's properties and methods and perform really cool operations like this. In this lesson, we'll talk about the with end with construct. So as we've seen so far, many times VBA requires multiple operations on the same object. A really good example is the font object on a range object. When we explored font previously, we saw that it has a wide variety of properties. There's name, there's size, there's color, there's bold, there's italic, there's underline, all of these different read-write properties. And we've written out all of these property references one by one, and that ends up taking a lot of code. The with end with construct allows us to simplify those operations. Whenever we have to do multiple things with a singular object, the with end with design allows us to have a shorthand for writing that. Let's take a look. I'll first populate a whole bunch of values here on my Excel worksheet. It doesn't really matter what they are. I'm just going to put some random characters in a whole bunch of cells here on my Excel spreadsheet. All right. So let's write a macro here that's going to target a selection. A selection, as we know, is just whatever the user has selected in the Excel interface. So if we, for example, highlight this clump of cells and then use selection in our VBA code, selection will refer to the actively highlighted cells. So this is the selection. All right, so what we want to do here, let me just click out of it, is write a procedure. Let's say I want to do a couple things with the font of the selection. So I'm going to write a procedure called modify font. Right in here, let's say we're going to do it the old way. So we know that we have a selection object that is a regular range object. On that range object, we have a font property, which represents a font object, so selection font. On that font object, we have a name property. We can set that property equal to some kind of font. Let's say I want to change the font to Comic Sans MS. On that selection object, one more time, again, we have a font property, which represents a font object. On that font object, we have a size property. We can set that equal to 12. And this whole process can repeat over and over and over again. Let me just do a couple more examples down below. For example, we also have a color property, which we can set equal to, let's say, RGB 02550, since it's going to be a green color. We also have a bold property that accepts a Boolean value, either true or false. We also have an italic property. We can set that to true or false. So all of this is completely valid code. I can demonstrate that by just highlighting this. This is now becomes our selection. So when I execute this with F5, we can see everything is going to be converted according to the instructions of the procedure. But as we can also observe, this code is pretty dense and it's pretty repetitive. There's a lot of duplication. We're always referencing the selection.font. There has to be a way that we can make this a little bit more elegant, and that's what with and with allows us to do. The first thing we do here is to put the with keyword. So we start off with, and after we put with, we actually put the object that we want to reference. In this case, the object that I want to target is not going to be selection. It's going to be selection.font because we want to target the font object on our selection, which is our range object. So the with keyword expects after it a valid Excel VBA object. It doesn't matter which one it is. In this case, we're simply targeting the font object. I can do a couple of line breaks here, and then I have to remember to put this end with keyword at the very end. It's one of those things, just like a procedure begins with sub and ends with end sub. We need the whole same thing here with starting off with and ending with end with. Another example is if statements. If statements start off with if, and then they conclude with end if. In this case, same idea, same logic. We want to put an end with. Now here's what's really cool. You can imagine within this body, within this block of code, that this thing is automatically being referenced in every single line that we write. This is a little bit of a weird syntax, but you can imagine that this is being written in front of anything that we write in here in the body. So if I want to reference the name property on my font object, all I have to do here is write .name and then assign it. So if I wanted to do the same thing that I did up here, Comic Sans MS, I can just copy it, put it here. This is the exact same syntax. Now, we don't really see the benefit right now because we're only assigning one property, but when we get to multiple properties, you can see how much it's going to cut down our code. So again, let's show another example. Remember that whatever we have here as the object that we're selecting, you can pretend that this is being written in front of every single line of code that we write here. So .name is equivalent to selection.font.name. If we want to reference, as another example, the size property on a font object, all we have to write here is .size and set it equal to 12. Similarly, if I want to reference the color property on the font object, color equals RGB 0255, 0. I'm just replicating the code from above. Similarly, if I want to set the bold and italic properties, I just write .bold. No need to write the object reference in front of it. Equals true. .italic equals true. And there we go. This section of code right here that I've written is identical to this one that we wrote above, but you can see it's a lot more elegant. It's a lot tighter. It's a little bit cleaner. It doesn't take up as much space horizontally. It looks more elegant. It even looks a little bit more stylish, I'd go as far as to say. And we're not repeating selection.font over and over and over and over with again. Rather, what we're doing is explaining to VBA that we want to do something with that object. That's what we're explaining here. The with keyword means take this object and perform the next sequence of operations with that object. And again, we're not limited to simply the font object. This could be a range object. This can be a worksheet object, a workbook object, a collection object. Whatever object you want to put in here is totally fine. And then in the block of code that you write after, between the with and the end with, you don't need to prefix it with the object. You can simply put the dot and then write whatever method or property you want to reference. Let's just confirm that this code is valid. I'm going to uncomment, or rather comment all of this lines of code, so it's invalid. Let's go ahead and just write a whole bunch of random text right here, just to make sure we can affect it. Let's repeat the exact same process. I'm just going to highlight all of this stuff. Now it becomes my selection. I'm going to execute F5. We should get the exact same results. There we go. Macro executes the exact same way, proving that these two sections of code are exactly the same. That's all there is to cover in this lesson. The with end with construct is a really powerful tool. Whenever you find yourself duplicating a lot of code, whenever you see that you are referencing the same object over and over again, perhaps to set multiple property values, perhaps to invoke multiple methods in a row, whenever you start seeing that in your code, consider implementing the with end with design. Really simple. Just write the with keyword, follow it up with the object that you want to perform those operations on. Make sure you put that end with at the end, and then everything within that block, within that body of code, you can pretend as if it's being prefixed with whatever object it is that you're referencing. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the exit for and exit sub keywords. The exit for syntax is used to exit a for loop prematurely before it's done with its natural iteration. And the exit sub keywords are used to exit a procedure prematurely before it reaches the last line of code within it. Let's take a look at both of these things, starting with exit for. In my workbook, I have a list of the 12 months, starting with January and going all the way down to December. And here's what I want to do. I want to iterate over all of these cells, and I want to change the font to Comic Sans MS. However, if I run into a value of August, I want to stop the iteration. So I want to stop what I'm doing at that point in the looping process. A real-life use case of something like this is if you have two reports in a single spreadsheet. Imagine that you have a report that sits above another report, and you want to iterate over every line in the very first report and perform some kind of operation on every single line. You're going to have to write some kind of logic to figure out where the top report ends so you don't execute the iteration on the bottom report. That's a perfect example of a use case for something like this. Sometimes you may want to iterate through every row in a spreadsheet, but you may want to say stop at this point if some condition is met. Tell it, don't go on any further. We've covered everything we need to cover. So let's pretend what we want to hit here is August. That's our endpoint. Everything up until August, and let's say including August as well, we want to change the font of that. Anything past that we want to leave alone. How can we implement something like that? I'll begin here with a procedure called finding August. That sounds like some kind of romantic comedy. So finding August. What we want to do first is to get the last row. This is just the best practice. We can, of course, iterate from 1 to 12, but let's follow the best practices here and dynamically calculate the last row. We can declare a variable called last row. We'll make it a long data type, which is a whole number. And we can use the familiar syntax to get the actual value of the last row. We can use the cells property. We can get all of the rows in the spreadsheet. This is going to be a value like 1,048,000 something. We'll target that row in column 1. So this is the bottom left cell in our worksheet. Once we have that cell, we want to move upwards. So we can use the end keyword, X cell up, to simulate the press of an end button followed by the up arrow key, which will bring us to the last row of data. In column A, that's going to be row number 12, but just the cell right now. So in order to actually get the numeric value of the row, we have to attach the row property. So now last row is going to have the value of the last row, which is going to be 12. Our next step is to actually perform the iteration. So I'll declare an iterator variable of I, also a long, it's a whole number. And this time I'm going to iterate from I equal to 1. Again, I right now is just going to represent our row. We haven't referenced the row yet, but I is going to go from 1 to 2 to 3, all the way to 12. And we want to iterate from 1 to the value of last row, which is going to be 12. We could put a step 1 in here, but that is the default behavior, incrementing by a value of 1, so we don't have to. The last thing I want to do here before I actually write the body, of course, is to write my next I. That just ensures that I is going to be incremented after the block of code within the for loop is executed. The first thing I wanted to do is to change the font of the cell to Comic Sans MS. I can do that right here within the for loop. We're not checking yet if it's August, but we want to perform that process up until the point that we get to August. So this is the standard default behavior of what we want to do within the for loop. So I can use the cells property, target the current cell that I'm iterating over, the value of the row is going to be changing from 1 to 2, so to 3 to 4. That's represented by I, so we can put I here as the row index argument. The column is going to stay consistent. It's always column 1 or column A. And once I have that range object of a single cell, that range object has a font property, another object called font. A font object has a name property, and we can assign that to a string of the font we want to use. I want to change the font to Comic Sans MS, and that should do it. Now we have to actually check if the value is equal to August. How can we do that? Well, we can get the value of the cell. So once again, the same syntax as the line above. We're going to get that range that represents that single cell. We're going to begin with A1, then A2, then A3, and so on. We want to get the value, and then we want to compare that value with August. So we're going to use the equality operator, the equal sign. Whenever we write an if statement, we need to add a then at the end and an end if. And right here is where we're going to write the code for what to do if that if statement is met. So if that if evaluates to true, if the cell's value is August, we want to exit the for loop. We want to call it a day. We want to say, stop this iteration, no more incrementation, no more repeating of this block of code, just move on. The way we do that is with the keywords exit space for. Exactly as the name suggests, we are exiting the for loop. It doesn't matter where it is in the process. It could be in the first iteration. It could be in the last iteration. In this case, it's right around the middle, but we are exiting completely. No other iterations will run. Now, if there is code below the for loop, that code would still execute, but the for loop in our procedure is the last thing that we're doing in this finding August procedure. So as soon as this for loop is done, the procedure is done as well. There's one more thing I want to do here. What I want to do is just make sure that we are actively targeting August, that everything has functioned as expected. So what I want to do here is when we get to this point, I want to make sure we highlight the cell so that we can verify that that's the point where it stopped. What I can do here is just do cells I of 1 and just highlight it for now. So we're going to just select it with the mouse cursor so we can see that it ended on the cell that we expected it to end on, which is August. So let's go ahead and execute this. I'm going to drag my cursor away from here. So if everything goes as planned, all of this text should be Comic Sans up to and including August. Once we get to August, this is going to value to true. We're going to select the cell, then we're going to exit the for loop, and none of the cells below August should have their font changed. So let's see what happens here. Here we go. 3, 2, 1. Perfect. Worked exactly as expected. So January through August has had their font changed to Comic Sans. The ones below are unaffected. So we have prematurely ended the for loop. We have backed out of it. We have terminated it prematurely, and we do that here with the exit for keyword. Now let's take a look at the exit sub keywords. Exit sub is going to be used to prematurely exit a sub or a procedure before it is done concluding. So I'm going to go ahead and create a new sheet here. And let me just go ahead and zoom in so we can see it a little bit better. And I'm going to populate a couple numbers here, just random numbers here. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what I want to do is create a procedure that's going to allow the user to highlight with their selection, which means with the mouse, with this little cursor, select a clump of cells. And whenever they execute the macro, it's going to double the value within every single cell. How can we do something like that? Well, we can begin here by running a procedure. I'm going to call it double cell value. And what I want to do first is I want to iterate over the user's selection. Remember that the user's selection is just a valid range object. So as we're iterating over each thing in a range, we're iterating over a cell. And a cell is just another range object. So I'll begin by declaring a variable called cell. It's going to be a range object. Then I'm going to begin a for loop. This is going to be an actual for each loop. We're now not manually specifying the iterator variable. We're actually telling VBA to dynamically calculate it. So it's going to run over all of the cells in our selection. So for each cell in selection, selection again is a property on the application object that stores the actual selection or the thing that the user has highlighted, the clump of one or more cells. We want to make sure we put a next cell at the bottom here so that we move on to the next one. All right. What we can do here to double the value in each cell is simply get the cell value, multiply it by 2, and then reassign it back to the cell that we're currently on. So we can do cell.value equals cell.value times 2. It's a little bit of a confusing syntax, but remember that whatever's on the right side of the equal sign takes place first. So whatever the current value in the cell is, we're going to grab that. This is just a number. We're going to multiply that by 2 to get a new result. Then we're going to overwrite the value in the cell. So as an example, whenever we're right here on cell E1, number 5, we're going to calculate 5 right here. Times 2 is equal to 10. This is going to evaluate to 10 on the right side, and we're going to overwrite that exact same cell, which we still have a reference to because we're still in the for loop. We're going to overwrite that cell with double the original value. In this case, 5 is going to be overwritten by 10. So let's go see if this works right now. I'm going to select and make an actual selection here. So here we have the highlighted cells. Execute this. We should see everything double. Perfect. So everything looks great so far. But what if we want to make this a little bit more elegant and we want to prepare for some kind of alternate scenario? Let's say the selection is going to include something like a blank cell, something like this. And for some reason, we can decide that if there's a blank cell in the user selection, we want to stop the entire procedure. We want to say something is not going right here. This isn't correct. We're going to stop execution of everything, not just the for loop, but completely the rest of the procedure is not going to run. Pretend that executing some kind of forward step is going to lead to a mistake in the spreadsheet, some kind of thing that can't be reversed. We want to exit the sub completely, exit the procedure completely if we run into some kind of case. How can we create that for something like this? Well, what we can do here is something like this. We can write, first of all, we only want to do this line of code if the cell has a valid numeric value. So I can say if the cell's value is not equal to, let's say, blank is what we're checking for. So if it's not equal to empty string, which means if it does have some kind of valid number, in that case, I do want to do this. I want to take the cell's value, multiply it by 2, overwrite the cell. Let's make sure to add the end if here. But here in my else statement, I'm going to introduce the keywords that we've been looking to learn in this lesson, which is the exit sub keywords. So what exit sub is going to do, it's not just going to exit the entire for loop, it's going to end the entire procedure. All of double cell value, the entire thing is just going to end. No more lines of code to be executed. It doesn't matter if we have 40 lines of code below the for loop. This exit sub, if it's hit, will completely terminate everything. So the reason I wanted to introduce this in the same lesson as exit 4 is because exit 4 doesn't end the procedure. It simply ends the for loop and any other code remaining will still run. Exit sub, in comparison, will terminate everything. If it's in a for loop, it will terminate the for loop and the procedure. No matter where you put it, it's just going to end the entire procedure completely. Let's just do one more thing here. I want to alert the user that they did something wrong. So I can do a message box with something like, there's a blank cell here. Not cool. All right. So that's just a little bit of an alert to the user that something's gone wrong. So let's try it again. I'm going to create a selection here. And what we're going to see is everything is going to function up until we get to this cell, which is actually going to be the 8th cell in a row because for each iteration over a range moves horizontally from column to column. So we're going to go from 2 to 4 to 6 to 8 to 10. Once we're done with row number 1, we're going to move on to the next row of our selection. 12, 14, we're going to get to this empty cell. That's where it's going to break. But the 7 values that we've encountered up to that point will still be doubled. So we're going to see 4, 8, 12 here, and so on. Let's see how this works. I have it selected, F5 right here. All right, we can see the values here have changed. And now it's going to say there's a blank cell here, not cool. All right. We can see here that the 2 values we have at the end, 18 and 20, have not been doubled. That's because right here, when we ran into this condition of the cell being blank, we hit this else clause, and within there, we exited the sub. So we never even got a chance to reach these 2 cells and have them be evaluated. That's what exit sub does. It completely terminates the procedure no matter where you are in the process. That's all there is to cover in this lesson. I'll see you in the next one. Over the course of the next 2 lessons, we're going to take an in-depth look at the message box method on the top-level VBA object. As a reminder, this is just a method that brings up this alert box with a single block of text and an OK button. It temporarily halts the execution of the macro until the user clicks the OK button, and then the macro continues. So as a reminder for you, I'm just going to declare a procedure here. I'm going to call it showBox. And in the past, we did a very basic implementation of message box. We just did message box. And we used its first parameter, which is called prompt. And prompt simply represents the text that we want to be in the message box when it appears on screen. So I can do a text like hello there. execute with F5, and this is an example of a message box right here in the middle of the screen. This little pop-up box, we have our text, our prompt, hello there, and then a single OK button. And that's the basic implementation, right? Just one argument. Well, as it turns out, message box actually accepts a total of 5 arguments maximum. The last 4 of them after prompt are entirely optional, and the 2 that I want to talk about in this lesson come right after prompt, and they are buttons and title. Buttons allows us to customize the button or buttons that are going to appear right here at the bottom, and title is going to allow us to customize the text that appears right here at the very top where it says Microsoft Excel. So let's take a look at these options. I'm going to click OK right here. And let's go ahead and comment out this code since I don't want all of these message boxes annoying me as we proceed. So let's go ahead and create a new message box. I'm going to skip the literal naming of parameters and just write my message right here. I have custom buttons. Cool. So as soon as we proceed to the second argument, we're going to see this list of appear, this dropdown, and this is a list of enumerations that's going to represent what buttons are going to be present on the message box. We see a whole list of options here. The standard one, by the way, is called VB OK only. So just like the name suggests, this means that there's only going to be an OK button. So when I render this, we're going to see that's the standard message box, one button, and it says OK. But we're not strictly limited to simply having that one OK button. We can customize what buttons appear. For example, we have an option called OK Cancel. And that's going to render a message box with 2 buttons, OK and Cancel. Now, right now, if I click on either one of these, nothing is going to happen. We haven't actually hardwired any logic to the clicking of any of these buttons. But it does make the message box more expansive. It does give it more opportunity to do more. In the next lesson, we're actually going to wire up any of these button presses to do different things, right? But this is just the displaying of those buttons on the message box. So we have OK and Cancel. We also have options. If you don't like that paradigm, we have Yes, No. That's just going to be a message box with 2 buttons, Yes and No. We also have Yes, No, and Cancel. That's going to be 3 buttons, a message box with 3 buttons. Our first encounter with this, Yes, No, and Cancel. And as just one more option to show you, we have something called retry cancel. And again, there's no literal technical difference right now between these. These are just aesthetic differences. We can wire up these buttons to do whatever we want. That's up to us. But this does modify how it's going to appear to the user in the familiar message box, if you will. All right, so there's one additional thing I want to show you when it comes to buttons. We can not only customize the buttons that appear here, we can customize the icon that's going to appear to the left of our prompt text. So let me show you how that works. Right here where I have VB retry cancel, I'm actually going to populate this with another enumeration. And it's called VB question. This is not going to affect the button, it's actually going to affect the icon. So when I render this, we can see our OK button is still present. That's our default. But right here, we have this blue question mark appear, kind of like a question, like, hey, what's going on? That's just one visual indicator that we can use to customize how the message box looks. All right, as another example here, in fact, let me give you a few more. We have this critical option, VB critical, which is going to be this red X, kind of this big warning. If you want to give them a message box that something has gone really wrong, it's probably a good idea to give them an X instead of a question mark, right? It's all about the context. So VB critical will give you an X. Again, this does not mean that anything has necessarily gone wrong with the program. This is just how we design the message box. We also have another option available here called VB exclamation. That's kind of going to give you this like semi-warning sign, kind of a alert, but not really a severe alert, if you will, this yellow triangle with the exclamation point. And as one more example, we have this VB information option, which is just going to be this little capital I, kind of like a information, kind of a peaceful alert message, if you will. All right, so you might be thinking, how do I combine the actual buttons down here as well as the icon in a single message box? All you have to do is combine multiple enumerations and add them together with the plus sign. The reason this is going to work is because behind the scenes, every enumeration is equal to an integer value. So when you add them together, it's basically like adding 2 integer values, and VBA can figure out which ones you reference because different enumerations are going to combine together, sum together to unique sums. And that's how VBA is able to figure out what you mean. So for example, what I mean by using the plus sign is if I wanted the question mark icon, I could just write VB question. And if I also wanted my buttons to be yes, no, and cancel, I can simply add in a plus here. I'm still sticking to my second parameter, which is buttons, but I can add VB yes, no, cancel. So I'm combining both of those ideas that we just saw. We're just doing them all in a single line and just combining them with the plus sign, the addition sign. So when I execute this, we're going to see a message box with 3 custom buttons, yes, no, and cancel. And then we, of course, have this question mark right here. One additional enumeration that we have access to here is called default button, and it's actually pretty interesting when you think about it. So I'm going to change this back to, let's say, VB. Let's do VB question. Let's do VB yes, no. And then we're going to have this option called VB default button. And you can actually see a list right here, default button 1, 2, 3, 4. So what this basically means is if the user opens the message box, or if we prompt them with it, and the user simply presses the enter key, so they don't literally click on a button, but they just press enter, this is going to represent which of our buttons is going to serve as the default. So for example, if we have VB yes, no, that means we're going to have a yes and a no button. Yes is going to be button number 1, and no is going to be button number 2. So if we want the yes to be the standard or the default when the user presses enter, that means we would set this to VB default button 1. If instead we wanted no to be the default, that means when the user presses enter, instead of clicking a button, we want it to be the no in this case, then we would simply put VB default button 2. And of course, the reason there are 4 options available is because we can have more than 2 buttons. So for example, if we have something like yes, no, cancel, in that case, yes is going to be a default button number 1, no is going to be default button number 2, and cancel is going to be default button number 3. Let me go ahead and clear some space here in this message box invocation. And the very last thing I want to show you in this lesson is the third argument to the message box method. It's called title. Title is pretty simple. It expects a string, and this will be the text that appears in the very top in the message box's title bar. So if I wanted to do some kind of thing here like delete stuff, maybe I'm going to give them some kind of button that says, do you want to delete this, and give them a yes, no choice. In fact, let's change this to VB question plus VB yes, no. And let's make sure this is actually phrased as a question mark. So now we're going to have a prompt text of I have custom buttons. We're going to have an icon of a question. We're going to have 2 buttons, yes and no. And we're going to have a title at the top, as you'll see in just a second, called delete stuff. So when I execute this, there we go. We have a question mark right here, yes and no right here, our prompt text right here, I have custom buttons, and then delete stuff as a question mark. So we can customize basically any aspect of this box, starting from the very top in the header, all the way to its body, all the way to its footer, if you will, which are the buttons. That's all there is to cover in this lesson. We took a look at how we can aesthetically modify the look and feel of the message box. But as we talked about earlier, clicking any of these buttons doesn't actually do anything. So in the next lesson, we're going to hardwire them up and make them each take a different branch of logic in our VBA code. All right, so now that we've taken a look at how we can modify the aesthetics of a message box, it's now time to wire up those button clicks to different branches of logic right here in our VBA code. So what I want to do here is write a procedure that's going to prompt the user with a question whether or not they want to delete row number 1. So let's go ahead and populate the row number 1 with a couple of values, 1, 2, 3, 4. Doesn't matter what the values are. We just need something to test. And what I want to do here is create a brand new procedure. I'm going to call it capture user response. And we know that we are going to begin here with a message box. The first argument to be expected here is prompt, which is what's going to be displayed. We can give them a message like, hey, do you want to delete row 1? Perfect. Next up is our selection of the buttons and the icons that we want to appear. We are asking a question, so it might be a good idea to write the question icon in right next to our text. That's cool. And then, of course, we're going to add a plus and then our actual combination of buttons. So what buttons do I want to appear here? I think a really good choice for this is simply going to be yes or no, right? If the user chooses to delete the row, we can respond to that yes click. And if the user chooses no, we can do nothing. All right. So I'm just going to do VB yes, no. And one other thing that I want to add here is actually that default button option. And I'm going to do default button 2. The reason I want to do this is whenever you're selecting a default button, it's a really good idea to choose the choice that does the least amount of damage or the least amount of mutation, the one that changes the worksheet the least. If the user is accidentally not paying attention and they press enter and they delete a row of content, that's not really great, especially since VBA is not reversible. They can't just press Control Z and get it back. So you always want to make the default button the one that's the least dangerous. If the user accidentally presses enter in this case, default button number 2 corresponds to the second button, our second choice, which in the context of VB yes, no means the no button. So if the user accidentally presses enter, that means pressing no and nothing will happen. If the user realizes, oh, well, I actually meant to delete the row, they can just rerun the macro again and then press yes properly, right? So we're going to choose the one that does the least damage. So VB default button 2 sounds good to me. And I'm going to decide, let's not put in a title this time because there's really no point to in this case. This is just a good enough prompt to explain to the user what it is that we're doing. All right, so here's how this is going to work. MessageBox is actually going to give back to us a number, a long, an integer, that's going to represent the value of the enumeration that the user clicked. So remember, behind the scenes, each of these buttons, VB yes and VB no, now bundled up together, are each represented by a given integer. Remember, an enumeration is just a mapping of some kind of string or name to a value. So what we're actually going to get back here from a MessageBox is going to be a whole number. So the response, I want to create a variable that's going to store it, and that variable is going to be a long or a whole number. So right above here, I can do dim response. I'm going to make it a long, a whole number, and I'm going to assign long to the return value of MessageBox. MessageBox is going to give us one of two different values, one number if the user clicked yes, and another number if the user clicked no. Now, an important caveat here is whenever we're assigning the return value of a method invocation to a variable, as we're doing here, we're taking whatever MessageBox returns and storing it in long. Whenever we do that, we have to wrap the method invocation in parentheses. This will no longer do. So right after MessageBox, I can create a parentheses right here, an opening parentheses, and at the very end, after default button 2, I'll create a closing parentheses. So perfect. Now, long is actually going to store a whole number. In fact, I can prove this to you by just going ahead, not long, but rather response. I can go ahead and print response. And if I press F5 and run this and I press yes, you can see the yes is equal to the number 6. And if I execute this again, and press no, no is equal to the number 7. But you don't have to remember these numbers. You don't have to commit them to memory. The important thing to recognize here, though, is that each of these buttons is going to give back a number, right? So yes is expressed as a 6, no is expressed as a 7. So what we can do here is write a bunch of logic that says, hey, if the user clicked yes, or in other words, if the value that we get back in response is equal to 6, then do this process that we want to execute, which is the deletion of row 1. So we want to do if response is equal to, but we don't literally want to write the value 6 because nobody's going to understand what that means if response is equal to 6. Rather, we want our code to read a little bit more logically. Now, for every single option that we have available as a button, there is a corresponding enumeration to represent it. So what I mean by that is if we have VBS no, that means that VBA will also have a constant called VBS, which is going to be equal to the exact same thing. So in this case, the yes button returns a value of 6. So VBS is a constant that represents the clicking of yes, but behind the scenes, it's also represented by the value 6. And of course, we have a corresponding constant called VBNo. And for every single option available to you as a button, there's going to be a corresponding constant. So for example, if we have VB yes, no, cancel, so yes, no, and cancel are going to be our 3 buttons, there's going to be a VBS, there's going to be a VB no, and there's going to be a VB cancel in the VBA language that you can utilize. So rather than hard coding the comparison to a number, we're just going to write if VBS. So this is going to be a number, this is going to evaluate to a number. If they're both the same, we know that the user clicked on the yes button. And if the user clicked on no, we don't care because we can take them back to the interface. So what I can do here is put a then, close off this end if, and right here, of course, we wanted to ask the user if we can delete row 1. If they said we can do rows 1 and then just delete it. And that should do it. So let's go ahead and delete this code, save this, press F5 to execute. I want to show you 2 examples before I actually delete the row. The first is what happens when we press no. In that case, nothing's going to happen because this is going to evaluate to false, so the body is never going to execute. One other thing, I'm going to press F5, and then rather than clicking a button, I'm going to press the Enter key. You can even almost see here that no is a little bit more raised than the yes button, so it's kind of targeted by default. So if I accidentally don't read this and press Enter, it's almost the exact same thing as pressing no. Nothing is going to happen. We've avoided any accidental damage. Now, if the user presses F5 again, and now they see the message box, and now they read it, and they realize, oh, yes, I do want to delete row 1. As soon as I press yes, there we go. It looks like row 1 has been deleted. All the values are gone. All right, and that's all there's to cover in this lesson. We talked about how we can hardwire the button clicks on our message box submission to actually do different branches of logic. You're not limited to strictly yes or no. You can do yes, no, cancel, retry. We took a look at all of those different available options in the last lesson. Whatever you want to react to, there's going to be a corresponding enumeration. So there's going to be a VB cancel, a VB retry, a VB yes, a VB no. You can take whatever button the user clicked, compare it to a given enumeration. If it's true, you know that that's the button that the user clicked, and you can write your logic in the body of that if statement for what you want the code to do in the case of that specific click. That's all there's to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at how we can use VBA to modify the message on the status bar in Excel. Now, if you're unfamiliar with the status bar, it's actually this little bar that appears on the bottom left corner of the Excel interface. Right now, it says ready. And the Excel status bar is usually used to communicate some kind of information to the user, such as the progress of a specific event or the rate of completion of something. So if we're executing a macro that can take a significant amount of time to run, and by significant, I don't just mean like minutes, I mean even a couple seconds, anything that's not lightning quick, it might be a good idea to give the user a heads up and give them a status update ever so often to communicate how far along the macro is as far as its execution, so the user just doesn't see this blank screen that appears to be frozen and doing nothing. So it's a good idea to use the status bar as that communication tool. We obviously can't do something like debug.print because we only see that as developers in our Visual Basic Editor, and we also don't want to use something like message box because that's going to halt the execution of the macro temporarily. So the status bar represents a really effective way that we can actually inform the user temporarily as we're proceeding through something that's a little bit more of an exhaustive process. So let's take a look at how we can do something like that in our Visual Basic Editor. I'll begin by declaring a procedure. I'm going to call it status bar process. And I want to do something here that's going to take a little while to run. So I'm going to do a pretty big for loop. I'm going to declare an iterator variable called I, and I'm going to loop for I equal to 1 all the way to, let's do 5,000. Let's make sure to increment I. And what I want to do here is, as I dynamically iterate over my rows, which are going to be represented by I, I'm just going to write a value into column 1 or column A. And that value is going to be a mathematical calculation. It's just going to be the square of the current number that I'm iterating over. So if I'm iterating over 1, this is going to be 1. If I'm iterating over 2, 2 times 2 is going to be 4. If I'm iterating over 3, 3 times 3 is going to be 9. So I'm going to be writing these values. And of course, these calculations, a total of 5,000 of them, are going to take a little bit of time for Excel to process, a couple seconds. So here's what I want to do. I don't just want to necessarily write to the status bar every single time, because it's actually going to be about 5,000 writes. And it's going to move so quickly that perhaps the user is not going to be able to see it. But what I can do here is do some kind of conditional statements that we only write ever so often. So one way that I can do it is something like this. I can say if I mod 100 equals 0, put a then, and then an end if, and I'll explain what this is doing in just a second. So you may recall that the mod operator is short for modulus, and that allows us to return a remainder. For example, if I take 5 mod 3, we're going to get the remainder of that division operation. So if we divide 5 by 3, we're going to get a total remainder of 2. So whenever a operation like this gives us a mod of 0 or a remainder of 0, that means that a number is evenly divisible by something. So for example, if I do 6 mod 3, 3 goes evenly into 6. So we're going to get a mod or a remainder of 0. So what I'm doing here is I'm saying if the number that I'm currently iterating over is cleanly divisible by 100, which means it's going to have a remainder of 0 when the mod operation is applied, then I'm going to perform some kind of logic. What I'm basically doing in layman's terms is making sure that the logic inside this if statement only shoots off every 100 iterations. So I don't want it to go every single time. I only want to do it every 100 iterations, which is going to reduce the total number of messages I have to write. Because remember, this is not doing anything permanent. This is just temporarily updating the status bar. So I don't want to write it every single time just to conserve a little bit of memory. I just want to do it every 100 or so. And because this is going to be writing very quickly, it's not going to be noticeable by the user. It's still going to be a very quick operation, and the user is going to be able to see that progress very quickly. So what I want to do here is target the status bar property on the top level application object. So application.statusbar. And we can give this a variety of arguments, but what I want to give it right now is actually going to be a string. And this string is just going to tell it where it is along the process. So what I can do is something like this. I'm going to use the I iterator variable, and I can do a concatenation and write out of 5,000. So it's literally going to write something like 100 out of 5,000, 200 out of 5,000, 300 out of 5,000, just a status update to show where we are in terms of the entire execution of the macro. There's one more thing I need to do here at the very end of the procedure, at the conclusion of my for loop. This is just a really good idea so you can reset the status bar back to its original shape so it can do its default Excel behavior, because many times Excel uses the status bar to communicate messages or the status of a specific operation. For example, a copy operation. Whenever you copy something, it's going to enter something called copy mode, and that's going to be written in the status bar. Just to make sure we don't run into any errors at the very end of a procedure in which you modify the status bar, it's a really good idea to do application.statusbar and just set it back to false. That's kind of like a reset operation that's going to bring it back to its default state. And that should do it. So I'm about to execute this procedure. It's going to write a total of 5,000 cell values. Each of them is going to be the square of the current iterator number. And then the place where you should be keeping your eyes, of course, is going to be the bottom left where it says ready right now. That's the status bar. And we should see that status bar being continually updated with our progress. So let's go ahead and take a look right now. F5. And we can see, of course, it was very, very quick, but we just saw how that number was being incremented and rising up. We can, in fact, make this a little bit even more complex. Let's increase this to 20,000. Let's see if that works and run it again. And we can see there, that's a much better example. Of course, we only wrote it out of 5,000. Let's change it back to 20,000. Now let's take one more look. Keep your eyes on the bottom left. We can see that number incrementing and offering the user a quick update about where we are in the process of evaluating the macro. That's all there is to cover in this lesson. We talked about the status bar property on the application object. You can set it equal to a string, especially a dynamically changing string is a really effective use of this, just to show the user some sense of progress, give them something visually changing on the screen so they know the macro is working as expected. In this lesson, we'll take a look at the application screen updating property, which can be set to false at the very top of a procedure or macro to speed up its execution. What screen updating does is it controls whether the screen or the Excel spreadsheet is actually updating over the course of a macro's runtime. Now, what you can do is actually disable it so that a lot of these updates will actually occur behind the scenes and they're going to be batched up and then pasted to the spreadsheet finally as a whole towards the end. So if it's not critical that the user actually see what's going on as the macro is running, if you don't necessarily have to show them as each cell is being written one by one, what you can do is just turn off screen updating at the very top of the macro and then turn it back on at the very end, and all of the final results will still be pasted to the spreadsheet, but it's going to execute a lot faster overall. So let me show you this example in action. What I'm going to do here is create a brand new procedure called times table. And what I want to do here is create a big times table where I'm essentially just going to multiply two numbers together and create a big grid of all of their products. So what I can do here is first set my screen updating property right on the top level application object to false. So this is not going to update the screen, which means any kind of write operations to the spreadsheet will not immediately appear as the macro is still running and processing additional data. Only at the end, when everything is processed, will we actually paste the data to the screen. The important thing that you have to remember, though, is at the end of the procedure, we have to turn this thing back on, which is setting it to true, the Boolean true. Otherwise, we might break other features of Excel. So essentially, it's sort of like a pause that says, don't paste anything, don't write anything until you're done processing all the data, and then in one batch, just paste it all to the screen and do that. So let's create a times table. I'm going to create two variables here. They're both going to be longs, dim I as long, dim j as long. And what I'm actually going to do here is do a nested for loop. So I'm going to begin my I variable, let's say at 1, and I'm going to go all the way to 100. And I'm going to put a next I right here. And then within here, I'm going to also initialize my j variable. And I'm going to do the exact same logic from 1 to 100. And then make sure I do a next j. So what this is going to do is actually create a nested for loop, which is a little bit of an advanced concept. But it's going to begin I at 1, and then j at 1. And then it's going to go j equals 2, j equals 3, j equals 4, all the way to j equals 100. And once it's done with that inner loop, the j loop, it's going to increment I to 2. And then when I is 2, it's going to again set j to 1, then j to 2, then j to 3, then j to 4, all the way to 100. And repeat that process. So we're going to go through 100 top-level iterations and then 100 iterations of j for each one of those top-level iterations for a grand total. I think that makes 10,000 total calculations right here that we write in the nested body. So what I can do here is just create a times table with something like this. Cells, and I can write simply to I and j. So my first outer loop, the I variable, will serve as my row that I'm going to be writing in, and my nested variable, which is j, is going to serve as the column that I want to write in. And let's say I want to write inside simply the product of multiplying I and j together. So as one example, when we're on I equals 1 and j equals 1, we're going to get a product of 1, and that's what's going to be written right here in cell 1, or cell A1. And of course, this is going to be accelerated and made a lot quicker because application screen updating is not going to write these properties one by one for each cell. Rather, it's going to kind of batch them all and then write them all at the end. We're not going to be able to see this effect one by one. We're going to see it all just pop up in the screen in just a second. So let's go ahead and execute this, F5. And there we go. We can see that a huge batch of numbers has just appeared on screen. We didn't really see the logic of the cells being written one by one, even though that process occurred 10,000 times. If you think about it, we didn't see it happen one by one or even in kind of a flash. We just saw this big blur, and then all of a sudden, all the values are pasted. So that's the big advantage of screen updating, is that it can really update the speed of your macro, because Excel doesn't constantly have to keep writing these values one by one. It just does them all at once. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the special cells method on a range object, which returns to us a brand new range object with cells that fit a specific condition or criteria. For example, if we want to start with a range and we only want to select the blank cells within that range, or only the cells that have valid values, or only the cells that have formulas, or only the cells that have comments or data validations, all these different criteria, we can use special cells to filter our original range to only include or target the cells that meet a certain condition in a brand new range. So what I'm going to do to begin here is just populate a bunch of values in column A. I'll begin with some static fixed numbers, for example, 3 and 5. I can then leave a blank cell. And then let's say we're going to have a cell with a predefined formula. The easiest one we can do here is sum. So I can choose sum, highlight these two values just as an arbitrary example, and we're going to get a cell with 8. We can also do another blank cell here. We can do, let's say, a word like hello. And finally, what I want to do is create a comment in one of these cells. Let's say cell A7. I can just right-click it here and select Insert Comment. And this is a regular Excel feature, nothing VBA special about it so far. I can just leave a comment like great cell, exclamation point, click out of it. And of course, the indicator of a comment is this little red flag at the top right corner of the cell. If I hover my mouse over the cell, that's when I see the actual comment in Excel. All of this is just random and arbitrary Excel features, but we can target any of these specific things using VBA. Let's take a look at how we can do that right here in my Visual Basic Code Editor. I'll begin by creating a new procedure. I'm going to call it Find Specific Cells. And the first thing I want to do, just to make things really simple, is create a variable that's going to point to the range that I'm using here, which is cells A1 through A7. So I'm going to keep it really simple. My variable will be R, and it's going to be a range object. And as a reminder, whenever you have a Excel object being used in a variable, you have to use the set keyword when you're assigning it. So set R equals range, and let's say I want to target cells A1 through A7. Perfect. So now we have a very simple reference to that range. It's just going to be the letter R. That's our variable. So special cells is a method on the actual range object, and it expects, of course, an argument. And that argument is going to be a predefined constant or an enumeration. So these are all, again, predefined values or constants that are built into VBA that we can use here, and they just translate to numbers when the actual language is processing these things. And as you can see from the drop-down list, these are all different things that we might have in our cells. We can see here blanks, comments, constants, etc. So what I can do here is begin with a couple examples. Let's say something like Excel cell type, which is what begins all of them. And then you actually specify what it is that you want to target. So one enumeration that's available is constants. And constants represent any values that are fixed or absolute or final. So these are going to be things that are not dynamically calculated like formulas or blank cells. These are just values that we've manually typed into a cell like 3 and 5 and hello. So this is going to give us back a brand new range object. So if I execute this, we're not actually going to see anything. It's just going to select it. So we can actually use the select method on the range that Excel will actually highlight those cells for us. And we can take a look at what this special cells will filter for us. So when I execute with F5, we can see those 3 cells that have constant values are going to be highlighted. So that's the new range that we're targeting. And it's really advantageous because it's not necessarily a contiguous range. It's disjointed and broken up. But that's what's really great about this special cells thing is we can only target cells that fit a specific condition. For example, if we wanted to only bold only the constant cells, we can use this to target that specific range and then apply all of our actual logic to this filtered subset of cells. As another example of special cells, I can do something like this, special cells, Excel cell type, and let's try blanks. So blanks is another option available to us. I can use the select method here, and now we're going to select all the cells that are blank. We can see A3, A5, and A7 selected. Let's take a look at a couple other examples. I'm going to do once again special cells. Excel cell type, we have an option to only show the cells that have comments within them. So I can select that, and we're going to see only cell A7, which is the only one that has the comment. We can see that again with the red flag at the top right. And finally, the last example I want to show you is Excel cell type formulas, which is going to allow us to select only the cells that have formulas in it. So the values that are dynamically calculated using some kind of Excel formula. And this should only be one cell right here, which is going to be cell A4, which again is using the sum formula to calculate the sum of 3 and 5. So special cells is a really, really powerful feature whenever you want to begin with a large range and then you want to filter it down to only those cells that meet a specific criteria. Maybe you only want to bold them or increase their font size or do something special with them, but you need a special way that you can target these things instead of manually writing some kind of VBA logic like if the cell value is blank, then do this. Rather, special cells is a really unique and powerful way that you can automatically let VBA do that work for you. It has a lot of these predefined constants or enumerations that know how to target a specific cell, an empty cell, a cell with a comment, a cell that has data validation, a cell with formulas, a cell with constants, and even more options that we didn't explore in this lesson. I do advise you to dive into the documentation and see some of the other options that you can provide for the enumeration, but the syntax will work exactly the same way. Just use the special cells method on a range object. It's going to give you back a brand new range object. Over the course of the next two lessons, we're going to take a look at two similar but different concepts, which is the input box function and the application input box method. They're both used to collect input from the user, but they function in slightly different ways. In this lesson, we're going to take a look at the simpler of the two, which is the input box function. This is a dialog box that allows us to collect user input. So something that the user types, we can ask them to input some kind of value. We can then take it and process it always as a string. So the input box in that sense is similar to a message box. It's going to run in the middle of a procedure. It's going to halt all other code from running, and it's going to give the user something to interact with. Up until the user actually interacts with it, the procedure will be halted, and then once the user confirms, we can continue on with the process. So unlike a message box, the input box is going to have a big field in the middle that's going to allow the user to actually type something in, a value that we're going to process. Unlike a message box, the input box offers a lot less customization when it comes to the buttons that the user can click. There's only going to be two buttons alongside the actual input that the user is going to type. Those two buttons are OK and cancel. Obviously, OK is going to submit their submission, which we can then process with our VBA code, and cancel is going to completely cancel the entire operation. The input box also offers us no validations, which means if we want to test something, we have to do it in our actual VBA code. So if you're trying to build something like a complex form with a lot of different inputs, it's not a good idea to use the input box. For that, you want to use a user form, which we'll dive into a little bit later in the course. But if you really want to collect just one value from the user in a simple pop-up box, that's what input box is absolutely perfect for. It's always going to give you back a string. So here's what I want to do in this lesson. I want to create a brand new worksheet in my workbook, and I want to let the user choose the name. So what I want to do is bring up this box, say, hey, what name would you like to give the sheet? They're going to enter a name, and then I'm going to create the sheet and automatically rename it for them. These are all, again, simple Excel functionalities, but these are ways that we can improve the user's overall workflow and efficiency. So here's how I can code something like that. I'll begin by defining a new procedure here called add new worksheet. And I'm going to need two things to store, so I'm going to declare two variables. The first is going to be a variable with a string. I'm going to call it worksheet title, or WS title for short. And this is actually going to be the string that's going to represent the user's entry, so what it is that they want to name the new worksheet. Eventually, I'm also going to need a new variable to represent the worksheet that I'm going to be creating, so I'm going to call that WS for worksheet. And you'll see how all these variables come into play in just a second. So what we want to do here is we want to take WS title, which is expecting a string, and here on the right side is where I'm actually going to use the input box function. So input box like so. And there's a couple of things that we have to watch out for here. Whenever we're going to be assigning the return value of an input box, which is going to be a string, to a variable, we have to use parentheses whenever we are invoking the function. So I do have to actually apply the parentheses here, and I'm going to close them as soon as I'm done entering all the parameters and arguments. So we can see a couple parameters here, and the most important ones for us in this lesson are the first three, which is prompt, title, and default. The prompt argument determines the actual displayed text. It's the prompt, it's the thing that tells the user what we're expecting to receive. So what I can do is something like this. Prompt, I'm going to do the := syntax, provide a string. So what do I want to prompt the user to do? I want the text to display enter new worksheet title. close my string, comma, to move on to the next argument. My next argument, the second in line, is title, and this is going to be the text that's going to display in the header of the input box that pops up. So it's kind of like an introductory title, if you will. So I can give this a simple title like worksheet box, and I'll show you where this appears in just a second. Finally, the third one that I want to show you to here, the third argument is called default. And default allows us to specify the standard or default text that's going to appear in the input box when it shows up. So it doesn't have to be necessarily an empty blank white box. You can have some predefined value in here. For example, I can decide that if the user just executes the procedure and then clicks OK, I want magic sheet to be the default value that's populated in my input text field, so it's automatically going to be submitted. The user, of course, is still free to edit it if they'd like. However, it's going to be the default value displayed there, which can allow them to move quicker through the process. All right, so I'm going to close the parentheses here. That just makes sure that everything is going to execute properly when we run this function. And this is going to pause the entire procedure up until the user enters the value in the input box, which we'll see in just a second. And then that's going to come back to us always as a string, and that's going to be stored in WS title. So what I want to do below is I want to create the worksheet, but before I get there, there's one thing I want to do, which is I want to run a little bit of error handling, which is accounting for the possibility that the user perhaps doesn't enter a value or clicks the cancel button or clicks the top right X button, the red X that's going to be on the top right corner of the window. There's many different ways that the user can exit the operation, and I want to catch that. The good lucky thing about that here is no matter which one of those options the user chooses, if they don't complete the form, if they click cancel or exit, what's going to happen is the input box is going to return back to us an empty string. And we can check if WS title is empty. And if it is empty, we know that the user followed one of those three ways to get out of the actual operation, and we can basically not do anything. So what we want to do is we only want to add a worksheet if the user gave us a valid string value, which is not an empty string. So I can do something like this. If WS title is not equal to, this is the inequality operator, which means not equal to, only if that condition is true will we execute the body of this if statement. And I want to compare this to an empty string, which is just two double quotes, nothing inside them. I want to write a then, and I want to make sure I write an end if. So what this is saying is whatever I write here where my cursor is flashing is only going to execute if the worksheet title is not an empty string, which means the user actually entered something. By the way, because of our default value of magic sheet, if the user just clicks OK, magic sheet is going to be our worksheet title, so it's going to bypass that check and everything's going to work out. So what I want to do here is use my set keyword. Remember, I have to do this whenever I'm assigning to a variable that represents a VBA object rather than a simple data type like a string. So because WS is a worksheet, I need to make sure I write set before it. And what I can actually assign it to is the return value of doing worksheets.add. The add method on the worksheets collection object will create a brand new worksheet and give it back to us, the entire object, which we can then store in WS. Once I have WS, a worksheet object is going to have a name property. That property is writable, and I can set it equal to whatever the user just provided me in WS title. And that should do it. We're going to prompt the user for a new worksheet title. You're going to see what that input box looks like in just a second. We're going to make sure that the user didn't exit or click cancel or enter nothing. And then assuming they entered a proper string, we're going to create a brand new worksheet and retitle it. And we should see it appear in our Excel interface at the bottom left. So let's go ahead and execute this with F5. And here we see our input box. So the first thing that you want to notice here is the title worksheet box. We specified that right here in our title parameter. This can be whatever you want. It doesn't have to be worksheet box. Right here below, we have the prompt, which appears directly below the title. That's what we entered right here. Enter new worksheet title. Here we have our choice of two buttons, OK and cancel. You can't modify these unlike a message box. And here finally is the input itself where the user can type. And you'll notice the default value that's populated here is magic sheet. So I can give this a new title. I'm just going to erase what's here and write something like super cool sheet. And that's going to be a valid input. So when I click OK, we can see super cool sheet is going to be created and inserted. So we've performed the process as expected. And just to show you what it would look like with the default magic sheet option, if I execute this again and don't type anything and just press OK or even click enter, it's going to automatically use magic sheet, which is the default, and the user can move through that process much more efficiently and quickly. That's really all there is to cover in this lesson. We talked about the input box function, which gives you this dialog box that allows you to collect user input. The user input will always come back as a string. If you want to do something like ask the user for a number, there are ways to do that, but you'll have to convert their string input into a number. You can look into a function called val to explore more of that. but it's always going to come back as a string, and then you can do with that whatever you wish. In this case, we created a brand new worksheet. It's important to also do as much validation as possible and error handling and check that the actual user entry is valid, that it's not an empty string or that the user didn't click cancel. And that's what we took care of here with the conditional statement. That's all there's to cover in this lesson, so I'll see you in the next one.